Hello everyone. So now we are going to start with CATIA series. We have completed AutoCAD, SolidWorks and Solid Edge. If you want to learn all the three softwares, you can follow the playlist under the channel 4 Dimensions Infotech. Today we are going to start with CATIA software. We are going to see the basics of CATIA, that is Sketcher. So to start with, I am going to select the software here. So this is the starting interface. When you start the CATIA software, it is going to start in assembly interface. We can see here the title, it is showing CATIA V5 product. Now the full form of CATIA means computer aided three-dimensional interactive application. The version we are going to use here is V5 and the interface is product. Product means assembly zone. But as we discussed, we are going to start with Sketcher. So I'm going to close this interface here. You can see the close sign, not the above close sign, but the sign that is coming below that. So I'm going to click on this close option. After that, we are going to say start, mechanical design and part design. So while entering in part design, it will ask you for the name. It means whatever name the file is going to be saved, you should specify the name here only. So I'm going to specify this name here as day 1. Say OK. So this is the part modeling interface. Here are the planes. At the left side, we can see this model tree area. Whatever will be the history of the part, that is how the part has been made. First feature, second feature, these sketches, all things will be saved here. So whatever feature you want to edit, you just need to say edit and you can access the feature to change it. This was model tree area. So in model tree area, first one is XY plane. It is showing the top plane here. The next plane is YZ plane, that is front plane, and ZX means the right plane. So all the planes are being shown. If you want to hide the planes, we can directly select the planes here by continuous pressing the control key. Select the planes and you can say hide. If I again want to show the planes, just select the planes, say right click and say show. The planes are visible now. This is the access system. It will be used in assembly so as to move the part from one place to another. Now we need to say sketch to the plane. So the plane will be activated and we can start with the sketching. So for that, we have this sketcher toolbar here. We can see the symbol here, this white symbol. You just need to click on this symbol here and then select the required plane you want to sketch. So I'm going to select front plane here, XY plane. As soon as you click the plane, the interface has been changed. It is showing the sketcher interface now. So before starting this sketch, we need to note down some toolbars which are very important here. There are total 5 to 6 toolbars which we are going to see here. So the first toolbar we are going to see here is profile toolbar. All the geometrical entities are going to come under this profile toolbar, such as lines, circles, rectangles, arc. Next one, after drawing the geometrical entities, we need to modify them. So for modifications, we have the operations toolbar. This operation toolbar we can perform fillets, chamfers, trim, mirrors, offsets and multiple commands. Next toolbar that is important here is after drawing and operations, we are going to say constraint. We are going to define the dimensions. So for defining the dimensions and providing the constraints, we need to go for this constraint toolbar. These are the 3 toolbars that are very important here. That is profile, operations and constraint. Next we have this sketch tools toolbar. Now this toolbar, when you select any command, it will expand and show the subtypes of the selected command. For example, if I take this line, you can see it will expand here. Now it is showing the subtypes here. Means this line can be converted to 3-point arc or tangent arc. So whatever command you are going to select, it will show the subtypes here. Say escape. After saying escape, you can exit the command here. Next toolbar is view toolbar. That will come in the bottom side. We can see this view toolbar. By using this toolbar, you can zoom in, zoom out, make the planes normal. We can say pan, or else if you want to rotate the model, you can use this command here, rotate. So all these commands will come in view tab. It by default comes at the bottom side here. So I'm going to place here only. The other toolbar is visualization. So in visualization, all the constraints are being shown. Means if I put on this all the 3 options at the last, the constraints will be shown in these sketches. You can control the visibility of constraint by using these 3 commands. If I put off this option, that is dimensional constraint, it will not show the dimensional constraints. If I go for this option to put off, then geometrical constraints will be hidden here. Means we will not understand whether the sketch is completely defined or not. So it is compulsory for us to keep all the 3 commands here. that is from visualization tool, that all the three commands should be kept on only. Same here in sketch tools, we have both this option at the last. The orange color is highlighting that these commands are being put on. So this geometrical constraint and dimensional constraint. If these options are being kept off, then after the completion, the sketch will be not shown as it is constrained or not. That's why these two options are also compulsory to kept on only. After that, we are going to start with the line command first today. So to start with line, we have this profile toolbar and we have this command here, that is profile. We have the line command also here. There is difference between profile and line command. We are going to start with the profile command first. Profile means we are going to take continuous line here. So if you want to draw a profile by using line command, then you can go for this option profile. We'll start with the origin only. Now if the line comes vertical, it will be shown in the blue color. And if I make the line inclined, it will be shown in white color. So you can judge whether the line is coming vertical or horizontal or not. So here again, if I keep this horizontal, it is showing blue color. I'm going to keep it vertical only here. Just click on this point here. Now after making this line, we can see one relation is also being shown, highlighting that line is vertical. It is showing the letter V here, means vertical. Now the line, if you make from origin, it will come in green color. But at the end point, we can see this strip is coming in gray color. This end point, it is showing in gray color. So if I drag this end point, the line is movable. Means this line is not fully constrained. If I want to go for sketch analysis, I just need to go on tools tab, say sketch analysis. And here I'm going to say diagnose. So this point, the above point is showing, that is point number 2 as under constraint. If I click on this point, you can see it has been highlighted in orange color here. And that point is being shown as under constraint geometry. I'll close it here. So if I want to constrain this line, or if I want to control the length of this line, we are going to go for constraint toolbar here. Select the second option, that is constraint. Just double click on this option. I'm saying double click, it is because if I single click here, then it will provide only one dimension here. If I double click it here, then I can go for continuous dimensioning. That's why double click. Select the line, double click here again to change the value. This constraint definition box will appear and you can change the value here. So I'm going to say 80, say OK. Now the length is coming 80 and we can see this point is also coming as in green color. That is, it is showing the line is fully constrained. If I again go for tools, sketch analysis, diagnose, now everything is showing constraint here. That is this line, point, this relation as well as the length. Everything is constrained completely. Say close. So in this way we can make the line or any entity here. If I am making randomly a line here, this line is not being made vertical. So if I want to make this line vertical again, I just need to select the line. Now in constraint toolbar, select the line, go to constraint toolbar and select this first option, that is constraint defined dialog box. So now by selecting this line, it is showing whatever relations are possible here. So I'm going to say the relation here as vertical if I want to make the line vertical. If I want to make this line horizontal, then I'll go for horizontal relation. I'm going to select vertical here, say OK, and we can see this V letter has been added, showing that this line is orientation wise vertical now. But still we can see this line is moving as the length also is not being provided and the relation with origin is not being provided. That's why this line is completely moving in this interface. So to define this line, we need some dimensions also here. Say double click, select the line, put up the value. I'm going to say it 80 mm length. Now as this line is not made from the origin, we need to provide the constraints from the origin here. So as to define this position of the line, I'm going to double click on this constraint option, select the origin, select the line. Now after selecting the origin and line, this dimension is coming aligned, means inclined. If I want to make this dimension as X dimension, means horizontal dimension, I need to right click here and say horizontal measure direction. It will show the dimension here as horizontal. Just double click it here and say 150, say OK. Next we are going to give the vertical dimension. Horizontally this line is constrained. If I drag this line horizontally, it is not going to move here in horizontal direction. But in vertical direction you can see it is still moving. So to constrain by vertical also, we are going to provide the vertical dimension from the origin. Say double click, select the origin as well as the endpoint of the line. Say right click and say vertical measure this time. and this line is completely constrained now. So in this way we can constrain the line even if we have not made it from the origin. But we can see here the number of dimensions required will be more here as compare if we make the line from origin. That's why it is better to start any drawing from the origin only. Next, if I want to continue making this line, I'm going to say one horizontal line and one inclined line. Now to constrain these dimensions, we can see this horizontal line length is not been provided. That's why it is moving horizontally. So I'm going to provide horizontal dimension here. I'll double click here and say 70. Now there was a line here. That's why for this inclined line we have not given any angle here. But if this line doesn't exist there, suppose if I delete this line, then to define this line we need to provide the length as well as the angle, both. We can see the motion here. Now this line is been rotating here. Means we need to provide the angle to stop the rotational movement as well as the length. It is compressing and expanding. So to define this line length, again go for double click on this constraint option, provide the required length as well as the angle. I'll say this angle as 135. Double click here also and say dimension as 100. Now this complete geometry has been constrained. To confirm that, I'm going to say tools, go on sketch analysis, say diagnose, and we can see every entity here is coming ISO constraint. Say close, and this geometry will also appear in green color, showing that this complete geometry has been fully constrained. Again, we will focus on this horizontal and vertical relation here. Suppose if I make this line inclined, I want to make this line vertical again. So you just need to click on the line, go for constraint dialog box and say whether you want the orientation as vertical or horizontal. I'm going to say vertical, say OK again, and this line is been made vertical. We'll make one more line here. Now suppose I want to define this line. So for that I'm going to start with giving the length, provide the dimension and double click on the dimension. Provide the dimension here is 150. Now the length has been defined, but still it is not been defined from the origin. I'm going to go for this constraint again. Select the origin and the line's endpoint. Say right click, one horizontal measure and one vertical measure. But still this line is not constrained. It is because this line is inclined. So if you want to provide the angle here, I'm going to make one reference line from this fully constrained point. I'll take this vertical line. It is coming complete solid line. I want to make this line as a reference line. I'm going to select this solid line here. Go on this sketch tools and I'm going to select this option, that is construction mode. Select the line and select construction. So this line is converted to reference line now. Again, if I want to put off the construction and then continue with this sketch, I'll put off this option here and then continue with this sketch. But if I forgot to put off this option and then continue with the geometry, by default all the geometries are going to come in construction line only. So better you remember to put off the option first and then going to continue with this sketch. So we have made one reference line here for providing the angle. The purpose of this line only was to provide the angle. That's why we have taken the reference line. Place the toolbar at its place. Go for the constraint dimension. Select both the lines and provide the angle. I'll say this angle as 25 degrees. Now this line is completely constrained. But we can see the endpoint of the reference line. It is moving. Now this line is construction geometry. So it doesn't matter if you don't provide the dimensions here. If I keep this point under constraint also, it is not going to affect the 3D here. Only the positional dimensions are required. That is this horizontal and vertical for starting the position of the construction line. Now you can see all these lines are being made with some length. And this length are having some units. The unit which we have used here is millimeters. CATIA will by default start with millimeters only. But if I want to change the unit, then go to this tools option, select the options, go for parameters and measure, and here you have the option units. You can change the unit if you require. If I want to work with inches, I can go for inches. If I want to go for millimeters, centimeters, all the units options are available here. But still I am going to continue here with millimeters only. Say OK. It is by default set unit as millimeters only. Means if you are working in millimeters, you can directly start with this sketch. Now I'll take this sketch tools here. So after seeing how to change the unit, we are going to go for the line command again here. But this time you just need to observe the sketch tools. If I select the line command again, this tool will expand and it is showing the subtypes of the line. Suppose if I start continuing with the line, this line is appearing here. But if I want to convert this line to 3-point arc, then you just need to select this option, that is 3-point arc. It is subtype of line only and it is coming in sketch tools. Select this arc here. As soon as you select this 3-point arc, the first point from the 3 points will be this starting point only. The next point will be second point and this will be the third point. As this 3-point arc has been made using line command only. Now if I continue with the line again, select the end point of the arc, make one line, and then going for the second line we have this option put on here, that is tangent arc. Means if I want to continue this line as a tangent arc, we can go for this option. It will be converted to tangent arc. Tangency relation will automatically be applied there. I'm going to select this option tangent arc and we can see this line is converted to tangent arc now. Now this arc commands, that is 3-point arc and tangent arc, we can make them by the separate command also. We are going to see the arc command later here in circle tab. So this was the lecture for today. Now if you want to learn CATIA, continue watching the playlist in which we are going to cover the upcoming commands. Till then, we'll stop here. Thank you. So hello everyone, today we are going to start with day 2 of CATIA. In first lecture we have seen line command, how to make line vertical, how to make line construction, what are the toolbars for starting the sketcher, how to select the plane, how to exit the plane. We have also seen in last lecture how to constrain the objects. And today we are going to start with further commands such as rectangles, circles and many more. So to start with, I'm going to select the start key, say mechanical design, say part design. And in part design we can define the name here only so as to save the file. So I'm going to define the name as day 2, say OK. Now we are going to go for the plane selection. You can select the plane from model tree or directly from the screen by clicking on this plane. So whether you want to select front, top or right, you can select any plane for the sketcher. So I'm going to select front plane here, say sketch. And now in sketch we are going to go for rectangle command. So here select the rectangle. It will start from the corner, so it is a corner rectangle. Now to constrain the rectangle we need to give the dimensions. So we are going to refer this constraint toolbar here. In constraint toolbar we have this second option, that is constraint. Just double click and put up the dimensions required. I'm going to put the dimension between the sides of the rectangle, not directly on the line, because after you provide fillets on the rectangles the corners will be removed and the length may get affected. That's why provide the rectangle dimensions in between sides instead of directly giving on line. Next, this vertical dimension, provide the dimension between sides only. I'll say it as 120. And now this rectangle is completely constrained. We can see the color is coming green, showing that object is completely constrained. We can also judge it by going on tools, sketch analysis, diagnose, and here we can see all the detailed information about lines and points showing the status as constraint. Say close. Next type of rectangle we are going to see here is oriented rectangle, and it is used for making the rectangles incline. So if you want to make any rectangle incline, you can use this rectangle, that is 3-point rectangle. Now to constrain this rectangle also same, provide the dimensions for the rectangle. Then we need to provide the angle also here, as this time rectangle is tilted. So we are going to provide this degree here. I'll say 25 degrees incline. Next we need to constrain it from the origin, as it is not made from the origin. So double click on constraint toolbar. I'll give one vertical dimension here as well as one horizontal dimension. So now as we have given the XY values, this rectangle's position is fully constrained. In this way we can define the rectangles if they are not made even from the origin. Next we are going to see here parallelogram. Now in parallelogram, the difference between rectangle and parallelogram is the angle between adjacent sides is not fixed in parallelogram. As in rectangles this angle is 90 degree fixed, but here we can provide any angle we want in between the adjacent sides. So this is the main difference between rectangle and parallelogram. So we will provide here the angle as 100. And next, again horizontal and vertical measure from the origin. Just right click so as to orient it vertically or horizontally options. Next, provide the side dimensions. So I'm not going to give the dimension on directly line. We are going to select the sides. then these two sides. Even then we can see this rectangle is not fully constrained. So the best option to understand why this sketch is not constrained, you just need to click on any point and drag the object or entity, and you can see the movement. If the movement is circular, such as in this case, we can say that rectangle needs to provide angle here. So we are going to provide the angle, making it constrained angularly also. I'm going to say 25 degrees. Now this parallelogram is completely constrained. Next, we'll remove the entities from here. We'll go for the next command, that is slot, also known as elongated hole. So we need to make one line and just drag the mouse. It will be converted into slot. This radius will come by default only. You just need to change the value. We don't need to provide radius for the side arcs. I'll say this radius here as 100. Next, we need to provide the center to center distance also here. So we are going to provide this center to center distance as 600 mm. Now this complete sketch has been fully constrained. Next, we are going to go for cylindrical elongated hole. I'm going to delete this one. And for cylindrical elongated hole, select the option. Select the center point as a first point. Then will be the start point and then will be the end point. You just need to drag the mouse then. And here you need to provide the side radius as it is coming by default. We just need to double click and change the value we require. Next, we are going to go for the radius here. So I'm going to say this radius as 500. Now only these points are remaining to be defined or constrained. We can see this movement. Now to lock this movement for these endpoints, we need to make two lines here. I'm going to select profile toolbar again. Say both these lines, say hold and control. Select this option construction geometry. Now both these lines are being converted to construction geometry by using this sketch tools tab, in which we have this option, that is constrain standard element. Now after making it constrained, as they are not required in geometry, they are just given for providing the angles. So I'm going to provide the angle here. I'm going to say it 45 degrees. And on the other side also I'm going to say the same angle, that is 45 degrees. Now both the lines are being constrained by the angles as they were drawn from the origin only. Now to stop this movement of this slot, we need to select the first endpoint and this line by holding the control key and then providing the relation, say coincide. Same way on the other side also. While selection, we need to hold continuously the control key and then select the objects, then provide the dimensions or relations. The extra thing was these lines. We need to make this line so as to constrain the ends of the slot. Next, we are going to go for the command, that is keyhole slot. Now keyhole slot is similar to slot command only. You just need to click the first end, the second end, and from the second end we can see the whole slot has been coming here. But we have not put off this option, that is construction geometry. That's why this object is also coming in construction geometry only. So we'll make it end the command here by clicking on escape key, put off the construction element off and then go for the command. Select this slot again, start point, end point, and from the end point we can see the first end of this slot, and the second end of this slot will be slightly larger than the first end. You just need to provide the center to center distance. I'll say 650 here. Next, the top side of the radius and the bottom side of the radius, we are going to change the values only. Now these three dimensions were required to constrain the keyhole slot, but still this slot is not constrained. It is because it was not made from origin. So I'm going to provide the dimensions from origin also, horizontal as well as the vertical dimension. Now this slot is completely constrained. So we can see the common pattern here. Whatever sketch you want to constrain, you just need to provide the dimensions of that particular sketch, maybe square, rectangle, slot, circle, and then we need to provide the dimensions from origin also if it is not made from origin. So this is very simple here. You just need to provide the dimensions so as to stop the movement of the part, and it will be completely constrained. Next command we are going to see here is hexagon. Now in hexagon, the other softwares provide number of sides for the hexagon, but in CATIA we can only make 6-sided hexagon. So I'm going to select the hexagon here. We can see by default the sides will come 6. You just need to provide the diameter for the hexagon here. So I'm going to provide the constraint as diameter. You can see the dotted circle with hexagon. I'm going to say this diameter for the circle as 1500. And now you can see this complete hexagon is been defined. Next command we are going to see here is center rectangle. So for center rectangle, select the command, say center rectangle here, provide the dimensions required. So I'm going to select the dimensions and provide the values here. We'll say 2500, and this vertical sides I'll say 2000. Now this rectangle was made from center itself, so it is a symmetric rectangle and it is more useful than the corner rectangle as the sides will come symmetric by default only. Next we are going to go for this command, that is centered parallelogram. Now in centered parallelogram we need to provide two lines first, and the sides of the rectangle will be parallel to these two lines. So we'll make them construction geometry as they are for only reference purpose. Then we are going to go for rectangle. Before that, just put off this option, that is construction geometry, and then go for the rectangle. Select the first line, select the center line, and the intersection of both the lines will be the center for the rectangle. Select both the sides first, then the other two sides, and then also provide the inclination angle. You can use this axis also as to provide the angle. I'll say 45 degrees here. Next, one horizontal and one vertical dimension. Now still this rectangle is not coming constrained. It is because we need to provide the angle between sides also, as it is a kind of parallelogram only. So the adjacent side 90 degrees is not fixed here. You just need to provide the angle and then it will be constrained. I have taken 80 degrees here. So these were the commands related to rectangles here. Now after rectangles we are going to go for circle command. Start with circle. We are going to start it from origin. You just need to provide the dimension here by going on constraint toolbar. We can also provide diameter or radius, whatever we want. We have these options here. I'm going to go for diameter. I'll say 4000 mm. Next circle, I'm going to make it a side only. We'll make it small and give this size as 2000 mm. But this circle is not fully constrained. But we can see here it has taken the relation as coincide. This constraint in green showing as 0 sign, defining it as coincide constraint. So it will not move vertically or horizontally. We just need to provide the dimension from the origin. So as to stop this horizontal movement, I will say it as 5000 mm. And this circle is completely constrained. Again, I will show how this relation has been taken place. You can see the dotted line here. It is passing from both the centers of the two circles. If I make this as a center point, we can see this relation again, it is coming, showing coincide with the origin, making it completely horizontal from this circle. This circle will not move vertically, it will just move horizontal only. Again, provide the dimension. From fully constrained object also you can provide, or from origin also you can provide the dimension. I'll say it as 3000 mm this time. Next, provide the dimension for the circle itself, 2900. Now I'll say this line command as a profile tool. Select this line from here and add this line here. We can see here this tangency relation has been taken place. Here also say control, select both the circle and line, go for the relation as tangency. Next, this line, making this line a circle constraint by going for tangency. Here also again tangency. Next, we are going to trim the extra entities here. Now for trimming we have this operations toolbar, and in operations toolbar in this third number option, that is trim, just click the drop down arrow and you can see the quick trim command here. Just double click on this command and we can see by clicking it, it will get trimmed here. The extra entities will be trimmed. So in this way you can use this trim command also in operations toolbar, and we have this complete profile now. Next we are going to go for this option, that is 3-point circle. First point, second point and third point. The other type of circle we have here is circle using coordinates. So I'm going to select one coordinate here. I've selected this origin only as a coordinate. We can select other coordinates also. Next we need to provide the horizontal and vertical dimensions, and then lastly we need to provide the radius. So here I'm going to say horizontal dimension as 5000 mm, vertical also as 6000, and here the radius I'm going to take is 900. Say enter, and we can see this 5000 and 6000 mm as coordinate dimensions, and the circle is been placed according to this coordinate values with the radius as 900 mm. Next we have this circle, that is circle by using tritangencies. So here we can say this first tangency, this as a second tangency, and this as a third tangency. So now one circle is been made having tangency on all the selected 3 points. So this is tri-tangent circle. You can also make it in rectangles. For example, if I take this corner rectangle here, then go for this tri-tangent circle, first tangency, second and third. We have this tri-tangent circle here. The size of this circle will depend on the width of the rectangles. You just need to quick trim it here, double click and then quick trim for continuous trimming. We have this profile now. Next type of circle we are going to see here is 3-point arc. So in 3-point arc there are two types. First one is this 3-point arc, in which I am going to provide the first point here, the second point in between, and then the third point. Here this arc is by default coming tangency. We can see these two parallel small lines indicating that this relation is tangent. Next, we need to provide tangency on the other side also. So then constraint dialog box we have provided tangency, say OK. Now the other side is also been made tangent. So here the order of this making arc is first point and second point in between only, and then the third point at last on this other circle. Then we need to provide the radius, the dimension for this circle also, making this circle fully constrained from the origin. This complete arc has been now fully defined. Next type of arc is same with the same name, but only difference is the placement of the points. Now this arc name is 3-point arc only, but starting with limits. So here if I go for this arc, I am going to say the first point here. Second point in previous arc was in between, but we are going to provide the second point on the other end of the circle, and the third point will come in between this time. Provide the tangencies on both the sides. Then go for the radius value. I'll say this radius as 8000. Next, provide the dimensions for this point also so as to make it completely constrained. Horizontal and vertical dimensions. Then we need to provide the object dimensions now lastly. And now the sketch is completely constrained. You also have one more option here to edit the dimensions, that is edit multi-constraint. Just click on this option and we can see whatever screen dimensions present are being provided as a list here. We can change any dimension value. So if I want to change this value here, you just need to select the dimension and then we can provide the changed value here in this box. I'll say 25000 and say OK. It will by default get edited here. That is edit multi constraints. Multiple constraints can be edited at one time only. After you select the dimension, it will be highlighted in orange color in this sketch, and then we can change the values here. Say OK. Now the difference between 3-point arc starting with limits and 3-point arc is, here the arc was started from this as a first point, mid as the second point, and third point at the end. And here it is start point here, end point as a second point, and third point is given in between. So this is the main difference here, that the third point is given in between here. Now the last type of arc here is center point arc. So whatever will be the starting point will be the center point for the coming arc. Then second point will be the start point and third point will be the end point. So it is like center point, start point and end point. You just need to provide the radius here. It is over defining, as if the sketch is showing in pink color means it is over defining. It is because it has taken the relation here that is tangent to this circle. That's why it is not getting any more dimensions. If I want to provide the dimensions, we need to select this relation tangency and delete it, and then we can go for the radius again. So I'll say this radius as 10,000. Double click and change the value. Next, we need to provide the end of this points making it constrained. For that again we are going to make this profile lines here to provide the angles and then making this point constraint on these lines. Select both the lines, make them construction. Select both the lines, make them construction geometry. One more line from the center to provide the reference angle dimension. Make it also as constraint geometry. And then go for the angles now. This I'll say 45. The other we are going to say as 35 degrees. Select the endpoint of the arc and line. Say coincide. Same on the other side. And this arc is now fully constrained. So these were the commands we were going to see in day 2. We'll continue with the further commands in day 3. Till then, do like, share and subscribe the channel 4 Dimensions Infotech, and please support us so that we can make more videos on CATIA software and other upcoming softwares. Till then, thank you. So hello everyone, today we are going to start with day 3 of CATIA Sketcher. So starting with the plane, I'm going to select the plane and say sketch. Here we need to select the commands. So we have completed lines, rectangles and circles. Today we are going to see some modification commands from the operations toolbar. So to start with, I'm going to make a rectangle first. I'm going to say center rectangle, provide the dimensions. Just double click on dimensions option or constraint option so we can give continuous dimensions. So I'm going to select both the lines here. I'll say 135. This side distance I'm going to say 220. So we are having one rectangle here, center rectangle, and now we are going to see the command that is fillet and chamfer. So fillet and chamfer, both the commands comes under operations toolbar. We provide fillets to avoid the sharp corners as well as to avoid the stress concentration at single point. So I'm going to provide the fillet here. Select the option. As soon as you select the option, you will get the subtypes here. Whether you want the fillet without corner construction, or you want the first element, or you want both the elements without trimming, or both the elements with trimming, or both the corner elements as a construction lines, or both the corner elements as a construction lines without trim. So all the options are present here. I'm going to select any one option. I'm going to select the second last option here, construction lines with trim. You just need to select both the lines now and provide the fillet. Now provide the value here. I'm going to say the value as 25. We have this value here, the radius, that is 25. Again fillet, but I'm going to say this time standard lines with trim. So select both the lines here and provide the value by double clicking on it. I'll say 20 mm this time. So we can see the difference. Here the corners are there with construction lines, and here the corners are coming with solid lines. So these are all the subtypes of fillet. If you don't want corners, you can go for that also. Select the fillet again and say the first option that trim all elements. Select both the lines here, and here we have the fillet without having any corners. So in this way we can provide the fillets here. I'll say escape to end the command and undo all the things here that we have made. Next we are going to go for chamfer. In chamfer also we have all the same conditions for the corners. Select both the lines, and we have these three options, whether you want the angle and hypotenuse distance, or else you want the double distance, that is first and second length, or else you want angle and first length. So I'm going to go with angle and first length first. Here we have the angle. I'll say this angle as 30 degrees, and the length I'm going to take here is 35. So we have the chamfer here with having the value of angle as 30 degrees and the length as 35. You can see here chamfer means a slanted cut removing the corners. We'll see all the types. We'll select the chamfer again, select the corners, and here I'm going to go with hypotenuse. So you have this hypotenuse length this time, not the horizontal or vertical length. You just need to provide the value for the hypotenuse as well as the angle you require. So I'm going to take this angle as 30 degrees this time. So in this way also we can provide the chamfer. And the last one, select the corner, drag it here. Now see, we have not provided the type of the chamfer required, so it is taking by default as an hypotenuse. So after selecting the corners, just don't click directly. Select the type of chamfer first and then go for the corner treatment. So again chamfer, select the corners and go for the type first. I'm going to say this time first and second length. So we have this length here. I'm going to say this length as 30 and this one as 25. So here we have the chamfers. Next we are going to see trim command. It is actually used for trimming as well as extend also. So we are going to make one line first. I'll make this line straight. Now go for this trim command. Select the line and here I'm going to extend it till the next extension or support. As soon as I keep this finger sign on the support, we can see the finger sign near the cursor. The opposite side of the finger will get trimmed and the side near the finger will be as it is. So if I want, I can do this trim as well as extend both at one command. Now in second scenario, again I will draw one line here. We'll go for the second type in the same command, that is trim. Select the subtype from the sketch tools tab. So all the command subtypes will be coming in sketch tools tab. I'm going to select the second type this time. First we have seen here. Select the line again and just extend it till the support. This time if I click here on the opposite line or support line, the other side will not get trimmed and the line will only be extended this time. So it is only used for extending the lines, the second type. So these were the commands, that is trim. Next option is break. I select this break command. It is used to divide any elements in this sketch. So I'm going to select the line here to divide it, and the first click will be for the selection and second click wherever I click here, this line will be divided at that point. So I've clicked here. So this line is divided in two portions, we can see here. These are the two portions. Line has been divided. We'll see it again. Select the break command. Select the objects you want to break. Then click wherever you want to break this object. And this object will be divided into two parts. We can see here. So in this way we can use break command. It can be used for any other elements also, such as circles or any elements such as ellipse, hexagons and all. Next we have this command, that is quick trim. We have seen already quick trim. It is used to erase the object or trimming the object. Just you need to double click here to continuous trim, and if I select it in one click, that means it is going to trim at once only. Not continuous trimming is possible. If you want continuous trimming, just double click it here and now we can trim it continuously. Any element you can trim here. So in this way we can apply trimming. Next is close arc. So I'll undo this sketch and we'll make one more sketch here. Say escape. I want to zoom in, zoom out. So here we have this tab, that is view tab, in which we have these options, that is zoom in and zoom out. So I'm going to place this tab again here. Select. So this is zooming in, and if I right click on mouse and continuous press the scroll button and then drag the mouse on the table, it is zooming in and zooming out. We can see the double headed arrow. You just need to right click on the mouse and then continuous press the scroll button. You will get this double headed arrow. Just drag the mouse on the table and zoom in, zoom out will take place. This way we can zoom in and zoom out the sketches. I'll take one center point arc here. First point as a center point, then second point and third point. Next we'll go for that command. We have this option, that is close arc. After selecting the close arc, I'm going to select this arc and we can see it is converted into circle. If I provide one fillet also here, I'm going to say fillet, and then if I go for this close arc again, select the arc and it will be converted into a circle. Complete 360-degree circle. If I want to define this circle again, just double click it here. Make this sketch normal first. We have this icon here, we can see in view tab, that is making it normal to. At the bottom side in the center of the screen, we'll select the origin and the center point of the circle, say it vertical dimension first and then go for the horizontal dimension in same way. Same selections and horizontal measure. Provide the radius or diameter, and here we have this sketch completed as a constraint sketch. Next we have this command, that is complement arc. So for complement arc, again I'm going to take one arc here, center point arc only. I'll take the same center as of the circle. We have this arc. We'll provide the radius here. I'll say this radius as 60 and go for this option, that is complement arc. Select the arc and here have the remaining arc. The arc which was present first will be vanished and the portion which was missing will be seen here. This is the option, that is complement arc. Next we have the option, that is mirror entities. So if I want to mirror the entities, I'll make one line here say this as a construction line, provide the dimension or placement. So I'm going to take it at 200 mm from the origin vertically, and then we are going to go for this mirror command. Select the objects you want to mirror, then select the line, and we can see this object has been mirrored at the upper side also. Same way again I'll repeat this. Select the objects to mirror, select the command, and then click on the line, and you will get this object as mirrored object. So in this way we can use this mirror command. Same is the command that is symmetric command. Now in symmetric command, first I'll make one reference line for symmetricity also. It is similar to mirror command only, but only one thing is changed, that the original object will be erased and the copied object at the opposite side of mirroring will be remaining. So I'm going to select this symmetric command here, select the object, select the line, and we can see the original one is been erased and the mirrored object is been shown here. Next command we are going to see here is translate. Now select the entity, put off this duplicate mode and provide one reference point so as to move as a base point, and provide the length you want to move with. So I'm going to say as 500 mm, and we can see this object has been translated from this position to this position at 500 mm. Translate means move command only. We'll repeat it again. Now if I want to translate this object at this side, I'm going to select the object first, go for this translate command. If this duplicate mode is on, put off the duplicate mode, provide the specific base point, and then drag it by providing it with the distance how much you want to move. I'm going to say 300 this time, and this direction at the left side. If I want to take it inclined, we can go for inclinations also, but I'm going to move it linearly. So yeah, it is moved at 300 at the left side. We can use this move command as a pattern command also. For that I'm going to make one rectangle. Now I'm going to select this rectangle, select the translate command. This time we are going to copy this entity, select the entity and put on the duplicate mode. Now if I want total entities to be copied as 6, I'm going to take the number of instances as 5. We have not included this original one. If I include this original one, the total amount will be 6. Just provide the base point and provide the center to center distance. I'm going to take it as 80 mm. And we can see there are total 6 entities. Instances were 5, and including the original one, it is 6 here. So here we have the 6 entities. Again we'll select all the 6 entities, go for translate. I'll put up the number instances as 6, including the original. It will show 7 rows here. We just need to put the center to center distance again. I'm going to say it's 70 mm, and we can see we have made this entities copied and they are looking like a pattern only. So in this way you can use this translate command. Then we have this rotate command here. So for rotating, I'm going to make one rectangle. I'm going to make one corner rectangle here. Go for the rotate command. Select the objects to rotate. Put off the duplicate mode. Select the base point of rotation against which the entity will rotate. Then put off the angle. I'm going to say 45 degrees. And this object has been rotated by 45 degrees here. So in this way we can rotate the entities also here. Next, we can make circular pattern also by using this rotate command. For that I'm going to make some entities first. I'm going to take one circle. I'm going to take one more circle at the quadrant here. After making the circle on the quadrant, we are going to go for rotate command. Select the entities to rotate. Select the center point of this bigger circle and start point. Select the second point as the center point of the second circle that is on this quadrant. Now here we'll put on the duplicate mode and we'll say this entity is at 7. Original will be included and the total entities will be 8. You just need to provide the angle here. We have taken total 8 entities, so I'll say 360 divided by 8. And here we can see these circles are being copied along the circumference of this bigger circle. It seems like circular pattern, but it is not a pattern command. It is rotate command only. We'll undo it again and repeat this command. Select the rotate command. Select the entities to rotate. Select the reference point or starting point. Select the point which will rotate the entities and then put on the duplicate mode. Give the number of instances. We have given it here 7. Original will be included and it will be 8, the total number. Provide the angle as 360 divide by 8. You can see here 360 divide by 8 and then say OK. Next we have this option that is scale command. So here the original scale of any object is 1. If I want to double the scale, we'll take the scale factor as 2. If I want to half the scale, I'm going to take the scale factor as 0.5. If I want to increase the size of the object by 20%, so the scale will be 1.2. If I want to decrease the size by 20%, the scale will be 0.8. So whenever we take the value below 1, the size will be decreased, and above 1, the size will be increased. So I'm going to select this scale command here, select the entities, put off the duplicate mode, select the base point. As soon as you select the base point, scale factor will be activated. I'm going to say the scale factor as 0.5. We can see here the size has been decreased as the scale factor was 0.5. Same we'll do it here also. Say scale, select any one base point, and this time I'm going to increase the scale. I'm going to say 1.5. Here is the scale factor. I'm going to say 1.5. So it is increased by 50% here. Again one more time. This time I'm going to select duplicate mode. Say scale. Say duplicate mode on. Provide the reference point, and here you can provide the scale factor. So I'm going to say the scale factor as 2. So now the objects we have selected will be sized by 2 times. As the duplicate mode was on, original will also be seen here, and the duplicated or scaled one will also be seen here. So in this way we can use this scale command here. And last but very important command, that is offset command. So for offset command, select the entity you want to offset. I'm going to select this line, make it normal first. I'm going to select this line, and here you can provide the distance of the offset. I'm going to say it as 50 mm. And here we can see this line has been made offset. I'll delete this line and again go for offset command. We'll make one entity here. Provide one fillet at any corner. Say this value as 35. Again go for the offset option. Select the second type and click here. We can see, just provide the value. I'm going to say it here as 15 and enter. So here the second option of the offset tangent propagation means it will continue the lines connected with the tangency to offset. Now the third condition of offset, I am going to select the offset command again and go for this third condition. Select one line and we can see this complete entity will be offsetted whether the tangency is provided or not. You just need to provide the offset value. I am going to say 20 mm. So all the chain offset has been taken place here with all the lines. So this was the third option of the offset. And lastly we have offset at bidirectional sides. I'm going to select bidirectional offset, and here I'm going to select the first type, select this line, and we can see this line is getting symmetrically offset on both the sides. We can provide the values later also. Just double click it here. I'll say 15 mm. And here we can see this offset has been occurring at symmetricity. We have selected this line and both the lines are being made offset at both the multi directions. Again offset command, repeat offset, select complete chain selection, go for multi-directional or bidirectional on both the sides, select the entity, and here we can see multi-directional offset has been occurring. Provide the distance of offset here. I'm going to say 10 mm, and here we have made both side offset for this entity. We have seen both the entities are coming as a chain offset here. So this was offset command, and these were the tools we were going to see here today. All were the modification tools. We'll continue with the further lectures. Still the sketcher command, some lectures are remaining. Just follow the playlist and continue learning the CATIA software. Till then, thank you. So hello friends, let's dive to some more tools of CATIA Sketcher. We are at the last stage of CATIA sketching. We have seen almost all the commands. Some of the last commands are remaining. So today we are going to start with that commands. We'll say part, design, and this will be the last lecture for CATIA Sketcher, day 4. Say OK. Now we have this planes. I'm going to select one plane here and say sketch. This is the sketcher tab. Say sketch. We have already seen the operation toolbar here. Only these project entities are remaining now. We'll see that in 3D. Here we have seen the constraint. means how to apply the relations and how to apply the dimensions by using these two commands. We have also seen multi-constraint here. In profile toolbar, we have seen lines, rectangles, circles. Today we are going to start with splines and some more remaining commands. So here I'll start with spline. Spline is a flexible line which can be used as a guide curve or a path. Now as I have clicked here to make this line, wherever I clicked there are some grip points which can be used to stretch the lines and acquire the shape we want. This is the flexible line. We are not going to define this line here. We can adjust it according to the path or guide curve we require. Now one more line I'm going to make here. So whatever clicks I'm going to tick, this will be the grip points. Now we can see these grip points. They are flexible. We have the second type of spline, that is connect line. This is used to connect the two splines together. So here we have seen how these two lines are being connected with a connecting spline. Here also we can do that. And now we can apply the connecting spline here. Say connect, select both the lines, and one connecting line has been applied here. So these are the flexible lines, we can say splines. Select and delete it. After splines we are going to go for ellipse command. So here starting with the center, first point and the last point. Center, first point and last point. So here to define the ellipse we are going to provide the dimensions between side and center. So I'm going to take this half of the major axis as 100. So the total major axis will be 200. The second minor axis we are going to take it here 60. So the total minor axis distance will be 120. It is sometimes difficult to define the ellipse, but we can complete it by applying the relations such as pressing Ctrl and selecting the axis as well as one side of the ellipse. Go here and say horizontal. Say OK. We have selected axis and one side of the ellipse. We have not selected any points here. And we have applied the relation as horizontal. In this way this ellipse has been made. So the unit of measurement for ellipse is major and minor axis. Next we are going to go for line command. It is same as a profile command, but when you start with the line and end at any point, we cannot continue the line. It will only be created for once, and then we have to select the command again if you want to use this command. So this is a regular line. Now we want to provide the relation. I'll select the line, and here we are going to select the constraint dialog box. We'll get all the relations for the lines and all entities here only. So I'm going to say vertical for this line and say horizontal. Here also vertical. We don't have the equal relation here for making the dimensions equal, which we have in other software such as SolidWorks and Solid Edge. So if you want to make these lines equal, provide the dimension for the first line. I'm going to say it 180. Then I'm going to make one construction line here at the end of this line. Then select the construction line and the endpoint of the other line. Provide the relation as coincide. Now as this line and this endpoint of the other line is connected or coincided, in this way only we can make them equal. Next, in lines only we have the second type, that is infinite line. So this infinite line is used to make reference construction lines only. We can see in sketch tools there are subtypes, so we can make these lines vertical, inclined or horizontal. It is by default coming horizontal. I am going to take it vertical line. So here this vertical line is coming, and if I want to make this line at angles, we can go for that also. Select the line, select the subtypes as line through points, and here we can make this line inclined by providing the angle here. So I'm going to take this angle as 135, and this line has been made. So this were the infinite lines. So for the next line we are going to make some entities here. I'm going to make one circle. Now when we are making circle, it is by default taking relation as tangent with this line here. If you want to delete that relation, just select the relation and say delete. We'll make one more circle here. I'm going to select the circle command. One more circle. We provide the dimensions. Say 300 of this circle's diameter, and this diameter we are going to take as 120. We are going to provide center to center distances also here. So for center to center distance, select the center points of the circle and say 300. Next we are going to make one line, say profile line. It will start from one end and end at the other end. But in this case we need to provide tangency by selecting the control key and then going for the relation as tangency in this constraint dialog box. But we can do the same thing by providing the line by the third type, that is by tangent line. So in by tangent line we need to select both the circles, and this line will come by default with tangencies only, connecting it with the circles as tangency. Again, I'm going to delete this one. Go for bar tangent line, select both the circles, and you will get the tangent line with both the sides tangent on the circles. We can make bar tangent line at cross sections also. So I'm going to select this circle here, and the other point I'm going to select at the lower side of the circle. So in this way also you will get the tangent line. Same way, you don't need to apply tangency manually, it will come by default only. Now the next type of line we are going to see here is bisecting line. It is kind of infinite line only. You just need to select two lines and the bisecting line will be created, which will be infinite. Once again, bisecting line, select both the lines, you will get this infinite. Next type we are having here is line normal to curve. You just need to select the curve and one line will be appearing there, which will be at exact perpendicular relation with the circle. We can see here this relation is coming perpendicular with the circle. So this is line normal to curve. You just need to select the curve and the line will come normal or perpendicular to the curve. Next we have the axis. So it can be used as a construction line also. Now the plane is tilted, we can make it normal by using this command in view tab, that is normal to this arrow. And now we can place this point here. So this point is been placed. If you want to define the position of the point, it will be similar to how we define the other sketches, that is by providing horizontal and vertical distances. So I'm going to provide horizontal and vertical distance here. Say right click and say vertical. So now this point is coming or appearing as a green color point, means it is completely constrained. So whatever the sketches which are appearing in green color are been completely defined, and the white color sketches are under constraint or under defined only. So we should define all these sketches and then only go for 3D applications. Next, in point command only we have this point using ordinates. So you just need to select the ordinate and then provide the horizontal and vertical distances in this point definition box. So I'm going to say it 150 as vertical as 100, and we can see one point is been located here with reference to this point which we have taken as an origin here. So this vertical distance is coming 100 and horizontal is coming 150, and this point has been located. Now it is coming underdefined even after providing the dimensions. It is because the reference on which we have taken the origin is also underdefined. Next we have equidistant points. These points can be used for dividing any entity into equal parts. So I'm going to select this circle here. Now it is asking us in how much entities we want to divide this part. So I'm going to take 10 points here, or we can say 15 points we are going to take here and say OK. Now we can see points are appearing equidistantly here. In this way we can provide the points. We can do this for line also. Select this command. Select the line you want to divide in equidistance. I'm going to select this line, and we can see this line has been divided by the points in equidistance in 15 numbers. So this is the equidistant point option. Next one is point at intersections. So if I take one more line here, now I want a point at this intersection of these two lines. So we are going to select this command, that is intersecting point. We'll take this profile toolbar here. So here we are going to select this command intersection point, select both the lines, and at the intersection of both the lines we can see in orange color one point is been appearing here. So if you want to provide points at the intersection of two lines, we can use this command. Lastly we have this command, that is projection of point. For that, first I am going to provide one single point here. We have this point, and now we want the projection of this point on this curve. So we are going to use this command, that is projection of point. Zoom it little bit, select the point and select the curve. So we can see this projection of point has been created normal to the circle. You can see this perpendicular sign. Again one more time, place this point and then go for the option, that is projection of point. Select the point and select the curve. We can see this point is coming normal to the curve now with this sign of perpendicularity. Lastly we have this command, that is fix together. So if I have one line and one circle and if I say fix together to both these entities here, say OK. Now whenever I drag this circle, this line will be moving with the circle. It has been clipped with the circle, or else if I move the line, the circle will move according to the line. Fix together. So these are all the commands which we were going to see today. Now we have completed with this sketcher. We'll make some drawings for practice, and then we are going to move for 3D, and then we are going to move for CATIA 3D. So continue following the sessions and playlist to learn the CATIA. We are going to come with more lectures for CATIA. Till then, tune in and subscribe the channel 4 Dimensions Infotech. Also share this video and comment us below whatever thing which we are remaining or you want us to make the lecture on. Till then, thank you. So after completing the sketching tools, now we are going to start with some exercise. So to start with, I am having this sketch here. We are going to make this exercise for 2D practice. First we need to make a slot here. So we will make this slot first. Say sketch to this plane and select this slot command. Now we need to make this slot symmetric with the axis. Say control press, select both the ends of the line, select the axis line and go for the relation in dialog box symmetric. Provide the center to center distance and radius here. So the radius we are going to take here is radius 3. Say 3. And the center to center distance we are going to take here is, the total distance is given 30. So we are going to minus this radius 3 from both the sides. That is, we need to minus 6 out of this 30. So this dimension will come 24. Say 24. Now this complete sketch has been defined. We are going to hide the planes here. You can see this sketch properly now. This sketch is fully defined. Next we are going to make these circles here. So we are going to make this outer profile first. For that we need to make this circle that is of radius 22. So I'm going to draw one circle having diameter as 44 as the radius was 22. So I'm going to take this diameter as 44. The distance from the slot center till the circle center is given 35. So we'll provide the distance here as 35. Say this as 35. Next we are going to make this outer circle that is radius 12. So for that again one more circle. I'll delete this one. Again move for circle. We are going to take reference for this circle as the center reference of the earlier circle, so that the circle's center points will be coincided together with vertical relation. Next we are going to take this value that is 24 as the radius is given 12. So this value will be 24. Next the center to center distance we are going to take here is 22 plus this 10, that is 32. So distance we are going to take here is 32. We need to take center to center distance, say 32. Next we need to go for this arc now, that is of radius 60. So we are going to select arc by 3 points with the symbol of arrow. Select this arc, say first point and second point on the other circle and this third point. We are going to take it tangent with the circle. The above tangency is by default been taken, that's why we don't need to provide tangency at the upper side. Just go for the dimension now. Say this value as 60. And we can mirror this arc here. So for that we are going to draw one axis line. Then go for the mirror command. Select the arc, select the axis line. And here we have this arc being mirrored here. Next we are going to trim the extra entities remaining. So for that go to operations toolbar, this third tab. Say quick trim, double click on quick trim so as to continue trimming. And here we have this profile been made. Next we are going to go for this connection with this arc that is of radius 10, that is been tangent to this slot above side and to the circle at the bottom side. So again 3-point arc, first point, second point and this third point. Say control press and select both the options. Say tangency here. Provide the radius. So I am going to take this radius here as 10. Now we are going to mirror it again. Again we are going to use mirror command here. Select the arc, select the reference line, and here this profile has been completed now. You just need to trim this area again. Say quick trim and click here. Next we are going to take this circle now with radius of 14. The center of this circle with radius 14 will be same that was of this radius 22. So I am going to take circle command again and say radius as 14 means diameter is going to be 28. So double click here. The diameter we are going to provide here is of 28 here. Next, again one more circle with radius of 5. One more circle. The center to center distance is given here as 22. So I'm going to select the distance here. Say constraint 22. By mistake I have taken 222. So I'm going to edit it. Say 22 again. And the radius will be 5 means diameter is going to be 10. So here the diameter is 10 now. Next, this arc with radius of 32. Again 3-point arc. First point, second point, and this third point. Again tangency for the circle and arc with the radius of 32. So I'm going to provide the radius here. Now it is completely constrained. Then we are going to mirror it. Select the entity to mirror. Select the command. And here we need to go for this line as a reference line. Next we are going to trim the extra entities again. Now we have this entity been completed. So in this way we can make the fully constrained sketches here. All the dimensions and profiles are being completely constrained here. We will continue with the second exercise at the side now. For that we are going to take the reference of this sketch now. So first we are going to draw one circle with radius 44. That will be construction circle. So again one circle with radius as 44 means diameter is going to be 88. As we have not taken it from origin, so we are going to define it from origin by giving horizontal and vertical value. So I'm going to take this horizontal measure as 150 and this vertical measure. So double click on dimension and go for the vertical measure now. We are going to take it as 40. Next, it is construction geometry. So I'm going to select the circle and say in sketch tools as construction geometry. Later put off this option. Next we are going to draw these lines here. So these lines are of total 60 degrees here. Means at one side it is going to be 30-30. So these two lines, two reference lines, both are of construction geometry. One more reference line here. This line for giving the reference angle. So I'm going to take this as 30. And the other side also as 30. Now after taking these lines we are going to draw the internal circles here. Remove this dimension first. We'll keep these dimensions aside. And then now we are going to make this internal circle. So the circle here it is of diameter 50. As we have not put off the construction geometry, it is coming in construction. We are going to put off this option here and then go for the circle. The diameter 50. Double click here and say diameter as 50. Now we are going to go for slot option. We are going to select this cylindrical elongated hole. First we need to provide the center point, then the start point and then the end point. And then drag here for making slot. Now the slot has been made. The radius for this slot is given 9. So I'm going to take this as 9. And here both the arcs we are going to say coincide. After that we are going to make the internal elongated hole. So again select the center point first and then go for the start point and then this end point. Drag this slot here. Now for this the value is given as internal value of radius 5. So we are going to take this value as 5. Now we are going to mirror both the slots. All the entities we need to select first. And we need to make one reference first. So I'm going to take one reference here. Take one line as a reference. Say construction geometry for this reference. Put off the construction geometry and then select the entities again, which we need to mirror. Then go for mirror option, select the line, and here we have the other side slots also. Next, lastly we need to make this arc here with radius 6. So here we are going to take one circle only. We will take this diameter as 12 as the radius is 6. Now we need to make tangency with this slot. So I'm going to select the tangency on both the sides for the circle one by one. We can't make them tangent at a time only, that's why one by one only. Again next we are going to trim the circles here. The extra circle is going to be trimmed. Now we are going to mirror it on the other side. Next we need to trim this area. So we are going to trim this slot. Now if the color is appearing pink, That means it is over defining the drawing. So we'll do one thing, we'll delete this angle here, any one of the angle. Next, we need to trim this area also. Now this complete profile, upper side profile is been made, but here it is showing underdefined. So we are going to make this point coincide on this line so as to stop this movement. Same way on the other side also, select this point and line, go for coincide relation again, but still it is not defining, so we need to provide the radius here. Now it is completely defined. Now to make this arc which we have made earlier also, we can directly mirror it, or else we have one more option, that is using 3-point arc. So this time we are going to draw that arc by using 3-point arc only. So here we have 3-point arc, say first point, say second point, and here third point. Now at the bottom side we need to make them tangent, say tangency, and then select the radius. So I'm going to take this radius as 9, select this size and say radius 9, and then we are going to mirror it again against this line, and you will get the option. Next we are going to trim the extra entities here. For that, select erase command, double click here. Now we are going to trim the extra entities. Double click here so as to continue erasing. So here we have completed this sketch now. We are going to take this radius as not 9, actually this radius is of 6. So here the radius is of 6 only, we have taken 9. Now it is completed. So this were the two sketches we have taken for practice, and here we conclude the sketcher. Now we are going to start with CATIA 3D. Before that, follow the playlist and subscribe the channel 4 Dimensions Infotech, and do continue watching the videos so as to learn the CATIA software. We have also made lectures on SolidWorks and Solid Edge as well as AutoCAD. So if you want to learn AutoCAD, SolidWorks, Solid Edge or else CATIA, you can follow the playlist directly by subscribing the channel. Please share also and make comment on what topic you want to make a lecture. We are going to try for that lectures also. So hello everyone, we are continuing with CATIA lectures and we have almost completed the sketcher. Some 1 or 2 commands are remaining, and then we are going to start with part modeling today. So to start with, I am going to draw one sketch here. Select the plane, say sketch. We are going to draw one rectangle as well as one circle here. We have not defined the sketches here. We'll say just exit workbench. As we say exit workbench, we are out of the sketch. Now we are in the part modeling zone. So after coming in part modeling zone, I want one reference plane. Reference plane means an extra plane except front, top and right. So we are going to take a reference of front plane so as to take a new plane. So I'm going to select this plane option, say this plane as a reference plane, and now we need to put the distance. The type of plane we are taking here is offset from plane. That's why we have selected the front plane here. You just need to put up the distance. So I'm going to take this distance as 600 mm. So now we can see one plane is coming at 600 mm distance. We are going to activate this by saying sketch, fit all in, and now we can see the sketches we have made earlier can be seen in background. We have activated the new plane here which we have taken. We can see it on model tree also, plane 1. Now I want these sketches to be drawn on this plane also. These previous sketches I want to be converted in this active plane. So for that we are having one command here, that is project sketches. Now project sketches is only useful when we have one sketch on another plane and we want the same sketch to be drawn on the new plane also. So for that we can say project sketch. It is used in 3D also. I'm going to select this project sketch here, and we are going to select these rectangle lines, this top line and this second line. Now we can see these two lines are being projected. We'll tilt the plane here. You can see this rectangle, it is being shown here. These two lines are being projected here. If I again continue or double click on this, so these other lines will also be projected. I'm going to click on this circle also. So we can see this circle is also being projected on this new plane. So in this way we can use project entities. Again, if I want one plane here, say exit sketch, go for this plane option from reference element toolbar, select the reference plane and put up the distance we require for the offset. So I'm going to take this time as 300 mm. Select the plane, say sketch. Again, if I want to project this rectangle and circle, just double click on project two entities. Now this project two entities tool come under operations toolbar. So I'm going to select these lines here to be projected for the rectangle then circle. Now we can see this previous sketches are being projected to this new plane also now. So in this way we can use project entities and reference plane. There are multiple ways of taking reference planes. We have seen only one by using offset plane option. We will see the other methods as we proceed in the part modeling. Now we are going to start with extrude boss and extrude cut. These are the first 3D commands which we are going to see here. Say exit sketch. We'll take new file here. Say file, part design. I'll say extrude. Say OK. Now we are in part modeling interface and the toolbar which we are going to see here is sketch base features. In that we are going to see this extrude boss and extrude cut commands. So for that we are going to make some sketches and then going to extrude it. For that we need to make these sketches that are completely closed. If we take open sketches, only thickness will be added. So I'm going to take one closed profile here. I'll say this top plane for the sketch. Take this center rectangle. We have drawn this center rectangle. Just double click and put up the dimensions here. I'm going to say 300 mm. And this vertical dimension we are going to take here as 140. Now one completely constrained sketch is been shown here. We are going to say exit sketch or exit workbench. This is the toolbar for exit workbench. We can see the symbol here, upper red arrow. Just select and say exit workbench. And now we are going to go for this command, that is pad. Select this pad option and we can see this material is been added here. Now we need to put up the length for adding the material. The extrusion height we are going to take here is 60 mm. Now we can see this part has been extruded by 60 mm, means material is been added linearly. Now we can see the edges are not visible. So to display the edges, we have this option here, that is shading with material and view tab. So in this view tab, we are going to select this cylindrical icon here. And we have this multiple ways of showing the part. So I'm going to select this third one, shading with edges without smooth edges. Now we can see the edges are being displayed. Next, if I want to edit the extrusion here, now this extrusion was taken only at one side, the above side. If I double click it here, we have this option that is mirror extent. So whatever dimension we have taken here, that is 60 mm, will be mirrored at the opposite side also. And the total extrusion will be of 120 mm. But if I want 60 mm extrusion only, then we are going to put up this half value here. I'm going to say 30, means 30 above and 30 below side. So the total distance of extrusion will be 60. So whatever extrude you want, if you want it on both the sides and the plane to come at mid side, then put up the half value of the extrusion. The total will come the same as you require. I'm going to say preview and then say OK. Now the 60 mm extrusion is been taken and that is taken from the plane at both the sides. Means plane is coming at the middle and this extrusion is taken symmetrically. So this was pad. Again, if I want to edit this feature, that is pad, just open it in model tree and double click on the feature. We can double click on the part also so as to edit the feature. I'm going to click it in the model tree here. Double click on the feature. This editing option will come again. If I don't want it to be mirrored, if I want in only one direction to be taken, I'm going to say 30 at the first direction, say preview, and then we can click on this option, that is more. And in the second direction, means second limit, we can put up the different value. So I'm going to take 60 mm here. 60 mm, say OK. Now we can see 30 mm it is coming above and 60 mm it is coming below the sketch. So this is non-symmetric extent. Pad has been taken at both the sides non-symmetrically, above 30 and below 60. If I want to reverse the direction, now it is taking below 30 and above 60. So we can go for both the options here, say preview and say OK. We'll take it symmetrically only, for that double click it again. and put up the second limit option, say mirror extend, say preview and OK. Now it is coming 60 mm, is 30 mm above and 30 mm at the lower side. Next, if I want to cut the material here, so I'm going to say pocket. So pocket, we need to draw the sketch first. So I'm going to select the face. Now we can select the face as a plane to draw the sketches. Any flat face can be taken. We'll draw one rectangle here. We are going to position this sketch properly. Make it constrained first and then go for the pocket. So double click. Say 40 as this dimension. Say 60 and this as 50. Now all the values are been put up and the sketch is been shown constrained here. Say exit and go for the pocket option. Pocket means we are going to remove the material linearly. You just need to put up the depth. So I'm going to take this depth here as 60 mm. So the extrusion was of 60 and depth is also of 60. That's why it is coming throughout. I'll double click it here. Instead of 60, I'm going to say 30 mm only. And we can see the cutout is being shown with depth of 30. If I double click on this feature, we can double click it in model tree also. So we can edit it. So in editing again, I'm going to say the limit as up to last. Up to last means through all. Now if I want one plane from this face as a reference plane, go for this option, that is reference element, select the plane option, select the face from which we want the reference plane to be taken and put up the value here. I'm going to say as 90 mm, select the plane, say sketch. Now we are going to draw the sketch on this plane. If I click on this normal view, it will flip the direction of the body. Now we are going to draw the sketch. So I'm going to take center rectangle here, say exit, and now we want to pad this sketch till the surface here. So select the command, that is pad, and this time we are going to take this limit option as up to surface and we are going to select this surface here. So this extrusion is been taken up to surface. Say preview and OK. So this up to surface, we have to show the surface as a limit to be extruded. This option is very useful here. Again, we are going to select this sketch, say circle, say exit sketch, and we are going to say pocket, reverse side. Now in pocket, we are going to select this up to plane option and select the plane here. Select the reference sketch, preview, and we can see here up to this plane. The depth of the cut will be up to plane, as we have taken the first limit option as up to plane. Say OK here. And now if I want to show it in wireframe, just select on this view tab and select the second last option, that is wireframe, and we can say this circular cutout is coming up to plane here, up to this plane. You can see it here, this sketch and the plane. Again we'll change the view style, say as shading with edges. So this was up to plane option. For next we are going to select the plane again and say sketch. We are going to draw one sketch here, say exit, go for pad option again and say up to next. It will by default grasp the next face and extrude it or pad it till the next face. Say OK. So these were the options in pad and pocket. Now we will see the subtypes of pad and pocket, that is multi-pad and multi-pocket. So to start with, I'm going to draw one sketch here, and in this sketch we are going to draw two profiles. First I'm going to take one rectangle, second circle. Make sure these two sketches does not intersect each other, or else the feature multi-pocket or multi-pad will not be applied. So we have these two sketches. Now the speciality of this command is that we can extrude both these sketches at different sizes at one time only. Means if I go for regular pad, say exit sketch and go for regular pad option, select this sketch, both these sketches will be extruded or may apply the pad feature of the same size. But if I go for multi-pad option, that is this option in third number, multi-pad, and select this sketch, now we can apply extrusion or pad size of different for both the sketches. So I'm going to select the extrusion 1. As soon as I click on this option, that particular profile will be shown in blue color here. So I'm going to select this extrusion 1 first. This is that rectangle. Now we are going to say the value for this extrusion. I am going to take it as 60 mm. Select the second. Now this is circle. We can see the blue color has been highlighted on the circle here. We'll select the length for the pad as 120 this time for circle. So we can see here both the sketches can be made pad at different sizes. Say okay. We can also do this for pocket. So for pocket I'm going to make two sketches more here. Say sketch on this face. Select center rectangle. Then select the circle. Say exit. Then go for this pocket option. Multi-pocket. Select the sketch, any one sketch. Now extrusion sizes are available. As soon as you select the first one, it will be highlighted in blue color, showing which profile is been selected. So the rectangle is been selected here. I'm going to select this pocket for rectangle as 20 mm. Second one is circle. I'm going to select as 35 mm. Say preview, and we can see both these pocket shapes have been coming but at different depths. This rectangular pocket is of 20 mm and the circle one is of 35 mm depth. Say it okay. So this way multi-pad and multi-pocket option. I'm going to take new part here. Say okay. Select the sketch. Go for the drawing here. I'm going to take two circles. This first one and this will be second one. Both the circles have been taken concentric, but they are not intersecting each other. You just need to keep that in mind that sketches should not intersect each other. So we'll put up the values here. Say double click on dimension or constraint toolbar. I'll say this as 200 mm. Say OK. And this one we are going to take as 140 mm. I'll say 120 mm only. Next, say exit. And we are going to go for this multi-pad option. Select the sketches. Now it is taking pad only. So we can see here the inner sketch is taken as a cutout and the outer one is taken as an extrude. I'm going to cancel this regular pad option, then go for the multi-pad option here. Now select the sketches. See this first one, we can see the internal circle. I'm going to take the extrusion length as 120. Say preview. I'll increase it more here. I'll say 160. Next, second extrusion, we are going to take it as 30 mm only. Say preview. So we can see one flange type profile has been coming here. This was multi-pad option again. We are not able to see these edges here. So I'm going to select this view option again. Go for this third option, that is shading with edges, and the edges are now visible. Both the circles are being made pad but of different sizes. So this was multi-pad and multi-pocket option here. Now one more type is remaining in pocket and pad, that is draft pad and draft pocket. For that we are going to draw one model here. We'll take center rectangle, put up the values for the rectangles here. I'll say 300 mm. This side as 160. Making the sketch fully constrained, we'll say exit sketch or exit workbench. Next we are going to add the material, say pad. I'm going to say 90 mm. Now on this face we are going to draw one sketch. I'll say center rectangle again. Put up the values, making the sketch constrained. Say 50 and this value as 35. Also at the reference dimension from origin, double click on constraint. Say 70 and now the sketch is completely constrained. Say exit sketch. First we are going to see draft filleted pad, means extrusion will take place. The material will be added here in pad form, as well as the sides will be drafted by some angle and the corners will be filleted. Sharp edges will be filleted by default. So you just need to put up the values there. Select the command draft filleted pad. Now the first limit it is taking as 90. We just need to add the second limit, and the second limit will be the surface from where we have made the sketch. So this will be the second limit. We can see here this pad is been added by 90 mm. Now if I want to make the angle as 5 degrees, we'll put up the value here as 5 degrees here. Say preview. Now we can see here all the corners and sharp edges are been filleted. Lateral radius means the corner radius, that is this vertical corners all, and the first limit radius will be the upper side radius, and the second limit radius will be the lower side radius. Now this draft angle is taking place from upper side, from the limit 1 to the lower side, that is up to limit 2, and the draft direction is coming outside. That's why the faces are being drafted at outer sides. If I want to change the limit, I'll say second limit. You will see the difference here. Now the draft is taking place from the bottom side, that is from limit 2, to the upper side, that is up to limit 1, and the draft angle is taking place on the faces at inwards, at inner sides, from bottom to top at inner sides. If I say first limit, then from top to bottom at outer sides. So in this way you can change this limit here as well as the draft direction. But suppose if I want, instead of inner sides, I want the draft angle to be taken at the outer sides, then you just need to put the minus sign here, say minus 5 degrees. So it is taking minus 5 degrees outside. And now if I go for edit feature again, double click it here. Now it will not show the interface of draft filtered pad, it will show the interface of draft command. So if you want to continue with the same interface that was being shown earlier, then I'll undo it and again go for draft filtered pad. So this is the first limit and this will be the second limit. Say 5 degrees draft preview. Now if I want this draft angle which is coming outer sides from upper limit to lower limit, if I want the draft angle to be shifted at inner sides, again I'll say minus 5 as we have done for the second limit previously. Say minus and say OK. Now it is coming at the inner sides now, draft. So this was the draft filleted pad. Now if I want to change the fillet dimensions again, you just need to click the fillet here, double click on it, and you can see this lateral fillets are being shown, that were vertical fillets. If I want to change the value, I'll say 6, and for the first limit I'll say 3, for the second limit I'll say 2. So in this way you can update the fillet sizes also. Same way we can do it here. I'll double click and instead of minus 5 I'll say 5 degrees only. Same way we can use this draft filleted pocket. You just need to make one sketch. So I'll make one sketch here. Say rectangle again. We can go for any shape. We are taking rectangle here so as to show you the lateral fillets. Say draft filleted pocket. Select. I'm going to say the depth here as 45. Now the depth we have shown as 45 will be the first limit. I'll say instead of 45 I'll say 65. This will be the first limit. And now the second limit will be from where the sketch has been made. The surface on which this sketch has been made will be second limit. Say preview. We can see here this draft filleted pocket is coming here. If I want to change the lateral radiuses, so I'll say this value as 6 degrees. First limit radius I'll say 5 degrees and second limit I'll say 4 degrees. Say preview and this changes. Limit 1 radius will be at bottom side, limit 2 radius will be at upper side. If I want to change and say second limit here, say preview. Now the draft angle will be from outer to inner, and for the first one it will be from inner to outer. So in this way you can apply this draft filleted pocket. Say OK and finish. So these are also type of pad and pocket only. That's why we have seen these types also here. So this was the day 6 starting with 3D. We have seen pad, pocket and subtypes. We'll continue with the upcoming further lectures for CATIA series. So keep continue learning and subscribe the channel 4 Dimensions Infotech. So hello everyone, today we are going to start with next lecture of CATIA series, in which we are going to see shaft command and groove command. Means we are going to make one profile, and we are going to revolve it around the axis, that is revolve boss and revolve cut, and in CATIA they are known as shaft and groove. So to start with, I am going to make one profile here. Select the plane, say sketch. Now I will draw one profile for the shaft. And we'll make it close profile. Next we are going to provide the dimensions. So whatever will be the largest diameter, I'm going to provide as a radius here. So I'm going to take this radius as 100. Next The other radius we are going to take for the other cross section as 80. For the next cross section we are going to take it as 50, and for the last cross section we are going to take it as 25. Next we need to provide the step dimensions. So the first step we are going to take it as 65, next one as 60, other next as 40 mm, and lastly 35 mm. So in this way we have made one closed profile which is completely constrained. Make sure that profile don't have any intersecting sketches such as lines between these 2 points. Sometimes we start drawing these lines also from these points. So make sure that these lines are not coming in between the profile and the profile is completely empty in between. Only one start point, the line will go above, and then it will close the profile at the end only, and then it will get closed. In between sketches are not required. If they have been made, it will cause an error in shaft command. I'll say exit now, as my sketch conditions are completely fulfilled here and sketch is fully constrained. Say exit. Next we are going to go for the shaft command. You just need to select the shaft command. Now it will ask you the angle. So we need to provide the rotational angle for this profile. So I'm going to take it as 360 degrees only. Next it will ask you for the profile selection. So this box will stand for profile selection. I'm going to select the profile. Now this profile is been added here. Next we need to provide axis. So I'm going to provide the axis as this one, this horizontal axis. That's why we have taken these values 80, 50, 25, 100 as a radius values, because they were going to revolve against this axis, this horizontal axis. They will be revolved around 360 degrees here. Say preview and OK. So this multi-step shaft has been created here. Only thing you need to remember is that the plane which is passing through the maximum distance should be selected for revolve cut. So I'm going to select this plane here and say sketch. As this plane was passing through maximum diameter, that's why I've selected this plane here. You can see it was passing through the center and the diameter of this particular bigger cross section. So we have selected the plane, we have set sketch, we'll make it normal too, and then we are going to draw one profile here which we want to revolve cut or groove cut. So I'm taking one corner rectangle. Now the diameter we want after cut will be 180. Earlier this larger diameter was of 200 mm and the required diameter now is 180. So difference is of 20 mm. We are going to provide the depth of cut as 10 mm on one side and 10 mm on other side, making it 20 mm. So the material will less by 20 mm in diameters. For that we are going to provide constraint dimension from axis, horizontal axis to the base of this rectangle. The required diameter here is 180, so I am going to take this value as 90. That is half of the value of the required diameter. Next we also need to provide the side distance. So I am going to take this distance as 4 mm on both sides. So double click and 4, and same on other side. Double click 4. Now we have completed the profile. There is no need to constrain this line here. You can see this line is under constraint. Just make sure that this line is coming above this circular edge. It should not lie below the circular edge, it should be above the circular edge. And therefore only this material will be cut which will come under this profile. The extra material or the extra gap here we can see there is no material and therefore there will be no cut here. Only this material will cut according to the required diameter of the cut. I will correct it to 90 here. We can also provide the opposite side dimension. For example, the earlier diameter was 100, so I'm going to take this one as 10 mm. Instead of giving from bottom side to upper side this 90 mm, I can give from the upper edge to this lower edge 10 mm. For that, we'll delete this dimension and say project to C hotel edges. I'll select this option. Now I've selected this option as project to C hotel edges and not the first option. It is because the upper edge is not flat, it is circular part. So for projecting the circular part edges, we need to select this third option, that is project. Just select the command and click the surface, and these three hotel edges are being projected. We'll make them construction geometry as they are taken only for reference purpose for giving dimension. So instead of giving 90 from bottom side, I am going to provide this dimension as 10 mm from the upper side. Both things can be done. Anyone will be correct. So this depth is coming 10 mm means the remaining is 90. Say exit sketch and go for groove command. Select the groove command, select the profile, provide the cut angle and then go for the axis. So axis, we don't need to make any axis manually. It will be by default taken when you go for the surface. The axis will be displayed here. If the surface is circular, only then. Or else you can select this yellow axis also as an axis for evolution. Say preview and this cut has been made. Now the upper diameter will come 100 and the lower diameter will be 80 mm. As the depth of cut was taken 10 mm on both sides. Now to measure any edges, we can use this command from measure, that is measure item. You just need to select the edge, the diameter or radius will be displayed here. So this radius, the upper one without cut is showing 100 and now with cut, the inner radius, it will come 90. This depth of cut was taken 10 mm. So this was groove command and this was measure command. Next, I am going to make some more profiles for groove. So for that I am going to select the sketch, go for the required profile shapes you want. So instead of rectangular, this time I am going to take circular one. But I need this edge here and this is circular part, so I am going to select the project 3D C hotel edge option. Instead of taking the first option, I am going to go for third option, that is 3D C hotel edges, and select the surface. The surface has been projected and it will be projected not only on the above side but also on the below side. So while projecting, if you want to make them construction geometry, you should keep in mind that both the sides are been made construction. Now both the lines are coming construction here. So we have the reference line here to make this point coincide on this particular edge. Go for coincide relation and now the circle is lying on this line or edge, we can say. Double click here, go for this dimension now. I'm going to give the dimension from center reference to the side. For locating this circle as 25 mm. Provide the diameter for the circle. So I'm going to take this diameter here as 25. And now we have this axis here. You just need to say exit and we can go for revolve or groove cut. But we'll make some more profiles here. So I'm going to select C hotel edges again and select both the surfaces here, making them also projected with the edges. Make sure they are construction geometry first and then only go for making the other profile. So I'm going to take one profile here, this time as elliptical plate, but I have not put off the option of construction geometry. That's why the ellipse is also coming construction mode. So I'll put off the option first and then go for the ellipse command. Select the center point of this line, major and minor axis. So I'm going to provide the dimensions here. We'll take the major axis here as 20. The minor axis I'm going to take 5 and the ellipse is completely constrained now. So we have made two profiles, one circular, one elliptical, and here we are going to make one taper shape. So for taper shapes we are going to take one line. Now we are going to provide the angle for the taper. I'll say this angle as 10 degrees. 10. So these are the profiles been made here. I'm going to close this profile. As for revolve or groove cut, we need the profiles to be completely closed. Then only groove command will be applied here. Next, if I want to make the cut in between also, so I'm going to take one move profile here till the center only. You have to make sure that whatever profile for groove or shaft, the profile must be closed and the entities of drawing must lie at one side of the axis only, not on the other side. So double click here, provide this size here as 10. So at this end the diameter will be 20 and here this profile I am going to say 30. So at this end the diameter will be 60. As this will revolve cut, the values will be doubled here as a diameter. Say exit sketch. So we have multiple profiles this time. We have this circular entity, elliptical entity as well as this taper entity and also this internal cut profile here. We have made already rectangular cut. We would have done all the cuts at same time only, but we have seen this one for the first example, and now we are going to go for the second example of revolve cut or groove cut. Select groove cut option, select the profiles, go for the axis, say preview and say OK. You can see here, I'll make this view oriented as front view. For that we need view toolbar. So in view toolbar we have this option isometric view. So in which we are going to take this front view. So now we can see this normally. This is the rectangular cut been coming. This is circular cut. This was the elliptical cut. This was the taper cut. And the mid profile we have made. At one end it will be 60 diameter. At the other end it will be of different diameter. So we'll measure it. So the radius is coming 10, means diameter is of 20. And on the other side the radius will come 30 as the diameter of 60. So in this way we can use shaft and groove command. You can see at this part. Now if you want to apply the appearance or color here, you can go on this part body, say right click and go for properties, graphics option, in which we have color option. So whatever color I want, I can go for that. I'll select this color, say apply and OK. If I want to apply the color according to faces, then you need to select the face, say right click, go for properties on that particular face only, and you can change the color here for that particular face. So for body if you want, go for this option and say right click, and for faces if you want, then go for this option and then right click for the properties. And if I want to apply color for feature only, not for the face or for complete body, only for one feature, then you need to expand this model tree and select the required feature you want to color. So I'll say this group 1, say right click, go for the properties again and go for the graphics window. So I'm selecting the second groove. I'm going to say purple color here, say apply and OK. Group 1, we can go for properties and we can apply the second color. I said yellow. So this was groove cut 1, this was groove cut 2. And for complete shaft I want the color to be changed. I'll go for properties. For complete shaft I'm going to take orange color here, say apply and OK. So in this way you can apply different colors and see the appearance will be changed. So this was shaft and groove command. Now I'll make one bolt here, say new part. I'll show you how to chamfer or fillet the bolt here by using revolve cut or groove command. By using groove command. So I'm going to select one plane, say sketch, and we are going to draw one rectangle here. Say double click and provide the dimensions required for the rectangle. So whatever shaft diameter for the bolt required will be taken here as the rectangle width. So we are not taking the diameter, actually we are taking the radius here. So if the diameter required for the shaft is 20, so I'm going to take this value as 10 and provide the height for the shaft of the bolt. I'll take this value as 70 mm. Now say exit workbench, and as this profile is completely been made closed, we can go for shaft command. Select the profile first and then go for the axis selection. Say preview and the shaft has been made. Now I'll say sketch to the above surface, flat surface. Say sketch and we are going to make one hexagon here. Provide the dimensions here. We'll take this dimension here as 40. Say exit workbench and go for pad command for making or adding the material. As this is hexagonal shape, it cannot be made by using shaft or groove. So there are two conditions for making groove and shaft, that are the part should be circular in cross section and the orientation of the part should be straight. That time only we can use groove and shaft command. Say OK. We'll increase the size of the length. I'll take this length as 90. Say OK. We'll make this size a little bit smaller. I'll take this value as 18 only. Say OK. You can double click and change the values here. You just need to double click here and change the required value for that particular feature, maybe sketch value or the feature value. Now as we have discussed, for making the profile for groove cut, the plane should be selected which will be passing through maximum distance of the cross section. So this is the hexagonal cross section, and the maximum distance will be between the corners, not between the sides. So I want one plane which is passing through the corners to make the profile for groove cut, and it is compulsory. So you should note it that whatever plane selection for groove cut will be taken at the maximum cross section only. Make sure that. So this will be the plane. Now this plane we can see here, it is passing from the corners here. This particular plane is passing through the corners. No other planes or faces will be valid for groove cut other than this maximum distance crossing plane. I am going to set sketch, and we are going to make the profile, make it normal and go for the profile. Before that I am going to select both these edges and say project two elements, 3D elements. So these edges will be projected as sketches for the reference purpose. Make them construction here, put off the construction. Next we are going to make profile for revolve cut by using 3-point arc. Select first point, the second point and the third point. Now make sure this arc is coming tangent at both the sides. So we need to provide the relation between them as tangency. Here the arc is taken by default tangency, but on the other side we need to provide relation manually only. So for that you can either go for this dialog box, constraint dialog box, by selecting arc and line and then selecting the dialog box and say tangency. You can do this by this way also, and while providing the dimensions also you can provide the relation here. Just select the required entities to provide the relation and then go for right click and say tangents. Then go for the radius. Radius we are going to take care is of 4 size. Double click here and then close for the profile. Here we have the completely closed profile, triangular profile. Lastly, we'll require one axis to groove cut, and we can use this vertical axis here for groove cut. Say exit. We have the profile at cross section that was on the mid plane, which was passing from the maximum distance of cross section. Only that plane will be valid here. Select the groove command, select the profile, select the axis, and we can see here this groove is coming. Say preview and hit. We can see here the sharp corners of the bolt are been removed by using this groove command. So this was the lecture for today, and we need to inform if anyone wants to join the classes 4 dimensions Infotech can contact us. The number for contact will be given in the link below. Till then you can subscribe the channel and follow the playlist of CATIA to learn the CATIA software. So for now, thank you. So hello everyone, today we are going to start with session number 8. We are going to see rip and slot command. These are similar to swept boss and swept cut in SolidWorks. You just need two things, that is one path and one profile. The profile will be swept along the path adding the material to it. Same way, the profile will cut the material along the path in slot. So to start with, I am going to make one profile and path first. Select the plane, say sketch. We are going to make the path first. For that, I'll make one line here. We'll start with line. Then we are going to go for 3-point arc. First point, second point and third point. I'll make this arc tangent to the line. Press Ctrl and select both the entities. Go for the constraint dialog box and say tangency here. Next we are going to add the dimensions. So for that we are going to say this line as 80 mm. This radius we are going to take here as 120, and then we are going to add one more line at the end. That line is also going to be tangent to the arc. Now this complete profile has been made. We need to give the dimension for this line also. Say 80. Now we have one path here having two lines and arc in between. Now I'll say exit sketch. Next we are going to make one profile. So for this we need to take one plane here. We can use this plane also, as this plane is coming perpendicular to this path. We can go for this plane also, or else we can take the plane at the other end also. So I'm going to select this plane option. You need to select the curve first. the option will by default now will be showing as normal to curve. Then you need to select the point at the end of the curve. Now the plane has been applied here. Say OK. So the selections are the guide curve first and then the end point. Plane will by default come normal to the guide curve. Say OK now. Select the plane and say sketch. Now we need to add one profile here. So I'm going to add one circular profile. Whatever profile you want to add, you can add any customized profile, but I'm taking the circular profile here. Select the circle. Put up the value for this circle as diameter 60. Now circle is not completely constrained as the center is offset from guide curve. So we are going to make one relation with guide curve and circle, say coincide here. Now the circle is fully constrained and positioned properly where we require. We'll hide this plane also. Now we have made both profile and path. We'll say exit workbench and now we'll go for this command, that is rip. It is asking for the profile first. The profile has been selected here. Next it will ask you for center curve, so I'm going to select this as a curve. And you can see the material has been added here. And we can see in preview that material has been added along the curve. Say OK. So in this way we can make rip by using one path and profile and adding the material. Next we are going to go for the slot command. It is similar to rip, only the difference will be the material will be removed instead of adding. So I'm going to use the earlier path only. For that I'm going to expand this model tree and will make this sketch which was hide to be shown. Now this sketch is being shown for the path. We'll utilize the earlier path only which we have used for rip command. Next thing we require is profile. So at any one face we can make the profile. So I'm going to say this as a sketch. We'll make one profile here. Profile could be of any shape. So I'm going to take center rectangle this time. We need to provide the dimensions. So I'm going to say double click, constraint, say 25 by 25. Still it is not showing constraint. The center of the rectangle is offset from the guide curve. So we'll make one relation again. Say this as coincide, center of rectangle and guide curve. Now we'll say exit workbench and go for slot command. Select the slot command here. It will ask first for the profile. So I'm going to select this rectangle as a profile and this path will be selected as the guide curve. Say preview and we can see this cut has been made along the path. Say OK. There are more things in this command. For that we are going to make one more model here. Say new part. Say OK. Now I'll make one circular part of cylindrical shape here. We'll make the use of shaft command for that. So I'm going to select the corner rectangle, go for the dimensions and make the sketch constraint. Say I'm going to say 60 and this I'm going to say this height as 150. Next say exit workbench and go for this command, that is shaft. We have seen shaft and groove command in previous lecture. So if you want to learn these commands you can follow the playlist. Select the shaft command. Select the profile required and then select the axis. Say OK. Next I'm going to select the face and say sketch. And for thickness I'm going to cut this part. I'll take this diameter as 100 this time. Say exit sketch and we'll say pocket here. So whatever thickness require you can go for that. I'll say as 146 and say OK. So now this part has been made. We'll go for this mid plane. Say sketch. And we'll make one curve for the handle. So basically I'm going to make one cup type body. We'll take it little bit outside and adjust this spline here. Now we need to take one plane. If you want to position this sketch you can go for the dimensions here. I'm directly going to make the profile by taking the plane now. So for that I'm going to say exit workbench and go for the plane option. Select the reference plane. For that we need to select the guide curve first and then the endpoint. Any endpoint we can select. We'll say this endpoint, say sketch. We'll make one elliptical shape here. Now this ellipse will act as a cross section for this handle. So we have made one path, we are making the cross section for this handle now. Next, we have made the profile as well as the path. I'll say exit. We have not provided dimensions. We are just going to see the feature only directly. But while practicing, you should give dimensions and make the sketch fully constrained and then only go for the features. So I'm going to say exit sketch here. Next, we'll hide this plane. Say right click and hide the plane here. Now I'll go for this rip command. Before applying feature, just notice that we have not connected this guide curve to the part. It will be connected by default from the feature only. That's why we have not connected it here. We'll go for the rip command now. Select the profile and then select the path as a guide curve. Save preview. But we can see here this handle is not been connected to this particular body. For that we have this option, that is merge ribbons. So I'm going to say merge ribbons. Once you say merge ribbons, this will be extended to the next body and this part or handle will be connected to the other body. Say preview, say OK. We can see now one handle type structure has been made here. So in this way also we can connect the ends of the ribs by using merge rib command in feature itself. If you want to provide the appearance for this part, you can go for that also. Select the part body in model tree, right click and say properties and go for this graphics window and you can apply any color you require. Say apply and OK. So after completing this part, you can see this part. Now we'll take one more example for this slot cut. For that I'm going to make one more part here. Say part, say OK, say OK again. Now select the plane for sketch. We'll take one rectangle here. Provide the dimensions required. I'll say it as 80 and this vertical dimension we are going to take here as 120. Say exit sketch and go for pad command. I'll say it as 40 mm. Now I'll make one sketch on this face of this rectangular block. For that I'm going to use again one spline here. So I've made one rough sketch. We'll adjust this point of this line. After making this guide curve as a spline, we'll do one thing more, that we need to coincide this point at this edge. So I'm going to select the point and edge and say the relation as coincide. Now I'll go for the plane. So for taking the plane, we are going to say exit workbench and go for the reference geometry. Select the plane option, select the option that is normal to curve. We need to select the point and curve. Still we can see this plane is coming little bit tilted. So to avoid that, I'm going to double click on this sketch. We'll remove this relation and we'll take it little bit outside only and then go for the plane. Select the plane, select the guide curve and point, and the plane will be taken as perpendicular plane. Now I'll make one profile here. Say sketch to the required plane. I'll take this time one circle only. I'll make the center point of the circle coincide with the path and then provide the radius or diameter required. So I'm going to take this diameter as 10. Still they are not connected, we can see here. So I'm going to select this point and this point again. Go for the relation and now it is properly positioned. Now we have the profile as well as the path. We'll apply the slot cut now. Select the feature from the toolbar as slot. We need to provide the profile first and then go for the center curve. Say preview and say OK. So now we can see here the slot cut has been made. So these were the commands which we are going to see, that is slot and rip. We'll remove the feature from this model tree now, that is slot feature. Say delete. We'll also delete the sketches as we need to go for the next command. So we don't require this one. So the next commands which we are going to see are from the dress up features. So in dress up features there are mostly modification tools only. I'm going to say this fillet command here. So there are different types of fillet which we can see here. I'm going to select the edge fillet. As the name suggests, we are going to select the edge for the reference and we need to provide the radius. We can see this radius also has been shown here. Say preview and say OK. So this particular edge radius has been applied or fillet has been applied. I'll say undo again. We'll see the next type, that is variable size fillet. Variable size fillet means we can take multiple radiuses on one single edge. I'm going to select the edge, and you can see at both the ends there are radius values been coming. So I'll click this first end. The radius is coming here 5. I'm going to say it 15 here. And on the other side I'm going to take it as 35. Say OK. Say preview. Variable size fillet has been applied now. Say undo again. Next we are going to go for caudal fillet. Means we are not going to provide radius here, we are going to provide length. I'm going to select this and say select the edge, and this value has been appearing here. This is not radius, it is actually the length between two endpoints of the fillet. So instead of providing radius, we are going to provide length here for fillet. I'm going to take it as 10 mm. Say OK. Say preview, and we can see here this chord length has been applied. If I want to apply this chord length on the other side also, I'll say it on the other side also, same chord length. Say preview and say OK. So this was the caudal fillet with multiple chord lengths at one edge. Now to confirm what is the radius of this chord fillet, for that we have this option, that is measure. So we are going to search for measure command here. Now toolbar is not available. So for the toolbar we are going to say right click, and we can see this measure toolbar. We'll select this toolbar. Now select this command, that is measure item, and you need to select this edge, and we can see the radius is coming as 7.071 mm. So the chord length was taken 10 mm and the radius by that is coming as 7.071, in which the length is provided and not the radius. Next type of radius we are going to see here is face to face fillet. So for that I'm going to select two faces here having one common edge in between. So for that I'm going to select these two faces, and the radius we need to give the value here. Say preview, say OK. Now this radius has been applied here, you can see. Next we have tri-tangent fillet. For that I'm going to select the radius values and say delete. Say OK again. And now the last option for the fillet, that is tri-tangent. Here we need to select two faces at the end faces. Here we need to select three faces, in which the two faces will be faces to fillet and one middle face will be faces to remove. So in faces to fillet I'm going to select the two sides of this block, and in faces to remove we are going to select this upper face. Say preview and OK. So now we can see this tri-tangent fillet has been applied. We don't require any radius or diameter. The width of the block will by default become the diameter of this particular fillet. Next thing we are going to see here is chamfer command. So for that we are going to delete this tri-tangent fillet. Now chamfer command, there are two ways for making chamfers. First one is by distance and angle method, and second one is by adding two distances. So both these things are here. You just need to select the command first, and we can see the mode option. First one is length and angle. So I'm going to select one length. Say I'm going to say as 10 mm is length, and angle we are going to take here as 30 degrees. Select the edge reference. Now we can see this arrow direction. Now we can see one arrow here. The direction is at vertical face. So the distance is going to be applied on vertical face, and on the horizontal face the angle will be applied for making this chamfer. Say preview. We can see here distance is coming at vertical and horizontal is angle. Say OK. Now if you want to flip the direction and take the distance at horizontal and angle at vertical, we can say reverse for that and say OK. Now the distance will come at horizontal face as arrow direction is showing, and the angle will come on vertical face, that is opposite face. Say preview and OK. This chamfer has been applied. Next we are going to go for this option, that is chamfer, but this time there will be two lengths, length 1 and length 2. So I'm going to select that option. Select the required edge, and the length 1 will come along the arrow direction. It is coming on vertical face this time. If I want to reverse it, we can reverse the direction, put up the values for length 1 and length 2. So we are going to take this length 1 as 25 and length 2 will take this as 60. Say preview, and we can see this length 1 is coming along the arrow direction, that is on horizontal face, the above face, and this length 2 is coming on vertical face opposite to this arrow. Say OK, and this cut has been made, chamfered cut has been made. So this were the options for chamfer. Say OK and finish. We'll continue with the commands in upcoming lectures. So to learn CATIA, you can follow the playlist, subscribe the channel 4 Dimensions Infotech, and if anyone interested to join the course offline or online, you can contact us. The number will be given in the link below. We also provide placements in mechanical design with 100% placement record. You can visit the website 4di.in. Till then, thank you. So hello everyone, today we are going to start with day 9. We have already completed pad, pocket, shaft and groove. We have also completed rib and slot command. Today we are going to see solid combine and stiffener command. So to start with, I am going to start with stiffener command. First we are going to make one base. For that I'll say center rectangle here. Provide the dimensions. I'll say 300. The other value I'll say it as 140. Say exit sketch. Say pad. We'll take it as 20 mm. Say OK. Next we are going to make two conditions here. First we are going to make one straight wall. For that we'll take corner rectangle here. And now we need to make these edges to project to sketch. For that we have the command here. Project 3D elements. Just double click on it. Select both the edges here and say construction geometry for both the edges. These are only for reference purpose. We will get these reference lines here in construction mode. After putting them in construction, put off the construction option. And now I'll say this line coincide with the construction line. This line of rectangle and this construction line as coincide. We'll take them coincide. Same on the other side as coincide. Say OK. Next we are going to go for the side value. So I'm going to take it as 10 mm and the width of this rectangular shape as 23 mm. Say exit sketch and say pad here. We'll say it 100 mm. One more scenario we are going to create here by the cylindrical surface. So I'm going to make one cylindrical shape here. For that I'll say this top face as sketch. Go for the circle and provide the value for this circle now as diameter. So I'm going to take this value as 70 mm diameter. Say exit sketch and go for pad command. I'll say it as 60 mm. Now I'll take this mid plane here for this body. And now we are going to draw one line for this stiffener. So for stiffener we don't require any close sketch. Only one line is enough. But that line should be constrained. We'll take these 2 points and say coincide. Same on the other side as 2 points coincide. Next we need to provide the dimension for the location of endpoint. So I'm going to say it as 55. Now this line is being placed here. Say exit sketch. Now we are having one single line, open sketch, and we'll go for the command that is stiffener. In other design softwares it is called as rib. Here in CATIA we call it as stiffener. Select the stiffener command and select the line. Provide the thickness required. So I'm going to take this thickness here as 8 mm and that too the condition will be neutral fiber. Means 8 mm will be divided on both the sides, 4 mm on one side and 4 mm on the other side. Suppose if I take this value as 10 mm, then this 10 mm will be divided neutrally on both the sides as 5 mm. Say preview and say OK. Now the stiffener has been made here. If I want to edit this feature, I'll just go in model tree here. Select this stiffener and say double click for editing it. Suppose here if I don't want neutral fiber, I want this thickness to be taken at one side only, then I'll put off this option that is neutral fiber. And then you can see here it is coming at the left side. If I want to reverse the direction, it is now totally coming on right side. Again reverse, it will come on left side. So you can switch this thickness left or right according to the profile. Or else if you want it to be divided equally, then you can go for neutral fiber. Now this arrow you can see at downside, it is going to come on downsides. It is because we have the supports on downsides only. If I say it reverse, it will show error here. We can reverse it from this depth option also. We can see here as we say reverse, this arrow is coming upper side, but there is no support to add the material here. That's why this arrow should come at the downside only, as we have these supports here. Say preview and OK. Now this stiffener can be in other shapes also. Suppose if I delete this option stiffener and I'll again go for the sketch here, say sketch to the mid plane or any plane you require, and I'll go for the sketch on the sides now this time. I'll say this right side, say okay. Instead of one line I'm going to take two lines here, but still it is going to be an open sketch only. So we have taken two lines. I'm going to say this endpoint of the line coincide at the feature, and by giving dimensional constraint also we can provide the relations, say coincide here. Same way I'll provide the dimension on this side, say this as 50 mm, and this height we are going to take here as 25, and I'll say this endpoint of this line should be coincided with the upper edge. Select the point and the edge, say right click and go for coincide relation. So instead of dimensioning we can also give relations by using this constraint command. Now say exit sketch and go for the command that is stiffener. Now it is showing an error here. It is because the neutral fiber option has been on, but we have drawn the sketch at the end of this plate. So it is not having support on both the sides. That's why we should off this neutral fiber here. After that we can take it on one side only. I'm taking it on right side. If I say reverse direction, it will again show an error. It is because there is no support for the other side. For that only it is not taking neutral fiber also. See, if we say reverse direction on the left side, there is no support for that. So again we'll say reverse direction only, and now it will come on the right side. Say preview and OK. So by two lines also we can take this stiffener here. I'll delete this one again. This time we'll take plane here. Say reference plane. I'll say 20 mm inside. So I'll say reverse direction and say OK. Say sketch. And now this time for the sketch we are going to take arc instead of line. So for that I'm going to select this circle option and say 3-point arc, starting with limits. First point, second point, and this third point. I'll say this point to be coincide on this corner edge. Say relation as coincide, and then this point to be coincided on the upper edge. Say coincide again. Now here we need to provide the radius value also. For that we are going to take this value as 150. Say OK. Next go for the stiffener command, say exit workbench and select the stiffener. Select the sketch here and we can see here it is coming divided by neutral fiber, say OK. So in this way also you can provide the stiffener in the arc form. Next we are going to go for this option that is for cylindrical shape. Now in case of cylindrical shape there might be some errors. So for that we are going to make one sketch on the mid plane here. Now this sketch should coincide with the cylindrical edge here. So if I want to coincide this point on the cylindrical face, we need to have one sketch here. So to coincide this point on the cylindrical edge, we need to have some reference here. So for that we are going to go and say project two elements again. And this time we are going to select this third option, project 3D see what edges. It is because this feature is cylindrical in shape. That's why we need to select this option, that is third one. And then click on the surface here. You can see here, these two lines are been coming as projected lines. We'll make this line construction, and now we can coincide this point on this line. Say coincide. So this point also coincide on this edge, and now we need to provide the dimension here, and here we'll say 50 mm, and this dimension here we are going to take it as 8 mm. Now we have kept distance of 8 mm. You need to remember this point that we have kept some distance here. Say exit sketch and go for stiffener command. This time there will be no issue for making this stiffener. It is coming by neutral fiber as 10 mm thickness. Say OK and finish. You can see the shape is coming as in arc form, and these two edges are being intersected to body at some upper height than this sketch point. Here the line's end point was here in between, but these 2 points are coming a little bit higher in height because there was a material above side. That's why they are being intersected at some little bit above height. But if I change the condition, suppose if I say delete to the stiffener again go for the same plane as sketch, say project, see what edges, make them construction, and then go for the line command, put up the construction first and then go for the line command. We have made this line, say coincide with the edge, and now put up the value for making it constrain here. I'll say the base I need at 60 mm from the corner of the cylindrical face, and here I'll say exit workbench, and if I say stiffener this time, then you can see here This arrow is coming at downside, still it is showing topological error. It is because this line is intersected at the toppest of the cylindrical body. Now if I go for the neutral fiber lines that are to be intersected by side, adding the thickness, there is no space above and the shape is cylindrical, that's why it will show error here. So to resolve this issue, we can do one thing, that double click on this sketch and add one more line here. Now this adjustment is done in SolidWorks and Solid Edge softwares also. Say exit sketch again, and after adding one line, I'll go for stiffener again, select the line, and now we can see these two side edges are being intersected to the body here. First they were not been intersected as there was no material above, but this time they are being intersected here because of this horizontal line. Say preview and say OK. There will be one small wedge formation, but still there is no other way to make stiffener than this. So we have to make this by adjustment only, by adding one horizontal line if there is a circular edge here. One horizontal line in case of cylindrical body if it is coming from start point. Only then. So after completing the stiffener command, we are going to go for the next type here. First we have seen stiffener and now we are going to see solid combine. So to start with solid combine, the need of solid combine is where when we have two cross sections perpendicular to each other. Means we are going to have two sketches that will be perpendicular to each other by two planes. And both these sketches will be combined together to make one body. That is known as solid combine. So to start with, I am going to make one view on front plane. So start with this front plane here, say sketch. And now we are going to make one profile here. For that we are going to select center rectangle. So I'm going to select a center rectangle. Next we are going to go for dimensioning. Say this dimension here as, I'm going to take it as 280. And this dimension we are going to take it here as 120. So after putting the values, place the values properly so as to understand this sketch here. Next we are going to take one circle here. So on the midpoint. And now we have made one circle. Next we are going to make one slot also here. So for slot, I'm going to select the rectangle command in which we are going to get this option, that is elongated hole. So here the elongated hole will come. This is the elongated hole here, and place the hole at the center here. So I'm going to take one center line. Make this line construction geometry. Only for reference purpose we have made this line. We are going to take this line coincide with the first line, that is rectangle line. We are going to provide the radius now. So the radius we are going to take here is 20, and the center to center distance we are going to go for that. So we'll take the center to center distance as 60 here. Now we'll trim the extra entities which we don't require. So I'll say quick trim. Now this line, it is moving and it is not horizontal, that's why it is moving. So I'm going to provide the relation so as to make it constrained. Next, trim the extra line in between also here. So this line also. We also need to trim the circle here. This line also. Say yes. Now this point, it is moving, so we need to provide the distance again. So the total dimension was 280, so I'm going to take it as 140 as half value. Next we need to say this point coincide with this axis. As we have made trim command, so some references were deleted. That's why we are going to repeat this relations again. The other side value also, make it 140. Now we have this profile here made on front plane. So I'll say exit sketch. So we'll calculate the distance. This is 140. Then this is total as 280. And then the radius we have taken here as 60. So this 280 plus 60 means it is going to be 340 mm. The distance from this quadrant point till the end point, that is 340 mm. Say exit workbench. Now we are going to take perpendicular plane for this second one. So I'm going to select this plane here, that is right plane coming perpendicular to the front plane. Say sketch to this right plane now. Now we are going to make the second profile. For that we are going to take this line, make this end point coincided with this line. Next I'll project this line here for reference purpose. Say project to element in construction mode. Now I'll provide the symmetricity here. Select the two ends of the line and make this two ends symmetric with the center line, projected line. I'll take this value here as 60 mm. Next we are going to continue with this sketch. So we'll continue in this form. So we'll make one profile here by this sketch. Put up the values. So I'm going to take this value as 30. This value coming from this center, I'll take this as 60. And then this last value again as 30. We'll make this line coincide with this sketch. And now we are going to mirror these lines here. First, second, third, fourth and fifth. These lines we are going to mirror it with this axis. Say exit sketch. I'll hide the planes here. And now we can see we are having two profiles. This one is the first profile made on front plane, and this is the second profile made on right plane that was perpendicular to front plane. Now we are going to go for the command that is solid combine. Now for the profile we are going to select the sketch which was made first as a first component. Then for second component we are going to select the second profile and say preview. And we can see we are having this object here. We'll make it normal. You just need to select the orientation as front view. So in front view, the part will appear as the sketch was drawn in front view. And from side view, this part will appear as the sketch was drawn in side view. You can see here. So this was the profile made on right hand side plane. And from front it will look as the profile was made in front view. So this is the command that is solid combine. You can see here. By two sketches combining together we have made this profile. So this was solid combine command. We'll apply the appearance here. Say solid combine. So for appearance we are going to select this part body. Say right click and go for properties, and we can go for graphics window here. Select the required appearance or color type you want. Say apply and close. This is the part being made by using solid combine command. Earlier we have also seen stiffener. So after completing this solid combine we are going to go for the next command, which will come under dress up features. In dress up features we have already seen fillet and chamfer commands. Today we are going to see shell command. So to start with shell command we are going to make one part here. Say part, control new and say part. Provide the name for the part. I am going to say it shell command only. Say OK. And for applying the shell command we are going to make one part which will be in a simple cubical shape. For that we are going to take center rectangle again here. Select the center rectangle. Provide the required dimensions. So I am going to select these two sides. I'll say this value as 300. And here we are going to take this value as 150. Place the dimensions properly. Next we are going to say exit workbench. And we are going to pad this rectangle. I'll say mirror profile on both the sides, so it will come above 40 and below 40. Total extrusion or pad will be of 80 mm. We are going to go for the command in dress up features. But if the command bar is not present, you can click on this empty space, right click and see the toolbar where you can see here dress up features. Just put on the toolbar. So we have this command that is shell command. So in shell command will provide the thickness for hollow part. So the constant thickness for inner sides I am going to take it here as 4 mm. And for outer side thickness I will keep this value as 0 only. So we can provide both inner and outer side thicknesses. Say OK. So now the part is being made hollow. We can see here. As soon as I click on this feature, this inner sides are showing in rectangular edges because the part is being made hollow inside and the material is being removed. Suppose if I double click on it and say faces to remove. Select this face as a removal face and say OK. So now this face has been removed and we can see the common thickness now. The thickness was 4 mm. So from each side the thickness is coming constant, that is 4 mm, even from the bottom side. We can add the thickness at outer sides also. For that I will double click here and say this default outer side thickness also as 4 mm. So now the total thickness is 8 mm. At inner sides it is 4 mm and also at outer side it is coming as 4 mm. So shell command can be applied to the part by adding thickness on both the sides, that is on inner as well as outer sides. Now if I want to remove more faces here, say double click on the feature, faces to remove, I will add this face also and say OK. So this face is also been removed now. Suppose if I want to add some other thickness also on the side, instead of constant thickness, if I want to go and change the thickness of any one face or two faces, we can do that also. Again, double click on the shell command, and here we have the option other thickness faces. So I'm going to select this box here. Click on the face where you want to add the thickness, which is not common. So I'm going to select this face here. Now it is showing two values when you zoom it here, that is inner side thickness as well as outer side thickness. So I'm going to change this value for the outer side thickness, and we'll take this parameter as 15 here. Say OK. Now here the inner side thickness is 4 mm, but the outer side thickness is added as 15 mm. So the total thickness will be 19 mm here. We'll just cross check it. Say measure item, click on the edge, and we can see this value is coming 19. 4 mm inside and 15 mm outside. So multiple thicknesses also can be applied on the faces by using shell command. Same way, if you want to apply the thickness at the inner sides, double click it here, select the element where you want to apply the different thickness, and here we need to add the face at other thickness faces. So I'm going to select this box and then add the face where I want to change the thickness. So the inner thickness here it is coming as, so I'm going to double click here to change the thickness, and inner side thickness I want this time as 8 mm. Say OK now, and we can see here. So here the total thickness is 15 mm at the outer sides and 8 mm at the inner sides. So in this way you can apply the shell command here by using multi thickness also. So these were the commands for today which we were going to see. We have seen stiffener command, solid combine, as well as shell command by using multi thickness and constant thickness. So this was the lecture for today. We'll continue with the upcoming lectures. So if you want to learn CATIA, follow the playlist for CATIA. We have made lectures from Sketcher till this command now. You can also apply for offline courses. The number will be given in the link below. Till then, thank you. So hello everyone. We have completed some of the sketch based features. Still some are remaining, and today we are going to see transformation features. So to start with transformation features, first we are going to see a translation command. So we are having one part here. We'll apply the translation command on this part only. Now translation means moving the part from one place to another. That can be done by using this compass also. You just need to select the part. You can see here this compass is showing now in green color. So if I want to move this part in Y direction, you can see here the Y axis has been highlighted. Here it is written Y. You just need to select that line, and this part will be moved in Y direction. Same thing we can do it by using this vertical axis. So if you want to move this part in Z direction, you just need to select the part again, and then pick and place the compass on that particular selected part, and you can move it on Z direction. Again, take aside and then drop it on the part required, and then move it here. So if I want to rotate it, I'll just keep it aside and then again place it on the part. This compass will be shown in green color. At that time only we can move or rotate the part. So I'm going to select this arc here that can be seen from the top side. You just need to rotate it, and you can see the rotation of the part has been taken place around the Z axis. If I want to rotate it along the X axis or Y axis, you just need to select this other arcs. You can see here, or else this way. So in this way you can use the compass for rotation or translation. But other than compass also there are options given here. So I'm going to select the translation command here. See, when you select this command, it will give a notification that the transformation can be applied by using this compass also. So it will ask you whether still you want to use the command or you can also go for compass. So if I say yes, means I'm going to use the command only. Say yes. And now after clicking on yes, it will ask you the direction where you want to translate this part. So I'm going to select here as Y direction, and I'll put up the value here. The main difference between compass and the command is that we can move it by applying the distances here. So I'm going to take this distance as 100 mm. We can see in Y direction it is moved by 100 mm. So this is Y direction, this is X direction, and this is Z direction. Again, if I go for translate, this notification will appear for compass. Whether you want to use compass or you want to go for command, just say we want to go for command and say yes, and apply the direction. So I'm going to take this time the direction as X, and provide the value here. So the distance we are going to take here is 300 mm. So now it will move in X direction only, and lastly we'll move it in Z direction. So again translate, say yes, show the direction as Z direction, put up the value required. So I'm going to take 300 only. You can see here this demo outline is being shown, notifying that this part is going to move at the above side in Z direction by 300 mm. So I'll say it okay. So now this part has been translated in Z direction. Next command we are going to see here is rotate command or rotation. Select the command. Again this notification will appear asking whether you want to use this compass or you want to go with command. So I'll say I want to go with command. For that just click it here. Yes. Now it will ask you the axis of rotation. So you can use this XYZ axis also, or you can use the edges of the parts also as the axis of direction. So both can be used, whether you want to use the standard axes or you want to use the edges here. So I'm going to say here I want to rotate it around Z axis. Now it will take this Z axis reference from the origin here. You can see. Lastly we need to provide the angle. So we can see here this part is been rotated by the angle along the Z axis. So whatever degrees I want to provide, I can provide that degrees here. I'm going to take it 180 degrees. Now the earlier position for this part was here. It is completely rotated by 180 degrees and been placed here at the opposite side. So in this way you can rotate the part. We'll rotate it again here. Select the rotate command, say yes. Again axis I'm going to take it as Z axis only. Provide the required angle. I'll place it somewhere here. Say okay. And then again translate it. Say yes. I want to translate it in X direction. Put up the value. I'll take this value as 1000 mm. Now if I want to position this part symmetric with reference to this plane, we can do that also. For that use this symmetric command. So for symmetric command I'm going to select here symmetricity. It will again give the notification asking whether you want to use the transformation features only or you can go for compass. So I'm going to say I want to use the transformation feature only. Say yes here, and then you just need to show the plane reference and it will be moved symmetrically on the other side. You can see here. Say okay. So it is kind of mirror command only, but the original object will be removed and the copied object will be shown on the other side. Same way I can do this with this plane also. Say symmetric, say yes, and show the required plane, and this part will be moved on the other side as a mirror part, but the original will be removed. Say okay here. So in this way you can use this symmetric command here. Next command we are going to see here is mirror command. Now this notification will not appear here whether you want to use compass, as mirror command is not dependent on this compass. It is an individual command dependent on plane selection. So you just need to select the plane now after selecting the command. You can see this part has been mirrored on the other side. Say okay. This time the original part has been kept and the mirrored part has been shown on the other side of the plane selection. So this way we can use mirror command. Next command we are going to see here rectangular pattern. For that we are going to make one part. So to start with, say new part. I'll say pattern as the name of the part. Say okay again. Select the top plane, say sketch, go for center rectangle and put up the values after drawing to make it constrained. So we are going to take this side here as 300 mm and the other side we are going to take here as 150 mm. Next, say exit workbench and say pad. So we are going to extrude it by 20 mm only. Say okay. Next thing, we are going to select this plane and we are going to make one more feature for pattern. This was the base part. So I'll make one circle here. Position the circle properly from the sides of the rectangular plate. I'll say this as 25 mm and the y direction I'm going to take again as 25 only. Put up the diameter value. So I'm going to take this value as 15 mm. And now we'll say pad for this feature also. Say exit workbench and go for pad. So I'm going to take it as 40 mm. Now we have this pad feature been applied on this plate. We need to pattern this pillar here in X direction and Y direction. So for pattern feature, rectangular 3D pattern feature, we need to show directions by using the edges here. So if I want to pattern here in this vertical direction or in Y direction, we need an edge reference that is moving in Y direction. And for X direction, we are going to select any edge that is going in X direction. Maybe upper, lower, any edge we can take. On the other side edge also we can take. So we'll start the command here, say rectangular pattern. Now first it will ask you the reference element. So I'm going to select here in reference element and put up the reference as this edge, and we can see the direction it is coming at the downside. So we want to pattern it on the upper side. For that we'll say reverse, and now we can see this pattern is coming on the reverse direction at the upper side. But we can also see this complete part has been patterned. We don't want this part to be patterned, we want only this feature to be patterned. So for that, expand the model tree here at the left side and then select the current solid option. Just click it here in this box. You just need to show which feature you want to pattern. So in objects to pattern, we need to click in this box and go for the feature you want from model tree. Now this feature pad 2 has been selected, which is going to be patterned. You just need to put the instances, how much instances you want in this direction, and what will be the center to center spacing later. So I'm going to say the center to center spacing as 25. Say preview for seeing the demo, and by using 25 we can see here these pillars are being patterned. I want one more entity, so I'll increase the value of instances here. We can see here now the instances are coming 5. And for the second direction also we'll do the same thing. Go for this option, that is this tab beside the first direction, that is second direction. In second direction also, first show the reference element. So I'm going to say this edge as the reference element, and then click on the feature you want to pattern. It is by default taking pad number 2 for pattern, so we don't need to change it here. You just need to increase the instances now. So we can see that instances are being increased on the plate in this horizontal direction this time, that is second direction. The number of instances I am going to take it here as 8, and this center to center distance we are going to take here as 35. Say preview. Earlier in first direction the distance was taken 25, and in the second direction the distance has been taken as 35. We can see both the edit features, first direction and second direction, in same command itself. Say OK, and this pattern has been completed here. Again we'll repeat this. I'll undo it. Hide the planes first. Go for the pattern command. Select the feature you want to require for pattern. Go for objects to pattern and select the feature you want to pattern. Then go for the edge reference. And if you want to flip the direction, then go for this reverse command. The arrow has been flipped. Put up the number of instances you want in the first direction. Then go for second direction. Select the reference edge for the second direction. Change the value of instances for second direction also, and put up the distances for that one also. I'm going to take it as 30 this time. If you want to edit this feature, just double click on the feature in model tree. Second direction, I want to increase the instances. In second direction, I'll take the instances for the rows as 8 rows, and for the columns we are going to go and say 6 only. But the distance, if I want to change, I can change it, say 21, and preview. Say OK and finish. So here the rectangular pattern has been made. Similar thing we can do for the circular pattern. I'll take new part, say part, say OK, and put up the name as circular pattern. Whatever name you are entering here will be shown on the model tree as the name of that particular part. So say OK now. You can see this title as circular pattern. We'll make one circular plate here. I'll take one disc, put up the value for this. So I'm going to take it here as 250 mm. Then we'll say exit and pad. Say OK. Select the face and say the sketch. Now we are going to take 2 lines. We'll make one helical gear profile here. So I'm going to take this line and one more line. Both the lines we are going to say here as construction geometry. This line is taken only for angle reference purpose. That's why we have made this lines construction. So double click here and put up the angle values. Next, we'll say this point coincide with this edge here. Say OK. Now we are going to make one line, one solid line on this construction line of 18 degrees. Put up the construction line option first and then go for the solid line. Take this much line here. Let's put up the value for that line. We'll take this line here as 15 mm in length. Next, we are going to make one more line from the endpoint of the previous line. I'll pass it above this edge, circular edge, and put up the angle value here. So I'm going to take this angle here as 70. Next, we'll select this edge, circular edge, and say project entities. Now I want to make this close profile of this line, the second line, and this arc. Other things we are going to trim here. So in operations toolbar, we'll go and select the quick trim option. So we have this close profile now, this yellow one, this green line. So just trim it here. Next we have this close profile made with this arc and these two lines. Say exit and then go for this cut. So I'm going to cut it here, say pocket and say OK. Now this one cut has been made. We are going to pattern this cut around this circular plate. Select the circular pattern command here. Now in parameters references, we are going to select complete cone so that all the entities are divided in complete 360 degrees. You just need to put up the number. So I'm going to say 10 instances we require here. Then for the reference, we are going to select face here. Now face has been selected and the pattern is being made of this complete current solid. We don't want this pattern to be made of the solid. We want the pattern to be made is of the cutout here. So click on this box, go in model tree and select the thing you want to pattern. So I'm going to select this pocket here and now this pocket has been made pattern. I'll increase the number, I'll say 20 instead of 10. We can see here this pattern has been made. Again, if I want to repeat it, I'll undo it here. So this cut is to be patterned in circular pattern. I'm going to select this circular pattern here. In parameters and instances, we are going to say complete cone, means making the pattern of this cutout equally in 360 degrees. That is complete cone. Put up the number of instances, say 20. Click on this box and select the feature you want to pattern, that is pocket 1. And for the reference, I'm going to select this face here. Say OK. So this pattern is complete now. We can edit this feature. Instead of complete cone, I'm going to take here total angle, instances in total angle, and instead of 360 degrees, I'm going to take this total angle as 180 degrees, and instances we are going to take only 10. Say preview. Now only half portion is been patterned, that is from 0 degrees to 180 degrees, as the total angle was only 180 degrees. If I want to reverse the direction for this cutouts, say preview, this direction has been reversed here. So we have seen the first one and this complete cone. The second option here is given as instances and angular spacing. So here we need to put up the angle between each instance, means from one cutout to the other cutout, the center angle is coming as 20 degrees. So if I want to change this angle, then I will change this angle only. Say I'll say 30 degrees this time, and this total angle will automatically get modified. Say preview. You can see it is coming 270 now, and the angle between each cutout feature is showing as 30 degrees. So in this way also you can pattern it. So these are the multiple options in circular pattern also, which can be applied for patterning any feature in circular manner. Next we have the scale command here. So I'm going to say scaling. Select the reference here. So I'm going to select one vertex point. I'll say this vertex point as the reference point, this one, and I'll say the scale factor as, by default it is coming 1. So I'll change the scale factor and say it as 2. Means the size will be doubled here. And the increase in size is taking place from this initial point, that is fixed point, which was taken as a reference here. Say OK. And now the size has been doubled for this disk here. I'll change the window and go in the first option. Similar thing we can do it for this by using affinity. So the last command here for scaling is affinity. In scaling, the part was being scaled completely in XYZ directions. But in affinity, if I go for affinity and put up this origin as this vertex point, now I can control the ratio of increase and decrease in XYZ directions separately. So if I want to increase the size or double the size in X direction only, I'll say this ratio value for the X as double the scale, that is 2. So we can see here, I'll say OK. So in X direction only it has been doubled here by the size. If I again go for this affinity, double click it here, and if I say in Y direction also I want to double the scale, say OK. Now in X and Y direction the sizes are been doubled for this part. Any features. But again if I want to say edit, I'll double click it on affinity, and in Z direction also I'll increase and say double the size. If I want to increase the height of the part, I'll say triple also. So now this time in Z direction it is multiplying in height by 3 times. Say OK. So in this way FNAD can control the scaling of the object in X, Y and Z directions separately. So this were the commands for transformation features. We'll continue with the upcoming more commands. Still some commands of sketch based features are been remaining, as well as the tracer feature commands are also remaining. So we'll continue these commands in next lectures. One more thing, if you want to join the classes offline for these courses and if you want placement in mechanical design, you can contact us by the number given in the link below. If you want to learn more mechanical software design courses, just follow the playlist and do subscribe the channel 4 Dimensions Infotech. Till then, thank you. So hello everyone, today we are going to continue with the sketch based features, and in sketch based features we are going to continue with the commands multi-section solids. Now to understand multi-section solids, so multi-section solids is required when you need a part which is having 2 or more different cross sections. Means the cross sections are going to be different at different ends. So for multi-section solids, first we are going to make one sketch on right plane. Select the sketch. This is the first sketch we are going to make. So for that I am going to take a center rectangle here. Put up the values for this rectangle. We always need a complete constraint sketch. Save this value as 120. So horizontally you have taken the rectangle as 200 and vertically it is 120. Next, say exit workbench. Now we'll take one reference plane parallel to the right plane. So this is the sketch we have made, this rectangle, and for taking the new plane from the reference of right, we are going to select this toolbar, that is reference element toolbar. You should remember the names. If these toolbars are hidden, then you can find the toolbars by names only. So in reference element, I am going to select this plane option, select the reference for the new plane and put up the value for the parallel plane. So I am going to take it as 200 mm. We'll increase this value. Instead of 200 we are going to take as 500 mm this value, and now we have the parallel plane here. Select this plane and say sketch. Now as soon as we say sketch, this sketch is not coming at the center of the interface. So for that we have this option in view toolbar, that is fit all in. Select this option in yellow color and this sketch will be shown parallel in center of the screen. We'll place it again in this bottom side. Next we are going to draw the second profile here. So earlier we have made this rectangle as a first profile and now we are going to go for second profile. Next we are going to draw second profile here, that is again one center rectangle. We have drawn the first profile in the back side. We can see here this rectangle was the first profile and this new rectangle is the second profile. You can see both the rectangle, this one and this one. So now we can connect them together by using multi-section solid. This time the shapes are same, rectangle, and the other sketch is also rectangle, but the sizes are different. So in this case also we can use multi-section solid. Say exit workbench. We are having the same profile shape and sizes are different in this case. We'll hide the other plane so as to understand these sketches. Say hide. We'll hide this new plane also we have taken. And now we can only see two profiles here. Both the rectangles are being shown clearly now. And we'll select this multi-section solid. In this first tab, here we can see we have to show both the profiles here. So we are going to show both the profiles. Now we can see this closing point option. So for multi-section solid, both the closing points should come on same direction and same corners. Means for the first profile, this closing point is coming at the upper right side. So for the second profile also, this closing point should come at the upper right side only, not on the opposite side. Suppose it is placed on the opposite side, or if you want to replace the closing point, just say right click and click on the other point where you want to replace. The closing point will be shifted on that point. So in this case the multi-section will not work. You also need to keep in mind the arrow directions. One is coming at the left side, the other one should also come on the left side only. If one is coming at the right side, then the other one should also come at the right side only. So if I say the coupling here, Now in coupling option, we need to show how we want to multi-section them by using ratio, tangency, tangency then curvature or vertices. So we are going to say here tangency then curvature or tangency. Now these two options can be taken only when the profiles are of same shape. So here both the shapes are rectangle only, so we can go for this option here. Tangency, we have selected the sketches, we have taken the arrows in same direction, only closing points are not coming at the same points. So here if I say preview, it will show me a twisted profile. We can see here. This is because the closing profiles are at alternate positions. One is at the right side, upper right side, and the other one is at the upper left side. So to resolve this issue or to avoid this twisting, say cancel, again go for multi sections, select both the profiles, make sure both of them are selected here, then just see the closing point are coming at the same corners and the arrows are also at the same direction. Then go for coupling and select any option out of this two, tangency or tangency then curvature, and then lastly say preview. Now we can see this material has been added without having any twisting here. Say OK and finish. So these are the things to remember while going for multi-section solids. Now in second scenario, I'll undo this. Say escape and then undo. Now in second scenario, we are going to change this profile. Instead of rectangle, I'm going to take circle here. So double click here to edit this sketch. Select this sketch and say delete. So at one end it is going to be rectangular shape and at the other end we are going to take a circle here now this time. So we have taken circle. Now earlier both were rectangles and both were having four corners, but this time this is circle, so it is not having any corner here. So to simplify that, we need four vertex points here. And suppose if we don't take four vertex point and say directly exit sketch, and if I try multi-section solid command, so select the profiles and then say coupling, and in coupling I am going to keep tangency then curvature or tangency. Let's say preview now. So you can see in tangency then curvature and tangency this kind of profiles are not accepted. I mean that both the shapes are different, then they are not going to work for these two options, that is tangency and tangency then curvature. But if I go for ratio option here and say preview, you can see here they are connected. Means if the profiles are different at both the ends, then you can go for ratio options. But as this was a circle, there was no vertex point. So this vertex point is taken randomly by system only, and that's why this model is coming twisted. So to avoid this, we need four vertex points. So I'll again cancel it, select the sketch, and we need to provide four vertex points here. So for that, I'm going to select one line command, pass this line through the center here, say control press, both the point and line are selected, go for coincide option, same way on this side also. Now select both the lines here and say construction geometry. As we require this line for only reference purpose, that's why we have taken them as construction lines. Next we need to make this line coincide with the corner rectangles so that the vertex points will match for the proper alignments. So I'm going to select this line and this point here, say coincide. Again for this line and point we are going to say coincide here, say OK. Now these lines have been taken. I'll make this profile normal again. Next we need to go for the option that is quick trim. Select the quick trim command by double click so as to continue quick trim, but select the third type here. For the subtypes, we can see in the sketch tools we have the subtypes at the upper left corner. We are going to select break and keep here. So double click here also and then select the circle. So this circle will be divided in four sections between these lines. This was the first section, we can see it been highlighted in blue color. This will be the second section, this will be the third one. And now we can see all the four sections in blue colors here. Now the circles have been divided. Say this exit workbench and we can see four vertex points here. Now I'll go for multi sections and select the rectangle and circle. Now this arrow direction, we can see this is coming at left side. This arrow is coming a little bit inclined, but it is also coming at left side only. So this is okay for the arrow directions. And the vertex point, both are coming at upper right side, we can see here. So whatever things we need to fulfill are been completed here. You just need to select the coupling for the next option and say tangency then curvature or tangency. But if I say preview, it will show me an error. So if you have taken vertex point, these two options will not work there. We can go for ratio option, but by taking ratio also, this loft will not be completed in proper sharpness. So I'll avoid ratio also and go for this vertices option. This is the best option if you have taken the vertex points. Say preview and say OK. Now this part has been lofted and been added with the material. Now this was multi-section in a simple way, but if I want a guide curve also in between these two profiles, so that the material will be added according to the guide curve, for that I'll undo it again, say escape, and I'll put on these planes here. These were hidden, so I'm going to show these planes, and we need to select this plane here, that is YZ plane. So again I'm going to hide the other two planes. I'll go for this plane for making this new guide curve. Now the reason for taking this YZ plane is this plane is passing through both the profiles. We can see here this plane is coming through both the profiles. So I'm going to select this plane and say sketch. Next thing we are going to go for guide curve. So guide curve can be taken by any option. We can use splines, we can use lines, we can use arcs. Any option can be taken here. So I'm going to select here spline only. Say first point, second, third and this fourth point. Say escape, zoom out here, select this point and this line by holding press Ctrl key and then go for this reference relation as coincide. Here also I am going to make this point coincide with the earlier sketch. Say OK. Now you just need to go for the option that is multi-section solid. Say exit workbench, select the option multi-section solid, select both the profiles here in this area, then go for coupling, and then we need to select the option that is vertices. And next in spine we are going to select this single guide curve. Say preview and say OK. Material has been added. Now after adding material by using spine, but in spine we know that only one guide curve was used. But if we have more than one guide curves, then we can go for other option. We'll see it now. So I'm going to undo it again. And now for guides option, for taking multiple guide curves, we need to make sure that this spine is connected at both the ends properly. So I'm going to double click it here and check it whether it is connected on both the ends properly. So we can see here, this point is properly coincided with the earlier sketch. So it is showing in green color. But at this end, it is not properly connected. For spine it is okay, but for guides we need to connect it properly. So for that I am going to say project sketch here. And we are going to project the upper end of the circle as a line here. Now we can see here, this circle is being projected as a line here. This upper portion of the circle is coming as a line. Just tilt it little bit and then go for the option coincide. Now as there is a line, it will be properly coincided. That's why we have made project entities here, so that we can get a reference for coincide. Say control press, select the point of the arc and the end point of this line also. Both of them are selected, then go for the relation as coincide. So now it is showing in green color, means it is properly connected. Next we need to make one more guide curve. I'll say exit workbench and we'll go for the second sketch. So you have to make sure both the guide curves are coming in both different sketches, not in the same sketch. So again I am going to select the same plane which was taken earlier for this guide. Say sketch for this plane, then go for the second profile. This is another sketch. But still we can see these guide ends are not connected to the profiles. Again we are going to say project entities, go for construction mode and then project. Select both the profiles here. They will appear as lines. Project to the second one also. Both these lines are been appearing now, and then go for the relation here. Say coincide. This is done to make sure that guide curves are connected properly. Both the ends are showing in green color now. So these are the two guide curves we have added here in two different sketches, not in the same sketch, but the plane was same. Say exit workbench now. We'll go for multi sections. This time we are not going to use spine, as there are more than one guide curve. That's why we are not going to use spine here. Select both the profiles. Show the coupling mode here as vertices. Go on this guides option this time. Select the first guide and you need to make sure that you should right click on this option which is selected as sketch 3 and say add here. Then only this guide curve is properly selected. Then go for the second selection. Again repeat the same step. Say right click and say add here, and then go for preview option. And we can see here now this multi section is been added according to guide curve. Both the guide curves are been referenced here. That's why the shape is coming a little bit diverge on both the ends because of this guide curves. Say preview and OK. So this is the multi-section solid using guide curves. So after watching how to add material by using multi-section solids, now we are going to remove the material using remove multi-section solids. So for that we are going to make new part here. Say Control N, say part, say OK. We'll take this right plane again, say sketch. We are going to make one rectangular shape. We need to constrain the sketch first. Next we need to go and say exit workbench. Now we are going to take plane for the second profile parallel to the right plane. So whatever distance you require, you can take the plane there. Say OK. Select this plane, say sketch. This time we are going to take same profiles. We'll center the sketch by using this fit all in command. Next we are going to make the second profile that will be also of same shape, that is rectangle. Say exit workbench. I have not constrained this sketch, but while working you should always constrain this sketch and then work. We'll hide the planes here. We'll hide the new plane also which we have taken. Next we are going to go for multi sections and select the profiles. Say multi-section solid, select both the profiles, add the coupling here as tangency or tangency then curvature. Say preview and OK. Now we need to remove the material. So now for the profile we are going to select this face and say sketch. Make it at the center. Go for the circle option. Select the circle, say double click and diameter. So we are going to say this diameter as 135. Say exit workbench. Next, select this face, say sketch, center the sketch. Here we are going to take circular profile only again, say exit workbench. Now both the profiles are been taken for removing the material. Go for the command remove multi-section solid. Select both the profiles. Make sure the arrows are coming at the same direction. If they are not coming in same direction and they are coming opposite, then just click on any one arrow. Both the directions are now coming same. Say preview, and we can see here this material has been removed. The coupling mode which was used here is then the coupling mode which was used was tangency then curvature. It is because both the profiles were same. So in this way you can remove the material by using multi-section solid. But now if I change the scenario and take the profiles as different, then I'll say cancel, undo this, select both the sketch and say delete, and we'll make two different sketches now. So on the first face I'm going to make rectangle again, center the body, then go for center rectangle, say exit workbench. So on the other end face, select this face and say sketch. Select the circle here. After making both the profiles, say exit workbench again. Now both the profiles are different, but this rectangle is having 4 corner vertex points. So we should add 4 vertex points for the circle also, as we have done in multi-section solid. So we are going to add this vertex point on this sketch also. For that we are going to make lines that are passing through the center, as well as this line should coincide the vertex point of the rectangle. Same on the other side also here. Control press and select say this line and vertex point. Say coincide and say OK again. Make both the lines construction, as they were taken for only reference purpose, that's why I have taken them construction. Say exit workbench, then go for quick trim option and select this third option of quick trim, that is break and keep. So the subtypes for this command are being shown with the status bar here. You just need to select break and keep, and then select the portions of the circle which we need to break here. First, this is the second portion and this one will be the third. So these 3 portions were selected and they can be seen broken here in blue color. So now it is not a combined circle, it has been broken in 4 different parts by the help of this 2 reference line and this command, that is break and keep. Say exit workbench, we can see the 4 vertex points. Now I'll go for multi-section for removing the material. Select both the profiles. We are selecting both the profiles. So for rectangle, it is coming at left side, upper left side. So I'm going to shift this closing point to this circles also upper left side. Say replace, right click and say replace here. Select the point where you want to replace it. Put the arrow direction in same direction. Both of the arrows are coming now at the right sides. Then go for the coupling mode and we'll select vertices here. Tangency and tangency then curvature will not work here. It is because the profile shapes are different this time. Say preview and we can see here this material is being removed smoothly even if the profiles are different by using vertices command. It is same similar to multi-section solid only, but only thing is changed that at that time we were adding material and this time we are removing the material. If you want to remove this material using one single spine, then we can go for that also. You just need to undo it, say cancel and select the plane which is passing through both the profiles from the center. That was this plane. I'll show it here. Now this plane is passing through both the profiles. So I'm going to select this profile for the spine. Spine is nothing but single guide curve. You have seen in multi-section solid. We'll select the spline option to make this spine. Say first point, second point, third point and this fourth point. Now to connect them together properly with the profiles of rectangle and circle at the ends, we'll hide this plane first, make the profile normal and we'll project this sketch of the rectangle. You can see this profile selected in orange color. It is nothing but the rectangle we have selected. We'll say it project. Make this line construction. Now after projecting we can see here this line is appearing in yellow color. So we can make this end of the sketch coincide with this line end. So we are going to select both of them. Say coincide, say OK. At the other end also we need to coincide this end point of this line with this sketch. But for this reference, we'll again say this area as project entities. By keeping normal only we can say. You just need to select this line as appearing for the upper end of the circle. Selected line is shown in orange color. You just need to say project entities. Now the upper end of the circle is projected as line. Say coincide this line end and this line end and say OK again. Next say exit workbench and go for remove multi-sections. In remove multi-sections, select the profiles. Say coupling mode here as vertices. Make sure the arrow directions and corners are coming at same. So we can see closing point is not coming at the same corner. So I'm going to say right click, say replace and replace it on the same corner. Change the arrow direction here. You can see this arrow direction is being changed. Then go for this option as spine. Select this guide curve as a spine. Say preview and say OK. Now this material is removed in the body following the spine. To understand it better, we'll take section view here. So for section view, we have this toolbar here, dynamic sectioning. Select this command. Now we can see this section has been made. It is not coming straight line, it is coming as curve here. If I want to rotate it, so here also you can see, I will take it to 90 degrees and then as this green color arrow appears, you can drag it and see better. So here we can see these curves are coming representing the spine guide curve. To off again, just click on this option dynamic sectioning. The section view will be offed. So in this way we can use remove multi sections also by taking single guide curve as a spine. And now for the second guide curve we are going to take one guide curve here at the other end. So for making second guide curve we are going to take same plane, that was YZ plane, but this sketch will be different. We are not taking both the guide curves in the same sketch as we have done for multi-section adding also. So to add, I'm going to select this spline now. So this is the second guide curve we are adding. Just make sure the ends of the guide curves are connected to the profiles. For that we are going to say project entities again. Select this line to project. Say construction. Select this lower end of the circle also to project as a line. Now we have the construction lines here. Lastly, select both the endpoints of the guide curve and lines. Go for the coincide relation. Say OK. At the other end also, select the endpoint of the guide curve and the endpoint of this line and say coincide. Now there are two guide curves having two different sketch. Just say exit workbench and then go for multi-section removal. Select both the profiles. Go for this coupling option and say vertices. Now the closing points are coming opposite, so I'm going to replace this closing point. Say replace and select this upper left end of the circle. Make sure the arrow directions are coming in the same. So both are coming at the right side now. Say guides this time. Select the first guide. After selection, just right click here and say add. And for the other one also select this guide. Say right click and say add. Now both the guides are added. Make sure the coupling is vertices, say preview, and this material has been cut according to guide curve. To see it properly, we are going to select dynamic sectioning, select this face, and here when this green arrow will appear, you just need to drag it. So we can see here, both the guide curves are utilized this time to make this multi-sectional solid cut. So in this way we can use multi-sections for adding material as well as for removing the material. And this was the lecture for today. We'll continue with the further commands in upcoming lectures. And one more thing here, if any student want to join the classes for offline courses or online courses with 100% placement guarantee, you can contact us in the number given in the link below. Also like, share and subscribe the channel 4 Dimensions Infotech. Till then, thank you. So hello everyone, we are continuing with the CATIA lectures and today we are going to see hole command. So in sketch based features we have this hole command. We'll start with this. For that we have made one part. So there are different type of standard holes that we are going to see here. How to annotate them and how to place them here. So we will select the command here. Select the face where you want to apply the hole. After selecting the face, wherever you click this hole is appearing here. Now we need to specify the diameter. I'm going to say it as 15 mm and the depth we are going to say here as 25 mm. So here the diameter is 15 and depth is coming 25. But we have not positioned the hole yet. So for that we are going to say position sketch. After putting up the diameter and depth, we are going to go for position sketch. And now we need to position the sketch. The sketch will appear in the form of dot here. So we need to put up the values for this. So I'm going to say it 50 mm. Vertically and horizontally we are going to put here the distance as 120 mm. We can see here this green dot. It is fully positioned. That's why the color is looking green here. Say exit sketch. And now say preview. This hole is positioned according to the values. The diameter is coming as 15 and the depth is coming as 25. This is a simple hole. If we go on this type option, you will see the types here. So after putting up the annotation and dimensions, we are going to go for type. So we can see here, this is a simple hole. That's why only depth and diameters are given. Say OK and the hole has been created here. You can see here. But the bottom of this hole is flat. If you want to see it by side view, making it transparent, then you can go in this view tab, shading with edges. Here we can change the appearance of the part. So I'm going to say it transparent here. We'll orient this part, say front view, and now we can see here this hole is flat at the bottom. Suppose if I want V bottom, because standard holes are made by drills, so drill bits are little bit conical in shape, having 120 degrees incline angle. So if I want the bottom to be inclined here, I'll edit the hole feature, say double click on it, and here we have the option bottom. So if I want this bottom to be taken as V bottom, say V bottom, you can see the angle, it is coming as 120 degrees. Say OK, we can see it here. This bottom is coming as V bottom. In this way we can place any hole. There are different types of hole. So we will see them one by one. So to start with, we have taken simple hole. Now we are going to go for the second type. We'll change the appearance again. Go to view tab and say shading with edges without smooth edges. So now to see the next type of hole, select the feature, select the face, and in type option, there are different types. So I'm going to take this time as tapered hole. Tapered means a conical shape hole. We can see here. It will have an angle here. So in extensions, we are going to see the basic depth and basic diameter. So here we can see in this yellow mark also, this basic diameter and depth, it is been shown here. So we are going to take the depth here as 60 mm and the diameter we are going to take here as 20 But for type, in type we are going to give the angle. So right now the angle is coming as 90 degrees total, means from the center it is 45 degrees at one side and 45 degrees at the other side. So if I want to change it, I'm going to say 60 only here, say preview, and we can see the taperedness of this hole is little bit decreased. We will again decrease this value here. I'm going to say it 40 degrees only, means 20 degrees at both the sides. Say preview, and now we have this bottom base diameter as 20, the depth is coming as 60, and the angle is coming as total 40 degrees. That is symmetric angle, means 20 degrees on both the sides. So in this way we can make this tapered hole. Say OK and finish. We can see here, if I want to edit and position it properly, you just need to double click it here, and here we can go for positioning sketch. For position, we are going to set this dimension here as, from horizontal reference we are going to take it as 100 mm, and from vertical reference we are going to take it from bottom edge as 60 mm. Say exit sketch and say OK. So here we have this hole here, tapered hole. Next hole we are going to see here is, select the hole feature, select the face where you want to place the hole. So here are the end conditions also given. I'm going to keep it blind only as we have kept it for earlier holes. Go for type, and this time we are going to select this counter bore hole. In counter bore holes, the bolt are inserted and the bolt head is rested on this face. We can see here there are total 2 depths and 2 diameters given. The first diameter will come in extension. This bottom diameter is shown as 20 here, and the depth, overall depth, is coming as 60 mm. In type we have the other diameter which will accumulate the bolt head. So here this diameter is given 20. So this lower diameter is 10 and the upper diameter is coming as 20. The depth for the head placement is given as 5 mm. We'll go in extension, and here we will decide it whether you want a V bottom or not. If you want flat bottom, you can select the flat bottom option. If you want V bottom, we can go for V bottom. Say preview and OK. So here is the counter bore. This counter bore holes are made only when you need to place the bolt where the bolt head upper face should lie below this surface. Means this bolt will be fully accumulated in this hole only. No projection head will be shown at the upper surface here. So this was the counter bore hole. This time we are going to change the end condition. We'll say up to last. Up to last means through all. The type we are going to see here is counter sunk hole. So in counter sunk hole, there are 3 different conditions been given. So in counter sunk, we will first specify the basic diameter, that is 10 mm, and depth we have not given as we have taken it up to last. Up to last means through all. In type we are going to see other parameters. The type here is showing as counter sunk, and the other parameters are shown in 3 types. First one is depth and angle, second one is depth and diameter, and the third one is angle and diameter. So there are 3 scenarios we can take here. First we'll go on extension again and position the hole here. So we are going to place this hole somewhere here. Say exit, and now the diameter, the outside basic diameter is given as 10 mm. In type, the other parameters we can see. First one is depth and angle. Depth means this depth, we can see in yellow mark, and this total angle, symmetric angle. So depth is taken as 5 and angle is been taken as 40. I am going to say it as 90, means 45 on both the sides. Depth will change and say it as 6 mm. So here the countersunk hole has been placed. Now the parameters were depth and angle. We'll see the second scenario. Again select the hole, place it somewhere here. Type we are going to take again the countersunk only, but this time we are going to change the sub parameters here, that is depth and diameter this time. So I'm going to select depth and diameter. So instead of angle here, diameter is being shown. Depth is coming as 6 and this upper diameter is coming as 22. So this is the depth and this is the upper diameter. The lower diameter in any hole type, it will be shown in extension only. So here the diameter is coming as 8. I'll take it 8 only. And the end condition we have shown here up to last this time also. Say preview. Now this time instead of taking angle and depth, we are taking upper diameter and depth. So this was the second type in countersunk, upper diameter and depth. Say OK and finish. So this is the second type of countersunk. Next type we are going to see again. Say hole, select the position, End condition as up to last. Basic diameter we are going to take as 12. Go to type, and here we are going to say angle and diameter. Means depth will not be shown this time. This angle is been given, and this angle will decide the depth and the upper diameter. So the angle will take this angle as 90 only. The upper diameter we are going to take as 25. Say preview. Say OK. So this countersunk is now been produced by angle and diameter. Depth is not been given here. So this was depth and diameter. This was depth and angle, and this is angle and diameter. So these are the types of countersunk holes. This was counter bore hole. Mostly hexa socket head bolts are being used here. This was taper hole. The last type in hole we are going to see here is counter drill. So for that, in type we are going to say counter drill here. So it is a combination of, we can say, counter bore and counter sunk. First, this straight distance will come here. We can see this distance is coming as 6. So the depth shown as 6. Then the angle shown as 90 degrees, like counter sunk only. And here the upper diameter is shown as 25. The lower diameter and the overall depth will again be shown in extension only. So this is common here. You take any type of hole and the diameter and depth will be shown in extension only. Basic diameter and complete depth will be shown in extension, and according to type the other parameters will be shown here in type only in this parameters section. The values are given here. This is the upper diameter 25, depth is coming 6, and the angle is coming 90 degrees. So if you want to change the overall depth, I'll say blind, and this time we are going to take it as 70 only. And we also see this option V bottom, we are going to add is V bottom only. Say preview and OK. We can see this counter drill has been given. Now we will see the threaded hole. Suppose if I go for hole option again, select the face, and I'll take this type here as simple hole only with diameter of 5 mm and depth we are going to say here as 60. Select the thread definition now, and as we have taken diameter as 5, we are going to go for threaded option. Select the type here as dimension, bottom type. Next we are going to say thread definition. For that, initially it is shown as no standard, but we are going to add the standards here. So I'm going to take metric thick pitch. Size we are going to say here as M6. So according to M6, it is close to 5 diameter now. We can see the pitch also here. So M6, 6 minus 5, the pitch will be by default 5 only. Next, this thread depth, it is shown on the right side. It is coming here as 10. I'm going to say around 50 here. And the hole depth we are going to say 55. 5 mm difference is there in thread depth and in hole depth. Lastly, we need to specify whether it is right hand sided thread or left hand sided thread. I'll say right hand side only. Say preview and OK. But still we can see no threads are being shown here. These threads will be shown in drafting only at last. So the thread display is not been highlighted here. So this was hole command and types of hole we need to see today. So this was hole command. Some dress up features are still remaining here. We are going to continue with them in further lectures. So if anyone wants to join the courses here for mechanical design, we are available with AutoCAD, SolidWorks, CATIA, UGNX, Creo, ANSYS and Solid Edge. So if anyone interested to join these courses for certification as well as for placement, they can contact us in the link below. The number is given in the link. You can contact us directly. So till then, thank you and continue watching the playlist for CATIA to get updated with the upcoming lectures. So hello everyone, we are continuing with the CATIA lectures and we are seeing the remaining commands of dress up features. So earlier we have seen fillet and chamfers. We have also seen shell command. Today we are going to see draft command here. For that we are going to make one part. I'm going to select top plane and say sketch. Select center rectangle here. We are going to make a cubical part here. I'll say 250. We'll take this height as 135. Then we'll say exit workbench and go for pad command. So here we are going to pad it by 50 mm and say mirror extend. Say preview and OK. We'll change the view style here. It is wireframe now. So in view tab, we have the view styles. Currently it is wireframe, we are going to say shading with edges without smooth edges. We'll place the toolbar again at its place. Next we are going to go for draft command. So draft command means we are going to make some faces incline at inner or outer sides. Maybe at inner sides or outer sides. For that we'll need one neutral face. For that we will need neutral face as well as faces to draft. So I'm going to select the command. Here the first type is constant draft. For that we need to specify the angle first. I'm going to say 10 degrees. Then it will ask faces to draft. So I'm going to select the faces which I want to draft or make incline. Next thing is neutral element. So whatever face or plane I am going to select as neutral element, the corners of that face or the edges of the face will act as a hinge. Means if this face or this face is going to draft, it will draft from the bottom side, not from the upper side, as the edges of this face will be hinge edges. So for that I am going to select neutral plane. We are going to select this top plane here. So now you can see this pink colored edges. These are the hinge edges and the draft angle is taking from the bottom side. We can see here this bottom side face will be inclined. This face will be inclined from the bottom side, not from the upper side. So now we'll say preview. So we can see these draft faces are taking angle from the bottom side. The direction of angle is outer side. It is because this arrow we can see here, it is coming at the upper side, means draft is going to be at outer side. Say okay. We'll orient it from the front view. So we can see this angle. This all three edges are straight, horizontal or vertical, but this face has taken angle of 10 degrees. Same way, the other face was this one. So if I say side view, we can see this face. It is inclined. The other faces are not inclined. Means draft has been applied here. If I want to change the direction, I'll just edit this feature by double clicking it. So double click on draft command. And for reversing the direction, I'm going to click on this arrow. Now as this arrow is coming at downside, the angle will be reversed inner sides. So the draft will take at the inner sides and material will be removed this time. Last time it was added. Say preview and we can see here this intersections of planes showing the draft angle or face being drafted at 10 degrees inside. Say okay. Again side view. You can see here last time it was coming outside and this time it is coming at inner sides. Same way on this side, this face is coming at inner sides. So in this way you can apply draft command here. We'll delete this one and see the next type in draft. So for that we are going to select the draft command again. Put up the angle. So I'm going to take this angle here as 15 degrees this time. Faces to draft, I'm going to say this face and this face. Here the neutral element we are going to select this one, and this time we are going to say variable points. It is showing feature definition error because in variable points the multiple faces cannot be selected. So we'll cancel it and select only one face for drafting. For that we are going to go in this elements option, faces to draft, and here I'm going to select this second face, say remove, say close. Now only one face is selected, we can go for variable draft. So as soon as you click on variable draft, first I'll hide this planes here to show you properly. Again we'll go for the command, select draft, select only one face for variable draft, show the neutral face element, and we can see here there are two angles coming at two ends. So first angle is 10 degrees, second one is also of the same value, but we can edit it by double clicking it. So I'm going to say 30 degrees here, say okay. In case I want to add more points here, I'll go on this option in points, two elements. I'm going to click it here somewhere. This the third point has been added, fourth and fifth. So how much points we require, we can add it on this edge. Say close, and we can vary each angle here. So I'm going to vary it. I'll say 20 degrees on the second point, and on the third point we are going to say 15 degrees. Here I'll say 10 degrees, and here I'll say again 15. So we can apply the draft in the form of multiple points on single edge by using these points. Just click on this symbol and you can add the points here. If you want to remove, you can remove the points also. Just click on the point and say remove, it will be removed. Say close, say preview now, say okay. So we can see this face has been applied by variable draft angles. This is the first point, second, third. That's why this face has been shown in a wave form because it is formed by different angles. If I want to change the direction for this variable draft also, just double click it and click on the arrow. So the draft will come inner sides, removing the material. Say preview and OK. So we can see here, due to different angles, the shape is coming as curve. So this was draft angle. Next command we are going to see thickness. For that we are going to select this thickness option and you just need to select the face where you want to add the thickness. So I'm going to select this face here. After selecting the face we can see this value. Just double click it and add the required thickness you want. So I'm going to say 50 mm here or 30 mm. The direction is coming at the outer sides. So the thickness will be added at outer sides. Say OK. And we can see this face is extended here, adding the thickness. Same way we can do it here also. Say thickness, select and put up the value we require. I'm going to say 60 this time. Say OK. But it will show error because as the face was drafted, it will not extrapolate in the same direction following the face shape. That's why this is showing error here. Say no and finish. We'll try this upper face now. Select this face. We'll remove the earlier face. Say close and say OK. So this 60 mm thickness is added at the upper side. We can see here the height has been increased. So whatever thickness you want, you can add it. Suppose if I say shell command and I'll keep the inside thickness as 2 mm constant thickness. Faces to remove, we are going to say this upper face. Say OK. And we can see here this complete body has been hollowed by using shell command. Now if I want to add the thickness here, external thickness, we'll go for the same command again and select this face. And we'll say I want to add the thickness of 10 mm. Say preview, say OK, and we can see this thickness is added. I'll double click it here, and if I want to add more faces, then select this other thickness faces. Select this other thickness faces, click in this box and select the face required to add the other thicknesses. So I'm going to click on this face. We can see this value appearing. Just double click it here. I'll say I want thickness of 5 only, 5 mm only on this side. Say OK. Say OK again, and we can see here the complete part is of 2 mm constant thickness. Earlier the part was of constant thickness, that was of 2 mm, but we have added the external thickness here using this command. This was 10 mm and this one is 5 mm. If I want to add the thickness in inner sides, just click here thickness, select the face, and the thickness will be added at the inner sides. So I'm going to say 10 mm only, say OK, and this thickness is added at the inner sides. Thickness, select this face, 10 mm thickness, as well as we are going to select the other thickness face as this one. This also we need 10 mm. Say OK. So we can see here these thicknesses are being added and the faces are updated with different thickness. So this was thickness command. Now for the next command, we are going to see remove face and replace face. These two options are remaining and the dress up features will be completed. So for that we are going to select this face here, say sketch, and we'll add two different shapes, one circle, one rectangle, and we'll go for multi-pad option. We have seen multi-pad means adding two thicknesses or two pads at same time with different heights. So I'm going to select this multi-pad option, click on this arrow, and here we have the multi-pad. Select the sketches. Now they are showing in green color, but as soon as I click on the extrusion 1, it will be highlighted in blue color here. Just add the extrusion or pad value here. So I'm going to say 50 mm for the rectangle, and then second extrusion, this is circle. So I'm going to add the value as 100 mm. Say preview and say OK. So now we can see two different extrusions taken by the single command, that is multi-pad. Now suppose if I want to level up this face with the circular face, means rectangular face should be added by the material, means this rectangular face should be added by the material and should be leveled up by this circular face. For that we are going to say this replace command here. First we will see replace face. So in replace face we are going to select this circular face, and faces to remove, we'll select the face we want to change. So I'm going to select this faces to remove as this rectangular face and say OK. So now you can see both the faces are coplanar with each other, adding the material. I'll undo it and show it again. We want this rectangular face to be coplanar with this circular face. These two features should be coplanar. So for that we are going to say replacing face. Replacing surface should be taken as circular face, and faces to remove will be taken as this pink one, that is rectangular face. Say OK. Next we have remove face. So remove face we can use it where you have the bounded area, means we can see here this is complete bounded area and there is a depth here. So if I want to remove this depth and I want this face to be leveled up with the upper face by adding the material and removing the depth. So for that we are going to use this remove face. Select this remove face. Faces to remove we are going to say this one, and faces to keep we are going to say this upper face. Faces to keep means leveling face. So the two different colors are designated, means this pink face will be removed and it will be leveled up or coplanar with this upper face, which is shown in sky blue color. Say OK, and we can see here earlier it was shelled and the material now has been added by using this remove face option. We'll undo it and repeat it again. Select the option remove face, select this face, faces to remove, it will be shown in pink color, and faces to keep, this one shown in sky blue color. Say OK, and the material has been added. So in this way you can use these two commands, replace face and remove face. So this were the last two commands, remove face and replace face. Replace face will be used when two extrusions are there and one face is to be coplanar with the other extrusion face. Whereas remove face will be used where the material was removed and to be added again in the same part, and the part should have complete walls on all the sides. Next we are going to see planes here. How to take planes? We have seen planes. Earlier we have used only two ways, by selecting the face and saying offset plane. Means in this way select the face and the offset plane will be created here, applying the distance. So if you want to take any distance you can apply it here, and the parallel plane will be created here by the reference of the selected face. This was the first way. The other way was taking the plane according to the guide curve. For that again select the plane, select the guide curve, select the end point, and this plane will be applied. So this option was known as normal to curve. We have also seen that only two selections are required, that is first guide curve and the end point. Any point we can take and the plane will be perpendicular or normal to that point. Say OK and finish. There are some other ways also to apply this plane. For that we are going to select this plane option. First one was offset from plane. Second we will see parallel through point. We have seen this option earlier. Second one is parallel through point. So I'm going to select one reference and one point. And just we can see here one plane is been appearing. So this was parallel through point. Next one, angle normal to plane. So I'm going to select one rotational axis. So for the axis we are going to select this edge here. Reference selection we are going to take this face, and now we need to give the angle. Say I'll say 45 degrees, and one plane is being created at 45 degrees revolving around this edge as it was shown as an axis. Now the next plane method is through 3 points. So here first point, say this second point, and we are going to select this as the third point. And we can see here one plane has been appearing passing through these 3 points. Means this plane is passing through these 3 points or cross section of this rectangular cube diagonally. So in this way also we can take planes here. Just select the first point was the lower point, then the upper point as second point, and third point as opposite of this edge, that is this point. And this plane will pass diagonally through this cubical shape. Next, again go for the plane option by two lines at the cross sections. So I'm going to select this line as the first line and this second line. So this plane is now appearing passing through these two lines diagonally to this cubical part. So this is the other way. We can use the earlier way also or this one also by two lines. The next type of plane we can take here is through point and line. So for that we are going to select this vertex point, and here we are not going to select the line connected to this point. It will show an error here, we can see. So for that we are going to select the command again through point and line, and this first selection as point will take this vertex point, and this line we are going to take this edge here. This is not connected to the point in any ways. that edge we can select here. So the plane will pass through this point and this edge. We can see this plane now appearing here. This plane passing through this point and this edge. Say OK. So this way the methods we can take different planes here. There are more commands according to the need in part modeling. And now we can conclude that this part modeling chapter is over. And in the further lectures, we are going to start with assemblies now. So for more videos, like, share and subscribe the channel and keep watching the further videos for assembly. If you want to join the classes for mechanical courses, you can contact us by the number given below in the link. We also provide 100% placements in mechanical design field. So anyone can call and join the course according to the packages. Till then, thank you. Hello friends, so in today's lecture we are going to start with CATIA assemblies and we are going to see bottom up assembly. There are two types of assemblies basically. First one is top down and second one is bottom up. So we are going to start with bottom up assembly in which parts are made and saved first and then they are used for making assemblies. So in CATIA we can say an assembly is a collection of individual parts brought together to create a complete product or a mechanism. Each part can be designed separately and then assembled using constraints like coincide, contact, angle or offsets. So assemblies help engineers visualize how parts fit and move together to detect interference and collisions. So let's start with an assembly. We are going to make a press tool assembly today. For that we have made parts already and now we are going to just assemble them together. And now we are going to assemble them together by calling them one by one. So to start with, we have this first toolbar, that is product structure tools. So in product structure tools, we have this fourth option, that is existing component. For calling any part in bottom of assembly, you just need to click on this icon, that is existing component first. So I'm going to click on this icon. Next we need to click on this title of the assembly, that is product. Click on this product option and now we can browse the files. So I'll go to folder where I have saved the files on desktop, teaching data. And here we have the folder for the CATIA assemblies. First part we are going to call here is base plate. So for making press tool assembly, we have the reference of this PDF showing the press tool assembly. So here the parts are bottom plate, guide pillars, then guide bush, and lastly we are going to assemble top plate. So starting with bottom plate, we need to call the base plate or bottom plate first. So let's get started with the option existing component, say product, and browse for the part. So in teaching data, I have kept here the folder. Here is the part base plate. I'm going to say it open. We have made the part first and then saved them. And now we are calling them for assembly. So this is the base plate or bottom plate. As this is the first part, we need to see the directions of motion which are on here. For that we are going to expand the model tree here. For that we are going to click on this base plate, say right click, and below the delete option, there is the option named on part name itself. Just select, expand this arrow, and here we have components degrees of freedom. So it is showing me the degrees of freedom as 6 degrees of freedom, that are 3 rotations and 3 translations in the context of the product. So we need to lock all the degrees of freedom for each part here. That will be the main motive to make a complete constraint assembly. And for constraining these parts, we need to give the mates that are known as constraint here. So for every part which is the first part in assembly, we need to give this constraint, that is fixed component. So I'm going to select this fixed component and click on the part here. You can see the constraint has been applied as the sign is showing here. This part is fixed. Now as this part is fixed, again we'll check the constraints, degrees of freedom. Say right click, go below the delete option, base plate, and then component degrees of freedom. So now it is showing that there is no degree of freedom and the part is fixed. Now this fixed constraint we are going to use only for the base part or the first part which we have called for the assembly. Other parts which are going to be called for making the assembly, we are not going to use fixed component for that parts. That parts will be constrained by using different mates here or different constraints such as coincide, surface contact, offset constraint, angle, perpendicular and parallel. So these are all the constraints which we are going to use further. The toolbar name is constraint toolbar here. We are going to call the next part as this part is fixed and the fixed method will only be used for first part. Just keep this note in mind. Now moving toward the next part, again we are going to select this option, that is existing component. Click on the product title and the next part we are going to call here is guide pillar. Here also we can see this base plate is been called and now guide pillar is to be assembled here. So we are going to call this guide pillar. We can see here this guide pillar is appearing. If I want to move this guide pillar aside, we are going to use this toolbar, that is move. In move toolbar, we have this manipulation command. Select this option and now we can see this dialog box here. Now the first three options X, Y and Z are showing that we can move this part in X, Y and Z direction using this icons here. If I am clicking on this X direction along the X axis, this part will move only along the X axis, plus or minus side both. Then if I select this option Y direction, it will move only in Y direction, not in X or Z. If I use this Z option, drag along the Z axis, then it will be moved along the Z axis only. Same way, if I want to move it along the plane in 2D plane, maybe in XY plane, YZ plane or ZX plane, we can do that also by using this dialog box. So if I say drag along XY plane, means this part is going to be dragged only in X and Y direction. You can see here. So this is the X direction and this is the Y direction. In Z direction we cannot drag it here. If I go for this option, drag along YZ plane, now this time it will be dragged in Y direction as well as in Z direction. In X direction it is not going to be dragged. Same way, if I want to go for this three option, lastly three, that is drag around X axis, means we are going to rotate this part along the X axis, Y axis or Z axis. Or we can select any edge reference also here. So I'm going to select the X axis first. You can see here. Now it is rotating along the X axis. You can refer this axis system here for better understanding. Next we are going to go for Y axis, rotate along Y axis. So now this time this part will rotate along the Y axis. You can see this Y axis here. It is rotating along that axis only. And lastly we have the Z axis. So if I click on this option, it will rotate around the Z axis only. If I want to give the edge reference here, I can select this edge reference also. And now this part will rotate along this edge only. We can see this white line showing the edge reference. So other than the axis system, you can use the references also here. So we are going to keep this part aside by using X movement. Say OK. Now we are going to apply the mate here. First we'll change the appearance or view style. We are going to take the view style here as shading with edges without smooth edges. So these extra edges will not appear here. You can see the difference now. The extra edges which were appearing here are now disappeared. Next we are going to move. Now for assembling this part into this hole, there are some things to be followed while making this part. Means when you are making these 4 holes, they should be compulsorily made by pattern command only. Means this first hole will be extrude cut or pocket and pattern should be made for these holes. This hole should be made separately and not with these holes. So this was the first hole which we have made. For my reference, I always use lower left corner to make the first hole. So I'm sure that I have made this hole first. So I'm going to apply my first guide pillar to the first hole only. And then we are going to pattern this or assemble them by using pattern here for other pillars. Now other than this original hole, these 3 holes, if I have not made them by using pattern command, then assembly pattern can also be not used here. So in assembly, whichever part we are going to assemble here by using pattern command, that is reuse pattern, the related feature should also be made by pattern command only in part modeling, and then only we can make them pattern here in assembly. So it is compulsory for us to use pattern command in part modeling, then only the pattern command in assembly can be used. So I am going to assemble this first pillar into the first hole. Now for assembling them together, the first constraint we are going to use here is coincide constraint. Now coincide constraint is only used when axis to axis are to be matched, means the center of the circular parts will be matched together, or else the flat faces are to be coincide or made coplanar to each other. Only that time this constraint is going to be used. So I'm going to select, if this notification comes here, say do not prompt in future and say close. Now after selecting this coincide constraint and activating it, The axis will be highlighted by default only when you move this cursor towards the guide pillar. So I'm going to select this axis here and the first hole axis. Remember, out of these four holes, the original feature hole, that is the first hole, should be used for making the first guide pillar to be assembled. Other than the first hole, the other three holes should not be used. So the first hole was this one. For making sure, we are going to expand this model here, that is of base plate, and we can see this pocket. This pocket one is this first hole, and this rectangular pattern are the other three holes. So I'm going to assemble the first guide pillar to first hole only. We cannot use the other three holes for assembling the first guide pillar. This point should be noted very clearly, or else there will be errors while using the pattern command in assembly. So I'm going to assemble this with the first hole here. You can see these constraints are being applied, but after applying constraint, we need to use this command, that is update. You can see the icon here. So the part will be at its updated position. You can see here. Next, we need to make this bottom face of guide pillar coincide with the bottom face of this base plate. So for that, again we have said, for flat faces we are going to use first constraint only, that is coincide constraint. So in assembly also, the bottom face of the guide pillar is matched with the bottom face of the base plate. So we are going to apply the mate here, say coincide constraint. Select this flat face. We should select the face only, not the edges, or the different mate will be applied here. Means every selection matters here, whether you are selecting the face or whether you are selecting the edge. So it is very important that you should choose the proper selection. Then we are going to select the flat face here. It will ask you whether you want the orientation of this guide pillar on the same sides of the faces as the reference given, or on the opposite sides. Means this faces, the guide pillar bottom face and the base plate bottom face will be at opposite sides or connected with opposite directions. Whether you want that or you want them to be connected in same direction. So both the options are given. If I select same and say OK and update, you can see both of them are at the same direction, means no part orientation has been flipped here. Go in constraint. If you undo, still the mate remains here. So better, after undoing, you should check the constraint also whether it is undone or not, or else you need to delete it. So I'm going to delete it again and then go for the same mate to show the difference of opposite and same, both the faces, and this time instead of same we are going to select opposite. Say OK, and when we say update, we can see here this guide pillar orientation is being changed at 180 degrees. These two parts are being oppositely connected. So this is the main difference between same and opposite while using coincide constraint. Same thing will be done if I use this surface contact constraint. So I'll undo it again. And as I said, after undoing also you need to delete this coincide constraint and then only it will be vanished here. So if I use this command also, that is contact constraint, the only difference is between these two commands. In this contact constraint, same direction option is not there. Here the part will be connected in opposite phase directions only. So if I select this constraint, that is contact, select the faces here and say update, we can see the faces are connected oppositely, not in the same direction. So here we have same and opposite both, and here we have only opposite connections for the flat faces to be coincided. But we are going to undo it here and going to use coincide constraint with the same direction only. This flat face and this flat face with same direction and say OK and say update. Now this guide pillar is been positioned here. First axis to axis connecting the centers of hole and shaft, and then face to face connecting the bottoms of the two parts. Next, we'll see whether the degrees of freedom for this part are completely locked or not. For that, just right click here, the model tree, on the title name, and here below the delete option, just go here in this arrow option, and here you will get component degrees of freedom. You can see here rotation is still on, and precisely rotation around the Z axis is on. We can see here in model area also, it is highlighted in yellow color that around Z axis this part is rotating. So we need to constrain this rotation also. For that we are going to use this command, that is angle constraint, in which we have three constraints: parallel, perpendicular and angle. So to start with, first select the constraint and we are going to use the references of the planes for the parts. So here for guide pillar these planes are given, and for giving references for constraint we are going to use planes of each part here. So for guide pillar these planes have been highlighted, for bottom plate these planes have been highlighted. So we are going to use guide pillar planes to log the rotation of this guide pillar. So first part which was fixed means this face was also fixed. So I'm going to make this plane parallel to this face, and when the face and plane are being parallel, this rotation of this part will automatically get locked. So we are going to use that constraint. We can also make this plane perpendicular to this face. By that also we can lock the rotation. As the plane will be perpendicular, this part will not be able to rotate due to restriction of the perpendicular mate. And the third option is, if I make this plane angular with this face, by giving specific angle mate or angle constraint also, this plane will be locked and this part will not rotate here. So all the three options can be used. We'll see all of them one by one. So I'm going to select this plane here and this face. You can see this constraint properties highlighting the three mates or three constraints: perpendicular, parallel and angle. So here I'm going to apply the perpendicular first one, making this plane orange colored plane and this face perpendicular. We are using this face because it is fixed, as the part was fixed earlier, that's why. So I'll say update, and after updating we'll see this plane will be perpendicular to this face. Update, and here this plane now is perpendicular to this face. We'll see the degrees of freedom now. Go on guide pillar, right click, select degrees of freedom, and here will show there is no degree of freedom, means this part is completely constrained, having no degrees of freedom. That's what we need here. Say OK and finish. So if I delete the perpendicular, the other option is making this plane parallel to this face. So we'll apply parallel constraint here. Select the plane and face, say them parallel. Here also we have the orientation option, whether you want on the same side as parallel or opposite side. We can choose any one of them. Say OK here and say update to apply the constraint properly. And here we can see in constraint dialog box all the history of the constraint. Here it is showing now parallel mate is been applied. So one more time we'll check the degrees of freedom whether it is locked or not. So degrees of freedom is locked. Here the degrees of freedom will show. Now I'll apply the third option to see how to constrain this part by giving angle constraint. So I'm going to select this plane and this face, and now we are going to go for this angle constraint instead of parallel and perpendicular. We have already seen them. So here the angle we are going to keep is 45 degrees. For angle also there are sectors, means for placing them in each different quadrant. There are total 4 quadrants, so different 4 sectors have been given. According to the quadrant position you can select the sector here. I'm just giving 45 degrees in sector 1. Say OK and say update. So we can see this plane has been inclined by 45 degrees with reference to this face. So in this way we can apply this angle constraints here, having all the three options: parallel, perpendicular and angle. All the three results, this guide pillar will show degrees of freedom are locked. There is no degree of freedom in context with the product. This is the thing we need. Say OK and finish. So the first part was fixed. The second part is also fixed now, but not by applying the fixed constraint, but by using the different constraint mates here. So we need to fix all the parts degrees of freedom by applying different constraints. Only for first part fixed component will be applied, not for the other parts. Other parts will be made constrained by using these 4 commands only. So after making this guide pillar fully constrained, we are going to go for the preuse pattern command now, and we are going to pattern this guide pillar. Then later we are going to call the guide bush, and then we are going to repeat the same thing here. So to start with, we are going to select the reuse pattern command, select the part which we want to pattern, then expand this base plate feature and select the pattern here which we are going to use as a reference pattern for reusing. We are doing 3 selections here. First guide pillar selection, second this rectangular pattern selection, and then thirdly we are going to say generated constraint. So the constraints of this first guide pillar will be followed by the other pillars also. Say apply and OK. Now just for check, I am going to select any guide pillar except the first one to see whether all the guide pillars are fully constrained or not, or fully degrees of freedom are been locked or not. So right click on any pillar except first one, say right click, below delete option, select this option, expand and go to component degrees of freedom. Here we can see it is showing there is no degree of freedom for guide pillar 3. Means all the guide pillars are properly patterned following the constraints. Now the next part we are going to call here is guide bush. So for guide bush, select the existing component, select the title, select the part, say open now, and we are going to manipulate it, taking it into X direction first. So manipulation in X direction, and then we are going to move it little bit upper side, in Z direction also little bit, say OK and finish. Now we are going to position this guide bush on guide pillar. Now one thing very important here, that this guide bush also should have the relation with the hole only, not with the guide pillar axis. So if I give constraint, that is coincide constraint between axis to axis, the axis of guide bush should be selected and the axis of this hole should be selected, not of this guide pillar. It is because if I want to reuse pattern again, I want the relation to be established between guide bush and plate only, not between guide pillar and guide bush. And if there is relation between guide bush and plate, then only I can use this reuse pattern. So for making the coincide constraint with access to axis of guide bush and hole, we need to hide this guide pillar. And if I don't do that, if I directly go for constraint, that is coincide constraint, select the axis of guide bush and select the axis of hole here, then the hole and guide bush axis are showing same as they are collinear. That's why we need to hide this guide pillar first and then go for the relation. So for hiding this guide pillar, I'm just going to right click it here, say hide. So if I hide one guide pillar, all the other guide pillars are also been hidden here. We'll show them later. First we'll maintain the relation between the guide bush axis and hole axis. Now this step is compulsory if you want to apply reuse pattern. And make sure that the guide bush also should be made with the first hole only, not with the other pattern holes. As the guide pillar was constrained with the first hole, same way guide bush should also be made constrained with the first hole only, hiding the guide pillar. Next, select the constraint, coincide constraint, axis of guide bush and axis of this hole. We'll zoom it little bit and then select the axis of the hole. Say update for making it proper position. Now we have the relation between guide bush and the hole. Means we are directly having relation with the plate now, which is necessary for reuse pattern. Then we are going to show the guide pillars here. So in guide pillar 1, expand this and go for this feature that was shaft. Just select and say right click and say show again. All the guide pillars are shown again. Next thing we are going to say offset constraint now. We can see here in assembly, the top face of the guide bush is at the distance from the top face of the guide pillar. We are going to assume this distance. I'm saying this distance here. So this distance we are going to take 20 mm. So this time we are going to use offset constraint. Offset constraint means applying distance between two faces, two planes, two parts, any two flat references. So I'm going to apply the offset constraint here. First reference as the top face of the guide pillar and second reference as the top face of this guide bush. Now as I have selected the first reference of the guide pillar and then the second reference of the guide bush, it is showing the minus sign here with the value. If I want the plus sign, I'll just escape, cancel it, again go for the selections, select the required mate or constraint, then select the face first of guide bush and then of the guide pillar. This distance is going to be shown in plus sign now. So I'm going to set 20 mm distance here on the same side, say OK. Next we need to update it here. Before updating, this value is shown in brown color, you can see here. But when we update, it is shown in green color, highlighting that the constraint has been properly applied by 20 mm. Now as we have applied the constraints, first was axis to axis by the plate hole and guide bush, then distance constraint between the top face of guide bush and top face of the guide pillar. We are going to go for checking the degrees of freedom for this guide bush. So right click on the guide bush in model tree and below delete option, just expand this and go in this arrow. Here the option is component degrees of freedom And we can see 1 degree of freedom is still on, that is rotational movement. It is also been highlighted in yellow color here. So just close it and go for locking this degrees of freedom now. And then we are going to go for pattern. Make sure that before going for pattern, any part should be fully constrained or should not have any degrees of freedom. Then only we are going to go for pattern. If you don't lock the degrees of freedom and directly pattern the part, the degrees of freedom which were unlocked for the one part will be followed in pattern for other parts also. Means all the other parts will also have the same degrees of freedom as the part which we have used for reference of pattern. So we will log the degrees of freedom of this guide bush also. For that I am going to use angle constraint. Now we have two options. Either we can go for parallel constraint between this side face of the plate and this plane of the guide bush, making them parallel, or else we can go for making the guide bush plane, this plane, parallel with the guide pillar plane. So both things we can do here. I'm going to say parallel between the guide bush plane and this guide pillar plane. So select the guide bush plane here and the guide pillar plane for the reference. Go for parallel constraint at the same side, say OK and update. After updating, this plane will be inclined and parallel to the guide pillar plane. We can see here it is inclined now. Now all the degrees of freedom are locked. We can see here there is no degree of freedom. Now we can go for reuse pattern again. So again expand the base plate here for the reference of pattern selection, as the pattern was given in base plate. That's why we are going to expand it first. Then go for reuse pattern. Select the part or component you want to pattern. Select the reference of pattern from the model tree. And then third step is to generate constraints. Means the constraints of the first guide bush will be followed to the other guide bush also, making them fully defined or fully constrained. Say apply and OK. We'll delete this assembly feature, the second rectangular pattern. All the history of the assembly features will be shown in the assembly features tab. So we are going to delete this second pattern again. Just for repeating it, we will repeat the reuse pattern. First expand the model tree and base plate options where we have the rectangular pattern feature. Then go for reuse pattern command. First step is to select component. Second step is to select rectangular pattern. And the third step that is compulsory is to select the generated constraint and then say apply and OK. So here this guide bush are also been patterned now, except first one. I can see any one of them, second, third or fourth. Just say right click, go for degrees of freedom to check, and here it will show there is no degree of freedom in the context of product 2. Means this complete part are been patterned as well as constrained now. Now I'll go for the last part of the assembly. Now for calling the last part, we are going to use existing component option, or else we can go for the other option also, that is existing component with positioning. Select that option, select the product, go for the selection of top plate. The difference between these two commands, that is first one existing component and the second one existing component with positioning. The difference is we will have this window here showing the part which we have called. Now here the base plate, means bottom plate and top plate, are being merged together as they were of similar sizes. That's why only the difference can be seen here is with this pillar which was not there in base plate or bottom plate. So it is difficult to select the faces directly from the assembly. That's why this window has been provided. If we use existing component with positioning, it will help you for direct selection of features to apply the constraint. So we can put on this option, that is automatic constraint, and directly apply the constraints here by selecting the features from this window instead of selecting the features from the assembly, as the parts are overlapped. So to avoid that only this feature is given, but I'm not going to use this one to apply the constraint directly. I'm just going to say it close, and we will use the existing component feature only. Select the product, again call this part top plate. It will be overlapped here. So the other option is to move this part aside and then apply the mates. So to move it aside, we are going to use manipulate command. First we are going to use Z direction. So the part will be dragged in Z direction here. I'll take it at downward sides, and then we are going to rotate it around X axis. So the orientation of this pillar will be at downside. So around X axis we are going to rotate it. Still we can see this pillar is coming at the back side and this hole is coming at the front side. So we need to rotate it again. So I'm going to select Z axis here for the rotation. and now it is oriented properly to give the constraints. Now this pillar is coming matching with the hole. Not exactly, but after constraint it will be matched here. So for applying any constraint, we are going to go for this option, that is coincide constraint. Select the axis as well as select the whole axis. Say update. Then go for this option. Select the coincide axis. We are going to make this axis of this hole of the top plate to be constrained with the guide pillar or guide bush axis. Coincide constraint. So we can select any axis out of bush or pillar. So I'm going to select this axis here. Now both the axes are been selected of the bush and hole. From top view we can see it is properly positioned, and now for lastly positioning it properly we are going to refer the PDF. Here we can see the top face of the top plate is coincided with the top face of the guide bush. So both the top face of guide bush and plate are coincided with each other. We are going to do the same thing by applying the coincide constraint between the two faces. So I'm going to select here coincide face, top face of this part as well as the top face of the guide bush. Say update at the same sides, not opposite, as the orientation will change if I go for opposite. So same side, say OK and say update here. And now finally this assembly has been constrained. So we have seen all the important constraints here, that is coincide constraint, opposite face contact constraint, surface contact constraint also we can say. Then for distance we have seen offset constraint, and for proper orientation we have seen angle constraint, parallel constraint as well as coincide constraint in the same command, this command. We have applied the fixed component also, and lastly we have used the reuse component. So in this way the press tool assembly part has been completed. Now we'll hide the planes here, as it is very hectic to see the parts here and to visualize them properly. So for that, for hiding the planes, just go on this view tab, this toolbar, go for this option, that is custom view parameters, and here say no access, say OK and finish. So the planes, all the planes will be hidden here. Next thing, if I want to edit any part, so I just need to select the part in the model tree. We are going to take the example of base plate, expand the features of the part which you want to edit. Go for the first feature with the settings symbol and double click on the name. And here we can see this interface, now it is coming as part modeling interface. So whatever things I want to change in the base plate or bottom plate, I can change it here. Now after applying the changes and moving to assembly interface again, you just need to double click on this product title, and in this way you will be moved again to assembly interface. Suppose if I want to edit the size of this pillar of top plate, so I'm going to expand it, double click on the title here after expanding, and this change interfaces of part modeling now. So if I want to change the size of this guide pillar, I'll just expand it again, go for this pad, double click on this pad, and here I will change the value from 80 to 100 or 120 I'll say, just to show the change properly. Say preview, and you can see this part has been updated. I'll change it to again 80 again, say OK. So it is moved little bit upward now again. We'll move to assembly interface by double clicking on this product title. So here we can see the toolbars of assembly features again now. Things important to note, we have used toolbar, that is move, constraint and product structure tools. These are the main three toolbars which we have used for assembly. So this was the basic lecture of assembly today. We have seen the bottom up assembly interface. We have seen how to assemble them by using the main mates or constraints. We have also seen if there is reuse pattern, how to relate the component with the part which is having pattern. We have also seen manipulation command, use of this compass, and we have seen how to see the degrees of freedom. Make sure that all the degrees of freedom are locked here. Suppose if I go for top plate lastly, see the degrees of freedom, there is no degree of freedom. This assembly is fully constrained now. Now suppose if I want to apply the appearances for the part, I'll just expand this in model tree, select the part modi, right click, go for properties. Here we can apply the appearance we need, say apply and OK. So for other parts also, directly don't go for properties on this title name, first expand them then go for the part body, then select the title name or properties option, go for graphics, and in graphics window you can apply the appearance you require. Say apply and OK. Next for the guide bush, again expand it, expand the feature, select the part body, go for properties, go for graphics and apply the graphics you want. Lastly, the top plate, expand it, go for the part body, right click properties and graphics window, select the feature, say apply and OK. So here the assembly has been completed now. So that's all for today's lecture. We'll continue with the assembly features and remaining commands of assembly in later lectures. We are also going to see top-down approach for the assembly. So stay tuned in the channel 4 Dimensions Infotech and keep watching the videos for CATIA series. Till then, thank you. So after completing the press tool assembly, we have completed the first day of assembly lecture basics. So for moving forward, we are going to continue with the toolbars that are present in constraint toolbar. So till now we have seen coincide, contact, offset constraint, angle constraint and fixed component. Further we are going to see today's fix together and the remaining constraint. As well as we are going to see this move command. What are the remaining commands in move command? So to start with, I'm going to take new assembly here. Say mechanical design and assembly. So in assembly we are going to call some parts here. Say existing component, or we can say existing component with position anyone. So I'm going to take existing component. This command we have seen in the previous lecture. If anyone wants to see this command, they can refer the previous lecture. So I'm going to select on this title after clicking on existing component. Select the product title. Next we are going to browse the part. I'm going to take the base plate here. So this is our base plate. Say close. After putting up the base plate, we are going to call some more parts here. We'll take one guide pillar also. We'll manipulate it little bit. In X direction we are going to take it. And next part we are going to call here is guide bush. So for the next part we are going to say guide bush, existing component, product, guide bush, say open. This one also we are going to manipulate, but by using compass this time. So any option you can take for manipulation, either move command or you can go for compass also. This move command you can move the parts here. So to start with, we are going to see fix together command first. In fix together, I am going to select the constraint here. Next you need to select the parts which you want to fix together and then say OK. So after fixing them together, we can see the history. It is showing fix together constraint is been applied. We'll say move command or manipulation command and we'll make this part move in Y direction. But you can see this part is moving individually even if we have applied the fix together constraint. This is because this option with respect to constraint is off. So if I put on this option and then if I try to move this guide pillar here in Y direction, this will move with the guide bush due to fixed constraint. Even if I apply the constraint here, suppose if I go for coincide constraint, select the axis of guide pillar and this hole, say update, both the parts will move together due to fixed together constraint. So this was fixed together constraint. We'll undo them, say escape and then say Ctrl Z for undo. So we have removed the constraint fixed together here. It is used for making the axis to axis coincide or flat faces to flat faces coincide. So it is similar to coincide constraint only. Quick constraint, select axis and axis, say update. Similar way, suppose if I go for faces, coincide constraint, this face and this face. Again update and they are coincided together. One more time, I need this plate here, base plate. So for that we have this option. If I want to repeat this plate here in assembly, then we have this option, fast multi instantation. That will come under product structure tools, the last option. So fast multi instantation, I'm going to select the part which I want to repeat in assembly. You can see the copy of this part has been created, but it will not have any constraint here. If I want to manipulate or move it, I can just directly go for manipulation and we can drag here in X or Y direction as we require. Next, again go for quick constraint. This time we are going to take edges here. So edge to edge coincide will be taken place If I go for quick constraint and say update. So now these edges are being constrained. Similar way, faces, this face and this face coincided together and now they are constrained. So now as these edges are being coincided, not the complete faces, we can go for angle bed also here. Select both the faces in which you want to make an angle, then provide the angle value. Suppose if I say 45 degrees, say OK and update. So you can see here, as they were coincided with the quick constraint using edges, the angular constraint can be applied here. So this was quick constraint option. It can be used for axes, faces or edges. Next we are going to go for flexible or rigid subassembly. Suppose if I insert any subassembly here, suppose if I want to call any component, again I will go for this existing component option, select the title as product and call the product here. So I have made this press tool assembly earlier for the lecture. So we are going to call this same assembly as a new sub assembly. Say open, we'll move it little bit. So I want to move it in Y direction. But you can see here when I am moving this assembly, it is moving combinedly as an assembly, not as an individual parts here. If I am dragging the top plate of this assembly, combined assembly is been moving either in X direction or in Y direction or in Z direction. Similar way, if I rotate it around the Z direction, it will combinedly rotate as an assembly only, not as an individual part. This is because this sub-assembly is a rigid assembly. So now if I want to move these parts individually, I need to make them flexible. So I'm going to select this flexible rigid sub-assembly, select this option and click on this product which we have called as a sub-assembly. Now you can see this color is coming pink. Earlier the parts were having color as blue color, but as we have applied the flexible assembly, that's why this color is showing pink. Means this sub-assembly has been flexible now. So if I go for trying manipulation command again, I will put off this option that is with respect to constraint, and then if I try to move this plate, it will individually move the plate only, not a complete sub-assembly. This is because we have made this sub-assembly a flexible one. So this was flexible and rigid sub-assembly. I'll undo it again and I'll say again this assembly as rigid. So just click and put off this option here. Say OK. If I again go for manipulate and try to move it, it will move as a sub-assembly only. So this is due to flexible and rigid sub-assemblies. Next constraint we are going to see here is change constraint. And if I select any constraint in the history, suppose this guide bush constraint which was made coincided with the face of the plate. Suppose if I select this constraint, then CATIA will show the possible constraint which can be changed here. So I am going to select this offset constraint. Earlier it is coincide constraint and we are going to change it into offset constraint. Say OK. You can see here instead of coincide now it is showing offset. Suppose if I want to apply the offset distance also, just double click it and you can go for the distance option. So I'm going to take this distance as 80 mm and say update. So now you can see this 80 mm constraint is been applied, and instead of having coincide constraint, now it is moving downsides due to offset constraint. This is done by using change constraint option. One more time, if I go for this change constraint option and instead of this angle mate, if I go for perpendicular mate, say apply and OK, these two plates will be perpendicular now. Say update. So this constraint is being changed from angle to perpendicular constraint. All this can be done by using change constraint option. We have seen the reuse pattern in press tool assembly in earlier lecture. So we are not going to repeat it again here. I'll delete this product. Earlier we have called. Next we are going to see the manipulation command again. I'll move this guide pillar to Z directions here. Whole complete assembly has been moving. So first I need to make this base plate fixed. For that I'm going to apply this constraint again, fixed component on this plate. So fixed component. Again go for manipulation command and I want to move this pillar here, but it is not moving. This is due to with respect to constraint option is on. So if I put off this option and try to move it in Z direction, it will again move it here. Say OK, and if I say update, it will again move to its original position as there was coincide constraint between the axes. You can see here But suppose if I go for this option, that is in manipulate, if I put on this option again with respect to constraints, say OK. And now if I try to manipulate it from its side, it will not get manipulated in X or Y directions. It is because the part is following the constraint here. That was axis to axis coincide constraint. So if you want to move the part according to constraint, then put on this option. And if you don't want to move the part according to constraint, you just need to move them directly, then you can put off this option. Say OK and finish. Next option we are going to see here is snap tool. So for snap tool, select the snap tool, select this axis of guide bush and axis of this hole here. You can see here the last constraint in the constraint history table was fixed constraint only. But if I again go for snap command and try this face to snap with this face, it will get snapped. If I want to orient it to and fro, and this will get oriented in opposite directions. So this is the snap command, means positioning the part without having any constraint history or without making any constraints here. We'll repeat it here. We know that this guide pillar is having axis to axis coincide constraint here. But still if I try for snap, select this axis and this axis here, this part will move here, snapping the position. So it is only used in fixture design for positioning the parts together so as to see how the assembly will appear there. It will not going to have any constraint history or no constraint will be applied here. You can see still this fixed constraint is the last constraint in the constraint history. No other constraint has been applied here. Only the part positions are being changed using snap command. If I try this axis and this axis, it will move in that orientation also, but only having snaps here, not having any constraint. If I again say update, it will move to its original position with this whole reference. So this was snap command. Next command we are going to see here is smart move. So smart move is nothing but similar to snap command only. Suppose if I go for smart move, this axis to axis, it will grasp the position for the axis to axis has been coincided. But we can see here no made history has been created, means no constraints are been applied. Similar way, if I go for smart move again with this hole now, it will be moved according to the axis to axis orientation, snapping the position only. No constraints are been applied. But additional thing in smart move that separates it from the snap command, it is that automatic constraints creation can be created here. Means constraint can also be added here. In snap we were not able to add constraint, but in smart move we can add the constraints also by using this automatic constraint creation. So this is the main difference between smart move and snap. So we'll put on this option, that is automatic constraint, and then try this constraint here. So the guide bush axis and this hole, we are going to make them constraint. Here in constraint history, the only constraint is fixed constraint. But if I put on this option and then in mid history, in constraint history, the only constraint here is fixed constraint. But if I put on this option and go for this axis as well as the whole axis, the new constraint has been added, that is coincide constraint. So this is the main difference, that you can add the constraint also by using this smart move. So this smart move tool will work as snap also as well as to add constraints also. Both things we can do, and these things are very important while working in fixture assemblies. Sometimes we need to snap the parts for the position and sometimes we need to make constraint for these parts. Now here in quick constraint there are multiple constraints here. We can see we can try any of them here. If I need to go for angle constraint, so I'll put this angle constraint in order wise at the top position first by moving with this arrow. Now this angle constraint is coming at top. If I put on the planes option to show the planes, by going in this view tab, custom view parameters, select on this option customize view parameters and then put off this option no axis. So this time if I want by smart move the angle constraint is to be added, then we can go for that also. So I'll keep on this automatic constraint option, select the reference planes in which I want to put the angles. Suppose the plane of this guide pillar and the plane of this plate, and then say OK and finish. So here you can see this angle value is appearing as 180 degrees. I can double click it here and change the angle I want, or else if I go for this constraint and double click on this constraint also I can change the angle. So I'll say 45 degrees here and say update. So now you can see both the planes are at 45 degrees with each other. Angle constraint has been added here. This plane is being made angle with this plane by 45 degrees. So in this way smart move can be used. I'll delete this mates here. And suppose if I go for again smart move option and I want this offset constraint here. So I'll move this offset constraint at the top and then go for the offset constraint between the faces. So this time I'm going to select this face and the other face I'm going to take the reference of this plate side face. Say OK and finish. So offset constraint has been added. If I double click on this and go for the value, then I'll put the value here as 100 mm. Say OK and say update now. So this offset constraint has been added here, having the distance between this face and the guide bush face as 100 mm. So in this way we can use smart move option also to put the constraints as well as for making snaps. Next command we are going to see here is exploded view. So for exploded view, I'm going to open one assembly here. I've already opened the assembly. Just go on this window option and change the window here. So I'm going to put on this assembly here, press tool assembly. And if I want to make this assembly exploded, so as to understand how the parts are been assembled with relation to each other, we can go for explode option. So here is the option in move toolbar itself. Beside this snap tool, there is explode command. Select the explode command. Here it will ask you the fix product. Means if I want to fix any part and then explode the assembly, I can do that. So for fixing this part, I'm going to select in this box and I'll fix this base plate here. Then at all levels, I want to explode it. I'll say apply and OK. Say yes. So now you can see all the parts are being exploded and can be seen at distance with each other. So as to understand how this assembly is being constrained. All the relations are also being shown here. Suppose if I want to move this top plate little bit upwards, so I can use this compass here. So in this way we can move the parts also here. Suppose if I want to move the guide bush this time, then select the guide bush, select the compass, drop it on the guide bush and then you can drag this guide bush here. So you can change the parts position in exploded view using this compass. Again place this compass here. And lastly, if I want to exit the exploded view, I just need to say update here. The shortcut key for update, if you don't have any toolbar, then you can go for Ctrl plus U as the shortcut key for update. So now it is again updated and positioned at its places. So in this way you can use the exploded view. Lastly, we have this option that is stop manipulate on clash. Suppose if I call any one more part here, I'll go for this option that is existing component, select the product. I'll call the guide bush again, say open. I'll manipulate it. With respect to constraint, I'll put off this option here. I want to drag this part in Y direction. Now if I go and put on this option that is stop manipulate on clash. Suppose this option is off, then put on the option also. Say OK. And if I try to manipulate now, having both the options on, that is with respect to constraint as well as stop manipulate on clash. If I drag here in Y direction, this part will not intersect the base plate. You can see here, it will stuck while touching the base plate. It will not move forward. If I drag it in the left side, it is not moving. This is because stop manipulate and clash is on. Suppose if I put off this option and try to drag, then it will clash here with the plate and intersect the plate and pass on. So this option is very important to see whether the parts are being clashed together or not. This will automatically stop the part while clashing. Say OK and finish. Next option here is graph tree recording. It is used to manipulate the positions of the part in model tree. Suppose if I go for this option graph tree recording, click on the title, you will get this chart here to move the model tree parts and manipulate them by their order. So if I go for this guide bush and try to move it upwards, move the selected product upwards, this green arrow showing the direction at upper side, then this guide bush will be moved at the top. I want this base plate to be dragged to bottom. I want this top plate to be positioned at second number. I want this guide pillar number 4 to be positioned at third number. Means we are manipulating or moving the positions of the part in model tree. Say apply and OK. So you can see guide bush 3 is coming at top plate is coming at second number, guide pillar 4 is coming at number 3 position, and base plate is coming at bottom now. So in this way, you can use this graph tree recording to manipulate the positions of the parts in model tree. So this was graph tree recording option. Next option is replace component. Now I'll change the window here, go to product 2. Before that, again I want some more copies of this part. For that I'm going to use this command, fast multi installation, and click on this part. Again click on the part and you have this 3 guide pillars now. If I want to change these guide pillars to guide bush and replace them with guide bush, then you can go for this command, that is replace component. Before applying replace component, I'll give one mate also here with one part or with one guide pillar. So for that I'm going to apply coincide constraint. Select the axis of this top guide pillar with this whole axis. Make them coincide with axis to axis. Now I will say replace part. Select the part you want to replace. Select the part you want instead of guide pillar. So I'm going to take guide bush here. Say open. It will ask you that these elements are going to be impacted by the replace component. Do you want to continue? If I say yes, it will continue. If I say no, it will not continue here. So I'm going to say yes and OK. So now you can see instead of guide pillars, guide bush are being shown here. But still the constraint which we have applied, coincide constraint with axis of guide pillar and this hole, it is still there. Means constraint will be continued but the part will be replaced using this command replace component. Next command we are going to see here, which is going to be used in drafting only, that is generate numbering. So if I need to make bill of material, I need to have the balloons also there. So in balloons, we can show the numbering for these parts. So if you want the balloons with having numbering for the parts, then you need to compulsory go for this option in assembly itself, that is generate numbering. Select the product and it will ask you which mode you want, whether you want integers as numbers for the balloons or you want letters for the balloons A, B, C, D. I'm going to select integer only for the balloons. This is standard one. So I'll say OK. And now for ballooning in drafting for bill of material, numbers are being generated here. So these were the toolbars we were going to see today. We have seen this toolbar, move toolbar, all the options. We have seen constraint toolbar, all the options. We have seen product structure tools, all the options except these two. These are not needed, that is selective load and manage representations. We have omitted these topics here, and except that we have seen all the commands in product structure tools. So these were the 3 toolbars that were necessary for assembly, basics of assembly. But still if you want to learn the assembly in deep, you can join the course. The number for joining the classes to make the contact is given below in the link. You can connect us and join for the courses here. We also provide 100% placements based on mechanical courses such as SolidWorks, AutoCAD, CATIA, Solid Edge, Creo. Any course if you want to learn in deep, you can join here. You can join us by contacting us. And for now, we will continue with the further lectures for CATIA. So keep watching the CATIA playlist and subscribe the channel 4 Dimensions Infotech. Till then, thank you. So hello everyone, today we are going to start with CATIA's next lecture. So till now we have completed all the constraints of assembly as well as the remaining tools that are required for assembly. But today we are going to start with top-down assembly. So we'll start with top-down, say start, mechanical design and assembly design. In assembly design, first we are going to make the part here, then we are going to assemble them one by one. So the first part we are going to make here is flange. We are going to make one simple flange coupling assembly only of 3 parts. So to start with, we are going to make flange first. Now to make a part in assembly, we need to click on this option, that is part in product structure tools. So I'm going to click on this option. Then we need to click on the assembly title, that is this product 1. In model tree, part 1 is going to appear here. So if you need to change the name of this part, we can change it. So we'll right click it here, go on properties. Here we need to change the name. So in part number we are going to provide the name here as flange. Say apply and OK. Now part 1 is appearing as flange. Now to make this part using features, we need to expand the model tree here. At present, we are in assembly interface. We are going to double click on this option after expanding on this title name only. And this interface, you will see that it will change to part modeling. So I'll double click it here and you will see this command changing. So now we are in part modeling interface. We are going to start with the front plane here. Select this plane. Now one thing more, these planes are not been highlighted here. It is because the appearance of this view parameters is being changed. So I'm going to click on this view toolbar. In that we are going to go for this customize view parameters and select this third option, that is shading with edges. And after that we can see here the planes are being highlighted. We'll shift this view bar at the bottom. Next we are going to start with the front plane. Say sketch. And now we are going to add the features for making flange. The first feature we are going to use here is shaft command. For that we are going to make this sketch first. We are going to use the shaft command. That's why we are going to make half sketch only at one axis side. Provide the values here. Diameter we are going to take the overall diameter as 120. So this value we are going to put here is 60 mm only. This distance we are going to take here as 3 mm. And this inner side diameter we are going to take 110. So I'll take this value here as 55. Next we are going to continue with the profile again. Now we have the complete close profile. So we'll put up some more dimensions here. I'll take this value here as 23 mm. So this inner diameter we are going to take 60. For that this value will be 30 mm. And this total length we are going to take here is 53 mm. Now the complete profile is been made and constrained. We are going to say exit sketch here and go for shaft command. Select the axis, say preview and say OK. Now we need to provide holes and appearance here. For that first we are going to go for appearance option. So for appearance, just right click on the title flange, go for properties option. So for appearance we are going to click on this part body here under the flange. Say right click and properties. Select the graphic window and say color. We are going to take this color here as blue. Say apply and OK. Now for making holes we are going to use hole command here. Select the hole command. Select the face on which you want to apply the hole. Now in extension we are going to provide the diameter. So I'm going to take this diameter as 9 mm. End condition we are going to keep up to last. Next positioning sketch. So now the hole is appearing at the center of this face. We are going to position it. Select the position sketch. First we'll make one PCD here, pitch circle diameter. So the diameter for PCD we are going to take here is 80 mm. Now we'll place this point on this circle. For that select the point as well as the circle and say relation as coincide. Say OK. Now we need to make this orientation vertical. For that select this point as well as the axis and go for the relation as coincide. Say OK. Diameter we need to change here as 80. Now after positioning this whole point, say exit workbench and the hole will appear here. Say OK and finish. Now we need to go for pattern. Here the total number of holes we are going to take here is 6. For that we are going to make the use of pattern command. We would have directly made these holes by making all the holes together in one sketch only. But after that we would not be able to make patterns in assembly. So for that it is compulsory for us to make these holes by using pattern command only. So total number of holes are 6. We are going to use the circular pattern here. First we need to select the objects to pattern. So here I am going to select this hole. Next I am going to say here as complete chrome parameter type. Total number of holes we require are 6. Reference we are going to select this face here and say preview and OK. So now all the holes have been made by the pattern. The original one is at the bottom here, we can see. We need to make one more hole at the center for shaft insertion. Select the hole command, select the face. It will by default come at the center only as it is a circular part. So diameter we are going to take here is 30 mm. And I'll say the end condition as up to last only. Say preview and OK. So now this part is completed, that is flange. Now as it is a top-down assembly, first we are going to go in assembly interface again as we have switched to part modeling. So for that we need to double click on this product title. After double clicking here, the interface will change to assembly here. So I'm going to click on this title, double click it here to change the interface to assembly zone. You can see here all the toolbars are being changed and we are again in the assembly zone. So we are going to go for next part now. Select the same option as part beside the existing component at the left side. Select the part option, select the product title. After clicking on product, one note will appear here asking whether you want to use the same origin that was used for this part 1, or if you want to make the part with new origin, then say no. So I'm going to say a no only as I want the new origin or new plane setup. Now here we can see part 2 has been appearing. I'll change the name here first. Say right click, go on the properties option. Same process as we have done earlier. Here we need to go on this product title. Change the name here as bolt. Say apply and OK. Now after renaming the second part, that is bolt, we'll expand the model tree here. And now we'll click on the subtitle with the same name as bolt. As soon as you click here, you can see the access system has been appearing in orange color. This is nothing but the new access system being overlapped with the previous one. So if I want to move this access system for the new part, I'll click on this compass and move it on this access system and drag it here. So you can see this new access system has been separated from the older one. Place the compass at its place, and now we are going to make the second part by using this access system here. Now to enter in the part modeling interface, again click on this subtitle named as bolt, and we can see here these toolbars are being changed. We are in the part modeling interface. Now in part modeling interface, you can see all the part modeling tools are been appearing. We'll start with the front plane, making the second part bolt. Say sketch, and we'll make one bolt here. For that we are going to make the shaft first by using shaft command. So here the length of the bolt we are going to keep it as 12 mm and the diameter is 9 for the hole, so we are going to take the same diameter for the bolt shaft. The radius for that diameter will be 4.5 mm. Next we are going to say exit sketch, exit workbench, and say shaft command. Select the profile, show the axis and say OK. Select the face and say sketch for making the head of the bolt. Now we are going to go for hexagon command in rectangles. We'll shift this toolbar here above. And now we are going to make one hexagon here. Take this line and say relation as vertical. Say OK. Put up the value for the circle. This circle for making the hexagon. So I'm going to take it as 15 mm. I'll say 16 here. Say exit workbench and go for pad command. I'll say 5 mm for the pad. Now we can see one bolt has been made. Now we need to go for the above fillets or chamfers. For that we are going to select the plane which is crossing the maximum distance of this hexagon. So the maximum distance for the hexagon is not in between the sides but in between the corners. So the plane that is passing through corners is this plane, that is front plane. Say sketch for this plane. Zoom out here. And now we are going to make one profile that will be for the fillet on the above head. After that we are going to project these edges here. Select both the edges and say project entities. Say construction mode. These are been taken for reference purpose only, these edges. After projecting the edges we are going to go for arc command. So in arc we are going to select start and with radius. Now this arc is coming tangent on one side. Provide the tangency on other side also. Provide the radius required. Radius we are going to take here as 1 mm. Now we need to close this sketch. For that we are going to again convert this construction line to solid lines. Select both the lines and put off this option, that is construction geometry. Next we are going to trim these entities again. So in operations toolbar, select quick trim, double click here, and these lines are being trimmed now. This is complete close profile. Say close sketch, exit workbench, and now we are going to go for groove command. Here select the profile, then next we need to select the axis and say preview. Say OK, and we can see here these corners are being filleted now. Next we are going to go for appearance for the bolt also. So here in part body, click on the part body option. Go for properties and graphics window. Select the color you require for the bolt. I'll select this brown color here, say OK and apply. Now for making other part, first we need to shift to assembly zone again. For that, double click on this title product and this interface will be changed to assembly. So I'm going to double click on this product and we can see we are again in the assembly interface. So to start with the other part, we'll repeat the cycle, that is select the part first from product structure tools toolbar, then select the title. It will ask you for the same origin to be used or you want the another origin. If you want new origin, just say no here, and this part we can see part 3 has been appearing here in the model tree. We'll expand it. We'll right click on this part 3, go to properties and provide the name required. Now in properties we need to provide the name here at the downside, say NUT nut and say apply and OK. Next we'll expand this and here in the subtitle also the same name will appear. We'll select it and we can see the axis has been selected. The axis system has been selected. This is the new axis system being overlapped with the previous one, with the first one. So we'll move this axis system to make the new part, or else we can make the part here itself. So first select the title again, this nut, and then keep this compass here. Drag the axis system again. Place this compass system at its previous place and we'll start with the new part. Again, for making the new part we need to change the interface to part modeling. So one more time we need to click on this subtitle, double click it here. It will change the interface to part modeling. Now we can see the part modeling tools have been appearing again. So we'll start with the nut. Say this right plane, say sketch. And now we are going to make this nut here. We'll select the hexagon. Go for the size here. We'll take this size here as 16. Same diameter as that was for bolt. Just hide the planes here. Make this sketch normal again. Select this line and go for the relation as vertical. Now sketch is constrained. Now if you want to see whether the sketch is fully constrained or not, you have this toolbar here, that is tools in part modeling. In that toolbar you select this sketch solving status. So select this toolbar and you will see it is showing here this, it is completely constrained. ISO fully constrained. Say close toolbar. Then go for the pad command by exiting the workbench. Next we'll select the plane for making the fillets here. So I'll select the plane again. The plane should be that plane which is crossing the maximum distance. So here this plane, front plane, is crossing the maximum distance of this cross section, that is these two vertex points. Say sketch, select both the edges, say project entities again, go for the 3-point arc, select the first point, the second point and third point. We'll provide the radius now. So I'll say this radius here as 1 mm. Now one side of this arc has been tangent. We'll make the other side also tangent. See the relation here as tangency. And we'll trim the extra parts of the line. Now complete close profile has been made. We are going to say groove. Say exit workbench. Say groove. Select the profile here. Show the axis. Say preview and say OK. Now we can see these corners are been filleted here. Now we'll mirror this fillet here at the downsides also. For that we are going to take one mid plane. So for mid plane this distance was taken as 5 mm. So for mid plane I need one more plane here at the distance of 2.5. So this plane is coming in between the thickness of this nut. Now for mirroring this feature at the downsides we are going to use transformation features mirror command. First select the feature you want to mirror. So I'm going to select this groove here. Then select the feature, that is mirror command from transformation features. Here it is asking for the reference element or a plane. So I'm going to select this plane. Say OK. So now this fillet is coming on both the sides. We'll give the appearance for this nut also here. Select the part body and then go for properties. So in window we are going to select the color here as green. Say apply and OK. Next we are going to select this face, say sketch, and we are going to make one circle. This will be for pocket command. So as to insert the bolt shaft, select the circle command here. The diameter of bolt was taken as 9. So we'll take this whole diameter also as 9 mm only. Say exit workbench. Next we need to select the pocket feature. Say OK and finish. So after completing this nut, we are going to shift to assembly zone again. For that we are going to click on this product title, and now we can see we are in assembly zone. These above toolbars are being changed. Next thing we are going to do here is we need to edit this part and we need to increase the length of the shaft. So to edit this bolt, I'll double click on this bolt title here, and here on this shaft sketch we are going to double click on this sketch to edit the length. So earlier the length was taken as 12 mm. We are going to increase it and say around 18 mm. Say exit workbench. This part has been updated now. If you want to manually update it, you just need to click on this icon, manual update mode. Now after editing the bolt, we are going to go for the assembly commands. We'll shift to assembly zone here, double click on product, and now we are going to assemble the parts here. Now as we are seeing the top down assembly, we have completed all the parts. We need to assemble them together. So to start assembly, we'll make this part fix. So fix constraint will be applied here. I'll call the constraint toolbar here first, and then we are going to apply the fix component. Just click on this option and click on the part required. The fix constraint is being applied. Next part we are going to assemble here is bolt. So for bolt, I'm going to say coincide constraint first with axis to axis. Before that we need to know which hole was made first and then all the holes which were patterned. For that we are going to expand the model tree of the flange. Here we are going to see the hole first. So as soon as I click on this hole, before pattern, this circular pattern, before that you can see this hole has been highlighted. So we need to assemble this bolt into this hole only. For nut also it is going to be same, that we need to assemble this nut on the first hole only. Then only we can provide the relation with the first hole, and after the first bolt been assembled we are going to go for pattern. So we'll go with the first constraint for the bolt, that is coincide axis. Select the hole which we have seen. I'm going to select the first hole. You can see this hole has been highlighted here. Now the coincide constraint has been applied. Say update here. So here is the icon for update. Just click on this icon, or else you can use the shortcut key as Control U. So it is coincided now. Next we need to say coincide with faces. So for that again coincide mate. Select this face and this face. We can go for the other mate also. Instead of coincide we can take this contact constraint also. Contact constraint is only used when the mates are to be applied on two opposite faces. Means the faces orientation are to be opposite, then only we can use this contact constraint. Contact constraint. Say update. Next we need to log the rotation of this bolt. Now if I want to see the degrees of freedom for the bolt, right click, and below the delete option there is one option with the same name as part. Go to component degrees of freedom. So here we can see rotation is on. So to lock this rotation we are going to use this angle constraint here, and within angle constraint there are three constraints: parallel, perpendicular and angular. We can apply any constraint out of three so that the part will not rotate here. I select the constraint. We are going to select this plane here and the plane of the first part, that is of flange. We are going to say both the planes as parallel. I'll say on the same side, say OK. Now the rotation of this part has been locked. We can cross check here. Right click, say degrees of freedom, and here you can see there is no degree of freedom. Next we are going to go for pattern command now. So for pattern we have this toolbar in constraint, that is reuse pattern. Select the bolt and select the pattern from the model tree. The pattern was made in flange part, so I'm going to expand this flange part and then select the pattern which was applied in part modeling here. So we are using the pattern which was made in part modeling itself. That's why the name of this command is reuse pattern. If you have not made this pattern in part modeling, you are not able to apply the pattern in assembly also. The first step was to select part, second was to select the pattern from the model tree, and the third step is to say generate constraint. Only three steps are required. Say apply and OK. So except first one, we are going to see any random bolt here. Say this 6 number. If I go on degrees of freedom, for that we can see there is no degree of freedom being shown. So now this part is completely and fully constrained here. Now next we need to establish the relation of this nut also with the same hole, that was this hole, the first hole. You can see here it has been highlighted in orange color. If I need to pattern this nut also in 6 numbers, for that again we need to make the constraint with the hole only, not with the bolt. But if I go for coincide constraint and try to select the axis of the hole, so to avoid this problem we need to hide all the bolts here. So I'm going to go for hide command for the bolt. Select the first bolt, say right click and say hide. Now this first bolt has been hidden here. We are going to apply the mate constraint now. As the bolt is highlighted, only axis of this hole will be shown, and that axis will be used to coincide with the nut, making the relation directly between the hole and nut. That is important need for the pattern. So select the axis of hole now and the axis of the nut. Say update. Coincide constraint has been applied. After maintaining the relation with the hole for the nut as coincide, now we can unhide the bolt. Next constraint we are going to go for contact constraint. So in contact constraint I am going to select this flat face of the nut and the flat face at back side of the flange. Say update. You can see here this nut is also been placed here. But now to lock the rotation we need to apply a relation between the planes of nut and planes of main assembly, making them parallel or perpendicular, or else we can go for angle also. Say parallel, say OK on same sides, and now the nut rotation is also been locked here. Just right click and see degrees of freedom whether they are locked. Yes, it is showing now there is no degree of freedom, means this nut is also been fully constrained now. Next we are going to pattern this nut and the assembly will be finished here. So reuse pattern again. We need to select the part, that is the first step. Then we need to select the pattern which was made in flange. Expand the model tree and select that pattern which was made in part modeling. Then we need to select the option that is generate constraint. Now this flange coupling assembly has been completed. Now one more thing, we need to hide the planes of this part here. For that select the view tab, and in view tab we need to go on this option shading with material. Go for this last option here with the question mark, customize, and say no access, so the planes will be hidden there. You can see no planes are being shown now, and this simple assembly of flange coupling has been completed by the use of top-down assembly. Now the last part is to save the assembly. So as soon as you click on this save option, this assembly will be saved separately and the parts will be saved separately. So we'll see whether all the parts and assembly are been saved into single folder or not. So we'll go on files in D drive, CATIA V5 R21. Here was the folder been made, and now we can see all the parts are separately been saved even if they are made in assembly interface only by using top down. After that also this part are been saved separately and the assembly is been separately saved. You can see the title showing as CATIA product. So this was CATIA assembly by using top down method. For understanding the assemblies of CATIA in deep, you can join the courses also. The contact number in the link will be given below. You can contact us for placements in mechanical design on software such as AutoCAD, SolidWorks, CATIA, BIW design, fixture design. Or else you can visit the website also 4di.in to know more. So for today, this was the lecture. We'll continue for the further commands in next lecture. And now from the next lecture, we are going to start with surfacing. So stay tuned, subscribe the channel, follow the playlist of CATIA. Till then, thank you. So hello everyone, hope you are following the CATIA playlist. We have completed part modeling in Sketcher. We have also completed assemblies in which we have seen two types of assembly forms, which were bottom up and top down. And now we are going to start with surfacing today. So as we talk about CATIA surfacing, it is crucial in product design and development because it allows designers to create complex, smooth and aesthetically appealing 3D shapes that cannot be made using solid modeling alone. It is widely used in industries like automotive, aerospace, For designing car bodies, we can say aircraft surfaces and also ergonomic consumer products. Surfacing ensures better control over shape, quality and aerodynamics, making it essential for high precision and visually demanding components. So that's why surfacing is very important here. But as we are saying, it is important to learn surfacing. It is also very tricky while modeling. So any design engineer should know which command to use at what time and how to proceed with the part in complex design. So the use of command is going to be tricky here. We'll start with surfacing. For that we are going to go on start click button, say mechanical design, and here we are going to say wireframe and surface design. Third last from the bottom side we can see here. I'll enter the name here. We'll see the basic commands only today. Say OK. Now the toolbars which are going to be important here, you should note down this because many times in CATIA the toolbar names are not present and the toolbars will be shuffled and placed anywhere. So it is better to know the toolbar names. By that we can search them easily. So the toolbars are surfaces. This is the first toolbar. Second one is operations toolbar. Third one we are going to see wireframe and surfaces and some more commands from miscellaneous toolbars here. So I'm going to start with surfaces toolbar today. We'll place the other toolbars at its place. We can arrange them anywhere as we require. Now surfacing means working with zero thickness objects. Any object that is going to be made in surfacing will not have any thickness here. We can add the thickness externally if you want. Usually by using all the commands we can make a part having zero thickness. That's why surfacing plays an important role in intricate shape designs like automobiles. So start with extrude command. So let's make sketch for the extrude. I'll select this plane, say sketch, and we are going to make one line here. To make this line symmetric by selecting 2 points and axis, go for the relation as symmetric, say OK. Next we are going to add the constraint here. Dimensional constraint we are going to say as 300 mm. Exit workbench and we are going to go for extrude command now. So we have selected open sketches. We can select open or close sketches both for the extrude command. Now put up the value for extrude. The material for extrude is been added in direction 1 called as limit 1. So in limit 1 we have extruded the part by 106 mm. If you want limit 2 also to be added, we can add the value for limit 2 also here, say 80 mm. Say preview. Now at one side limit 1 which is coming in front side is of 106, limit 2 of 80 mm. Say OK and finish. But if I want to reverse the direction, now 80 is coming in front and 106 is going at the back side. If I want the same value symmetrically to be extruded on both the sides by center plane reference, then we can go for this option, that is mirror extend in the command extrude. And the value taken for limit 1 will be by default applied on the second side also. That was 106 mm. Say preview and OK. So in this way we can extrude the part here. You can see here the part is not having any thickness. Now this was with the open sketch. We'll see one more example for extrude by making a close sketch. Say part, say OK. Now we are going to make one close sketch on top plane. Say center rectangle here. Next we'll make this part dimensionally constrained. Say double click on this constraint toolbar. Select both the lines. I'll say 200 mm. And the other side we are going to take here as 80 mm. Next say exit workbench and go for extrude command again, but this time we have used close sketch profile. So we can see here material will not be added completely, the mid portion is empty here, but the side walls will be created by using surfaces. So I'll say extrude now. We can see here this extrusion has been taken place 60 mm. Say OK and finish. Next select this sketch and go for this hide show component, click here. Now in this way we can use extrude command. We'll change the window here. We'll hide these sketches here. If you want to hide the planes, we can hide the planes also. Now extrude command can be applied on these edges also. For that select the extrude command, select the required edge, and now we'll require to show the direction here. So I'll say Z direction. We can see here the Z direction was on the compass at the above side. It is coming on both the sides at the upper and lower side. If I want to extrude this edge at one direction only, then keep the limit 2 as 0. Say preview. We can see here it is extruded at one side only by 106 mm. We'll change the value as 150 mm here. Say preview. Again one more time, say extrude, select the edge required, select the direction. This time we are going to say Y direction. So Y direction here. Whatever length you require, you can extrude it. If I want limit 2 to be extruded, then we can use the limit 2 also here. You can see by dragging this, we can change the limit 2 value also. If you don't want limit 2, just put it 0. Say preview. If I want this value as 150 mm on both the sides, you can say mirror extend. Say preview and OK. So this was extrude command. Both ways extrude can be done by open sketch or by close sketch. Next command we are going to see here is revolve command. Say new part. Say OK. Now in all toolbars you can see here only material will be added. Cut command is not being shown here in surface toolbar. It is because all the parts are 0 thickness here. So for revolve command I'll select the plane, say sketch. I will select all the planes and say hide here. Next we'll make the profile. We'll use the line command only. We are making a simple step shaft here by using line command. We are going to take the radius value only. So I'm going to say 130 here. Next radius we are going to take 90 to make the diameter 180, and last one we are going to take here as 60. So the diameter here will be 120. Now the step heights, I say this size here as 40 mm. This size we are going to take as 30 mm, and just this one we are going to say as 20 mm. Say exit workbench. We have this open profile now. We are going to say revolve. So for that we are going to select this command revolve. In profile we are going to select this profile, and for revolve axis we are going to select this vertical axis. We can see here this part is coming by revolve command. The angular limit for revolve at one direction is 180 mm. So that's why it is a semicircular type part. But if I want to increase the angle on the other side also, we can go for that. So here I'm going to say angle 2 as 150. Say preview. Now this one was 180 in direction 1. And the other angle is coming 150 in direction 2. That's why there is small gap here. If I change this value to 180, say preview, you can see here. Or else we can do one more thing, that select the revolve command, select the profile, go for axis of revolution as this vertical axis, and in angle 1 limit only we can add this 360 degrees value. Say preview and OK. So in one angular direction only we can complete the angle here. But as we have not made any horizontal lines at the upper or lower side, that's why this part is open from upper and lower side. So if I want to modify this or customize this, then double click on the sketch and then go for the line command. We'll make this line here at the bottom side also. Don't let the sketch pass on the other side of the axis, or else revolve command will not work here. So I'll drag it on one side, go for the relation with point, and this point say as coincide. Say exit workbench, and now as the part is showing in red color means it is asking for update. So shortcut key for update is Ctrl U if you want to use keyboard, or else you can go for this icon in tools bar, that is update, and we can see this part has been updated and the above and below surface are been added as we have added the lines in the sketch, these horizontal lines. So in this way you can use revolve command here. Say exit workbench. If you want to hide the part, you can hide the part here. Next command we are going to see here is sphere, means spherical shape, and after that we are going to see cylinder. So for both the commands, the basic requirement is same, that we need one point here. This point will act as a center for spherical shape or cylindrical shape. So to start with, I am going to say new part. Say part, OK, and we are going to make sphere. So I am going to give this name here. Say OK. Now for making the center point, we can use the wireframe command, in which we have this 3D points here, or else we can make the plane sketch and then add the point in sketcher tab only. So both things can be done here. Either you can add 3D point, or else you can go for sketch and then add the point. So I'm going to add the 3D point here. Select this point, and the x coordinate distance I'm going to keep it 0 only. If you want this sphere to be made by the origin reference only, but if I want to change the distance, then I can change the distance also. So in x direction I'll say 20 mm, in y direction I'll say 20 mm for placement, and in z direction also I can say 20 mm. So now if I preview this point, we can see here this point is coming from the origin as by 20, 20 and 20 distance on all the directions. Say preview and OK. X, Y, Z directions. Now we can use this point as a center for sphere or cylindrical shapes. So I'm going to make sphere here. It will ask you the center point. We have made the center point earlier only. Next you can add the parallel start angle. It is showing minus 45 degrees, means at the bottom side we can change this angle here. You can see here in the model the change can be occurred. If I say minus 90, it will be at complete bottom side. Say preview. You can see here at bottom side is completely semicircular now. And for upper side also, parallel end angle, we can see at the upper side this 45 degrees. We'll change it to 90 degrees here. So a semicircular part has been made. We can change the angles as we require. We can plus or minus these angles. You can see the change in the screen. So these were the vertical controls. Now double click on the part, and now if I want to control it horizontally, these angles, so we can go for this option, that is meridian start angle. I'll change the value here. So we can see here horizontally from right side or left side, we can control the angles here. Say preview and OK. Now if I want to make this sphere complete round, then double click it here. I'll set this angle as minus 90 and this as plus 90. I'll say 180. Say preview, and here also minus 180 and preview. So by the use of these parameters we can make this sphere in this way. And one more shortcut is given here. Suppose if I cancel it, double click on the part and go for this option, that is create the whole sphere. Then also we can make this part here completely spherical shape. Say OK and finish. So this was sphere command. We'll delete this sphere and go for cylindrical now. Say delete. Say OK. Now for cylindrical shape, select the cylinder command. Select the point reference. And we need to give the direction, whether you want this to be made in XY plane, YZ plane or ZX plane. So if I select here Y, you can see here in this compass, this line in Y direction. So this sphere is coming parallel to the Y axis here. So we can give the limit values also, limit 1 and limit 2. And now if I want to change the direction, I'll say X direction. So it is coming in X direction. Same way in Z direction, making vertical. So by this way we can change the directions of the surface cylinder. If you want to change the diameter or radius, we can go for this option, that is radius here. I'll say 50. So the diameter will be 100. Say OK and finish. Same way if I want this length to be equal on both the sides, that is for limit 1 and limit 2, just double click on the part to edit the feature and go for the option mirror extend. So here 56 mm is the length on both the sides, making this part symmetrically from the center. Say preview and OK. This way we can make the cylinders. Next command we are going to see here is offset command. So for offset command, select the offset command, select the surface you require and put up the value for the offset. I'll say 20 mm offset here. Say preview. It is coming at the outer side. You can see this 20 mm offset cylindrical shape is coming. If I want this to be reverse direction, then there is option, just click on this option here, reverse direction. Say preview, and we can see now it is coming at 20 mm inner sides offset. If I want this offset on both the sides, just click here. I will change the value. I'll say only 15 mm. Say preview again, and we can see now offset of cylinders is coming on both the sides. Say OK and finish. So this was the offset command. We will see on one more example. Now suppose I want the offset here of any particular surface, just select the command offset, click on the offset option and select the surface. Put up the offset value, say preview, say both sides, preview. So this distance of 27 is coming on both the sides. And we have selected the individual surface, that's why offset is coming for only this individual surface on both the sides. Say OK and finish. So this was the lecture for today. We have completed some commands of surfacing that were extrude, revolve, sphere, cylindrical and offset. We'll cover the remaining commands in next lecture. But still, if you want to learn CATIA surfacing in detail, you can join the course here. We are available for offline and online both courses. Even for placements, they can go for domains such as BRW design, plastic design, seating design, or else basics of CATIA, they can join the course here. The number for contact is been given below in the link. We'll continue with the CATIA playlist. Till then, thank you. So hello everyone, today we are going to start with the new lecture of surfacing. In surfacing we have seen extrude command, revolve, sphere, cylindrical shape and offset command. Today we are going to start with multi-sections, then we are going to see fill command, and after that we are going to see blend command. Multi-section command. In part modeling also we have seen this command multi-sections, where we can use two or more profiles which are different from each other and can be connected together. So in surfacing also we are going to do the same thing. We are going to take multiple profiles here on different planes and then we are going to connect them. So we'll start with it. We'll make one profile first on the right plane. I'll take one center rectangle here. We'll delete one side of this rectangle. Make this sketch constraint. Add the dimension here, say 38. Then next we need to define it symmetrically, so I'll select both the lines and the axis. Say the relation in constraint dialog box as symmetric. Say OK and finish. Say exit. Now for the other side of this part we'll take the different shape here. For that we need one plane. Select one reference plane. We'll add one plane here at certain distance. So I'll take this distance as 300 mm. We'll increase the distance a little bit more. I'll set this distance as 400 mm. Say OK and finish. Select the plane, activate the plane and draw the second profile for multi-sections. So this time we'll take a circular shape here. In this way. Now we'll project this entity for reference purpose. Say project entities. Say construction geometry. We'll make one reference line here. We'll take this line and coincide with the center of the circle. Next we are going to provide the diameter for the circle here. Say 100 mm. We'll extend this line and say trim. After drawing the second profile, we realize that this line is not equal to the other side. So for that I'm going to edit the previous sketch again. Say exit sketch first. Double click on the previous sketch and we can see here on one side we have provided the dimension, but on the other side we have forgotten to provide the dimension. So we'll provide the value here also. Say 80 mm only. Now say exit. Again activate the second profile. Now we can see we are having two corners here, but in circle we are not having any corner. So for vertex point alignment we need to add 2 points here as a vertex point. We have one command. I'll make one line passing through the center as well as at the corner point of this rectangle. So we'll make this coincide here. Same line on the other side also, passing through the center and making coincide with the corner of the rectangle. Now as these two lines are passing through circle also, we are having two intersections here. So to make this intersection converted to vertex point, we will use this command, that is quick trim only, but we'll select the third type of this quick trim, break and keep. We'll select this area of this arc, then the second area and this third one. So now as we have used break and keep, this circle is divided into 3 sections that are been broken and kept as the sketch. So by default we'll get this 2 vertex point here. After exiting the workbench we can see these 2 vertex points. We just need to go for multi-sections now. Select both the profiles. I'll select the coupling mode here as vertices. Say preview. And we can see here these multi-sections are being added. Say OK. Now after double clicking we can edit the feature. This time we have selected the vertices as a subtype, but if we have selected ratio also we will get the same result. Sometimes the edges may differ and it will show double corners at any one side. It happens in ratio, but this time it is coming okay. So we can use ratio as well as vertices, both the commands here as a subtype of coupling. But for tangency and then tangency then curvature, we need to have profiles of same shape. Means if you are having one rectangle at first corner, then we require at the other side also as a rectangle shape only. Then only we can use this tangency and tangency then curvature. Means we need similar profiles on both the sides to use this two types, tangency and tangency then curvature. Say preview and OK, finish. Now next, if I want to add one spine here as a guide curve, we can do that also. I'll undo this. We'll hide the other two planes which are not required, and we'll select this plane, say sketch. Now we need to add one guide curve as a spine. So for that, now for the end of this guide curve, we need the two ends here. So for that, we are going to project these entities, say project elements, and say construction geometry. After that, put off the construction geometry and go for this spline now as a guide curve. We can make use of arc also here, but I am going to take spline. Here we have one spline that is connected end to end. Say exit workbench. Again go for multi sections here. Select both the profiles. Go for coupling mode here as vertices. And in spine we can use this guide curve as a spine. Say preview. It will acquire the shape of that spine. Say OK and finish. So in this way, multi-sections can be used in surfacing also. Say hide sketch and finish. Now the next command we are going to see here is fill command. So for fill command, we need one close profile. Either it is having edges on all the sides or it is having sketch. Or if we have mix of both sketch or edges, we need one close profile only to make the use of this command, that is fill. So we are having three edges here, but it is not a close profile. So we need to add one line or sketch here so as to make it a close profile. So we'll use this command, that is wireframe, and in wireframe we are going to use this line command here. This is 3D line in which we can use this option, that is point to point. So by using this option point to point, we can make one 3D line here. You can see. Say OK and finish. There are three edges at three sides and one sketch at the other side. In this way it is making a close profile. So we can go for this option now, that is fill command. Select first edge, this second one and this third one and the last one as this sketch. The three edges and one sketch, making it as a close counter. So now after it is a close counter being shown here in sky blue color, we can say OK, and one surface has been added here, making it a fill portion. Here also if you want to add the fill command, you need to close this profile by adding one line. Select the 2 points, the line has been added. This is 3D line from wireframe. Now we'll go for fill command, select the edge 1, edge 2, edge 3. Now it is showing as 3 edges here. It is because we have divided this profile into 3 sections so as to make equal corners for multi sections. That's why we have selected 3 times here this same profile. This is guide curve 1, 2, 3, and lastly this line, making it as a close counter. Say preview and say OK. Now you can see here, similar way on other side also we'll make one more line here. Say OK. Go for fill command. Say preview and OK. So now it is closed from the other side also. Now for the other side, we'll do one additional thing here. We'll add the vertex point in this fill command. For that I'm going to select this plane and take a reference of that plane. We'll take this distance as 150 mm. Say this plane as sketch. Take this sketch at mid of the screen. And we'll add one vertex point here. I'll take this point here. We'll add this point somewhere here. We'll provide the distance also. So for reference, I'll take this distance as 25. And from the other side, we'll take this distance as horizontal measure. And the distance will take as 40 mm, 140 mm. Say exit sketch and over. Now again go for fill command. Select the edge as well as the sketch. making it close counter. And we have one more option here, that is this fill command will pass through this passing point. Select this box and show this point here, say preview. So we can see here this profile is been made closed, but it is failed to pass through this point. It is because the distance for this plane we have taken little bit more. So we'll decrease this distance here and then again try to pass it through this point. So we'll take this distance as 80 mm only. Say preview and OK. Say update, control U. Now we'll try again. Say fill command, select the edge and this line, making it close counter and allow it to pass through this point. We'll see preview here. Now we can see this surface has been closed and it is passing through that point also. Last time the distance was much more, that's why it was not taking this passing point. Say OK and finish. So you can see here we can use multiple points also here. I have used only one point. So this was close section or field section. Now if I want to apply any appearance, I'll select this apply material option. Go to fabrics or painting. Here we are going to select one color. So I'm going to take this as the red color. You just need to select, drag the color and drop it on the title of the part. Say apply material and OK. Now this material has been applied. You can see it in the model tree. But for the appearance to be shown, we are going to go on view tab, select this option for the appearance, and here we are going to say this third last option, that is apply material. After applying the material, we can see this part, it is appearing here in red color. We'll hide the sketches here as well as the planes. Say hide. Also hide the sketch here. Now you can see this part very clearly. We'll hide this line also. So this was fill command by using passing point. Next command we are going to see here is blend command. So to start with the blend command, we are going to take new part here. Say control new. Say part. We'll assign the name here only. So I'll say this part name as blend, depending on command name only. So a blend command will be used for connecting two surfaces which are offset from each other. So to start with, I'm going to make one surface here. First surface, make one line, give it a constraint dimension, say as 140 mm. Provide the distance from the axis also. I'll take this distance as 15 mm as well as the height. So I'm going to take this height here as 56 mm. Say close and say extrude. I'll say mirror. Distance we are going to take here as 50 mm. And now for the second surface, again say the same plane as sketch. One more line. The distance for this line we are going to take as 200 mm. Next, the vertical distance we are going to take here as 80 mm. And lastly, distance from this axis to this point, I'll take this as 40 mm. Say exit and say extrude. Say preview and OK. Next, hide the sketch. Now we'll use the blend command. This will add the surface between these two offset surfaces to connect them together. So to start with, select the command, select the edge first and the edge second. Both the edges are been selected. We have not selected the supports yet. First we'll see the blend command without support and then we'll see the blend command with support. So it is without support now. Say preview and OK. So we can see here one surface has been added between the two offset surfaces. This was without support. I'll double click it here. If I change the arrow direction, suppose if I change the arrow direction to the other side, say preview, it will show error. So better if you keep the arrow directions on the same side for both the arrows, for upper and lower arrow both. Say preview again and say OK. Now I'll cancel it and we'll delete this blend command. Say delete, say OK. Again we'll go for blend command only. We'll select the first edge and this time we are going to add the support for that edge. So we'll take the support for that edge as the surface only. Then second edge. Now we'll add the blend with supports. For that, select the command, select the edge, and for the support selection we are going to select the same surface of the edge. Now for the second curve I'm going to select the second edge and for the support the similar surface of that which the edge is connected. Now we can see these arrows are also been added here. It is because the surface which is going to come in between will be tangentially connected with both the surfaces. That's why we can see the first continuity as tangency. Say preview, and we can see here instead of taking sharp edges as it were taken in previous type, this time they are not coming sharp. They are coming in tangential position. The corners are coming tangentially here. Say preview and OK. If I change the directions here, suppose if I go for this direction and say preview, then both of the directions are on the similar side. That's why the surface will come in this way. Tangent only, but with the first surface, not with the second one. If I change the direction of this one also, now the arrows are at opposite directions. Say preview, and you can see here, in this way the surface will be connected. That's why we avoid the opposite arrow directions. Again, if we flip the arrow directions, say preview, say OK, the surface will be tangentially connected to the offset surfaces which were taken previously. So in this way, you can use the blend command to add one more surface between two offset surfaces. Now if I remove this blend and add a simple blend without having any tangency, say I'll delete this one, again go for blend, select both the edges without having support selections, say OK and finish. Now you can see the sharp corners are coming here. And if I want to add fillet at these corners, so for that we'll do one thing. First we'll join these surfaces. We can see in model tree all the surfaces are different. Extrude 1, extrude 2 and this blend surface. So we'll join them together and then we'll go to add the fillet. Without joining them we cannot add any fillet here. So join command is compulsory for this kind of surfaces if you want to make fillet on the corners. So first join command, for that we are having this toolbar, that is operations toolbar. So in operations toolbar we are going to select this join command, select the surfaces to be joined. All the three surfaces are selected, that is extrude 1, blend as well as extrude 2. Say preview and OK. Now as you click in the model tree this join command, you can see complete body has been selected all together. Now here in wireframe interface fillet command is not given. So for that we need to change the interface here. So to change interface we'll select start, go to shape design and here we'll have generative shape design. It is little bit different domain here, but the commands are almost similar to surfacing only. So we'll call all the toolbars which we had taken earlier. And here in operations toolbar in shape interface, you can see this command, that is fillet command toolbar, is also added. This was not available in wireframe interface. We are going to change the interface to shape. Now select the fillet tool and in fillet there is second option, that is edge fillet. Go for edge fillet now. You can see these values are coming now. Go for this value and say preview and say OK. Now you can see fillets are being added to this blend surface. But it was possible only when we join the surfaces. If we don't join the surface, suppose if I delete the joint surface here, again delete the edge fillet also. Now the surfaces are not joined, and if I try to make fillet for these surfaces here without joining them, you can see these edges will not be selected here for making the fillets. It is because all the surfaces are not joined and they are separate features. That's why for making fillet, join command is compulsory first. First we need to join all the surfaces which contains the edges where you need to provide the fillets. So I'll join them together again. And after joining, we can see in the model tree, then we'll go for fillet. Select the corners here and apply whatever fillet you want. Say preview and OK. The fillets are applied at the corners. So this was join command with fillet. There are different types of fillets. We'll see them in further lectures. Next is the swept command. So for swept command, we'll take new part here. Say part. OK. Say swept. So in swept command there are total 22 types of swept. All of them are not required always, but for today we are going to see only the first basic type. So we'll make one profile here, say sketch to this front plane, select the center point arc, start point and end point, center, start, end. Next provide the radius you require here, so I'm going to take this radius as 30 mm. Say exit, select the mid plane now, say sketch, We'll zoom out here, and for the first profile we are going to say project entities. Now the arc which was made earlier will be seen as a line in normal view. So we are going to project this arc. It will be projected in the form of line only. Say construction here. This is only for reference purpose we need to project it. So as we get this point to start the guide curve. Now I'll take the guide curve here. Before that, put off the construction mode and then go for guide curve. So we have made one guide curve also now. Say exit sketch, go for this option, that is sweep. So in sweep we are going to see the first category, that is known as explicit. So in explicit also we are going to see only the first type, that is with reference surface. So profile we are going to select this one, and the guide curve we are going to select this one. Say preview and say OK. So in this way you can use this sweep command here with the help of one profile and one guide curve. You can make any shape here. It is very useful while making any kind of plastic product such as hair dryer handles, mudguards for cycles, and many more things. So these were the commands which we are going to see today. We'll continue with the further commands in the upcoming lectures. If you want to join the CATIA course for certification or for placement, you can join in 4 Dimensions Infotech. The number for the contact will be given in the link below. So till then, thank you. So hello to everyone. Today we are going to start with CATIA's next lecture. We are going through surfacing series, and till now we have gone through 2 lectures in which we have seen certain commands like this complete toolbar, that is surface toolbar. We have also seen some commands from the operations toolbar. We have seen join command there, and in join command we have seen how to make fillets on the corners of the surface part. So after seeing all these commands, we are going to proceed with the further commands, that are healing, trim, untrim, and some more commands of operations toolbar. So to start with, we'll again start with join command only. For that we are going to make some surfaces here. Say sketch to the front plane, and we are going to make one sketch here. I'll make one line, single line. We'll exit the workbench and then say extrude command to this line. I'll say this length as 50 mm. Say mirror extend on both the sides and say OK. Next, we are going to say extrude again. Select this edge and provide the direction for the edge. I'll say Z direction, but in the bottom side, so I'll say limit 1 as 0. We can see one more surface has been added in. Next, we are going to go for the third extrude with the bottom side edge. Select this edge, provide the direction, we'll say Y direction this time. I want the horizontal surface here. Say OK. Now there are total 3 surfaces and 2 corners. We want fillets on these corners. So for that we need to change the interface here. Go to start option. Here we are going to select shape and select the option generative shape design. It is kind of surfacing interface only. And here we have this toolbar. So in same operations toolbar, you will get this additional command bar, that is for fillet. So in fillet, we are going to select edge fillet. On edge fillet, if I go for this corners, we can see here, these corners are showing that they cannot be selected. It is because the surface is not connected here. It is not a single surface so that we can provide fillet. So here comes the condition. For providing the fillet, we need a complete joint surface, then only we can go for corners fillet. So first I'll make this surfaces join. For that we are going to use the first command of the operations toolbar, that is join. Select all the 3 surfaces to be joined. Here you will get 2 different conditions such as check tangency. If I go for this option, check tangency, and here if I select these 3 surfaces here again, say preview, it will show an error as there is no tangency being given here. So other command is check connexity. We'll continue on this command only. Say preview, and we can see now it is showing as this complete 3 surfaces are being joined. Say OK and finish. In model tree, expand the model tree, you can see all the three surfaces are being joined together. Now we'll go for the fillet command again, edge fillet, and you will select these edges here. Now they are selectable. Just provide the value you require for the radius. On the other side also, say preview. Say OK and finish. So here we have the complete join surface. Just hide these sketches here. Now after joining the surface, we'll make some more extrude here. I'll say this edge to be extruded, and the direction for the edge we are going to take set direction. We'll provide the dimension for this as 50 mm, so say preview and OK. So we have one surface been added here. Now if I want the thickness to be added on the surface, then you just need to go on start button, say mechanical design and part design. So for thickness there is toolbar known as surface thickness. Just select the option that is thick surface and select the surfaces on which you want to add the thickness. So we are going to select the surface here. Now you can see only join surface can be selected for adding the thickness. This surface we have not joined, so it is not been selected here. If I try to select, then here only thickness will be added to the single surface, not to the joint one. So at a time we cannot select both the surfaces to add the thickness. So from that we can understand that if you want to join the surface, you should select all the complete surfaces and then go for the thick surface. We cannot keep individual surfaces aside and then join together. So again select the thick surface, select the surface to be added thickness and provide the thickness here. Say 11 mm, say preview and OK. So here we can add the thicknesses on the surfaces so as to make them part molding part. But condition is all the surfaces must be joined. After that, we'll undo it and delete this thick surface. We'll change the interface to surfacing, say mechanical design and wireframe surface design. So after changing the interface, we are going to go for the next command, that is healing. We'll make new part here, say part. We'll give the name of the command only for this part, HEALING, healing. Say OK. Now this healing command is used to join the surfaces which are having very intricate gaps in between them and which are to be connected tangentially at that surfaces only. So for understanding this command, we'll make one example. We'll make two different extrudes here. Select the front plane, say sketch, and go for the spline command. Next, exit workbench and go for extrude command. Say this as 40 mm on mirror sides, means both sides, say preview and OK. We'll select the same plane for the next sketch now. First sketch we have extruded it. We are going to go for second sketch. Now I'll try to make it in a same path so as they can become tangent surfaces. So for that, again select this spline here and we'll try to make the alignment same as of the first surface. We'll try to make them tangent only. Now we have made the second sketch also for the tangency. Now here we will assume one gap distance. So for that, provide the dimension between this point and this sketch point. I'll take this distance as 0.7 mm. We know the distance also now. Now I'll go for extrusion of the second sketch also. Make it surface by using extrude command. And here we'll take the same size of it, that is for 40 mm. Say preview and OK. So now we can see here in between these two surfaces there is gap of 0.7 mm. We'll go for heal command now. Select the healing command. Select both these surfaces. Say as continuity as tangent and provide the merging distance as 0.7 mm. And here we can see both the surfaces are now being made tangent here. We can go for point selection also. I'll undo it. And now again go for healing command. This time we'll see the condition as continuity of point. Select the surfaces here and provide the merging distance as 0.7. Even then we can see both of them are connected together. We'll hide these sketches here. So healing command will work in this condition that if two surfaces are to be joined having minor gaps and they are not offset from each other, they are almost tangent to each other, then only we can go for this healing command. If both of the surfaces were made offset from each other and then if we are going to try healing, then it will not work there. I'll undo it and suppose if I try to go for that kind of surface having offset distance, suppose if I delete this distance and make this surface little bit offset, then exit sketch. And if I go for extrude again, say okay, and if I try healing now, having some gap, I will say 3 mm, they are not going to be connected together. It is because the offset surfaces will not work with the healing command. The surfaces which are in alignments that can work for heal command, so as to join them together by healing the small gaps. So this was heal command. Next command we are going to go for untrim command. Before that we need to understand trim and split command. Then we will see this command, that is untrim command. So again, now for trimming I will make one part here. We'll give the command name only, trim and split. So the next command is trim and split. We'll make one extrude here. Select the front plane, say sketch, select one line, go for extrude, say exit workbench and say extrude again. Mirror extend, say OK. Hide the sketch here. We'll make offset of this surface. For that we'll select the offset command. Select the surface to be offset. Make the offset of 50 mm. Now I'll go for one more extrude. Select the face and say sketch. We are going to make one circle here. Say exit sketch. Go for extrude command now. Select the sketch. Limit 2 we are going to say 0. And we'll increase the limit 1 value. Say I'll say 60 here. Say preview. Now we have this extrude bit made crossing both the surfaces here, intersecting both the surfaces. Say OK. You can see here this extrude has been made. We'll hide this sketch, and now we are going to select the command, that is split command. So in split command we need to show two different types of surfaces. That is, the first surface is going to be element to be cut. So I need to cut this surface here, and the cutting element which we are going to use as cutting tool, that will be this cylinder. So here we can see one hole has been made here. If I try to change on the other side, make it other side, then the external surface will be gone and the internal circular surface will remain here. Again, if I say other side, so you can see the difference. The in between intersected surface has been removed. Say OK and finish. After taking this extrude, we are going to select this split command. So in split command we need to show two types of elements, that is elements to be cut, in which we are going to select both the surfaces here. I'll click on this icon for the second surface. We'll add the second surface. Now it is showing two elements, and cutting element we are going to take this cylinder here. Now we can see complete removal of material from both the flat surfaces, and this cylinder is acting as a cutting tool. If I wish to go on other side, means the surface which has been cut here will remain and the other side surface will be gone. Say other side, and you can see the flat surface has been removed and only surface which is intersected with the cylinder from the internal side will remain. So by this other side we can change the directions. Say OK and finish. Now if I want to hide this cylinder, we can hide this cylinder here. Say hide, and we can see both the surfaces are now having holes here. Similar is the trim command, only difference is we cannot hide the objects after trimming. In split command we can hide the remaining objects. In trim command, if you use trim command, then you cannot hide the remaining objects. It is because trim commands merges the remaining objects. I'll go for trim command here. So we'll make one more sketch, select the surface, select the circle command again, say exit workbench and say extrude in Z direction only with the similar length of 60 mm at the downside. Say OK and finish. Go for trim command now. Instead of split we are going to use trim. Now in trim command we don't need to select the surfaces as cutting element or elements to be cut. You can directly select the surfaces on which you want the trim to be work. So I'm going to select all the three surfaces here, and we can see here these two flat faces are cut internally on the bottom side also. But if I say OK and if I try to hide this one as we have done in split command, this will hide complete object. It is because after trimming whatever remains will be connected together as a single body. So if I try to hide this cylinder, this will hide the faces also. So here we cannot hide any object. But if I go for trimming option again, and if I go for other sides to be trimmed, then we can see here there are many more possible conditions of trimming. Here the upper surface as well as the cylinder is gone, and only the lower flat surface and the remaining cylinder is being shown. If I go for other side previous element, then only this surface will remain and the flat surface of the second side also will be gone. If I try to make change on the other side next element now, the upper surface will be shown with the hole and the cylinder, and the lower surface is gone. So here there are more possibilities of trimming, but the remaining surface you cannot hide it here. Now if I change the cylindrical height, suppose if I go for this extrude command again, double click it here, and instead of 60 if I go for 40 mm only, now it is not intersecting the second surface. Say OK and finish. Say update. If the object is appearing in red color, means you need to say update. Control U is the shortcut key for update. Say delete. Now again we are going to go for trim command. In selection we are going to select both the elements, flat surface and cylinder. Here we can see the material is been removed internally from the flat surface and cylinder is also been shown. But if I go for other side, the flat surface is gone. But if I click on the bottom side option, that is other side for previous element, then the cylinder is also been gone. So there will be no need for hiding the cylinder. You can trim both the elements, that is this flat surface also internally as well as the cylinder which was used as a cutting tool. Both the things can be trimmed. So it is better to use trim command only when two objects are to be trimmed together. But in split command we can go for multiple surfaces to trim, as there is a provision that we can hide the cutting tool. So this is the main difference here. Say OK and finish. Now the next command after trim and split we are going to see here is boundary and extract. So to start with boundary, we'll select the command, and the propagation type it is showing here as point continuity. So as soon as I select this surface here, we can see this is showing the individual surface and this surface is individual. So I'm going to select this surface, and here one boundary has been created. If I want to include this surface also as a boundary, so I need to join them together first. So I'll cancel it first and then go for join command, select both the surfaces and then say OK. Now if I go for boundary again and go for the type as point continuity, this complete boundary has been selected. And we can see here this sketch has been extracted from the edges as a boundary. I'll double click on boundary and we'll select this as limit 1 left side and this as limit 2. So only this boundary is being shown now. We'll flip the limit directions. I'll say cancel. Again go for boundary, double click here to edit the feature, and limit 1 this time we are going to take on the left side and this is limit 2. So now this is showing as the boundary here, starting from this point and ending at this point. Say OK and finish. So except this edge, everything the outline is being mentioned here as a boundary. We'll make one fillet, say 10 mm. But we can see here, as the boundary was applied before making this fillet edges will not be counted in boundary. So again I'll delete this boundary here and repeat the boundary command after making this fillet. Say boundary, select point continuity. If I go for complete boundary also, it will show complete boundary, or else if I go for boundary command again and select the point continuity also, it will take the complete boundary. But if I go for this option here in boundary, if I say tangent continuity, then it will continue only till the tangent edges. Now this edge is not tangent with this continuity of edges, that's why this is not selected. Again if I cancel and go for the command, say no propagation, if I select this line, only this particular line will be selected as a boundary, no tangency will be continued or no complete point propagation will be continued here. Say OK, only single line will come. So these are the different types. Complete boundary and point continuity means selecting complete boundaries here. Tangency means selecting only tangent boundaries, and no propagation means selecting only one entity that has been clicked here. Say OK and finish. So I'll delete this one. Go for boundary again, select point continuity, select the surface, limit 1 say left side and limit 2 this side. Say OK. Now I'll make one profile here at this end. So for that we have this toolbar, that is wireframe toolbar, in which we can use this line command. This is a 3D line command. Select this option, go for point and direction option here in subtypes. Select the first point as this reference point and the direction we are going to take here as Z direction. So I'll say right click and Z direction. So instead of going at the upper side, we'll reverse it. Now I'll go for the sweep command. We have profile as well as the boundary. Select the sweep command. This command we have seen in earlier lectures. Just follow the playlist if you want to see this command. Go for reference surface option. Select the profile here as this line, and the guide curve will select here as this boundary and say preview. Say close. Now one boundary is made, you can see complete boundary is being swept here with this line of 5 mm. We have excluded this edge as limit 1 and limit 2. That's why this boundary is not coming along this edge. But except that edge, all the edges of this part are being covered with the sweep. So in this way you can use the boundary command here. If you want to highlight this sweep command, we are going to apply the appearance. Say right click and go for properties. And here in graphics we can apply any appearance here. So I'm going to say, now you can see this sweep properly. We'll hide these sketches. And here one sweep is being made by using boundary command. So in this way we can use this boundary command to generate boundaries around the part. Next command we are going to see here is extract. For that first we are going to delete the sweep command. Next we'll make one more extrude here. So for extrude I am going to select the edge directly, and here the direction we are going to take here as Y direction. Reverse and say OK. We'll go for join command again. Say OK. Now the command extract is used for extracting multiple surfaces from a single surface. For that select the command. Here no propagation. If I select this, only one surface will be selected. If I go for point propagation or point continuity, it will select all the surface to extract. If I go for tangent continuity, then it will show there is discontinuity in this tangency. I'll select this one. I'll right click and say clear selection and select this one. So here it is showing the tangent surface are being taken, but where there is no continuity of tangency, it will show this sign here, making it showing that the remaining surface is not in tangency. Say cancel. And lastly again extract, go for curvature continuity. Next we are going to go for curvature continuity, in which you can select the curvatures here. You just need to click on this icon for continuous selection of the curvature. So similar as boundary, only this is curvature command, where you can extract the curvature only. We can see here. So we'll select one of this. I'm going to select extract only and go for this option, that is point continuity. Say OK. Now one surface has been extracted. Now if I hide this joint which was made earlier, even then one surface is being showing as extracted one. As soon as you hide the joint, the other features which were included in joint will also be hidden. But you can see still the surface is being shown. This is because this is extracted surfaces from the first surface. Means this is the copy of that earlier surface. I'll delete this one, say OK, and show this joint one. Again go for extract, say tangent continuity. So now only the surfaces which were tangent are being extracted. If I hide this join command, you will see the difference. Only the surfaces which were tangent are being shown now. We'll delete this extract 2 again, say OK. Again show the join command. We'll repeat the extract. We'll go for the next type in extract, select no propagation. And when you select no propagation means only individual surface will be extracted here. They will not continue with the tangency or point propagation. Say OK. Now only this mid surface has been extracted. So here if I hide this joint, you can see the extracted surface, only that inclined surface is being shown now this time. So these are the different types of extracts. We'll again delete this extract 3 and show the join command. So these were the different types of extracts. We have one more option, that is multiple extract. Now it is similar to extract command only, but in this we can select multiple extracts at one time only. If I deselect this one, say right click and remove. Now in multiple extract only this bottom side surfaces are being selected. If I hide this join, you will see the difference. This is multiple extract. Multiple surfaces can be selected at one time only. Now this can be done in single extract also. Suppose if I go for this option extract only and no propagation, and if I go for this single surface, only difference is I need to click on this icon and then show the surfaces. So now it will be similar to multiple extract only. Just you need to hide this join. We'll delete all the extracts here and show the join command again. Translate command. So in translate command, you need to select the surface you want to translate. Then select the direction. So I'm going to select Z direction here. And you need to show the distance so as to translate or move the surface. You will have the option that is hide or show the initial element. So this was the initial element. If I click on this icon, show hide the initial element, then the original will be hidden and this copy is being shown. But if I double click on it and say show hide initial element also, then both the surfaces will be shown. Say OK and finish. So we can say here this translate command will work as move and copy command for the surfaces. So these were the commands today we were going to see. We'll continue with the further commands in the upcoming lectures. Follow the playlist for learning CATIA surfacing. Like, share and subscribe the channel. For offline or online courses you can contact us. The number will be given in the link below. We also provide placements in CATIA. If you want to go for BIW domain also, we can provide the placements here. Do contact if you need. Till then, thank you. So hello everyone, welcome to 4 Dimensions Infotech. Today we are going to start with part modeling and we are going to see some models. As we have completed 2 toolbars of the CATIA, we are going to see how to use the tools and make some models here. So to start with, we are going to say file, new. We are going to start with part interface here. Say part, okay. Next we are going to go here and change the interface to surface modeling. For that we are going to select wireframe and surface design. After selecting, we have the toolbars here. And the part we are going to see today, we are going to open that part here first. So we are going to start with this part here. So this part is a simple surface modeling part. We have some parameters been given here. So first we are going to make this part. To start with, first I am going to draw this line that is of 30.5. We'll select the plane for sketch. We'll start with the line now. So this horizontal line, the value here is given as 30.5. Next we are going to go for this vertical line now. So we are going to make one vertical line also here. With the origin reference we are going to take this horizontal to the origin. There is no length been given here. One arc is going to come here, that is going to be tangent with this line. So the length of the line will be defined by default only. Next we have this arc that is of radius 40. So we'll make one 3-point arc here. First point, second point, the third point we are going to take somewhere here. It is going to come tangent with this line. The radius is given 40, so put up the values. Say this radius as 40 mm. Now the height from this base is given 50 mm. Put up that value here. Here as 50 mm. Next, this distance is given as 59. So for this line from origin we are going to take the horizontal distance as 59. Now we have the complete constraint sketch. So it is very important that we should make constraint sketches only, so that there is less possibility of errors here. We are going to say exit sketch, but we can see here when we zoom it, we can see that these sketches are not been connected here properly. So for editing this sketch, we are going to double click it here and we need to connect this one. So to connect this point with this arc, we are going to say coincide relation, say OK. Now say exit sketch. After exit, we are going to go for extrude command here. So from surfaces toolbar, we are going to select this command, that is extrude. Select this sketch. And now the extrusion size is given as 70 mm. So we are going to say mirror extent on both the sides. For that we need to take half value only, that is 35. So the total length now will come as 70 mm. To cross check the length, you can go for the measure toolbar here. Select this tab measure item and you need to select this edge here. So we can see the length is coming as 70 mm. Say OK and finish. Next we are going to make the circle here on this side. So here the circle size is given as radius 27.5. To make this circle, we are going to select the front plane, say sketch. Now for center fitting of the sketch, we are going to click on this icon, that is in view toolbar, command known as fit all in. If I want to flip the part orientation, you just need to click on this option, that is normal view. Again go for circle command now. Here the circle center is given collinear with these two edges. So we are going to take this point on this edge, say the relation as coincide for proper positioning. Next the radius, that is 27.5. So 27.5 into 2 we are going to say here. Diameter will come as 55 mm. Next we are going to say extrude now. So exit workbench and go for the command, that is extrude. In limit 2 we don't want any value here, so I'm going to take this value as 0. And in limit 1 we are going to extend it little further. Say OK and finish. One thing is missing here, that we are not able to see the edges. So for that, go in this view tab and in display styles we are going to select this option, that shading with edges. So now the edges are visible properly. Now for trimming, we are going to select the split toolbar here. Now we can see here this circular portion has been cut from this part and there is no cylindrical shape remaining. So we are going to do the same thing. So here we are going to say elements to cut as this part, and cutting elements we are going to take this cylinder. We can see the transparency is being changed of the outer body, but we are going to trim the inner side. So say other side here. Now we can see here this part is coming transparent, means material is going to be removed here. Say OK. Next we are going to go for the same command, split, but this time elements to cut will be the cylinder and the cutting element will be this part. Say other side, and we can see this upper cylindrical shape has been removed. Now we are going to hide these sketches here. Next is we are going to remove this cylindrical shape here, the cylindrical cutout. So for that, again select this plane, that is right plane, say sketch, and we are going to make one circle here. The center position of the circle is given at 30 mm from the bottom. So put up the value from this horizontal axis to the center of the circle. The value is 30 mm here. We need to make this sketch constrained completely. So here the 20 mm distance is given as horizontal value. Put up the value here. This value is going to be 20 mm. Lastly, we need to give the diameter, making the sketch constrained. So the diameter for this value is given as 30, as the radius is 50. So here the value is taken as 30 mm. So for extrude boss, again select this toolbar We are going to extrude it on both the sides, so mirror extend. Make this value a little bit smaller. I'm going to say 50 mm only. Now we need to remove this cylindrical shape from this body to get this cutout. That is this cutout. We can see here. Now after making this cylinder, we are going to go for split command. Elements to cut, we are going to take this body, and cutting element we are going to say this cylinder. You can see from the inner side this part is coming transparent, means the material is going to be removed from this part, and the cutting tool will be at the cylinder only. Say OK. Now we need to hide the cylinder after cutting this part. Here we are going to hide this sketch also. Now one more thing very important here, that you should always remember the CATIA toolbars. The names of the toolbars are very important to be remembered, because many times when you open the interface of CATIA, the toolbars are being shuffled at the places. So if you are knowing the names of the toolbars, then only you can call the toolbars again here. So after completing this part, we need to go for the appearance. So for appearance, I am going to select this apply material option. Select this command here, apply material, and in painting we are going to give some color here for this part. So I'm going to take this fire red, just drag and drop it on the part title. Say apply material and OK. Now in model tree you are able to see this material has been applied here, but the appearance is not yet changed. So for that, so in view tab we are going to select this display options. And to show the material, we are going to select this option, that is shading with material. And we can see here, this color has been applied. If I want to change the color, just go and select, and whatever color you want, we can go for that. Just drag and drop this color on this part, the title one. I'll say this green onyx, drop it on this part title here. Say apply material and OK. Now we can see here, this part has been applied with the appearance here. So this was the first part we are going to see. Now the second part we are going to see here. First we'll open that part. The next part we are going to make is this part now. So we need to make this part in two sections. First we are going to make this top view here in top plane. And in the front view, we are going to make this curve. Then we are going to merge them together by extruding. And finally, we are going to trim the extra parts or portions to obtain this last shape. So to start with, we are going to say new, mechanical design and part design. So to start with, I am going to select this and say new, say control N, say part, say OK and finish. Now part 2 is this one. So first we are going to make the top view here. So the orientation also I am going to take the same plane, that is top plane. First we are going to make two lines. Make sure that lines are equidistant from the origin. So the total distance here is given as 250 mm. From origin we are going to take it as 125, making them equally symmetric on both the sides. Next put up the sizes here. So this left side line is going to be 100 mm and the other side is going to be 77 mm. Next we need to make this line symmetric from the horizontal axis. So for that we are going to select the points, the 2 points, 2 end points and this horizontal axis. Go for the relation here as symmetric. Do this for the other side also. Say symmetric and OK. Next we are going to go for 3-point arc here. First point, second point and this third point. Make sure that these 2 points are being coincided. The extra entities, if they are going extended, then we should trim them or we should make them coincide first. So here we can see this arc has been extended little bit further. We are going to say it coincide. Say OK and finish. Now next for the other side we can mirror this arc here. So for mirror, select this command, select the arc, select the axis. Next we need to go for the radius. So the radius has been given here as 1000. Put up the value. Now we can see these corners are been given as fillet with radius of 25. And on the other side both the radius are going to be of 15 mm. So we are going to make fillets. One more fillet on the other side. Put up the values here, say 25. Now there is no equal relation been given, so we are going to make them individually as dimensions. Here also we are going to go for fillet on the other side. Say double click on this fillet command, that is corners. Select both the entities and click here. It will give a warning that relation is going to be break. Just say it OK. And now the radius here we are going to take as 15. On the other side also as 15. Now we can see here this complete sketch has been constrained. So we are going to say exit workbench and we are going to go for extrude command. But the thing here is that we are in part modeling interface. We can see the toolbars. So even if you are in other interface, you can go for the wireframe and surface in between also. Say start, say mechanical design and say wireframe and surface design. The toolbars above are being changed now and the interface is now of wireframe. Just select this extrude command, select this sketch, and now we are going to extrude it. So the height of extrusion here is given as 30 mm. We are going to take little bit more here, other than 30 we are going to say 40 mm. Say preview and OK. Now after completing this extrude we are going to hide these sketches here. Now for the second part we are going to select this plane, say sketch. Next we are going to make this arc here, that is of 750 mm. For that we need to project these corners, these edges. But as they are circular in shape, the regular project entities will not project these sketches here. So for that just go here and say project 3D, see out edges. Click here on both the sides. And we can see here these two lines are being projected. Select both the lines and make them construction geometry. As they are going to be for reference purpose only, that's why we have said construction geometry. Next, for the arc, select this 3-point arc. Make sure that you are not going to start this arc from the center of this line. A little bit above, first point, then this second point somewhere here, and this third point. But as we have not put off this option, that is construction geometry, the arc is coming in construction mode only. So first we need to put off this option and then go for the arc. First point, this is the second point, and this is the third point. Now this arc height is going to be 30 mm. You can see here maximum height of this part is going to be 30. So we are going to take this arc height as 30 from this horizontal axis. So here this size is going to be 30 mm. Lastly we need to say this 2 points symmetric with this vertical axis. And put up the radius value here. So the radius here given as 750 mm. We are going to make this single arc only here. We are not going to make the lines here. These vertical lines from the bottom. It is because when we extrude this by making this line, then this surface and this line surface after extruding will be overlapped. So avoid making lines here. Only arc is required. And say exit workbench and go for the extrude command. Push these values here. Say mirror extend on both the sides and say OK. Finally, we are going to trim the extra entities remaining as we have taken a little bit larger dimensions. So for that, again go for the split command. Say these elements to cut as this body, and cutting element we are going to take this surface, the curved surface. Now the bottom side has been removed. We need to remove the above side. So for that we are going to say other side. Say OK. You can see the above side has been removed and the height now is going to come as 30 mm only. Next we are going to remove the extra faces here, this corner side faces. We only need the inner side surface here. So for that again go for the split command. Say elements to cut as this one, and cutting element now this time we are going to take this one. Say other side. Say OK. And finally we have this shape here. We can see this shape. We are going to hide these sketches again. If you don't need the planes, we can hide the planes also here. Say right click and hide. We'll take this mid plane to show. We'll take this right plane here. Select this plane and say sketch. Next we are going to make this rectangular shape that is of 150 mm by 5 mm. This height for this rectangular shape is given as 5 mm. We can see here in this view. So say corner rectangle and go for this rectangle. Make this line as construction geometry. We don't want this line to be extended or extruded as it will create one unnecessary surface. So to avoid that we are going to say this line as construction geometry. Then put up the values, say normal position first. So this value here is given as 150 mm. Say both the side of this rectangle symmetric with this vertical axis. And this height we are going to take here as 5 mm. Finally we are going to say extrude here. So we can see no bottom line is been made as it may create one unnecessary surface here at the bottom which we don't need. That's why no line to be made here. Say extrude now. Say OK. We have taken a little bit extra only material here so as to make it trim properly. Next we are going to go for again split or trim. This time we are going to select trim command. So either split or trim, we can use both of them. So we are going to select trim this time. Now in trim command there is no need to say that which element you want to trim and which will act as a cutting tool. You just need to select both the elements directly. And we can see here this extra portion has been cut. Say other side. So the extra other side portions are also been cut, this one. We can see here in transparency we can see. So the extra remaining portions are also been cut here. If we click on the other side option, say OK. And we have this object here. Just hide this sketch and go for the appearance. Hide the planes also. Now in appearance we are going to apply a little bit different color here. We are going to say this blue color. Just drag and drop it on the part title. You can see in model tree this appearance has been applied. Say apply material and OK. Say Ctrl S and we can save the part wherever we want. Say save. Go for isometric view here to make this part properly arranged. The other part was this one. So these were the two exercises we were going to make. We'll continue with the further exercises and some toolbars remaining in CATIA surfacing. So this was the lecture for today. If you want to join the courses for AutoCAD, you can join in 4 Dimensions Infotech. The contact number is given below in the link. You can contact us and you can go for the domain courses also. We also provide placements in mechanical design. So anyone, if you are in need of the placements also, you can contact us. Till then, thank you. So hello everyone, today we are going to start with the surfacing series next lecture and we are going to continue with the part practice. So to continue with the part, we have this sketch here. We are going to make this part in surfacing. So first we need to make this profile. The first line is horizontal, then this tilted line, again lastly this tilted line. So we'll start with the software. Select the line command. We have selected the front plane earlier only and now we are going to make that profile. We need to put this horizontal distance as 135. Say right click, say horizontal measure. Put up the value as 135. Next we need to put this angle that is of 50 degrees. And this angle will be of 150 degrees. We can see here the values are given as 50 and 150. Next we need to put the heights here. So the overall height of this line from the origin will be 150 mm. This value will be 150. Then this point value will be of 112. Here it is given as this corner will stay on 112 mm. So this value as 112. Next constraint will be of this point, that will be of 90 mm. And now this sketch is completely constrained. We can see here it is showing in green color, means this part is completely constrained. We'll exit the workbench. We can see now in the side view the distance is given as 80 mm. So the total width will be of 80 mm, but here one angle is also given, that is of 12 degrees. So if I take the center line, that will be 6 degrees on each side. So we'll make this extrusion by 80 mm. We'll take it little bit larger here. Instead of 80 we are going to take 100 mm. You will understand it later why we have taken it 100 mm. So select the extrude command, select the line, say mirror extend, and the value we are going to say here is 50 mm. So total will be 100. As we have selected mirror extend, say OK. Next we need to select the side plane now. Say sketch. We'll flip the side here. We need to make one line here now. This point will be coincided with this edge. Say coincide. Next we need to give the angle. Double click the constraint and here we'll put the angle here as 6 degrees. As the total angle is given 12, the half will be taken as 6 degrees. We'll put up this constraint for the dimension from the mid side. So total was 80. I'm going to take this value here as 40 mm. Now this line is completely constrained. Angle is 6 degree and the distance is taken as 40, as this total distance was 80 mm. Next we'll say exit workbench and we need to say extrude now. We'll not take limit 2 here. Say I'll say this limit value as 0. We only need limit 1 value. So here the distance is given as 135, maximum distance. So I'll take this value as 135 only. We can see here this extra portion is remaining. Later we will trim it. Now next we are going to say mirror for this face here. So this surface will be mirrored on the opposite side. So for mirror we are going to select this operations toolbar and here we have the option that is symmetric. We need to select the element and then we need to select the reference plane. Say OK. We can see this other part or other side is been made. We are not going to make this complete profile and then extrude, because if we do that, the surface here will be overlapped. If we make this complete profile and then extrude, that's why we had made single face here and then we have mirrored that face so as to avoid the overlapping over this surface here. Next we need to select this mid plane, say sketch. Now we'll say project entities first. Project this line in construction mode. Then put off the construction mode for further geometry. Next we need to make this line here that is tilted by 20 degrees from this vertical line and then the other second line. Select the line command and then the last line. We'll put up this value. It is taking 90 degrees, but we'll delete this angle here and go for the value as 20 degrees from this vertical. Now the height for the intersection of two lines here is given as 56 mm. So we are going to take this point and line as 56 mm. Value. After this value we need to give this angle here. So the angle is given as 125 degrees from the horizontal. Put up this value as 125 degrees. Lastly, we need to extrude this line now. We have only made two profiles, that is this first line and the second line. Other things we have projected here for the reference. Say exit workbench and go for extrude command now. We need to extrude it on both the sides. I'll say mirror extend here. Say OK and finish. Next we are going to make the extra parts trim here. We'll select the split command here. Elements to cut, we need to select this surface and cutting element will be this surface. We need to say other side. As it is looking transparent, this surface will be removed. Say OK. Do this on the other side also. Say split. Elements to cut and cutting element will be this surface. Say other side and say OK. Next we need to remove these extra corners here, these triangular corners. Select the split command. Elements to cut will be this surface and cutting element will be this surface. Say other side and say OK again. Do this for the other side also. Say split. Elements to cut will be this corner and a cutting element will be this surface. Say other side. Now it is coming transparent. Say OK. Now we need to hide these surfaces here. Next, this remaining corners of the upper side. So for this horizontal corners, select the split command. Elements to cut will be this surface and cutting element will act as this right hand side surface. We can see here this corner is showing transparent now, means we can say OK. Go for the other side also. Elements to cut, this one, and cutting element will be this surface. Say OK. And finally we need to cut the upper corners now. Then we'll get the shape which we require. Say split. Elements to cut will be this surface and cutting element will be the mid surface. Say other side. Now the upper corners is being removed. Say OK. Do this for the last side also. Elements to cut and cutting element. Say other side and say OK. And now we have finally made the shape which we require. Hide this sketch. Now to make the fillet on the corners, we can see here there are some fillet on the corners. We need to join the surface first. So I'll join the surface here. Select all the faces and say OK. After joining this surface, we are going to go for fillet. For that we need to change the interface. Go for the shape option. And here we have the option that is generative shape design. And in generative shape design, we need to go for the operations toolbar. And here we have the option edge fillet. Select the second option. Now here the radius for this corner, upper corner is given 25 and same value will be taken for this lower corner. And for this vertical edges, we have this value here as 12 mm. So here first we are going to select these two edges. Say this value as 25 and say preview. Say OK. Next we are going to go for this edges now. So the value for this edges is given as radius 12. We have seen here this value is given as radius 12. So go for this value as 12 and select the required edges. Say preview and OK. After taking this shape, we are going to go for boundary command now. Now next, over all these front corners, we need to make this flange here. For that, we are going to select the boundary command. So we'll go for the boundary command now. In operations toolbar, we have this command that is boundary. We need to select this edge. And you can see this option is given as point and continuity. If you want to see this command in detail, you can refer the previous lectures which are been given in playlist. Now we need to select limit 1 and limit 2. So I'm going to select this point as limit 1 and this one as limit 2. We only need this front side edges. That's why we have selected these limits here. Say OK. But before taking this boundary, we have forgotten one thing, that we need to make the fillet here also. We can see here this fillet of radius 30. But the fillet here is for this vertex points. At this vertex point we need to give fillet. So it is not possible to use this command edge fillet for this vertex point here. So we need to make one extrude and then we are going to trim it for making this fillet. Finally we will get the result as a fillet here. For that we are going to select this mid plane. Go for this sketch. Say project entities to both the edges. I'll say project here. make them construction. They are for reference purpose for starting and ending the arc. Put off the construction later and then go for the 3-point arc option. Here in circle tab, there is 3-point arc starting with limits. First point, second point and third point. We need to go for tangency here. Say tangency and then put up the value for the radius. So we are going to take this radius here as 30 mm. We don't need to close the sketch. We just need single arc here. So only one arc is enough to extrude. Say exit workbench and go for the extrude command. Say OK. Next go for the trim command. So here we have the option split. Elements to cut, we are going to say this surface, and cutting element will act as this surface. It is removing the mid portion, we are going to say other side. Say OK. Next we need to go for one more split and we are going to remove these corners with that split here. So say split command again. Elements to cut, we are going to select this surface, and cutting element this time we are going to select this mid body. We can see here these corners are looking transparent, means they are going to be removed. Say OK. Now the remaining portion in between we are going to say hide, and finally we have this radius of 30 mm at the corners. Not by using the edge fillet but by using extrude command, and then we are going to split them. Now we need to go for this flange. We can see here in this sketch we have the flange at the front side. The height is given as 14 mm. So we need to make one sketch here by using 3D line. So in line definition, select the option as point and direction. Say the direction here as X direction, as we are going to make this line somewhere here, and then we are going to make it sweep along this edge. But one more thing, before making it sweep, we need to make one boundary around this edge, and then we are going to go for this line. So I'll cancel it for this time. Select for the boundary command and select the front edge. This will show us the complete boundary, but we don't need the complete boundary. We need this flange from this point continuing with this side here till this last point. This backside portion we don't need flange here. For that we are going to say limit 1 and limit 2. So we have this option in command itself. Say this as limit 1 and this as limit 2. This limits option are given in boundary command only. Just say OK and finish. So we can see here this white colored line being shown here as a boundary till this point. This portion has been removed by using this boundary command and limits. Now we are going to make that line. Select the line, and this line is from this toolbar, that is wireframe. We are not going to take 2D line. This is a 3D line. We just need to select the line command and go for the direction. So I'm going to select this line command, select the starting point, and here we need to provide the direction. So here the direction is going to be X direction, as we are going to make this line at this side, at left side. So click on this option and say point and direction. We have selected the point. Just right click on the direction option and say as X direction. The height of this flange is given here as 14 mm. So I'm going to take this value as 14 mm only. Say preview. Say OK. Now we have this line and this boundary, this combined boundary. You just need to go for this option, that is sweep command. So here in surface toolbar we have the option that is sweep. Select the sweep command. We need to select the profile. So I'm going to select this line as a profile, and guide curve we are going to select this boundary. Say preview and say OK. Now this flange is being made around this surface. We can see here, and we have made this flange after completing all the fillets here. Before that we don't need to make the flange first. Now as this flange is not a part of this complete body, we need to join them together so as to make them a complete part. And this joining is much more needed for the fillet here, because at this edges, at this joining edges, fillet is given. We can see here in sketch, at this corners fillet is been given. Before that we need to join it together, then only we can provide the edge fillet. So again join command. This command we are using for the second time now. Select the flange and the body. Say OK. After joining, we'll go for this fillet command now. Select edge fillet. And you need to select the edges. Before that, you need to hide the sketch and then go for the selection of edges, or else the edges selection will not be possible properly. Again, go for the fillet option, say this radius as 5, select the reference edges. As you select one edge, the selection mode is on tangency. This complete edge will be selected by default only. Say OK, and we can see here radius 5 fillet has been added at all the corners. This complete corner around the boundary. You just need to hide the sketch, and here this part has been made. Now only cutouts are to be remaining. So I'm going to select this mid plane, say sketch for the cutouts. The circular cutouts we are going to make it now. So here this circle is given of radius 10 with the height of 34 mm from the downside, and horizontal it is placed at 26 mm. So here one circle with radius 10. Go for the circle command. One circle. We need to define the circle properly. I'll say this diameter as 20 as the radius was given 10. Say OK. And from the bottom side, this height is given as 26 mm. So say 26 mm. And from this vertex point till this corner, this horizontal distance, here it is given as 26 mm. The height is 34 actually, this vertical height. So I'm going to correct it, say 26 for the horizontal, and for this vertical we'll say 34. Next circle, it is somewhere here. From the bottom side it is at 120 and horizontal it is 23. So the next circle, now the size for the circle, it is not given here. We are going to assume that value. So we'll take this value here as 8 mm. So the distance horizontal is given 23 and vertically as 122. So this value is 23. Now the vertical distance from the bottom side is 122 mm. So I'll say this value as 122. It is completely constrained now, the circle. Next this hole. Here also the diameter or radius is not given. So we are going to assume this value here as 25. One more circle. Diameter will take here as, we are going to assume this diameter as 26. So one circle with the diameter of 26. This will be the last circle. Say this diameter as 26. Now positional dimension, it is given at 69 from the bottom side. So here 69 from the bottom side. Next, horizontally this dimension is given at 95. So this dimension as 95 horizontally. We are going to say exit and go for extrude now. Say OK. Select keep all sub-bodies elements and say OK. Lastly, we are going to select the split command again. Most of the time we have used split command. It is because lastly the remaining part we can hide it here. But if we use trim command, the remaining parts we cannot hide as they get merged with the main body. That's why split command is more efficient. Elements to cut, we are going to say this body, as we need hole on this body, and the cutting elements will be the cylinders. Now we can see in between of the circles the portion is showing transparent. Say OK. Means these holes are been cut now. Lastly, we can hide this portion now. Remaining portion say hide, and we have this cuts on the body. Say hide on this sketch also. And finally we have made this part. If you want to provide the thickness for the surfaces, now we can go for the thickness. So for thickness option, say start and go for part modeling. We have changed the interface for surfacing to part modeling, and here we have the tool for surface thickness. Say right click, and here we have the option that is surface based features. So we need to search that toolbar. It is here, surface based features. I'm going to select this option, thick surface. Select the surface. It will ask whether you want to add the thickness at the outer side. That's why the arrows are showing at the outerwards. Or else if you want the thickness to be added at inner sides, just say reverse direction. All the arrows will be reversed here at the inner sides. I'll say reverse on the outer side only, and we'll say this thickness as 2 mm. Say preview and say OK. If you want to change the value, I'll say 4 mm, and lastly say preview and OK. Now the surface part is also being shown. So if you want to hide this surface, just expand the model tree and hide this join here, this edge surface also. Now this part is shown only with thickness. We can see here. We'll hide the thickness again and show the body again. Now if you want to add the appearance here, just go for the apply material option. You can add the material, or else if you want you can add the appearance for the color painting, stone, wood, whatever appearance you want you can add there. So I'm going to select metal and we'll select this option, that is silver. Click it and drag it on the title of this part. So select the material, drag and drop it on the title of this part in model tree. You can see here silver now is showing in model tree also. Just say apply material and OK. And for appearance, to show it with material, go on this view toolbar and here at the third last option from the bottom side we have shading with material. Just click on this option. We can see here this metallic finish is being shown on this part. So this was the lecture for today. We have made this part. We can see here this part has been made. We'll still continue with some more parts. So for CATIA surface practice, follow the playlist and continue watching the lectures. If you have not subscribed yet, then do like, share and subscribe the channel. Till then, thank you. So hello everyone, today we are going to start with the other lecture of surfacing, in which we are going to go through one more part of surfacing. We are going to make one TV set. We can see the image here. So we are going to make one TV set here by using surfacing tools. So for making this TV set, we are going to go through multiple features of the surfacing tools. So that will be the practice for surface tools also. We'll start with mechanical design and we are going to select wireframe and surface design to start surfacing. We'll say TV casing here. Say OK. Now first thing we are going to make here is this profile. Means the cross section of this part you can see here. The values for these are given here. So one horizontal line with length of 12 mm. At the bottom side one 22 mm line, horizontal only. And the distance between both the lines is going to be 100 mm. Later we are going to make one arc of radius 125. So let's start with the model now. Select the front plane, say sketch. And first we are going to make one horizontal line. The length for that is going to be 12 mm. So I'll double click here to change the length. Next one more line at the lower side with reference to the origin only. So this distance we are going to take here is 22 mm. Upper one was 12 mm, this one is 22. The distance between these two lines is going to be 100. That will be the vertical distance. So here the distance between these two lines, vertically it's going to be 100 mm. Next we need to make one arc also here. So for making an arc we are going to select circle tab and here we have 3-point arc. 3-point arc starting with limits. Double click here. First point, second point and this third point. So the radius for this arc is going to be, I'm going to give this here radius here as 125. Say 125. Say exit workbench. Now I'll say extrude boss. So extrude command and we need to make it extrude by total 100 mm. It is not given here. We have one more diagram for the reference. So here we can see this total width of this TV case is given 100 mm. As well as the height is also given 100 mm. So this width is 100 mm. We'll say 50 mm and symmetric extent on mirror sides. So that the total distance will by default come 100 mm. 50 mm on one side and 50 mm on the other side. It is because of this mirror extent. Say preview and OK. Next we are going to cut these corners. For that one we have image reference here. So I'm going to open this image. We can see here. We'll zoom it a little bit. We need to make one arc or we can make a circle also with radius 50. So here we need to establish this point and make one arc or circle with radius of 50 mm. Distance of this point is 5 mm from this vertical edge. I'll make one sketch here. Say sketch. We are going to take one circle. The radius for this circle is given 50. So I'm going to take this diameter as 100 only. Say 100. Next we need to position this point properly here. So from this edge the distance is given as 5 mm. We'll take this distance as 5 mm. So here we can see one sketch has been made and the 5 mm distance is taken from the front side of this casing. Next we are going to say extrude to this circle here. Say exit workbench and go for extrude command. We don't need direction or limit to, we'll say 0. And the length we are going to say here is 100 mm. Preview, say OK. Now we can see here, after making this cylinder, this is the extra portion we need to cut. We can see the corner sides of this flat face above side are also to be cut here. This portion as well as the upper side little bit, these corners are coming outside. So they are also to be trimmed or cut. For that we are going to use split command here. So for split command, select the command, say split. And elements to cut, I am going to select this mid body. And cutting element that will act as the cylinder. And now we can see the outer side of this mid body part are showing transparent. We need to confirm it. We need to see the corners also. So now this corners are also showing transparent here, means they are going to be cut. Say OK and preview. Lastly we have cut this corners and the above corners also. We can see here no extra corners are remaining now. We'll hide the cylinder later. It was the cutting tool, we'll hide it later. Next we need to hide this sketch also now. So here we have this main section, center section of this TV set. We need to make this backside portion now. Now after cutting that corners, we can see the shape. I'll say this side view here. Now we can see this shape, it is cut in a curved manner. At the above side also, suppose if I say top side here, in top side also you can see this curve is coming now. It is not a straight edge, it is curved now. As the above corners also been trimmed. After making this cut, we are going to go for the back portion here. So we can see here, this back portion we need to make. We are going to use loft command for this. And the profile we are going to refer this image here. So we need to make one line first at the mid plane of this body. So we'll go on the model. Select the mid plane. So this plane, that is the YZ plane, is passing through the mid. I'm going to select that plane and say sketch. And we need to make one line here. Something like this, and we can see the values are given here. From the bottom side this point is given 60 and the above side also this point is given 60. The angle here is taken as 20 degrees and the horizontal distance is given 20 for the starting point of the line. Say constraint for dimensioning. From the bottom side it is given 60 mm and the other end point of the line from the upper side is given also 60 mm, same value. Next the angle. So for the angle we are going to take this horizontal reference and this inclined reference. Say this angle as 20 degrees. The starting point we are going to set 20 mm here. So I'll take this line little bit backside and continue with the constraint dimensions. So these 2 points, right click and say horizontal again. We are going to take this value as 20 mm. Now this line is completely constrained, we can see here, it is not movable. If you want to confirm whether this sketch is constrained or not, we have one more toolbar here. So this toolbar name as tools, we are going to select the last option, sketch solving status. Now it is showing ISO constraint. So in this way also you can confirm whether your sketch is constrained or not. We'll place it above here and now say exit workbench. Now we need to make 2 rectangles at 2 endpoints of this line. So first we are going to make one rectangle at the back side. We need to take one plane here. For that we have this image reference. We can see here this backside rectangle is showing here. And the rectangle's above side is coming at the line's end point at the back side. And the rectangle size is given as 50 by 40 mm. So let's make it now. So to start with, we need to take a plane here, select the wireframe toolbar and select the plane option. Here we'll select the line and then we need to select this point. The plane will come normal or perpendicular, we can say, to this line. Say OK. And now say sketch to this plane. Make it normal at proper side. And we are going to make one corner rectangle here. The size for this rectangle here is given as 50 by 40 mm. So double click on constraint toolbar, select the side of that rectangle and we are going to take this value here as 50 mm. And this height we are going to take as 40. It is also shown in the figure that the rectangles above top side is coincided with this line's end point. We can see here in this sketch, the rectangles above side is coincided with the end point of this line at the center. So we need to say coincide relation here. I'm going to select this point and line and we need to go for the constraint as coincide. Next we need to make it normal and say symmetric to make it at the center position. So I'll say it normal here. Select both the sides of the rectangle, select the axis here and say symmetric relation. So the rectangle will come automatically at the center of this body. Now after constraining and making this rectangle, we need to go at the other side. We need to follow the same process. Say exit workbench, then select the wireframe toolbar first and we need to select the plane option, select the line and end point here. So the plane will come perpendicular. Say sketch to that plane. Make it center align at this screen. Now we are going to make the other rectangle. We are going to take the corner rectangle only. Now next, here it is a little bit faint image, but we can see here this above rectangle or the bigger rectangle, it is having 9.5 mm distance from the upper side of the smaller rectangle. Both the rectangles upper sides are at 9.5 mm apart. So we'll take the value here 9.5 mm. This line and this line, we are going to say it as 9.5 mm. We need to make this rectangle also symmetric with the center axis or vertical axis. Say OK. Next we need to put up the value for this rectangle. So the sizes for this rectangle is given as 65 horizontally and 60 vertically. This distance is given from the center as 32.5, half of 65 mm, the total width. So we are going to take this value and make it constraint here. So this distance is given as 65 and this distance is given as 60 mm. Next say exit workbench and now we need to make a multi-section here. So the toolbar we are going to use here is surfaces and in that the second last command, that is multi-section surfaces. Select both the profiles. But here we can see the closing points are coming at the opposite corners. They are coming at upper side only, but at the opposite corner. One closing point is at the first rectangle at right side and second one is at the left side. So we need the direction of the closing point at same point corners only. So I'm going to make one point replaced here. I'll select this point, say replace, and we are going to replace it in front of this closing point, the above one. So now they are coming in place front to each other. Say OK. We also need to see the arrow directions of these rectangles. They are coming both at the left side only. Say OK. So now this multi-section has been made. We can see here. But this extra portion we don't want it here. So we are going to say trim. These extra portions also as well as the in-between portion also we need to say trim. So for that we are going to use trim command only now. This time we are not going to use split command, we are going to use trim command. Select both the entities in between which we want the trim to be occurred. So I'm going to select this face and this body. Say other side. We don't want this to be trimmed. Say other side here also. And now we can see this mid portion and this extra portion is going to be trimmed here. So till the time we don't get the result for the trimming which we want, we are going to click on these other side options. One combination you will get which is going to be this one. Say OK. And these two extra portions, that is this mid portion and the corners, are going to be trimmed now. So now the extra portions are been trimmed. So this is the main shape we required here. After completing this, we are going to hide the planes and sketches which we don't require here. We can see here. But one issue is coming, that even after making this multi sections, the corners are not been connected properly. As we can see, these edges are little bit twisted here. It is because of the multi section cross section selected. So I'm going to click on this command here to edit it feature. And here in coupling, we are going to select the mode as tangency or tangency then curvature. So instead of ratio, it was selected ratio earlier. That's why these edge issues are coming. So to solve that, we are going to select tangency or tangency then curvature. These two options are to be selected when the two profiles are same, means rectangle on the other side also and the same side also. Or else if you are having both side circles, then we can go for this tangency and tangency then curvature. Both sides of the loft are same in shape, then we can go for these two options. Say OK. And now we need to say update as it is showing in red color. If the part is shown in red color, we need to say update. So shortcut key for update command is Ctrl U. And now these corners are repaired properly here, we can see. So after making this part, we are going to make these sides close here. These sides are to be made closed. We can see here in photos also, the sides are closed by the panels here. So we need to close that sides, both the sides, right and left. But it will only work when the sketch or boundaries are completely closed, then only. So we need to make one line here. The other boundaries we are having these edges, but we need one line here to close it. So in wireframe we have the 3D line option. We are going to select this line option, and here we are going to use this option, that is point to point, to make the 3D line. So your point to point only, select the first point and the second point. We can see here this line is coming, say OK. Now at one side there is line and on the other sides edges are there, so as to make it a closed profile. These were the conditions for fill command. We'll apply the fill command now. Select the fill, select the lines, then the edges. And while using this fill command, the selection should be such that all the figures are to be selected one by one in the cycle mode only. Means we cannot jump from this line to directly this edge. We need to give the selection in the cyclic mode, that is first line, then this edge, then the upcoming edge, and then the last edge. It will show close counter, say preview and OK. So now we can see this side panel is also been made. Same we are going to do with the other side also. Select this line, select the point to point option and select both these 2 points of vertex points. Say OK. Next we need to go for this fill command now. Select the fill command, select this edge, this line, this other edge, and lastly this edge, making it a close counter. Select in cyclic manner only, say OK. And this other side also has been made now. Hide the line sketches. OK. Now we need to close it from the back side also. So for that again we are going to use same command, that is fill. Select the edges in cyclic manner. When this close counter option appears, it means we can say OK now. Next we need to make this cutout here. One cutout is here in there. So we are going to make this cutout. So this cavity we can see 5 mm deep, having corners rounded by 1 mm. That round corners we are going to give it at last. And this cavity shape is given rectangular at the back side by the sizes of 20 by 10 and depth is 5 mm. So we are going to make that rectangle on this face. I'll flip this side here first. Next we are going to make this rectangle. The placement dimensions are given 20 by 10. So we'll take these dimensions here, make it fully constrained. This size is 20 mm, this one is 10 mm. And for positioning dimensions, the values are given 5 by 5 from the left and bottom side. So here we are going to put that dimensions 5 by 5. From this side it is 5 mm. From the bottom side also it is given 5 mm. Making it a complete constraint sketch. Say exit workbench and go for extrude by making it extrude by 5 mm. So here we are going to say extrusion by 5 mm only. We can see here it is extruded it by 5 mm at the internal side. We need to cut the extra portion here. So for that we are going to say split command. Say elements to cut this one and cutting element this extrude. So we can see this in between material is going to be removed. Say OK. And finally we have this cavity also here. So according to the shape we have completed the body here. Lastly we need to give the fillet at the corners. For that we are going to give 3.5 fillet on all the 4 sides here, and the remaining edges we are going to fillet it by 2 mm. But for fillet it is compulsory for us to join them together first. The all bodies should be joined together. So we are going to say join command. We are going to select all the joints we need. Say these 2 sides also and say OK. Now after everything is joined we are going to go for fillet. So fillet option we are going to get this option in different interface, that is generative shape design. And here in generative shape design we have this operations toolbar. Here we are going to get this option in operations toolbar at the 4th number. The type we are going to select the second one. We are going to say this fillet says 3.5 mm all the 4 corners. For this back panel, say them 3.5. Say preview and OK. Next, all the remaining corners are going to be filleted by radius 2 now. We have selected face instead of edge. Just remove it and go for the edge selection only. Zoom it properly and then only select. Sometimes the face may get selected and that will not be proper for the selection. All the edges we need to select here. Only this internal edges are remaining. The radius size for that is different, so we are not going to select them together here. Say preview and OK. The radius we need to take here 2 mm only, so we are going to update it. We have taken 3.5 here. Just double click it for updating and change the value. Next, lastly we are going to go for the radius 1 fillet on the internal side of this cavity. So again fillet command, select all the 4 sides, give this fillet as radius 1, we'll confirm it here. So here all the round is of 1 mm, we can see corners rounded by 1 mm. So it is 1 mm proper, say OK. But still these 4 corners are remaining that are also to be added by 1 mm. So I'm going to double click the feature to edit. We are going to add this all internal 4 corners also. Zoom it little bit. Select these corners now and say OK. Now this complete body has been made. We are going to apply some appearance here. So for applying the appearance we have this apply material option. Just click on it. So in painting we are going to select any color here. I'll say this color as dark green. Just drag and drop it on the title of model tree. We can see here this color has been applied in model tree. We can see it here. Say apply and OK. Now to show the appearance we need to change the view style. Select the third last option, that is shading with material. And we can see here this material has been applied. If you want to apply the thickness, we can apply the thickness also. But we are not going to apply the thickness here. You can see this complete appearance is being shown. So this was the part for today for practicing the surfacing tools. We are going to continue with some more parts for the practice for surfacing. So till then, thank you and continue watching the playlist for CATIA and continue learning the CATIA tools. So till then, thank you. So hello everyone, today we are going to start with another toolbar of the surfaces. For now we are seeing CATIA surfacing and we have completed the surfaces toolbar as well as operations toolbar. Still some commands are remaining for the surfaces. So today we are going to see the toolbar name as wireframe. Basically wireframe stands for 2D and 3D sketches. Then we can apply the 3D features on them. So to start with, first we are going to see the point command here. So in point command, just click here. We don't need to select any plane. It will ask you the X, Y, Z references for positioning the point. So for the first point, we are going to take X, Y and Z as 0 only. Say OK. So we can see at the origin one point has been created. We'll go for the second point now. Select the point option and here we are going to put the X distance as 60 mm. Again select the point. Next we are going to take the Y distance as 60. So X and Y are going to be 60. So this point will be placed somewhere here. So this is the X distance and this is the Y. That's why X and Y as 60 mm placed here. Next point again. This time we are going to take Z also as 60 mm. So we can see here Z is coming as 60. Next we are going to take Y 60. Other values as 0 only. So here these 4 points at the base are being made and one point at X and Z distance. We are going to make one cubical shape by the help of points here. So next YZ as 60 and say preview. Say OK. Next X and Z as 60 and Y is going to be 0. Say preview and OK. Lastly Z is going to be 60 and X and Y are going to be 0. Say preview and say OK. We'll hide the planes here. Say X, Y, Z planes to be hidden here. Now we have this point coordinates. If we join them together with 3D lines, it is going to be seen as cube here. So we are going to select the 3D line from the wireframe toolbar. Select this line option and we have the line type as point to point. So we are going to select point to point. This is the first line. At one command you are going to make only one line. Say OK and finish. Then for the next line again we need to repeat the line command by type as point to point only. Say OK. Here also. And lastly this line, the upper line. So this is the line command connecting by points to points. We can also go for line command by point and direction option. So point and direction, select the point. And now this time I want the direction to be taken here in this way between these 2 points. So the direction here will be Z axis. So I'll say the direction as Z axis. Say right click and say direction Z. Here we need to give the length also. So I'm going to take this length as 60 mm. So it is coming 60 mm at the upper side. I'll say reverse. So we know it is going to connect at 60 till this point only as the distance between the 2 points was 60. Say preview and OK. So one more line with direction option. So in this way by point to point and direction we can make 3D lines. We also have one more option here in lines, that is polyline option. So we don't need to say one by one line. We can directly click on the points and line will be created here. So I'm going to select the points all together. and we have this line here, but it is going to be combined single line. Here all the lines were separate individual lines. Here it is going to be polyline, means combined line. So the difference we can feel in polyline and single line set that if we try to make fillet here, 3D fillet, we'll have the fillet option also here in the second last option. Just go for this corner operation, and here in corner if I try to make the fillet between these two upper lines, so if I try to make fillet with radius of 10 mm, and if I say trim elements to corner, so the corners will be trim. Say preview and OK. We can see here one fillet between these two lines is been made of radius 10, trimming the corners. But if I try the same thing on the set of polyline, it will not take fillet there as it is a combined single line. So if I try to select one line, it will be selected as a set. So this is the drawback of polyline, that no fillets can be made as it is a single line. So it is better if you want to avoid the corners and make fillet, then you can go for single individual line only, not with the use of polyline. Say cancel now. We have one more option here, 3D spline. So in 3D spline, we are going to select the points in such a manner that this will be the first point, this will be the second point, this will be the third point, and this will be the fourth point. So we can see here one spline in the shape of curve is been made here, starting from this point, coming in this way and ending at point 4. Say OK. So now this is a spline being made here, 3D spline, by using points only. Next thing, if I want to close this spline, we have the option here for closing also. So in the second last option below fillet command, there is connect curve. So we need to select this connect curve. We need to select the point first and then spline. Then again the last point and the spline. So here we can see this two spline ends are connected with one curve here. If I want to reverse the direction, I can reverse the direction here. On the other side also I can reverse. So here this spline is coming now from the upper side. We can see here it is coming from this upper side. If I want to reverse the direction and take it below direction, so just say reverse on both the sides, and now it is coming from the downside. So we can reverse the directions of the end curve connect to connect these splines. So one shape or profile is being made by the use of splines only. Say OK and finish. So in this way we can use splines also. After that we are going to see 3D circle. So if I want to make one 3D circle, I can go for that also. You just need to select the circle command. It will ask you for one vertex point or center point. So I'm going to select this corner as a center point. So this corner has been selected as a center point. Now we need to select the plane reference, or we can select the support reference here. So right click here and I'm going to say I want to make this circle on XY plane. So on XY plane, this circle we can see here in orange color being shown. Now for size, if I want to change the radius, I'm going to say this radius as 60 mm. Say preview. So we can see in orange color, this half circle or semicircle is been made with the radius of 60 at XY plane. If I want to change the plane, instead of XY, I'm going to take YZ plane. So now it is coming on YZ plane. If I want to change the plane again, I will say XZ plane. Now it is coming at XZ plane. So we can change the plane here. If I want complete circle, not a partial circle, then we can go for whole circle command. So this complete circle is coming now. We can see in orange color here on the plane name as ZX plane. Say OK and finish. So this was circle command. Now we'll delete this circle, as well as we are going to delete the splines here. Connect spline and spline. And now we need points and plane repetition on one single curve. We'll take this line as a curve and we are going to make some points equally divided on this curve or line with having some planes also perpendicular to them. So we are going to take this option, points and plane repetition. You just need to select any curve. So when I try to select this one as a single line, as it was made by polyline, it is not selecting a single line here. So I'll try this on upper line. Just select the line and you need to provide the instances to be equally divided on that line. So I'm going to say 5 instances we need. After giving 5 instances, we are going to select this option to create normal planes also. So I'm going to on this option here, just say preview, and we can see now This line curve is divided in 5 different sections: first, second, third, fourth and fifth. Also planes are coming normal to them. Just say OK and finish. So this command was for making the points on any curve, maybe a line, maybe a spline, maybe an arc, and we can make equidistant point with planes also. And here the thing is that points will be made equidistant, but planes also will be added with them. So this is the speciality of this command, that is points and plane repetition. Repeat one more time. Select the curve, divide the instances. This time I'm going to say 6 instances and just say create normal planes also. Say preview. And now we can see after making this fillet, this complete curve is selected as one entity and the planes are coming equidistant by the number of 6 we can see here. Say OK and finish. So this was the option points and plane repetition. Next option we are going to make helix here. Now for helix we are going to take new part. I'll put the name here as helix only. Say OK. We need to select one plane and put one point here. That point will act as the endpoint of the helix. We just need to select the plane, say OK and put one point. This point will also represent as the radius from the axis. So the distance from this point to this axis will be taken as radius for the spring. So I'm going to take this 20 mm. Now after taking or placing this point at 20, if I try to make helix, then the diameter of the spring will be 40 mm. Say exit workbench, go for the helix command. It will ask for the starting point, so I'm going to select this point. Now it will ask for the axis, so I'm going to select this vertical axis, that will be Z1. So I'm going to say our axis as Z axis. Now it will ask you for the pitch, so I'm going to say this pitch here as 5 mm. And the height we are going to take for the spring here as 120 mm. Say preview. If I want to make this spring taper, I can add the taper angle also. So we can see here, now it is coming 3 degrees taper. So here also it is been seen, little bit taper in shape. If I want this taper to be acting as outward side, so I'm going to take this as outward. So now the taper is coming outward by 3 degrees. If I want to increase the angle, I can increase and we can see the change here in model. Now it is taking 6 degrees taper. If I want them inside, so inward. If I want outside, so outward. If I don't want taper, I'll just say 0 degrees here. Say preview and OK. Now this profile with the helix command has been made. So we are going to shift this interface to part modeling. There we are going to apply the sweep command, which is also known as rip command in part modeling. So to shift, I am going to select the start button, say mechanical design, and we are going to say part design here. The interface will be changed and we are now in part modeling. We are going to apply the rip command here. For that we need to make one profile at the end. We also need one plane so that we can make that profile. So here at this end point we need one perpendicular plane. For that we are going to select the plane option, select the curve first and then select the point. So you will get one perpendicular plane here. Say OK. Now select this plane and say sketch. Next we need to make one circular profile. As we are going to make spring, the cross section of spring is always circular, that's why we have made this profile as circular. Next we need to select both the points of the circle and center. Then we need to select the center point of circle and this end point. Say coincide here. Say OK. We'll provide the diameter for this circle. So I'm going to take this diameter here as 2.5. Next, after making the profile, say exit workbench and go for the feature rip command. Select the rip. First it will ask profile, so I'm going to select this profile. Then it will ask the center curve, in which we have to select the spring profile. Then say preview and we can see the profile is being swept along the path made by the helix. Say OK and finish. This was helix command. Now after helix, again we are going to change the interface and go to wireframe and surface design. I'm going to delete this part body. Say right click and say delete. Say update, say Ctrl U for the update. So the next command we are going to see here is projection command. This command is useful in such conditions. We can see here in image, one part has been made here. This part is not completely flat. It has one diversion at the upper side and then it is continued as a flat surface. So if I want to make this swept, we can see here this swept feature has been applied on this surface, but this surface is uneven, not flat. So if I want to create a sketch of 245 mm, we can say a line, then we cannot create a line on this uneven surface directly saying sketch. So to solve this problem, we will take one parallel plane from this surface above, and on that plane we are going to make one line that will be of 245, and that line which is made at the upper side in the flat plane will be projected on this uneven surface by using the project command, or we can say by using the project feature. So we'll take this example only. So to make this profile, we are going to select the plane, we are going to select the front plane, and we are going to make this profile first. And then we are going to add one line, and that line will be projected on this rectangular face. So to start with, select the software, select the front plane, say sketch, and make one line. The starting point of this line will be coincided with the horizontal axis. Next, we are going to take these inclined lines here in this shape. We can see this shape here. So this distance is given as 110 and the total distance is 340. So we are going to select the values here. Say this distance as 110. So it is 110 here, 110. And the total distance here it is given as 340. Take this distance as 340. We'll drag this profile a little bit inside this point also. Next, this height we are going to assume it. We'll take it as 40 mm. And this angle we are going to take here as 135 degrees. Now this distance we are going to take 90 mm, and the other side angle also as 135. Next, we'll move it and see what dimension is remaining now. So it is not coming symmetric. Again we are going to add the symmetricity here. Select both the endpoints and the center axis. Go for the relation as symmetricity. Say OK. Now say exit workbench and we are going to make it extrude. We are going to make it extrude by 50 mm on mirror extend sides, so that the total distance will by default come 100 mm. Say OK and finish. Now we need to add some fillets here. As we have made all the surfaces in one single extrude, we don't need to make it join here. We can directly go for fillet. Just change the interface, go to shapes, and here we are going to continue with generative shape design. In operations toolbar, you will get the fillet command here at 4 number, this second type. So the fillets we are going to take here as 30 and 20. So this corners we are going to take as 30 mm fillet, or else we'll continue with the same size of 30 on 4 sides. Say this value as radius 30 and finish. Next we need to hide the sketch here. This feature was made by using rip command and making one profile at the cross section. But for that we need to make this path first. But as this surface is uneven, it is not a flat surface, we cannot directly say sketch on any one surface and make a line here. The line should be length of 245 mm. So directly flat line is not possible for making the rip command. So here we will introduce this command, that is projection. For projection, first I am going to take one plane from this top plane's reference. Add one plane here, it should be above the surface. Say OK. Height we can take anything here, say sketch. And now we are going to add one line. It will start somewhere from here at mid portion and we are going to end this line on the other side. So the distance, we are going to take this line's length as 245 and from side this distance is given as 40 mm. So this is 245 mm length, say 245, and this distance from the end side is 40 mm. Now this value make the line fully constrained. But this line is been made on the upper plane, we can see. It is not projected on this surface. So we are going to say project, just exit the workbench and go for the command, that is project entities. In project entities, first we need to select the projected, that will be this line, and the support surface we are going to select this one. Say preview. But we can see here This line is being projected here in a normal form. Projection type is normal. So this line is not coming completely as 245 mm line. For that we need to change the projection type and say along a direction, and we need to add the direction. So by seeing this axis system we can say this direction is Z direction. So just right click on this option and say Z direction and say preview. Now we can see here the starting points are coincided with each other. Starting is same and the ending will also be same, coincided at the same points. Save, preview and OK. Now we'll hide this sketch here, and from the top if we observe, we are going to arrange this view in top view. For that select the view and say top orientation. We can see here this line is now been projected on the uneven surface with the same length of 245. This length will be same. If I want to cross check it, I'll just select measure command and we are going to select the type of measurement as points only. On the second side also points only. Select the first point and second point. We can see this length has been maintained as 245, but we have made it on this uneven surface, not a flat surface. So in such conditions where uneven surfaces are there, we can use this projection command. Next command we are going to see here is intersection. For that I am going to select this face and say sketch. Now for intersection I am going to make one line and we are going to say extrude on this. Exit workbench and say extrude for this line. So after extrusion, we'll hide the sketch here. We'll hide the early sketch also. But now you can see there is no edge formation or any intersecting sketch between these two surfaces. But if I want one intersecting sketch on these two surfaces, exact on the intersection, then we are going to go for this command, that is intersection. Select both the surfaces, say preview and say OK. Now at the intersection of both the surface we have this line here. Just say extrude it, select the line. In the direction we are going to say Z direction. And we can see here one extrusion is coming with length 50. If I want to increase this extrusion on both the sides, we can increase it. Just because we have made this intersecting line on both the surfaces which are intersected. That line was obtained using intersection command. Say OK and finish. So in such cases we can use intersection command here. Lastly we are going to see this extrapolate command. So for extrapolate command, suppose if I make one sketch here, I'll say part, new part, name I'm going to say extrapolate only, say OK. Now make one extrude here by using spline. Say escape and go for exit workbench and say extrude. Now extrusion we are going to take as mirror extent on both the sides. Say OK and finish. Now if I say extrude to continue this edge as a surface tangent to this previous surface, we cannot do that. We are going to select this edge and for direction we have only these three options X, Y, Z. If I select Z also, then this tangency is not been continued here. So limit to as 0, but we can see these two surfaces are coming as intersected surfaces, not continued as a tangent surfaces. So to avoid this, there is a command known as extrapolate. So I am going to delete this surface and we are going to continue this surface extrusion by tangency. For that we are going to select the command, select this boundary and select this extrapolated surface as this surface which was previously extruded. And you just need to add the length now. Say I'm going to say as 100 mm. So we can see here this surface has been added but in tangency with the previous surface which was extruded. So in this way we can continue with the extrusion by maintaining the tangency with the other surfaces using extrapolate command. So these were the commands for today. We are going to continue with the lectures. We are going to see the sweep and sweep types. Some more types of sweeps are remaining now. We'll see in next lecture how to make use of some more sweep types. Till then you can follow the CATIA playlist. And if you want to join the course for placement, you can join the courses here. The number for contact will be given in the link below. You can join the courses for placement. You can also go for BIW and surface design courses. You can go for domains such as plastic domain, BIW domain, sitting domain, We also provide placements in that particular domains. So if you want, you can contact us and join the courses online or offline. Till then, I'm going to say thank you. So hello everyone, today we are going to continue with surface lectures, and today we are going to see the types of sweep command. We have already seen one type of sweep command, that was the starting type, the first type. Today we are going to continue with the other types. So we'll make one sketch for starting this command. Select the plane, say sketch. We need to make one arc here, so I'm going to make center point arc. Select the center point, then start point and the end point. We'll repeat the first type also today. Now the endpoints of this curve are coincided with the horizontal axis. We need to give the radius first. So we are going to apply the radius. The radius we are going to take here is 50 mm. Say exit workbench. Now one profile has been made. Next thing we require is path. Here we are going to add one path by using spline. We can use spline, arc, line, whatever thing we require at that time. So I am going to select this spline here. But to start with the profile, we don't have any reference of the profile here. So we'll select the profile first and say it project entities. So we'll get the reference point or starting point. Next we'll put up this construction here and go for this spline command. Say escape. So now we have one profile as well as one path. Say exit workbench and go for the sweep command. So here you will get the first category, that is explicit. And in explicit the first type is with reference surface. So in here with reference surface you need to show the profile and guide curve. So here is the profile and here is the guide curve. Say preview and you will get the sweep command applied. One more option is given here, that is this relimiters. These options you will get in every type of sweep command, where you can apply the relimiter in the same way as we are going to see now. So for using this relimiter, we need to add some planes here before that. We'll cancel this command for now and we'll add some planes here. So I'm going to take one reference plane from this front plane. I'll take this plane parallel. So the distance we are going to take here is 50 mm. So here we have one plane. This plane will be for relimiter 1 and we are going to add one more plane for relimiter 2. We are going to select this plane for the reference and we are going to add the plane at the distance of around 200. That will be minus 200. Now we have these two planes here added, acting as relimiter 1 and relimiter 2. Again go for the same command, sweep. Select the profile first and then we are going to add the guide curve. Say preview. But this time we are going to add the relimiter also. Select this relimiter. Say this relimiter first and this plane as relimiter 2. Say preview. So we can see this profile is starting from the relimiter 1 and ending at relimiter 2. Say OK and finish. So in this way we can use relimiters. This option will be available in every type of the sweep command. Next we are going to see the second type of the sweep command and we are going to hide this one, this guide curve, and we are going to make two more guide curves here on the top plane. So I'm going to select this plane and say sketch, and for having the ends we are going to make this earlier made profile, that is this profile, to be projected as line. So first make it normal in condition and then go for projection. So I'm going to say project entities and make it construction. It is just for reference purpose. So we are going to add one line, put off the construction and then go for the line command, or else the other line is also going to come in construction only. So this will be the first line and this line here, this will be the second line. Say enter and finish. We have these two profiles now. We can say two guide curves only. Say exit workbench and then go for the command. So select this command. Instead of reference surface we are going to go for with two guide curves. So profile we are going to say this one and the guide curve one we are going to select this line. But we can see here, as we are selecting the left hand side guide curve as a line, the second guide curve is also been selected. So this is the error we need to show you, so that you need to understand that these two guide curves are to be made differently on different sketches but on the same plane. We can see this error is coming. Say OK, cancel this feature and say edit sketch. And instead of having this second guide curve in the same sketch, I'm going to delete it. Say exit workbench Select the same plane for the second guide curve, say sketch. The difference is only that we are making two guide curves in two different sketch, not in the same sketch. Say sketch to this plane and add the second guide curve. Again we need this point, so we are going to say project entities, say construction geometry, put off the construction geometry later and then go for the second guide curve. We have added the second guide curve also here. Say exit workbench. Now we have this mid profile and these two different sketches guide curves. We'll go for the command now with two guide curves. So profile we need to select this one, and the guide curve one will take this guide curve as we have made this earlier, and then we have made the second guide curve, so it will be selected as second only. Say preview, say close. You can see here this part has been made. You can add the delimiters here also by taking plane or surface reference. This time we are not going to add. This option will appear in all types of swap here. We have seen in starting only how to apply this. We are not going to repeat it again and again for every type. Say OK and finish. So this is the swap command using two different guide curves. Next we are going to go for swap and third type, that is with pulling direction. Profile we are going to select this one only, and guide curve we are going to take this one. But here the extra thing we are going to add is direction. And in direction we need to select the direction which is perpendicular to this line. That will be this y1, this y axis. So we are going to select direction as right click and say y. Always keep in mind that if you are using this pulling direction option, this direction should be always perpendicular to the guide curve we have made. That's why we are going to take y direction as it is coming perpendicular to this guide curve. Say preview and say OK. So this is the another way of making swap by using guide curve. Next we are going to delete this swap again. Say OK and finish. So the next category we are going to start with now is line category for swap command. So to start with the line category we are going to take new file. Say wireframe and surface design only. We will make the part name as by the name of category only. Say line and say OK. We are going to take and select the top plane here and say sketch again. We are going to make two lines here. So this will be the first line. We'll make it coincide with the origin. And the second type we are going to make one more line only, starting with the same reference, this inclined line. So here the distance we are going to take here is 200, and angle we are going to take, if you want angle or if you don't want angle, in any case we can make this swap here. I'm taking this line inclined just for an example. Say exit workbench, but notice that we have made both the lines in same sketch. We'll see whether it is possible to take them as two different sketches or not. Select the swap command and select the category as line this time, and we will see this first type, that is with two limits. So as soon as I try and select this first line, we can see both the lines have been selected. It means that if you want two different guide curves, then you need to make this two line in two different sketches only, not in this same sketch. So as soon as you select, it will show an error. Say OK and cancel, and we'll edit this sketch here. We'll cancel this line and make this line in another sketch. Say exit workbench. Again select the same plane, but this time in different sketch. Select the line command, select the reference point as same starting point. We are going to end it somewhere here. Now we have two different sketches. Again we can put on the angles. I'll take the same angle as 15 degrees. I'm repeating that it is not compulsory to make this line in inclination, but just for the example purpose I am going to take this incline. Say exit workbench. Now we have two different lines in two different sketches. Go for the swap command and select the second category, that is swap using line features. So the first type is by two limits or two lines we can say. Guide curve 1 we are going to take the first line, and guide curve 2 we are going to take the second line. Say preview, and we can see here the swap surface has been added between the two lines, but here some extra surface is also been added by 20 mm reference. This is because the length 20 is by default been added here. So if you want to extend these surfaces by two ends we can extend it by using this length 1 and length 2. Just we need to add the value here. So if I don't want, I'll take this value as 0 only. You can see here. If I want to extend this surface on both the sides, I'll just double click for this feature and I can add this length here. So length 1 will be added from the guide curve 1 and length 2 will be added from the guide curve 2. This will extend the surfaces further in both the directions. So I'll say this value as 50 mm from length 1. You can see here this 50 mm is extra added here. And for second also we are going to add this value, say preview and say close. Say OK and finish. So this 50 mm is further extended from both the guide curves, that is from guide curve 1 and guide curve 2. This is optional if you want to extend, or if you want to take 0, you can take 0 values also. So any further surfaces will not be added here. That is totally optional. Next, I'll delete this sweep again. Now the second type of this category, we'll select the sweep command and we have this category named as limit and middle. So here the guide curve 1 will select this one. It will act as limit 1 and this guide curve 2 will be acting as middle, and the same amount of surface will be added on the other side also, as this line will be in middle of the surface. Say preview. You can see here same amount of material is added on the other side also, and this second guide curve, that is the sketch, will act as middle reference. So this was limit and this was middle. That's why the surface is coming on other side also. Now for the third type also we are going to delete this sweep. Say OK and finish. After limit and middle we are going to see with reference surface. So for reference surface we need one guide curve, we can see here, and one reference surface also. But at present we don't have any surface. So we'll add some surface here by using the earlier command, that is with two limits. So this limit 1 and limit 2. We don't need the limits here, so I'm going to take the limit values as 0, 0 only. Say preview and OK. Now with reference surface we are going to select the guide curve. We can select any of them, the boundaries as guide curve. So I'm going to select this one as guide curve 1. And the surface, support surface, we are going to select the same surface which is connected to this guide curve 1. We also need to add the length here. So I'm going to add this length as 50 mm. Say preview. But it is getting merged in the same surface. So we are going to change or say reverse direction for this length. You just need to select this arrow. So the direction will be reversed. You can see here. You can also add the angles here. So I'm going to take this angle as 45 degrees and say preview. So now the surface is coming at 45 degrees incline. We can see here this value. The surface is nothing but the length we have added 50 mm by the support surface. We can change the quadrants here. For the angular sector, I'll say previous. Now it is showing in red color, means it is going to be updated. Say preview and you will see the quadrant of this angle has been updated. I'll say previous, that will be the first quadrant. Again say preview. So now it is coming at the lower side. If I go for the fourth quadrant, say preview, it is coming now in this quadrant. So here one by one we can edit the quadrants. Just you need to say previous or next. Say preview again. So in this way you can add the reference surface here. Say OK and finish. So this was the type in line category by using reference surface. You only required one guide curve and one reference surface and the length 1 to be added. You can add the length 2 also here. It will come on the opposite direction of this length 1. If I say length 2 also by 50 mm only, same length, say preview, it will come on the opposite side. Here also the quadrants will be changed if I change this angle sector. You can see here. So this was swept command using line category and reference surface option. Next type we are going to see here. We will go to the previous sketch only by this window. We have already made one curve here. I'm going to delete this swept and I'm going to delete this line also here. We'll take one plane for the second reference. So in the other category, we'll select this swept command and we'll see the next type after reference surface we have with reference curve. So in reference curve, you need one guide curve and one reference curve. Two curves are needed here. So I'm going to cancel it and add the second reference curve. We'll take one plane here for adding the second reference curve. Select this plane and we are going to make it reverse in direction. Make this value as minus 300. Now on this plane we are going to say sketch. So for this type you need two different planes and two different sketches as guide curves. First we have already made and second we are making it now. So this time I am going to select the line only, simple line we are going to make here. And now I'm going to say symmetric this two endpoints of this line with the middle reference axis. Say symmetric, say OK. Whatever length you require you can give it here. I'm going to say 150 mm. Say exit workbench. Now we can see we have these two sketches. This one is arc which was made on front plane and the other guide curve is made in the form of line on the other plane which was taken parallel by 300 mm distance. We'll go for this type now. Select the swept command. Select the second type category as line and here the option we are going to take is with reference curve. Guide curve 1, select this one and reference curve we are going to take this one. Say preview now. It is showing error. It is because we need to add the length also here. So I'm going to add the length. We'll take this value a little bit here. Say 60 mm value and say preview. Still it is showing error. So we'll do one thing. We'll cancel this command and again go for the swept, but this time we'll change the selections here. Earlier we have taken this arc as a guide curve and this as the reference curve, but this time we are going to take this line as a guide curve and this reference curve we are going to take this earlier made arc. Say preview. We can see here it is coming on the reverse side. I'll make it switch on this side here. Just click on this arrow option and say preview with adding some length. I'm going to add this length as 90 mm. Say preview. So we can see here this length 90 mm. This will be starting of the surface and the width of the surface is not been taken by the reference line's width. It is taken according to the width between these 2 points. You just need to increase or decrease the length. We can see the change after that. So I'm increasing the length here. You can see this number has been increased to 162. Again say preview. So we can see here as this surface is getting closer to this reference curve, it is going to take this shape here. First it has been started with the reference as flat only as there was only line here. But the second reference curve was in the shape of arc. That's why this shape is also been changing as the length is been proceeding further. Again make this length little bit more here. Say preview. And we can see this arc is coming in the form of this shape only. As close you are going to get here, this shape will be changed and will come closer to this one in shape wise. The total distance was 300. I'm going to take this as 300 only directly. Say preview. So we can see here it is getting attached to this reference curve. So this was the option using reference curve. You can see here started from the line as a guide curve and ended at the reference curve which was an arc. Reference curve shape is been carried forward. So this was step using reference curve. Next type we are going to see here is with tangent surface. So for that I am going to delete this swap. Say OK. Delete this sketch also which was made as this line. We don't need this now. And we are going to make this arc extrude. This will act as the reference surface. We will take this length here as 300 only. After extrusion we are going to select this top plane. Now the endpoints of this curve are lying on the top plane. So we need to make one line that will be on the same plane where these endpoints are. So that plane is top plane. I'm going to select the top plane here, say sketch and make one line here. We'll take this length of the line also as 300 mm only. Say this line length as 300 only. Say exit workbench. After taking swept command, we are going to change this type and take the next type, that is with tangent surface. So in with tangent surface, guide curve 1 we are going to take this line and the tangent surface we are going to select this surface. Say preview. And we can see here by the reference of the guide curve one surface has been added, that is tangent to the earlier surface. And now if I want to remove this extra surface which is coming after tangency in between, by clicking on this option, that is trim with tangent surface. Say preview and the surface which is coming in between will be removed. Say OK. Say close. So one tangent surface has been made by removing the extra surface. So I'll say OK and finish it. Next type here we are going to see here is with draft direction. So for draft direction, again I am going to delete this sweep, say OK and finish. We'll show this sketch, the earlier sketch 1 we have shown here for the next type of sweep. So here sweep command, the type you are going to see is with draft direction. You need to show the guide curve and then we need to show the direction. So direction, we are going to add the direction here as x direction, which is going to be perpendicular to the profile we have made. So here for direction I am going to select x reference. You also need to give the limit here. So I am going to take this limit as 200. Say preview. If I want to change the direction, I am just going to click on this arrow. Again say preview. The direction is coming on opposite side. But the sweep here is coming is similar to the extrude command. What makes this command different is the angle. So I'm going to add the angle here. I'm going to set 10 degrees. So this will be swept along with the 10 degrees angle, inclination angle. Say preview. And we can see here, this inclination angle is coming at the bottom side. If I want to change the angular sector, I'll say next one and say preview. So this angular sector was third one, I am taken fourth one now, say preview. And we can see here, now the draft angle is coming at the upper side or outer side. If I again go for the previous sector, say preview, this time the angle sector is coming at the inner side. So in this way we can make this sweep command work along the direction by using these angles here. This is the thing that is being changed in this type, this angle. Say 15 degrees now, say preview and change the category of angle sector. So now it is coming swept by 15 degrees incline and with the length of 200 mm. Say finish and OK. Now for the next type, I'll delete this sweep here and make one extrude. On the reverse direction we'll say and say OK. We'll make same sketch again on the same plane, that is on the front plane. Earlier this size was of radius 50, so I'm going to take the size radius 50 again. We'll make one more arc with the same size. The radius value I'm going to take 50 only this time also. And the center to center distance we are going to keep here is around 160 mm. So half will be 80 mm. Say exit workbench. Say extrude on this curve also. Say reverse direction and OK. Now the center to center distance was 160 mm. We are going to add one mid plane here in between these two surfaces. So I am going to take one plane to add this mid one. Total distance was 160, so I am going to take this distance as 80. To allow this plane to be positioned between these two surfaces, we are going to take this length as 80 mm. Say OK. I'll select this plane and say sketch again. And here we are going to make one guide curve or one spine we can say. For that I am going to say project to this line, project curve. Make this project curve as construction geometry only for reference purpose. And then we are going to make one line here. This line will act as one spine or we can say one guide curve. Put off the construction mode first and then go for the spine, making this one line. So this line will act as spine. Say exit workbench and go for the sweep command. Type we are going to change and say with two tangent surfaces. Where we can see this option spine. So I am going to take this line as a spine. First tangency surface I am going to take this one and second tangency surface we are going to take this one. Say preview and we can see here one surface has been added between these two tangent surfaces, making that third surface also tangent with the other two surfaces. Here if I want to trim these inner sides of these surfaces, I will say trim with first tangent surface, this option, and also click on this option that is trim with second surface also. And these two inner surfaces will be trimmed, first and second. Say OK and finish. If I want to hide these sketches here, we are going to hide them. We can see here with sweep command having two tangent surface, we have made this surface here.
We have already seen the half types of the sweep command and we are going to continue with the remaining half types. So we'll start with this sketch for the next type. To make this sketch, I am going to select this plane, that is this top plane, say sketch. And here we are going to make one line first. We'll make it fully constrained by adding the dimensions. I'm going to say the length as 100 mm. Also one horizontal distance from the line to the axis. So we are going to take it around 60 mm. Say exit workbench. Now the next type we are going to see here is swept along 3 guide curves. So here we need 3 guide curves in which we have made the first one. Still we need 2 more guide curves here. So I'm going to cancel it, and in this same plane but having different sketch we are going to make one more line. Say sketch, one more line here. I'm going to take the same length. So double click on the dimension and we are going to put here the length as 100 mm, and distance from the line to the axis we are going to take it 60 mm. So we are having 2 lines here on the same plane but in the different sketches, not in the same sketch. If we try to take the line in the same sketch, both the lines, then they will be considered as a single sketch, not a different profiles or different guide curves. Say exit workbench. That's why we are going to take them separately on same planes. Now for the third guide curve, I'm going to select the right plane, add one more line here. Length we are going to take 100 mm. And the height we are going to take here is 50 mm. Say exit workbench. After making the guide curves, we are going to go for the command, select the swept command. Here we have seen the 2 categories, explicit and line, and now we are going to start with the third category, that is circle. And in circle, the first type is 3 guides. So we have made the 3 guides, we are going to select them one by one. Guide curve 1, I am going to select this one. Say guide curve 2, we are going to take this one, and guide curve 3, we are going to select this one. Say preview. Now according to selection, this was the first one, that's why it is starting from here, and this line was the second guide curve, so that's why it is passing through the second guide curve and then it is ending at guide curve number 3. But if I change the order, suppose if I change the order, I'm going to cancel it first. We'll repeat the command swept. Now show the guide curves. This is guide curve 1. This time we are going to select guide curve 2 as this mid one, and then the last one as guide curve 3. So this pattern will be now the first, then the second, and then the third. So in this path we are going to make this surface here. Say preview. We can see here, this was the first selection, this was the second, and this was the third. So it depends on the selections of the guide curve how we are going to apply the surface, in which direction it will start and what will be the mid and end of this surface. Say close. Say OK and finish. Now the second type in this category is 2 guides and radius. So instead of 3 guides, now we are going to go for 2 guides and 1 radius. I'll cancel this swap. Say delete. Select the swap command. Select the second type, 2 guides and radius. So the 2 guides we are going to take, the first one, this one, and this second one. So here the distance was 60 at one side and 60 on the other side. Means the total apart distance between these 2 guide curves or lines we can say is 120 mm. So I'm going to cancel it. And we are going to take this radius little bit more value. I'm going to say this value as 90 mm. Say preview. So here we can see here the surface has been added according to the radius 90. If I say OK, we can see this surface is coming. Now while adding this surface, there are going to be multiple solutions. We can say there are going to be 6 solutions here, in which first one we have seen. If I say next and say preview and say OK, so this will be the surface which is going to be appear here. Again we'll change the next solution. Double click on the swept command. Say next. And now we can see in this orange color, this surface is showing from the bottom side. So this surface will appear here if I say OK. So this is solution number 3. Again double click for the editing. Now for solution 4, I'm going to click on next. Now this orange portion which is remaining will be shown here as the number 4 solution. Say OK. And we can see this surface has been shown here. Double click and go for the next solution, number 5. Say OK. This complete circular surface has been shown in between these 2 guide curves. Say close. For editing and going for the last type in this swap, double click on this feature and this 6 number solution, the upper circular surface. Say preview. Say OK. And we can see here, now the circular surface which was coming at downside is now coming at upper side. So these are the 6 solutions which can be added between these 2 guide curves using this type of feature in swap. That was between 2 guides and radius. Radius was we have taken 90 mm. Just we need to make sure the radius that is going to be taken should be more than the half distance of these two lines. Means the distance between these two lines, suppose it is 120, so radius should be minimum 60 or more than that. Means half of the distance between these two lines should be half or more than the half. We'll cancel this swap now and go for the other type. So the next type in swap command we are going to see center and two angles. Before that, first we are going to hide the planes here. And then we are going to go for the command swap. Here the center curve we are going to select this one, this line. And the reference curve, which will be the starting curve for the reference surface, will be this line. We'll take this angle as 180 degrees. Say preview. Say close. And here we have this surface starting from this reference and ending at the angle 180 degrees. But if I try to put the angle 1 as 30 degrees, so this angle will be minus or deducted from this 180 degrees, and this angle effect will be shown on the surface also. Say preview, and we can see this surface is coming in minus direction with 30 degrees angle as we have added this angle. If I take this angle as 360 degrees, say preview, so here the angle 1 is been deducted from total 360 degrees. If I want the surface to be taken as complete 360 degrees, then we must not add this angle 1. We must keep this angle 1 as 0 only. Then this complete surface will come as 360 degrees. We can see here, if I say 180 degrees to angle 1, preview, only half side will be shown here. Half angle will be shown. So in this way, we can use the center and two angles as a type for the swap command. Say OK and finish. We have seen the three types till now. We are continuing with the other type. After center and two angles, we have center and radius. So for center and radius, it is similar here. I delete this swap first and we'll hide one of the guide curve. We only required one guide curve now. Select the swap command. Go for the next type, center and radius. For the center curve, we are going to select this line, and for the radius, we need to add just the radius value. So I'm going to take this radius value as 120. Say preview. So here one surface having radius value of 120 is appearing. Say OK and finish. If I want to change the value, again double click on this swap to edit the feature and go for the value as 90. I will say 60 only this time. So here one surface has been added around this line or guide curve, we can say, with the radius of 60. So this was one of the swap type. We will move to the next type now. Select the swap command again. Now we have two guides and tangency surface. So for two guides and tangency surface, we are going to make one sketch first. So let's select one plane here. Say sketch. And here we are going to make one center point arc. Starting with this center, start point and end point. Next we are going to make it extrude. So we'll make it extrude command here. Reverse, and we are going to apply one distance. So I'm going to take this distance as 100 mm. We'll update this value and change it to 200 mm. After making one extrude, we are going to select the top plane and say sketch again to make the guide curve. So for guide curve, I'm going to add one line. The length I'm going to take the same, that was 200 mm. Next, say exit sketch. If I want to define the position of the line, we can give this value also here. So I'm going to take this value from origin as 100 mm. Then after that, say exit workbench, and we are going to go for the swap type. Select the swap, and here is the type, two guides and tangency surface. So I'm going to select this option here. First it will ask limit curve with tangency. For that I'm going to select this edge. Next, tangency surface. So I'm going to select this surface here. And lastly we are going to select limit curve. For that we are going to select this guideline. Say preview. Now you will get two tangency surface. And now we can see here we are having one surface with two solutions. This is the first one, and if I say next, this will be the second one. That is from the bottom side. In previous one, the surface is coming from the upper side, and in the second solution, the surface is coming from the lower side. So whatever position we want, we can take it here. Both the surface will come tangent to each other. Say preview. Now you will get two tangency surface with two solutions. This is the first one, and if I say next, this will be the second one. That is from the bottom side. In previous one, the surface is coming from the upper side, and in the second solution, the surface is coming from the lower side. So whatever position we want, we can take it here. Both the surface will come tangent to each other. say OK. So we can see it is coming at the lower side now. If I want to change the side, double click the feature, say previous solution and say preview. In both the cases, both the surface will be tangent to each other. So this was the type 2 guides and tangency surface. Next type we are going to discuss here is one guide and tangency surface. So first we'll cancel this one and we'll see one guide and tangency surface. Say OK and finish. And we are going to cancel this swap first. We are going to say delete here. Say OK. And now for this type, we are going to use the same entities which were taken earlier. Select the swap command. Go for the next type, one guide and tangency surface. Now the guide curve one we are going to select this one and tangency surface we are going to select this one. Say preview. It is showing error here. It is because we have not put the radius value. So we have to keep in mind the radius value. This distance was around 100 mm. We need to take at least minimum 50 mm radius value here. The value should be proportionate to the distance between the tangency surface and guide curve. That's why we need to increase this value here. I'm going to take is 50 or 55 something. I'd say 55 here. Then say preview. Now we can see one arc surface is coming with radius of 55. There is only one solution that is been shown. We cannot flip these sides in this type, but we can remove this extra surface here. We'll zoom it little bit. This surface can be removed just by clicking on this option, that is trim with tangency surface. Say preview and OK. Now we can see the extra surface which was coming, it has been removed now. Say close and finish. We'll hide this sketch. For this type, we need to keep in mind that the radius value we have taken should be proportional or should be fulfilling the distance between the surface and the guide curve. Then only this swap can be applied and surface will appear here. Or else if the radius value is less, then it may not take the surface. Suppose if I want to change this radius value, I'm going to say 80, say preview. Now we'll get two solutions. First one we are seeing here. Next one will be as previous one. This surface will come. But in both cases, we are going to trim the extra surface. Say preview and OK. Say close for this note. So if I'm going to increase this radius value at higher level, then we can get two solutions. But if this value is less, then we are going to get only one solution here. You can see here, this was one guide and tangency. Next type of swap we are going to see here is, and this will be the last swap of this category, that will be limit curve and tangency surface. So for limit curve and tangency surface, first we are going to delete the swap command, say OK, and now select this command and go for the type, that is the last type, limit curve and tangency surface. So here we are going to take this edge as the limit curve, and for the surface we are going to select the same entity which was extruded, that is the surface extruded. Say preview, and we can see here there are two solutions been found. If I go with the first solution, say OK, this surface with tangency will appear along this limit guide curve at the upper side. If I double click it for editing, and if I go for the second solution, say preview, this surface instead of coming at upper side will come at the lower side, having the limit curve tangent with the previous surface. Say OK. Now with one more example we can see this. So for that I'm going to delete this swap, and we are going to take one plane above parallel to the top plane. So select the plane option from the wireframe toolbar. Reference plane is top plane. We are going to take one reference plane at above of this surface. Say OK. We are going to make one line on this plane. Say sketch to the plane. Make the part center fit, and I'm going to draw one line here. I'm going to make this line symmetric from the center axis. Say OK. We'll take this length as 100 mm. I'll say 120. Next, say exit workbench. After making this line, we are going to go for the command from the wireframe toolbar, that is projection. So I'm going to select this projection command. Here we need to show the projected. So this line will act as the projected entity, and the support entity we are going to show this surface. Say preview, and we can see this line is being projected on this surface, but it is been projected partially. So we are going to change the projection type. Instead of normal, we are going to take along a direction. And for the direction, we are going to take the Z direction. So in direction tabs, here right click and just say Z component. Say preview, and we can see now this line is coming along the direction upon this surface curve. It is in the shape of curve only. Say OK and finish. Again go for the same type in sweep command, limit curve and tangency surface. So for limit curve we are going to select this projected sketch in the form of curve, and for the tangency surface we are going to take this one, and here we need to put the radius value, so I'm going to take this radius value as 50. Say preview. Now it is not showing any surface because of these angles, so I'm going to take this angle as 0, angle 1, and this angle we are going to take as 45 degrees. So angle 1 I have kept 0 and angle 2 we are going to take 45 degrees. Say preview. Now we can see here there are two solutions. First solution is coming from the inside, so this surface will be tangent from the inner side, having this angle as 45 degrees. If I increase this angle, say preview, we can see here this surface length is also been increased from the inner side. But if I go for the solution 2, it will be shown from the outer side. So the outer side surface will be shown and the inner side surface will be trimmed automatically. And if I increase the angle 1 value also here, say preview, so the second side which is not going to be shown will be decreased in size, as well as the tangency which has been connected to this surface will also be decreased here. That's why angle 1 was not taken earlier, it was taken as 0 only. Suppose if I take this value as 15 degrees, say preview, it is shortened in both the conditions or solutions. That's why the surface is not been connected to the curve. So I'll keep this angle value as low as possible. If I go for 0 value only, then only it will be connected properly. Say preview. Now this surface is be connected. So this is the solution 2, and if I go for previous, this will be solution 1 coming at the inside of the body. Say OK and finish. Double click for editing. I want this at the outside surface, so I'm going to take the next solution. Say OK and finish. The inner solution will be trimmed automatically. So this was the last type in circle category of the sweep command. Now we are going to start with the another category, that will be conic. So for the next category we are going to change the interface. We are going to take new part. For making this sketch, first I am going to take two planes. One plane at certain distance, say I'll take this distance as 80 mm. One more plane at the 80 mm distance from the other side, say reverse side. Say OK and finish. Now the first type in conic category of swept type, we are going to see it. Select the swept command, and here we have the type conic, and in that the first type is two guide curves. So for two guide curves we have made two planes. For making the first guide curve, select the first plane and say sketch. Make it center fit, and we are going to make one line here. So we are going to start this line from origin. This is the first line. I am going to take it and make the relation as horizontal. It is little bit tilted, so I am going to take the solution as horizontal properly. We'll put up the length. So the length we are going to take here is 100 mm. Say exit workbench. Same we are going to repeat the thing on second plane also. Say sketch, and we want the same line with the same length. So instead of making any line, we are going to make this project entities. Select the line and say project entities. So we have the another line on second plane. Say exit workbench and go for the type now. In swept command, select the category as conic, and in that the first type is two guide curves. So first it will ask you guide curve 1. I'm going to select this line as a guide curve 1. Then it will ask you the tangency support or tangency surface. So I'm going to select this plane only. Next, the last guide curve we are going to select this line, and the tangency or support surface, for that we are going to select this plane only on which we have made these lines. Say preview. Now it is not showing any curve, it is showing an error here if I say preview. It is because we have not put any angle value. So I'm going to take one angle value as 15 degrees here, and then we are going to say preview. Without angle, if I say preview, it will show error. Say preview, and we can see here at 15 degrees it is coming at the bottom side. If I go for this angle, I'll say 15 degrees on this side also. It will show a null effect. That's why it is not suggested to keep this angle similar. So suppose if I am going to take this angle as 24 degrees, we are going to take this angle in minus side. I'll say 24 degrees. So we can see here one balanced conic curve is been made. One angle is at the positive side with the same value having the angle at negative side, 24 degrees and minus 24 degrees. And if I suppose change this angle, if I change this angle say 30 degrees or 35 degrees, the depth will be decreased here. And suppose if I increase the angle 1, say 35, this depth will be decreased here. Say preview, and we can see the depth has been decreased here. Again, if I say this angle as minus 35, say preview, this curve will come at the center from both the lines or guide curves. If I change this angle and say minus 10 degrees, it is coming at one side been tilted more. If I double click on the curve, and for balancing, if I increase this angle, say 65, say preview, this will come in this way. If I want to change this angle, I can change it from here also. So instead of minus 10, I'm going to say 20 degrees, or else I'm going to say minus 40. Say OK and preview. So in this way, by these two angles, we can change the shape of this conic using two guide curves. I'll say 30 only. Say OK and preview. It is coming bended at the right side now. So these are the few variations we can make in the angle, and we can change the conic type or shape. This was conic type with two guide curves. Say OK and finish. Now the next type is with three guide curves. First we will delete the swept command, and now as we have taken plane, we are going to select this plane and add one more guide curve. Make it normal first, then go for the line command again. Say exit workbench, and we have added the third guide curve also. We are going to go for the next type, that is swept, and select the type here as with three guide curves in conic type. So first guide curve I'm going to select this one, then the second guide curve we are going to select this line, and the third guide curve, that is last guide curve. I'm going to select the tangency for the last one also. Only this mid guide curve will not require any tangency surface. Say preview, and here we can see the angles. Here are also angle coming. Angle 1 is 40 degrees, angle 2 is coming 0. We can see here. So it is minus 40 actually. So I'm going to change this value. I'm going to say minus 20. And for balancing it on the other side, I'm going to say plus 20 on the other side. Say OK and say preview. So now it is coming balanced at both the sides. Say close and finish. So this was the option by using three guide curves. First guide curve also requires one surface support. Second will not require any tangency surface. And the third one will be this last guide curve, also require the tangency surface. So here two tangency surfaces are required, but having guide curves as three. We need to balance the angle if we want it symmetric on both the sides. Say OK and finish. We continue with the swept command. Select the command. The next type is four guide curves. So we are going to select this command and we'll see what we need. So here we need guide curve 1, then one tangency surface, then next guide curve 2, 3, and last one, that is fourth number guide curve. Last guide curve. So we'll start making the geometry for this. Say cancel. So we'll start making with tangency surface first. Select the plane and say sketch. And here we need to add one spline. And we'll make it extrude here first. So let's make it extrude. Say exit workbench. Say extrude command. And extrude should be symmetric, so I'm going to say mirror extent. I'm going to put up the value as 60 here. So whatever width of the sweep I want, I can take it in this surface only. Therefore, let's take this width as 100 mm, not 60. Next, we are going to go for the plane command now. So I'm going to add one plane. We'll take this profile a little bit upwards. Say update. Control U is the shortcut key. And then we are going to go for plane, as we said. So select the plane command. Take one reference plane in reverse direction. So in bottom side, below this edge, I want this plane to be coming. So we'll take this distance here as around 60 mm. Make this plane sketch, and we are going to add one line here with the length of 100 mm. Make the endpoints of the line coincide with the edge of the surface. On the other side also, I'll make them coincide. Say OK and finish. Here we need to put some distance, so we'll take this distance from the edge to the sketch. I'll say this distance as 100 mm. If needed, we are going to change the distance later. Say exit workbench. So we want here to show that whenever the surface will be added by the sweep command here, it should look tangent to this above surface. So I think we need to take this plane little bit more lower side. So we'll edit the distance here. Instead of 60, we are going to take 100 mm. Say update, and this line will get updated by the new position. We can see here the change. The line is coming at downside now. Earlier it was looking very much upside, so the surface might not have looked tangent here. That's why we have taken it at lower side little bit. Next we need to make one more plane now, a little bit upward side. So we'll take the reference of the previous plane only we have taken here. Now let's take this distance as 50 mm. Select the plane. So to understand the order of the plane, first we have taken this plane at the bottom side, lower bottom side, with the reference of this top plane, and then with the new previous plane we have taken one more plane, that is this plane. We'll make this plane sketch. Say sketch, and we are going to make one more line here. So start with the line command, make one line, make this line horizontal with the relation, and say this point coincide with this edge. On the other side also we are going to say coincide. Now we have one surface and three guide curves. This surface, this is the surface, this edge is the guide curve 1, this one is guide curve 2, and this one is guide curve 3. Now I think we should move this plane little bit downside. So for moving at downsides, we are going to decrease the distance value here. I'm going to say 40 mm only. Now the other plane we are going to use is this top plane only. Select this plane and say sketch. Make this center fit. We are going to make the other line, the fourth guide curve. Now say point and edge to be coincided together. On the other side also we are going to make it coincide. Say OK and put up the value also here. I'm going to say this value as 120 only. Say exit workbench. So after making the required sketch, we are going to go for sweep command. Select the type 4 guide curves. Now guide curve 1, we are going to select this edge, and the reference surface or tangency surface, for that we are going to select the same surface attached to this edge. Next guide curve 2, we are going to select this one. This will be the guide curve number 3, and this will be the guide curve number 4. We can see here it is shown guide curve 1 with the surface, then guide curve 2, then guide curve 3, and guide curve 4. Here it is shown in the preview window. Lastly, we need to provide the angle. So for angle, I'm going to put the value here as 25 degrees. Suppose if I keep this angle value 0 degrees only, then also we can see in preview the surface has been added. And if I increase or decrease this angle, we can see the change in the surface here. After saying 22 degrees, it is coming at a little bit lower side. And this surface is looking like the two different surfaces are being intersected together. So if I decrease this value, it will take this surface to the upward side. If I say preview, as it is negative angle, it is not giving any surface here. So I'll take this angle as 0 only for the minimum. And here this surface is added using the 4 guide curves with an angle reference. If I want to increase the angle, if I say 10 degrees, we can see here it has been decreased to 10 degrees. If I want to change the sketch of the previous one, which we have made the surface, we can change that sketch in between also. Say exit workbench and say update by clicking Ctrl U. And if I say 0 degrees, it will look like a tangent surface now. So this was the sweep command using conic type and having 4 guide curves with tangent surface. We'll move to the next type now. So in next type, first we'll see what are the requirements. So the name is 5 guide curves. This will be the last type of the sweep command. Select this type. We only require 5 guide curves. G1, G2, 3, 4 and 5. So in this way we need to provide the guide curves only. So let's make this one now. say cancel, go for new part, say part, say OK. And now with 5 guide curves, I'll put the title only here, with 5 guide curves. Say OK and finish. We can see as the title with 5 guide curves. If you want to increase or decrease the font size of this model tree, just continuously press the Ctrl key and scroll on the mouse. This text will be increased. Now we can see it clearly. So we'll start with this sketch now. Select the front plane, say sketch. We'll add one line. We'll take this length here as 120 mm. So we have added this on the top plane. Now in this time we are going to take 2 reference plane more here. So exit workbench, select the command as reference plane to add one more plane. Select the reference plane here and put up the value. So I'm going to take this value as 25 mm. We'll take one more plane here with the same reference distance as 25 at the above side. Now we have 3 planes here and we have made one guide curve already here. So now we are going to make 4 more guide curves. Select this plane, say sketch. So this is the mid plane of the planes we have taken new one. Select the sketch, make one line here. I'll keep the same length of this line, that is 120 mm. We'll make this line coincide with the horizontal axis. The end point of this line will be coincided with the horizontal axis. Put up the distance. So I'm going to take this distance here. We'll take this distance as 80 mm. Next, say exit workbench. And on this same plane, in the same way, we are going to add one more sketch. Select the line. One more sketch coincided with the horizontal axis and with the length of 120 mm only, having distance from the center as 80 mm. I'll take this 120 and this distance from the center line axis we are going to take it as 80 mm only, same as we have taken from the left side. Next, the last plane, the uppermost plane now. Select this plane and say sketch. Say center fit to the sketch and add one more line here. We'll take this line, coincide with the horizontal as we have done earlier also. Take this length same as 120 mm. It is not necessary to put this value as 120. If the length has been taken more also, it will continue adding the surface of 120 mm only, as measure of the lines having the distance as 120. But still we are going to put this value as 120 and then this horizontal distance. So we are going to take this distance as 80 mm. Say exit workbench. And then the last one, say sketch. And the last line now. Say 120 mm. Put this value also here, 80 mm. Now say exit workbench and then we are going to go for the command now. We'll hide these planes so as to understand the sketch. We'll hide the in between taken plane also. We can see now there are total 5 guide curves been added. Let's go for the command now, swap with 5 guide curves. So guide curve 1 we are going to take this one. Now in order only we are going to select these guide curves. So first one was this, second will be this one, third guide curve will be this one, and this will be the fourth one, and this will be the fifth one. Say preview. You can see here it is showing error. Sometimes it may show error, but if I change the distances little bit or the plane distances, it will automatically create the swept surface here. So let's change some values here. Say cancel. And now the center to center distance we have taken 80, will increase this distance little bit. So instead of 80 we are going to take 120 only here. I think we have not changed the distance for this one. So select this guide curve and we can see here the distance reference has not been updated properly. So I'm going to delete it and add it one more time. We'll take this distance as 120 only. Say exit workbench. Now let's try it one more time. Go for swap. Select the guide curves. Say preview. Still it is showing error. So let's change the plane distance now. So here the plane 1 was taken at 25. I'm going to take it 15 mm only. And the plane 2 also we are going to update it. I'll take it 15 only. Now say Control U for update. Again try the sweep command. First, second guide curve, then the third one, then the fourth one, and then the last one. Say preview. Okay, still it is showing some issue. Again we'll update the plane values. I'll say it 12 mm. Now after updating the plane 1 value for the distance as 12, let's try it one more time. Select the sweep. Say five guide curves. First one, this will be the second, this will be the third guide curve, this will be the fourth, and this will be the last one. Say preview, and we can see now this surface has been added with the help of 3 guide curves. So yeah, in this type of conic shape, angle is not required. That's why we have not given any angle here in 5 guide curves. Other than this, all the above one will require angle, but only the last one will not require any angle. Say OK and finish. So these were the swept types. We have seen total number, as we can see in first category, there were 3 types. In second category, first, second, third, fourth, fifth, sixth and 7. So there were 7 types in the second category. So this total will be 10 types. And now in third category, we have 1, 2, 3, 4, 5, 6, 7. So 7 types in third category also, means 17 total. And in the last type we have 4. So there are total 21 types of swept in swept command for the surfaces. We have seen all of them one by one. Now we'll conclude this lecture, and for more lectures for the CATIA series, now we are going to start with the drafting for the next lecture. So stay tuned and continue watching the lectures to learn CATIA software from basic to the end. Our institute name is 4 Dimensions Infotech, and we also provide placements here in CATIA as well as BIW fixture design. So if anybody is interested to join the courses for automation, manufacturing placements, for placement in SPM design, BIW design, fixture design, or any mechanical design, you can contact us directly. The number will be given in the link below. Till then, thank you. So hello everyone, today we are going to start with CATIA drafting. We have continued with the CATIA series in which we have seen how to make sketches. We have seen the sketcher platform, complete part modeling we have seen. Then after that we have seen how to make assemblies. Then later we have seen surfacing commands and surfacing interface. And now we are going to start with drafting today. So what is mechanical drafting or drafting? Mechanical drafting is the process of creating detailed technical drawings that represent mechanical components, maybe assemblies or systems. These drawings serve as a universal language between engineers, designers and manufacturers, ensuring that a part or a machine is made accurately to these specifications. Means when you create any part, that part is in 3D, but you started with 2D only. So we can say first we'll start with 2D, then we are going to make it in a 3D part to visualize the 3D concepts or features. Later we are going to again go for drafting, and in drafting we are going to take orthographic views to convert them to 2D. Then we'll add dimensions, GD&T symbols, surface finish symbols and many other things that are required for making a part readable for manufacturers during production. So this process is known as mechanical drafting. Now there are some key points about mechanical drafting. We'll see it now. So a specialized branch of drafting that focuses on machine parts, mechanisms, tools and equipments. The purpose of drafting is to communicate design intent, provide manufacturing details such as dimensions, tolerances, material and finishes, ensure standardization and interchangeability of parts. Now there are types of mechanical drafting. So the first one is orthographic projections, in which 2D views such as front view, top view and side view have been shown, and then dimensioning has been provided with the other things such as GD&T, finish symbols and all. Second one is isometric drawing. In isometric drawing, 3D like representation has been shown. Then there are different types of views being shown in drafting such as sectional views. Sectional views are nothing but cut views to show hidden details. Assembly drawings then show how multiple parts fit together. Means in drafting only we are going to show the assembly drawings to show how the parts are going to be fit together with relation. Then lastly we are going to go for detailed drawings. In detailed drawings, individual part specifications have been shown. The essential elements. Now what are the essential elements to be considered while drafting? That are dimensions and tolerance. These are the main elements of drafting. Next, we also require geometrical dimensioning and tolerancing, that is GD&T. Then we require surface finish symbols, then welding symbols, bill of material, that is BOM table. This is also very important here in drafting. Then what is the standardization of the drafting? That is ASME Y14.5, American Society of Mechanical Engineers, or we can do it in DIN, that is German standards. But as we are working in India, so ISO standards are being followed here. Now the tools for mechanical drafting. What are the tools for mechanical drafting? We'll see. Traditional tools are drawing boards, T-squares, compasses and set squares. But in modern times, CAD software such as AutoCAD, SolidWorks and CATIA, Creo, NX, these are the tools which are required for drafting. So we'll start with CATIA drafting today. Now the applications. Applications of drafting are in machine design, automotive and aerospace industries, manufacturing and fabrication, product design and development. Means every area field of design, drafting is compulsory so as to read the model properly and to communicate with the manufacturer what drawing is asking for. In short, mechanical drafting converts an engineer's design ideas into precise technical drawings for manufacturing and inspection. So this is the short introduction about drafting. Now let's start with drafting here in CATIA. So this is the part we have made in CATIA part modeling. And there are two ways to start with drafting or to take the part to drafting interface. So the first one is directly going for drafting without having or opening any part. I'll minimize this one and directly you can go for drafting, that is by clicking on this start button, say mechanical design and drafting. So as soon as you click on this icon, this new creation wizard will appear here, showing that you can select any automatic layout here. So we need to select any automatic layout and what will be the paper size, what will be the global scale and what will be format of that particular drawing or drafting. Say OK. And here with a blank page you can start the drafting process. But we'll start with mechanical design and drafting. Then go for automatic selection of layout. The layout may be empty, maybe with all views, maybe front, bottom and right, that is third angle method, or maybe front, top and left. So we'll start with the empty sheet first. After selecting the empty sheet, you can see here the standard is showing ISO, Indian Standard Organization. Format is A3, means the paper size is going to be A3, and that A3 size has been elaborated here with the values shown as 297 by 420. Means the A3 size of paper is going to be 297 by 420. If I want to change or modify the format, you can go here, say modify, and here you can see other paper sizes are being also shown here. The other standards are also being shown. Standards such as NC, ASME, ISO, JIS. Then in format, we can see the size which has been shown earlier also. And then we can see the orientation of drawing we want. So it is showing landscape, means the paper size, horizontal direction size will be more as compared to the vertical one. That will be 420 in horizontal way by 297 in vertical way. If we select landscape, and if we go for portrait mode, that means 297, the shot length will be in horizontal direction and then to 420 will be in vertical direction. Means the paper size will be in a vertical portrait mode. So whatever mode of layout we want, we can select it from here. We are selecting landscape here, say OK. After that again say OK, new creation wizard also. And here the paper size or drafting sheet will appear. Now after that we are going to go and set the template. Templates means we are going to make a table here and also we are going to have one border for this paper. This blank sheet is not perfectly usable for making a drafting part. There should be some scale border as well as the table template table here so as to understand what kind of drawing or drafting we are working on. So for that we are going to select edit, and in edit The last option we are going to see, that is sheet background. Select the sheet background here. Now after selecting the sheet background, we can see the interface color has been changed to blue color here. It is showing that we are now in editing interface for the drawing or template. So we can do it by going in insert, select this drawing tab, and here we have the option frame and title block. You can either select it from here, or else you can go for directly this tab. This drawing tab may be sometimes been appearing here also. So this icon is important to understand that we are selecting the proper command or not. So here the toolbar name is drawing toolbar, and in drawing toolbar we are going to select frame and title block. So either you can select it directly from toolbar, or else you can go for insert and then select the drawing and then frame and title block. So in frame and title block, the first option here is coming as create. It is asking us to create a title block here. So for title block, there are multiple samples have been given. We can use this title 1 block, sample 1 or sample 2. We don't need this playbook or Innova. So I'm going to select here drawing title block sample 1. Say apply and OK. So we can see here this scale has been appearing at the borders, means template borders have been appearing now to show or select these zones, as well as one title block is also appearing here. We'll zoom it little bit. So we can see here designated by, means we can type the name of the admin, date is been displayed here. Then we can also show by whom this drawing has been checked by, the date of checking, the paper size, scale, angle method, weight of this particular part or assembly. Then lastly the title, the subtitle, drawing number and sheet. But if I want some more contents in this particular title block, then we can change the format of this title block. Again we are going to select the same command, that is frame and title block. And now first we will delete the earlier made title block, select the delete, say apply and OK. So we can see here all the thing or title block scales were applied are been deleted now. Again we are going to select the create, and now this time we are going to select drawing title block sample number 2. After selecting the sample number 2, say apply and OK. So same kind of scale at the borders will be appeared, showing the zone selections, but a different type of title block will appear here. There is some note area now, drawn by, checked by, designed by, dates, then the title of the company, drawing title, paper size, drawing number, revision. In addition to that, scale and sheet number is also been added here. So there are some more titles been added in this title block. So in this way, these two formats can be used for title block. Now the next thing in title block, select the option frame and title block. After create and delete, we have the option resize. So resize option, we'll see that first we'll exit the background. For that, again go on the same command, that is edit, and say working views. We will be exited from the background and working views will be activated again. So for that, select this option from edit tab, that is working views. Again we can see the background color has been changed to white color, and now the drawing views are been activated again. Means we cannot make any changes in title block or this frame borders. But here we came to resize the sheet size. So earlier we were using A3 size. We can see here the paper size was A3. Now we are going to change the size and update it. So for that, I'm going to select the model tree, and in model tree we have this option, that is sheet 1. Select this and say properties. Now in sheet properties, we can change the sheet size as well as the first angle projection method also. We can change the scales also here. We can update the name also here. So everything related to sheet in the properties can be changed here. We are going to upgrade the paper size. We are going to say A4 size, and A4 size we are going to say landscape. So say apply and OK. Now we can see here the paper size has been updated, but the title block and border size has not been updated yet. It is because we need to update it by going into this window, that is edit, and in edit we are going to go for sheet background. Now after coming in sheet background, again we are going to go for the same option that was in insert, drawing and frame and title block. So in frame and title block we are going to say resize. As we have updated the sheet size, this title block and frame should also be updated. That's why we are going to select resize here, say apply and OK. Now we can see this frame size as well as the title block is now coming properly in this particular change sheet size, that is of A4. We can see a A4 size, say apply and close. Again if I want to go and change to A2, just go to edit, working views, Then go for the model tree. In model tree, select the sheet 1, say right click and go to properties. Here in properties, we are going to select A2 size this time. Now this A2 size will be little bit larger as compared to A3 and A4. As the numbers will decrease, the sizes will increase for the sheet. So here instead of A4 and A3, now we are going to go for A2 and the size of the sheet will be increased. Scale we are taking 1:1 only. Say apply and OK. You can see here the title block and frame size are coming according to A4, but the sheet size has been changed to A2. So for updating it, say edit, sheet background, select the option frame and title block, and here we can say resize, say apply and OK. This title block will automatically move to the at corner. Say apply and OK, finish. Now if I want to update the names and all, we can directly double click on this text to update the names. So I'm going to put the name here. After updating the name, we are going to update it checked by name also. We are going to add here. Next, designed by. Next, date has been updated. Same date we need to copy here and here also. So I'm going to select this date. Text editor will open after double clicking it. Just select and copy the date here. Say OK. Double click on this format and here we are going to paste the same date. Say OK. Same thing we are going to do at the last option also. Select and say paste. Say OK. Now our Dassault system, instead of that, we are going to put the title here as 4 dimensions Infotech. Say OK. Now the drawing title we are going to say casting part here. Drawing number, we can add any number. Many times we can see in industries the parts are designated mostly by their drawing numbers. So in just for the case, we are going to put one number here. Say OK and finish. Scale is also been shown here, that is 1:1. If I update the scale for the drawing views in working window, then again we need to come in edit, and here in template we need to change this scale also here. Now after updating all the details here, we'll take one more drawing, directly the new drawing, say Ctrl N, and instead of saying part we are going to say drawing here. So as to directly go for drawing, say OK. Same A3 size, say OK. One new drawing has been added here. Go to edit command, go for sheet background, and now in title block we are going to see update. What is the meaning of update? For that we are going to create one title block sample here. Sample 1 we are going to say apply and OK. So in sample 1 this angle method has been given, whether it is third angle or first angle. So this icon is showing that we are working in first angle method. In later lectures we are going to see what is the difference between first angle and third angle also. But for now we need to understand that we are working in first angle method. Now we need to update this angle method as well as the scale factor. So for that, first say OK, and then we are going to go in working views. For that we are going to exit this one, say working views, and in sheet 1 go to properties. Here we are going to say instead of first angle we are going to use third angle, and scale also we are going to update and say 1:2. Say apply and OK. So this scale has been updated by 1:2, but still it is showing first angle method only. So for this angle method to be updated, we are going to go and edit again, say sheet background, select the frame and title block option, and here we are going to click on this icon, that is update, and say apply and OK. So now we can see this angle method is being changed to third angle. So in this way you can update any title block features if you want to. Next in frame and title block is checked by. So this check by we can directly double click and check it, as we have seen earlier. If I want to change any name, so the document has been checked by John Smith. If I want to change it, if I want to say another name, I will say so we have updated the name here. Say OK. We can see this is updated. Next, if I want to update this property, you can directly double click also here, or you can go by this command also, frame and title block, and then go for check by. So these were the commands which were seen in frame and title block. Okay, we don't need to check this add and revision block. We don't need that. Say close this time and go to working views, edit and working views. After coming in working views, in next lecture we are going to see how to call different types of views, what are the different types of view and how they can be placed here. We are also going to see how the views can be edited here. So this was the lecture for today. Do like, share and subscribe the channel 4 Dimensions Infotech and continue watching the CATIA series to learn more about CATIA. The complete course for CATIA playlist has been updated in YouTube, so you can directly learn from there, or else if you want to learn in detail with models and drawing and standards, you can contact us directly on the number in a link been given below. So till then, thank you. Have you ever made a 3D part in CATIA and then struggled to show all the inside details and measurements on a 2D drawing? How do you show what's on the inside without making the drawing messy and confusing? The answer is using CATIA drafting views. The 3D model is for your design, but the 2D drawing is what the factory needs, and it has to be perfectly clear. Hello everyone, I am Sagar Rathod and welcome to day 26 of CATIA series from 4 Dimensions Infotech. In our last video, we learned the basics of drafting and how to set up our drawing, sheet and title block. If you missed that, you should watch it first. The link is in the description. Today we'll continue from there and learn about different types of view we can generate there. We will cover how to make section views to see inside a part, detail views to zoom in on small areas, and auxiliary views for parts with angled sides. And remember, if you want to learn CATIA from start to finish, check out our full course on the 4 Dimensions Infotech website or contact us for more information. The course provides complete training and certificate to help you in your career. And if you like this video, don't forget to like, share and subscribe the channel. Let's get started. So to start with, first we are going to take this part to drafting. Say file, new. We are going to select drawing here. Say OK. Here we need to put the settings as we have seen in last lecture. We are going to take A3 only. The orientation for the sheet we are going to take is landscape. Say OK. Scale factor is taken 1:1 by default. We can change the scale factor later. Now, every time you open, the toolbars will not be in the position as they were earlier. So you need to arrange the toolbars every time. To call the views, we have this views toolbar in which we are going to see the first type, that is front view. Now as we have selected the front view, we can see here it is showing in orange color. We just need to go in the Windows option and select the part we want to open in drafting. After coming here, we need to select the front view we want. So I'm going to take this front view. You can see at the lower right side, oriented preview is being shown. This preview is showing how the front view is going to look in the drafting phase. If you want this to be taken as front view, you can take this one also. So whichever face you want, you can just select and that face will be oriented as the front view. Now after the view getting placed here in this sheet, we have some more options to rotate or move sideways. So here the options are, if I want to rotate the orientation here, you just need to click on this arrow. You can see it is coming in vertical position now. To go back to same position as earlier, we'll undo it by clicking on the left arrow. Now here, if I want to change the front view, you can click on these triangles here. After clicking this, the downside is showing as the front view. In this way, you can orient the front view also here. And finally, if you are good with the view, just click outside the window and that view will be placed here. Scale here it is showing 1:1. We need to drag and place wherever you want. Next, we are going to take the projection views for this view. So for that, select this view option again, and here at this fourth option you have the projection view. Just select this option and now we can see these views are being projected here. One more time. Now if you see at the angle method, it is the first angle method in which the views are being arranged. CATIA is by default set to project the first angle method views. So if I want to change the angle method, you just need to go in the model tree area at the left side and right click on this sheet 1 and go for properties. In properties we have the option, you can see default setting is first angle method. So if I want to change it to third angle, I'll just click on this third angle and say apply and OK. But still the projected views will not get updated. We need to again select and delete the earlier taken view and go for the projection again. Now it is showing in a third angle method. In this way we can change the first angle to third angle and we can arrange the views as we require. Next, if I want to change the scale of the views, so instead of projecting, I'm going to change the scale first. It is because if I change the scale after projecting, only that particular view scale will be changed. The updated scale will not be applied for the other views. That's why before projecting only we should change the scale. So I'm going to right click on this view, say select properties, and here we need to change the scale. I'm going to say the scale as 1:3. I'll keep it 1:2 only. Now if I want to take some more projected view, I can take it from here. Projection, this is the top view and this will be the side view. Now we can see whatever scale the front view is carrying, that same scale is being carried by the top and side views. It is because it is a parent view. But instead if I project all the views and later change the scale for any particular view, then it will not be implemented for all the views here. So whenever you come with the part in drafting, first you need to go and change the first angle to third angle if you need. And one more thing to change is this scale. So whatever scale front view is having, if you are satisfied with that scale, you just go for projection, or else if you want to change the scale, then change the scale before taking the projection views only. Next, I want the isometric view now. So for isometric view, again we are going to select this views tab only. Click here, and in the second last position we have the isometric view. Just put on the isometric view. As the command is on, we can see it has been highlighted in orange color here. You just need to go and select the window, go to part. First arrange the part in isometric view. Here we have the view toolbar and there we have the option for arranging the views. So this fourth last option, it is showing isometric view. I'm going to click here. So if I shuffle this part, and here the fourth last option in view toolbar, we have isometric view. Just click on this option and the part will be arranged to isometric view. After arranging it, you just need to click on any face and then this part will be directed to drafting. Right click, go to properties. Here we need to select scale, say 1:2. Again, put the view at the place. Next, if I want to show this view in original appearance, then I just need to go and say right click, properties. Go at the downsides. Here we have the view generation mode. In view generation mode, it is showing the exact view. If I change it to raster and go for the options, we have their options known as shading with edges. After changing it to shading with edges, the appearance will be shown as the original part appearance. Say close, say apply and OK. We can see here, this appearance has been changed as it was in part modeling. One more time, right click, go to properties. For changing, go to view generation mode at the downside. Here, exact view. If I apply it again, it will be shown in line diagram. You can see here. So for changing the appearance only, we have this option, that is raster options, and going for the option shading with edges. Apply and OK. Now after arranging the views, we can see this window is showing in blue color. All the three views window is showing in blue color, but the front view window is showing in red color. It is because this view is active now. So if I want to make any changes, if I want to take section views, or if I want to generate new views from any particular view, you just need to activate the view first, and then only that particular view will respond to generate the new view. So now this front view is active as it is showing in a red window. Next, we need to go for this option, that is auxiliary view. Now auxiliary view feature is applicable in some conditions, such as we can see here this cut is being made slanted and there are two feature cutouts being made, but we can't see them properly in top view as well as in side view. So if I want to show the dimensions for this feature, the placement dimension as well as the feature dimension itself, it is not possible for me to show in top view or in side view or in front view. So for that I need to change the direction of observing the view. So to read this feature properly and make dimensions, we are going to go for auxiliary view. We'll observe this side of the cut in a perpendicular direction, or we can say in a normal direction, so as to apply dimensions in a proper way. For that we are going to select auxiliary, and for reference we are going to select this edge and place it here. So we can see one view is being generated showing this cutout feature in a proper way. Now I can put the horizontal as well as vertical direction, and also we can put the feature dimension here for this rectangular sheet, which was not possible in top view and side view. We'll pull this text downside, but it is going out of sheet. So if I want to drag it in the sheet, we can see it is not easy to drag at any position I require. It is because of the attachment of the views. So if I want to delete this attachment, I just need to right click on the auxiliary view and go for the view positioning, and we can say here position independently of the reference view. Just click on this option, and now we can see it is movable as it has been detached from the parent view. I'll arrange this view properly again. Put it somewhere here. Also arrange the toolbars properly so that you can get correct space you require. Now the next option we are going to see here is advanced front view. It is similar to front view. This feature also will call the front view only, but instead of changing the scale after placements, we can change the scale here before only placing the views. So if I select this option, I can change the scale here only. If I want to change the name also, I will change the name. Say OK and then go for the front view. We'll call the front view one more time here. So this time I'm going to select the front face, and here we can see the front view has been placed, but this scale is coming 1:2. Instead of 1:1, this scale is by default coming 1:2 as we have changed it earlier only. So this is the only difference between front view and advanced front view. So after advanced front view, we are going to see the next command, and in next command we are going to see section types and section views. So to start with section views, we are having total 4 types of section views we can see here. First one is offset section view, second is align section, third is offset section cut, and fourth one is align section cut. So here the term is used as section view, and here the term is used as section cut. That will be the main difference between these 2 commands, upper 2 commands and the lower 2 commands. So we'll start with the upper section view, that is offset section view. Now what is section view? Section view is nothing but cutting the part into section to show the internal feature, whether it is solid or hollow, as well as to understand the depth of the cutouts. Next, to understand what are the internal parts being assembled in the assembly. So this section views will be helpful in both parts and assemblies. In parts it will show the internal features, and in assemblies it will show the internal features as well as the parts which are mounted inside and cannot be seen from the outside. For starting this section view, just click on this option, and before starting you need to activate this view. Suppose if I have activated the bottom side view, and if I am trying to take the section view of this upper side view, it will not be possible for me to take the section view without activating this drawing view. So it is compulsory before generating any views, you need to activate that particular view for the reference. After activating only, then we are going to go for section. Just take the reference of the center, and you once click here. At the bottom side you need to click twice, double click here, and one section view has been produced. Now this section view is showing the internal feature, that is this cutout, as well as the holes depth. We have only covered 2 holes in the section line, that's why only 2 holes are being shown here in the section view also. Section view name is coming B and B. We can see here, it is for the reference purpose. You can shift this text here. If I want to change the text size, you just need to click on that particular text and you can change the size here. So if I want to multi-select, I'll select them, this one also, and go for the size here. I'm going to take size as 1 only. So all the text size are being changed. We can see here, now it is looking smaller. Section BB, we have placed it at the left side. It was vertical section. Next, it is important to understand these arrow directions also. So I'm again going to place this view. Just delete this view. Repeat the section view. Take the same reference from the center. Click once at the upper side and twice at the lower side. And when you are dragging it, you can see the blue colored arrows are being shown on the section line we have taken with the center reference. this blue colored arrow direction is coming from left to right side. If I want to change the direction, I just need to flip the view. Now you can see this arrow directions for the section line are now showing from right to left side. So this way we can shift the section view. You can also see the section view also is being changing. At left side it is showing something else, and at the right side it is showing the right side features. So whatever direction I need, I just need to click here, and at particular direction the view will be placed according to the arrow directions. Next, if I want to take the section view horizontally also, again I'll take the same feature. This time I'll take the circular feature. Just click at once on the first side and twice at the other side. Now whatever direction I want, I'll take it. So I'm going to take this direction from lower side to upper side, and the view has been placed. Now the section line is covering only one cutout feature, that is circular cut. That's why it is showing only one depth of cut for the circular feature. The other features we have not covered in the section line. Now if I want to take the align section view or incline section view, we can take that also. For that we need to select the align section view. So align section view, this time we are going to cover, we'll start it from here. We'll cover this circular hole feature also, this one, and we'll go and double click at the bottom side. So this align section view has been produced here. Just place it wherever you want, and we can see this cutout which was shown here. The section line is passing through that cut, and that is shown in this upper view also, covering this section, means this hole also. That's why the depth of this hole is shown here. The other portion is solid while the cutting line is passing across. That's why it is shown in hatching lines. Place it properly. And if I want to break the alignment of this particular align section view, I just need to right click and go for view positioning option. Here you need to say position independently of the reference view. So this view will not be dependent on the parent view for the section. It can be dragged and placed wherever you want. So in this way we can break the alignments of the views. Now in next option it is shown offset section cut. So for offset section cut, I'll just activate this bottom side view, and I'll right click here, go to properties, and I'm going to put on the option that is hidden lines should be kept on, as well as if there are threads, we want to show the threads also. If you want to show the axis line, center line, boundaries and everything, you can just put on or off the option from the properties here, where you can also change the scale of this particular view. Say apply and OK. After activating this view, I want to take a section cut from this circular feature. So for that, I'll place this front view text beside. Next, I'm going to go for section cut. So now the term is changed. First it was offset section view. Here it is coming offset section. The last word is cut. Instead of view, it is showing cut. So in cut portion, the edges of the cut portion are not being shown. That is the only difference. While taking any section view, if the material is not there, the portion will not have any edge reference also there. So I'm going to take the reference here, section cut. I'm going to start this section cut from the upper side and double click at the bottom side, and here we can see the section cut has been produced. But as we have said, in section view and section cut, it is the only difference that it will not show any edge here if there is no material. Whereas if I take the same section view instead of cut, I'll try this also, which we have seen earlier. Double click here, and I'm taking section view instead of section cut now, just to show the difference. So in section view, we can see the other features also being shown in dotted, as the hidden lines have been kept on. But here the edge is not visible in section cut. But in section view, these edges, if you are not having any material also, then also these edges will be shown. This boundary will be shown. That is the only difference between section view and section cut. One more time, we'll take the same cut by applying section cut feature. Just zoom it a little bit. And now I'm passing the section line through the same holes which we have passed earlier for section view. Just double click at the bottom. Now it is showing a drawing warning. So this warning is showing that this view first it is not activated. That's why we cannot take the section view here. So that's why I've said first activate the view and then only go for section view. Again select the section cut here, passing through the earlier section view only with same center reference. Double click here. Now you can see the difference. In section view, this edge also was being shown if there is no material, and here if there is no material, these edges are not being referred there. In the internal features also you can see the difference. Here the edges are being shown on the upper side also, but here on both the sides these edges are being removed. This is section cut. Same is the align section cut. If I go for the align section cut again, which is coming at the bottom side, just double click for the align section cut. We'll take the same corner reference only, passing through this hole now. Instead of this hole, we are going to pass through this hole this time. But we are taking section cut instead of section view. And that is align section cut. Double click here, place it somewhere here. You can see the difference. Here also, the backside edges as well as the border for the cut is being shown. But here, these edges are not being shown. The section cut where there is no material, the edges are also not there. This was the difference. We'll continue with the next type of the view, that is detail view. So for detail view, just double click here and we have activated this view. We can see the red border is showing on this view, means this view is activated. Then only we can take the section views also here. So I want to show the chamfer here. You can see this chamfer cut. I'm going to make a boundary around this cut, and in detail view, this boundary will be scaled in the double size and it will be shown in a separate view here. Only that particular portion, that is detail view, means showing the details of this particular portion in the side and taking the scale for this detail view as double the size of the scale we have taken earlier. So it was earlier 1:2 and here the scale is showing 1:1, means we have double the size to show this detail in proper way. So this chamfer is being shown here, but we can see here this circular border for the detail view, it is not being shown completely in this type of view. So if I want to show this complete border, so instead of taking a regular detail view, we are going to take quick detail view here. Just double click it here. Again, we are going to make one circle. Double click here. After double clicking only, this view will be generated. And we can see instead of regular detail view, if I have taken the alternate option, that is quick detail view, it is showing the border completely. But in detail view, this border was not shown completely here. This is the only difference between these two options, that is detail view and quick detail view. Both will take the circular profile. We cannot customize the profile shape here. Scale is taken same, 1:1 only. Now we'll go for the second option, that is detail view with profile. Now in detail view with profile, instead of taking this circular profile, you can go for any type of custom size profile. So I'm going to delete this circular views as well as the detail views here. This time we are going to go for the third option, that is detail view with profile. So any profile instead of circle, you can draw anything here. Double click and that portion will be shown in detail. So I'm going to take a rectangular shape. Just close it. Double click it here while closing. The view will be generated. But as we have taken the second option, that is regular detail view profile. So double click here. Again we are going to make one boundary. Any shape we can take. We are going to take a triangular shape this time. Double click it here. And now we can see this complete border is being shown. Boundary is being shown completely, not partially, as we have seen in the second option, that was regular detail view profile. Profile word is added, means you can draw a custom profile. Here only view was there, not profile word was added, means only circular type of view will come here while taking a detail view. So this is the difference between regular detail view and quick detail view. So after detail view, there are further commands also to see. There are more different types of view to be seen here, but we will continue with the lecture in the next session. One important thing to tell you, that we are making these videos for you. It takes a lot of efforts to make this video. So we expect you to subscribe the channel and also share the link for subscribing the channel to other friends also. Do like, share and subscribe the channel and share these links to your friends also, so they may also get the chance to learn the CATIA software. We also provide offline courses. If you want to join, you can come to Ambegaon, Pune. In Siehgad College campus, we are having our institute here. We also provide 100% placement with placement assistance for lifetime. So you can join the courses and take the benefits of the courses as well as placements here. We have the record of 100% placement. You can check the website of 4 Dimensions Infotech, that is 4di.in. So if you want to contact, you can contact us in the number which is given below in the link. Till then, we'll say thank you and we'll continue the other views in the upcoming sessions. Till then, thank you. Have you ever needed to focus on a specific section of your 3D part in CATIA or quickly show a detailed cut without cluttering your drawing? The solution is using clipping views and break views in CATIA drafting. They help you highlight the important parts, show details clearly and keep your drawing organized. Hello everyone, I am Sagar Rathod and welcome back to day 27 of CATIA series from 4 Dimensions Infotech. In our last session of day 26, we explored different drafting views like section, detail and auxiliary views. Today we'll take a step further. The topics we are going to cover today include clipping view with profile that focuses on a specific shape or counter. Then quick clipping view makes a fast section view with a complete boundary line. The third one is quick clipping view with profile, fast and precise with custom boundary shown completely. We will also cover broken views and break views which are used to show long parts in a compressed space. Next we will see add 3D clipping to control which part of the model appears in the drawing. Finally, we will explore the view creation wizard and different types of the views it offers. If you want to keep up with this series and never miss an update, hit that subscribe button and turn on the bell icon so that you can get notified every time with a new video comes out. So let's get started with clipping views and break views to make your drawings clear and professional. So now we will move to next type of view. The other view we are going to see here is clipping view. So clipping view is just like a crop view. Whatever portion from the view we want to crop, we can crop it and we can show it in the drafting. So it is similar to like how we crop images in our mobiles. So let's get started with the view type. For that we are going to call a different part here. Select window. First we are going to select front view. Go to window and we are going to take front view of different part now this time. So let's take a front view about this plumber block. We have just placed it here. We'll take it little bit aside. Now we'll go for clipping view. Select the clipping view and we need to make one boundary here. So I'm going to make one boundary. As we have selected the first option, the boundary will be made in a circular shape. Just click here and we can see the other portion of the part has been removed and only the circular internal portion part has been remaining here. So in this way we can clip or crop the part here. There are other types of clipping also, means customized profile we can go for that also. So let's make a crop view of this part. We'll drag this part outside. Now we are going to go for clipping view only, but profile. Means we are going to make a customized profile here instead of taking a circular boundary. Select the clipping view option. It is asking us to update first, so I'm going to make it update. Now again we'll select the command clipping view with profile. And one custom profile we are going to make this time. We just need to close the profile here properly. And now the customized profile is been added for making the view clip. Now for the next type, double click it here. Again go for clipping view. But this time we are going to select quick clipping view. The difference between clipping view and quick clipping view is this complete circular boundary will be shown. And in regular clipping view, the complete boundary of the circle was not shown. We can see it here. Earlier when we have made this dotted circle boundary is not shown completely here around this part. So for that only we are going to go for third type. Select the type and we are going to make one boundary that will be circular boundary only. But this time the boundary will be shown completely, not as a partial circle as it was shown earlier. We'll drag it here. So this is the main difference between the clipping view and quick clipping view. This boundary will be shown completely. And if I want the same quick clipping view with complete boundary but with a different profile, then we'll go for the fourth option. That will be this quick clipping view with profile. Now for that we are going to make this view active first. Double click here. After activating the view, we are going to go for the command quick clipping view with profile. This time only difference is this profile will be made customized instead of making it circular. We place it here and we can see this boundary was made and only the inner portion of that part is being shown here as the view has been cropped. But the boundary of this profile is being shown completely as we have taken the fourth option quick clipping view. So wherever the word quick is coming, this boundary will be shown completely and the inner portion will be shown of the part and the other outer portion will be deleted or cropped. So this was clipping view. Next we are going to go for the type that is breakout view. We'll take a new sheet now this time. Select the drawing, say OK. Select the A3 size only, landscape mode, say OK. Now we need to call front view. We are going to take this plumber block assembly view only. Select this face as the front view. If I want to arrange it, I will drag it somewhere here. Let's change the scale first. Go to properties and we are going to change the scale here. Select view, and in view we are going to change the scale to 1:2. Next thing we are going to do here is to change the projection method. For that I'm going to select this sheet in model tree. Right click here, go to properties again, and we are going to select the type here as third angle method. Third angle standard, say apply and OK. After changing the angle method, we are going to go for the projection view. This time the views will be projected in third angle. So this is the top view here. Again one more side view. If I want, I can take the isometric view also. So I'm going to go for isometric view. Select this second last option and go for the window. Select the assembly you want isometric. First arrange this view in isometric here only, and then go for the isometric view. Then we are just going to select the one face, and this view has been presented here as an isometric. Right click and go to properties and change the scale also. So in view, say 1:2, similar as we have done for the earlier views. If I want to show it, we'll make it show in color display. Right click and go to properties and change the generation mode, view generation mode. Instead of exact view, we are going to say raster here. Go to options and select the shading with edges option. Say close, apply and OK. We can see here. Next thing we are going to do here is go for the next view type. First we will see the breakout view. Later we will see the broken view. So for breakout view, select the option. Select the view you want to make a breakout view. Now make a profile around the view which you want to break out. Just make a close profile, and when you end this profile at this end, you will be directed to this screen here, part modeling interface. We can see this 3D viewer is being shown. Now here, if I want to adjust the planes, I can adjust the plane position also here. Means we can drag it and adjust it wherever you want. I'll keep it at the mid only. Little bit more at the mid center. Now say OK here. So we can see here this inner portion is being shown. Now if I want to transfer this broken section view into isometric view also, just right click here and go to front view object and select the option apply breakout to, and click on the view where you want to apply this breakout view. It is showing that you can't apply a breakout view to a raster view. So we'll change the view type here. Instead of raster, we are going to take exact view. Just double click it, make it active and go for properties. Here you need to change the raster to exact view. Say apply and OK. After that we'll select the view on which we have applied the breakout, and now we want to transfer this breakout to this isometric view. Say right click and go to this option front view object. Here you will get the breakdown window. Just go to this option, that is apply breakout to. Select this option, and we want to apply this breakout to this isometric view. Just click on this window for the isometric view, and we can see here this breakout view has been applied to this window also. Now we can see the inner portion. The shaft has been also been cut and shown, and all the internal features till this depth are being shown here. Now suppose if I don't want this shaft to be shown in a cut section in this particular view, we can do that also. So for that we are going to open the window, go to assembly first, and here on right click on shaft, go to properties, and in properties we are going to go for drafting, and we'll click on this option, that is do not cut in section views. Means the shaft will not be shown as a cut part in a section view. Click on this option as well as this option, do not use when projecting. Say apply and OK. Say Ctrl S here for updating, and now we are going to move to our drafting file. Say update here, and we can see the shaft is not being shown here. And suppose if I want to show this shaft again but without cutting, again go to window, go for the assembly, select the shaft, say right click, go to properties here. In properties we are going to select drafting, and we are going to put off this option do not use when projecting, and only put on this option, that is do not cut in section view. Say apply and OK. Again say Ctrl S and Ctrl tab. Next we are going to go for window and select this option, that is drafting file. We'll update it here. Now this shaft is being shown completely here. Even though we have taken the broken out section and all the other parts or components are being shown cut here, but this shaft is not being shown cut. It is because we have updated the properties in assembly. So in this way we can go for this option, that is broken out section. Now if you want to remove the broken out view, just right click on the view, go to this option, that is isometric view object, and here we have the option remove breakout view. This part will be shown completely again. Same here, go to this option front view object and you will get remove breakout. So moving to the next command we are going to see here is 3D clipping. For 3D clipping we are going to take a new assembly. So we'll change the window. Here we have motor blower assembly. So we'll take this file to drafting, say make file new. Here we are going to say drawing, say OK. Size we are going to take A4 only this time. Now we are going to call front view here. Select the front view, go to Windows and select the motor blower assembly. In front view we are going to consider this one. The scale is coming 1:1. We'll change the scale and hide this UCS icon. Now here one more important point to show you, that if you don't want this border frame, red colored border frame to be shown, you just put off this option, that is display view frame. If I put off the option, these frames will not be visible. And suppose if they are not visible, you want to show them again, just put on this option again. Here this option is going to come under the toolbar, that is going to be named as visualization. So in visualization just put on this option and the display frame will be shown again. Moving to the point, we will first scale the object. I'll make it little bit larger. Go to properties for that and say scale. I'm going to say instead of 1:1, I'm going to double the size by saying 2:1. Say apply and OK. Now I will project one top view also here. And I want to project one isometric view also. So for isometric view, change the window, and already the part has been set in isometric position only. We just need to select the face and it will be shown here. We want to change the scale of this view also, say 2:1. We'll move these views little bit aside. Always place the views in such a way that each view should be set separately and should be visualized separately. Next thing, adding the 3D clipping view. So 3D clipping is nothing but cropping the view only, but in a 3D platform or a 3D interface. So just select the command and you will be directed to the 3D interface. Here you can see this back plane is being shown. There are different modes of clipping. From this we are going to see back clipping plane first. So here we can see this back clipping plane is coming. If I don't want this motor body to be shown in this view or else in the front view, then we can just drag this plane in front. And whatever thing is coming at front of this plane, only that portion of the view will be shown. Say create. Now you can see here at this back side, this motor body was being shown earlier somewhere here, but now it is not being shown. I'll undo it to show it again. So we can see these edges are coming here, as well as the bottom side edge of the motor is also being shown here. But as soon as we add clipping view, this motor will be removed from the view. So again go for that 3D clipping. Just bring this back plane to the front side, removing the motor and putting the motor back of this plane so that it will not be visible in current view. Say create. And now we can see this motor body which was been shown in the form of edges is not been visible now. If I want the same thing to be done in this isometric view also, I don't want this motor to be shown, I'll just click on this view, go to this option front view object, 3D clipping, and here apply 3D clipping to. This option should be selected. This was done in broken view also, and click on the isometric view to remove that motor. We can see this motor has been removed now. Only the portion which was in front of the plane is now visible. So this was the basic way of doing 3D clipping. Now if I want to remove the 3D clipping, I just need to right click, go to isometric view object, and here in 3D clipping we can say remove 3D clipping. This complete view is being shown again. Same thing we can do here. Just go here and say front view object, go to 3D clipping and say remove 3D clipping. Again this motor edge or the borders of the motor will be shown. Now we'll see the second type of the 3D clipping. Go for this option and we have clipping by slice. Now in clipping by slice, I'll just drag this front plane and the back plane both. Means in this option you will get two planes for cropping or clipping. Just need to position them wherever you want. So I'll remove this front body as well as the motor body here. I'll just clip this cap as well as the rod. Say create, and we can see only the mid portion, that is this rod and this cap is being shown now. Cover cap. If I want to transfer this clipping to the isometric view also, we'll repeat the same thing. Just go to front view object, 3D clipping, and say apply 3D clipping to, and select the view on which you want to apply. We can see this cap, cover and rod is only visible now. Other front and back side portions are being clipped by the two planes. So this was the second method, second way. We'll make this view as it was earlier. Just say isometric view, 3D clipping, and say remove 3D clipping. It will be back to its position again without clipping. We'll remove the clipping from here also. The other option shown in 3D clipping is, last option is clipping box. So by clipping box, we will get all the 6 side planes to be cropped or make a clipping. So we'll move these planes here. We'll make this half of the portion, remove the upper portion, and remove the quarter portion of this assembly. We'll make this box in such a way that only this 1/4 portion will be shown. The remaining outside portion other than this cube will be removed. Say create. We can see here only this 1/4 portion is being shown by adding clipping box. Only advantage over the other types is you will get all 6 planes to be cropped, means more planes for cropping the part. We'll transfer this clipping box view to other view also, isometric view. So I'm going to select front view object, go for this option, that is 3D clipping, add 3D clipping. Click on this option and only 1/4 option view will be shown in isometric also. So this was 3D clipping by using clipping box. Now the next type remaining is broken view. So for broken view, I'm going to call a new part here. Broken view is nothing but a type of view which will adjust such parts which are long in length and are having same cross section throughout. If they don't fit in the drafting sheet, we can break them from mid portions and then adjust them in the drafting sheet. So we'll see. For that we are going to call one part. Go to this open file. I have saved that part in somewhere in folder. So we'll open this rod here, circular rod having 2 different cross sections. You can see this part now. This portion is been made flat from the upper and lower side both, as well as from the upper side, the left side portion is also been removed. We will call this part in drafting view. Go to drafting window and here we are going to call that part. So select front view option again, go to windows and go for this option to call that rod. Part is circular. We need to show a plane for the reference to take the front view. So I'm going to select this XY plane, that is front plane. This view has been placed by the scale of 1:1. Now if I want this view to be fit here in this particular portion of the drafting sheet, first I will make it broken from the midsection. Then we'll just go for the option broken view. Select the broken view. First you need to select the horizontal line. Then you will see one green line is appearing there. You just need to adjust it whether you want it horizontal or vertical. If I just flip the mouse, it is coming horizontal. Again flipping it, coming vertical. I'll place it somewhere here. As soon as I click, the second line will appear asking us where you want to position the second breakpoint. So I'll place the second breakpoint here. Just click here and click outside for 2 times. This broken view will be applied for this part. Now we can see this length. It is not showing as it was earlier, but still the length while displaying the dimension will appear same as it was while making the part. I'll undo it again and first we'll count the length here. So for length, we'll go for dimension, select this dimensions option, click here, then click here on this curve and you will get the center to center distance. It is coming 200. And when I apply the broken view, select the broken view, click on this edge and one green line will appear. Orient it as you want, vertical, horizontal. I'll place it vertical and then orient the second breakpoint somewhere here and just double click outside. But still this length is showing 200. This view is being broken from the midsection from one endpoint to another, but still the length is coming 200 only. and it can be easily placed where you want now. So for the views placement adjustment, it is very useful command. So this was broken view. Next we are going to see that command is view creation wizard. So for view creation wizard, we'll add one sheet here. Now for adding the sheet, you just need to go on this option, select add new sheet. This toolbar, first we will see the name of this toolbar. So the name of this toolbar is coming drawing toolbar. Here we will get the option new sheet. It is showing sheet number 1. If I select or click here, sheet number 2 also will be added here. Now we'll go for the view creation wizard, and in view creation wizard you will get different type of configurations from which you want to select. For the view arrangement you can select that configuration. So I'm going to select this configuration here, showing front view, bottom view and right side view. If I want to see the other configuration, just click here and you will see the changes. Now it is showing the left side view. If I go for this type, it will be shown in the first angle method. We can see here. If I want all the views to be shown, I can go for this also. So this window, here you will see bottom, isometric, left, right, top. If I go for this option, more views will be added. Rear view is also been added now. So whatever configuration you want, you can take here. I'll select this all view configuration. It will also show one value, that is minimum distance between each view. Now it is taking 40 mm. If I want to change the distance, I can change it. I'll say 60 mm. That will be distance between each view. Just say finish. But here no views will appear directly. The command is still going on. That's why this icon is showing in red color. The command's name is view creation wizard. Now for selecting or showing all the views, you just need to go in Windows as you are doing for the isometric and other front view. Just go here, select the assembly you want and click on the front face. Just by clicking on the front face, you will get all the views you require. So here we can see front, bottom, top, right hand side, left hand side and rear view. We can adjust them as we want later. We have taken 60 mm distance for each view, that's why they are being shown in this way. So all these views for this particular assembly are being shown now, including the isometric view. So this is a very helpful command here. We can see the other options also, front, top, left, front, top, bottom, all views. All the types which were present in this option are shown here at the upper side also. So this was the lecture based on remaining views. We'll continue with the dimensioning in next lecture. To understand the earlier views before 3D clipping, such as section view, front view, top view, side view, auxiliary view, we have already made one lecture. You can see the playlist. The earlier lecture was based on these views only. Later we have added this lecture which included 3D clipping as well as broken view and all view creation wizard. So this lecture has been made in 2 parts. For complete understanding, first was the first part and then was this part. So this was Sagar from 4 Dimensions Infotech. Do like, share and subscribe the channel. Share this video as well as the playlist of CATIA with your friends to understand or learn the CATIA software. You can also join the offline classes. The number will be given in the link below. We'll continue with dimensioning and dimensioning type in next lecture. Till then, thank you. Have you ever finished creating a perfect 3D model in CATIA and then struggled while adding dimensions to the drawing? Too many numbers, overlapping lines and confusion everywhere. Well, don't worry. Today we are going to fix that, because a good drawing isn't just about views. It's about clear and accurate dimensions that make manufacturing easy and error-free. Hi everyone, this is Sagar Rathod. Welcome back to day 28 of CATIA series from 4 Dimensions Infotech. In our previous session, day 27, we learned how to create clipping views, break views and 3D clipping tools that help you display the right portion of your model clearly. Now we will move to something equally important, that is dimensions in drafting, where precision meets presentation. We will start with chain dimensions, where each measurement continues from the previous one, ideal for step-by-step or sequential parts. Then comes cumulated dimensions, where all measurements starts from a single base point, clean, organized and professional looking. Next we'll talk about stacked dimensions, perfect for saving space and keeping your drawing tidy. We also cover length dimensions and thread dimensions, which are essential when you are dealing with bolts, shafts or threaded components. Then we'll move to the coordinate dimensions, great for making exact point positions. And finally we'll explore hole tables and coordinate dimension tables, which automatically list hole sizes and positions directly from the 3D model. By the end of the session, you will know how to present every measurement in a way that's neat, professional and ready for production. And if you are new here, make sure to watch the entire CATIA series from the beginning. Each session builds on the previous one, helping you learn CATIA step by step. Don't forget to subscribe and press the bell icon so you don't miss our upcoming sessions. Alright, let's begin with dimensions in CATIA drafting, day 28. So to start with, I'm having this part here. We'll take this part for drafting and we are going to apply dimensions and see what are the different types of dimensioning methods in drafting. So let's get started. But before that, do like, share and subscribe the channel and hit the bell icon to continue watching the upcoming videos. We are going to take this file to drafting, say start mechanical design, and here we are going to select drafting. We are going to take empty sheet only, modify the paper size here. The format is coming in A4 ISO. I'm going to select modify. And we are going to take A3 size here. Say OK. So after taking A3 size, one empty sheet is appearing. We are going to call the front view for the required part. Select the front view, go to Windows, and this part is been on in background. So I'm going to select that part. We need to select the front view. The oriented preview window will come here at this side. Just observe whether you want the front view, it is coming or not. The desired front view, it is showing or not. I'm going to select that face. It is coming as a front view now. If I want to rotate or make any changes here, I can use this wheel here. Just click outside the window now and the view will be placed. We'll change the scale here, say properties, and we are going to say scale as 1:2. We'll take the half size only so as it can adjust easily in the drafting sheet. So next very important thing is to change the angle method. So I'm going to right click the sheet and go for the properties. Here we are going to select the angle method. So the angle method we are going to use is third angle method here. By default, CATIA always takes angle method projections in first angle only. We are going to change it to third angle. Now say apply and OK. We'll take the projection views now. Upper side view and the right hand side view. After placing the views, just arrange the part as you want and go for the isometric view also for proper visualization. Go to window, drafting, and first we'll arrange this part in isometric view. For that we are going to use view toolbar. So here we'll see whether view toolbar is present or not. We can see view toolbar is not showing here. So we'll call the toolbar now. Just click on this empty space and you will get the options. I'm going to call the view toolbar here. It is not been displayed here also. So say customize. If you are not getting any toolbar, just do this thing. Go to customize. Select the toolbars option and say restore all contents as well as restore position. Say OK again. Say close now. So now we can see the view toolbar has been appearing here. Just make sure that this part has been arranged in isometric view in part modeling first only. Then it is easy to take this isometric view in drafting also. Just select the face now and this view will be appeared as an isometric view in drafting. Change or update the scale here also. Go to properties. We'll take this scale as 1:2 only here. Put off the extra toolbars you don't want there. After arranging the parts, we are going to go and select this toolbar, that is dress up features. In dress up, we are going to see different type of center marks here. So we'll start with the regular center line. After selecting center line, you just need to click it here. You can see center marks are been appearing. As I've selected this center mark for once only, so only one center mark has been appearing. If I click on the other, it will not take there. So if you want to continue giving the center marks back to back, you just need to double click it here. Now, we can see the center marks are coming back to back here. Say escape to end the command. Next type of hole we are going to see here is center line with reference. So just select this command, double click for continuous selection. This is the first circle. As the name indicates, center line with reference, we are going to take this circular edge as the reference. Again the second circle and this edge, third circle and this continuous edge, fourth circle and this edge, fifth one with reference, sixth with reference. And when you zoom it, you can see one dotted circle type shape has been created along all the circles, which will act as a PCD, pitch circle diameter. Again the next circle and reference and the last one. So here we can see a PCD like circle has been appearing along all the centers. So in this way, this command is important to create a PCD type circle here while dimensioning. Next type is given here as thread. So if you want a threaded center mark, just click on this icon. I'll escape and double click it here for applying continuous center mark with thread. So double click, we can see a center mark is coming with threaded hole icon. So in this way we can use this threaded center mark. There is one more option, threaded center mark with reference. For that I am going to remove all the center marks which we have made earlier. So I'll just delete all the center marks here. We'll again repeat. Now we will apply the thread with reference. Double click it here. It is same like center mark with reference. Selection method is same. You can see one PCD has been created here. Only the difference is this mark is threaded type. Here we can see this icon, partial circle and complete circle, is for threaded holes only. This is actually a sign for tapping holes. We'll move to next type in center line. So the next type is access line. For that we'll do one thing. We'll put on the hidden lines here. Go to properties. Put on the hidden lines. We will get the center line by there itself, but we are not going to put on the center line here. Just say hidden lines on and apply and OK. Now if I want to make a center line for this circular hole, you just select these options, access line, and select the holes in cutouts. You can see access is coming for all the center line. We would have done this in this way also, that select the properties and put on all the access. Say apply and OK. Even in this way all the access would have been shown. Lastly we are going to see one of the important command in center marks, that is center mark with access line reference or access line and center line. Select this command. I'm going to double click and select it for multiple selections. This type of command is used when the hole alignments are same. So from drafting and manufacturing point of view, this hole alignment lines are to be shown compulsorily so as to understand the alignments of the hole. So just select the hole, second hole, third one with the second reference, with the fourth reference. Again fourth with the first one. So in this way you can see the center line and center mark both are coming, showing that these four holes are aligned with each other. It is very useful because when I provide dimension for this hole, means that dimension is to be followed for the upper hole also, for the vertical alignment. Same way, if I provide the dimension from the horizontal reference to this hole, this vertical dimension is to be followed for the second hole also, as both the holes are in horizontal alignment. So it is very important here to make center marks or center lines in this way when the holes are in proper alignment. So next we are going to continue with the dimensioning. This is the part we are going to take this part to drafting now. So to start with, I am going to select the file, say new, and go for drawing. Select the drawing option and say OK. And now we need to select the paper size. We need to select the orientation. We are going to take A3 and orientation as landscape. Say OK and finish. Next we need to go for view toolbar and we need to select front view to call the views. After selecting, go to Windows and you need to make sure that the part is open in the background, whichever part you want to draft. So this part has been opened here. I'm going to select this part. Now select the face you require as a front view. So here one window will appear in the lower right side showing that which face is going to be looked as front view. So I'm going to select this and say this face here as front view. Once the view is placed, just click on the screen. Next, if you want to change the scale and angle method, you can change it here. So for changing the angle method, by default CATIA takes first angle method only. So we are going to change it to third angle method. For that we are going to select sheet 1, say right click and go to properties. And in properties we need to select third angle method. There is the option given, projection method. I am going to select third angle method, say apply and OK. Now we need to change the scale also. So I am going to select and say the properties option. Right click on the view and select say properties, go to scale and say 1/2, 1:2. Now if I want to change the text size, I just need to select the text and here we have the toolbar known as text properties. Just go there and change the size. After selecting the text, then you need to change the value. I'm going to say it as, now it is 3.5 as a font size. I'm going to say it as 2. This is one of the method, or else you can do select the text, say right click and go to properties. Here also we can change the font size. So in font only we have this size been given 2, 2.5, 3.5, 5. If I want the size to be put as 1.8, I'll type here, say finish and OK. Now the size has been updated as 1.8. So you have both the options. Either you can go for this text properties toolbar, or else you can just right click by selecting the text and go to properties and change the size there. Next we need to take the projection views here now. So for projection views I'm going to select view toolbar, and here we have the projection views option. I'm going to take the top view as well as one side view. Place it and arrange it properly here. Then start dimensioning. Now we can see the text size for this view was changed. I want to change this text sizes also. So for that we have this option here, copy object format. It is similar to AutoCAD's command, that is match properties. So you just need to select this command, copy object format, and select the text you want to change first, and then select the source text in which you want to convert your selected text. So the size of this text has been converted to the source text size. Same you can do here also. Select the text you want to change, then select the source text. So in this way, text can be matched here by the size. Next, we are going to go for dimensioning toolbar. So for dimensioning toolbar, we have this option here. There are two options been given, technological feature dimension as well as dimensions. We are not going to see these technological feature dimensions. This toolbar is sufficient for giving the dimensions. Now, there are multiple types of ways for giving the dimensions. We will see each of them one by one. So first we'll start with dimensions option. So by selecting this option, you can give the length, radius, diameter, whichever type of feature there is, the dimension will be provided according to that feature. Then second one is chain dimensions, means giving dimension point to point. Third one is cumulated dimension. It is similar to coordinate dimensions, means zero reference first is given and then the other dimensions by the reference of datum 0 will be added. Then next one is stack dimension. It is similar to ordinate dimension only. Only one reference will be taken for the datum and the other dimensions will be placed. Then this option length distance dimension is used for giving length only. This one is for angle, this one is for radius, and this one is for diameter. So there are separate and segregated dimensioning methods here. We will see each of them one by one. For chamfer also there is option given. So we'll start with the first option, that is dimensions. I've selected the dimensions. You will get this tools palette. Here we can see the option that is projected dimension, means maybe it is horizontal, vertical, incline, whatever type of dimension you want you can take. If I go for this, it will take only aligned dimension. If I go for the third option, it will take only horizontal dimension. If I go for the fourth option, it will take only vertical dimensions. So there are different types of methods here in tool palette. I'll go for the first option only. So we'll select this circle here. You can see diameter has been added. If I select the same option for dimensions and go for this length selection, then the linear dimension will be added here. Now before adding the dimensions, first we'll do one thing. We'll delete them. And first we'll provide the center marks here. In the last or previous lecture, we can say we have seen this command bar, that is trace of features, in which we have seen how to provide center line, center marks, different types of center marks were there. So we'll select this center line, and for the holes we are going to provide this center marks here. I'll double click it for continuous selection of the center mark. After providing the center mark, we are going to go for dimensioning now. So again, we'll select the dimensions option, first one, and we'll provide this dimension here, this length and this length. As I've selected it for once, the dimension will be provided for one time only. If I want to give continuous dimension, I need to select it by double clicking it, and now we can give continuous dimensions back to back. We can see here, say escape to quit this option. Now if I want to change the precision value, we have this one toolbar name as numerical properties. So in numerical properties, you need to select the dimension, and after you select this dimension, this option will be unfreezed. Here you can change the precision you want. So if I want the roundup value, I'm going to select this first option, that is 1.0, means the roundup value will appear. No decimal numbers will appear after this point. If I go for 0.1, one decimal will be appearing there. You can see here, only 1 point or 1 value is coming here. If I go for 2 decimals, I'm going to select 0.01, then 2 decimals will come after this point. So whatever precision or how much precise value you require, you can select the zeros from here. So this was precision. If I want to make this value round up, I'm going to select this value. I'm going to select the first option. Now it is showing roundup value. If I want this precision value to be coming as 0.1 only, select this one and select 0.1. Now this value is coming in 0.1 only. After that, if I want to change the text size, now the default text size is coming 3.5. If I select this text size, you can see here this default size was 3.5. If I want to change it, I'm going to select it and say 2 instead of 3.5. Here this value has been updated. Now after changing the text size, if I want to change the other values also in the same size, I'm going to select the same option, that is copy object format. Select this option. First select all the dimensions you want to change. If this doesn't work for the selection, say escape, and then first get selected with the values or dimensions you want to change, and then go for the command. I'm going to select, after selecting the dimensions, I'm going to select this command, and I'm going to say I want to change the sizes of the text to this size, this dimension size. Select this one, and all the sizes will be updated according to the last selected dimension. So in this way you can select or update the text size here as well as the precision values. Next, if I want this text to be placed outside the dimension line, you just need to select, say right click, go to properties, and here in value there is option been given position. So in position, if I say outside, the text will be placed outside. You can see here this is the dimension line and this text has been placed outside this dimension line. If I want it again to be taken inside, just select the text, say properties, and here in position I'm going to say auto or inside, say apply and OK. Again it is coming at inner sides. So in this way you can position the text. If I select this option again, say right click and go to properties, and here in properties we have the orientation option. So now this orientation is coming as parallel. I'm going to say perpendicular. Say apply and OK. Now the text will be placed perpendicular to the dimension line. So in this way you can change the position or orientation of the text or dimension. Select it once more, say right click, go to properties and make it parallel again. Say apply and OK. Now if I select this text again, say right click and go to properties. Now in properties there are some more options. So I'm going to select, say right click, selected the dimension, go to properties. Here pull this scroll bar downside, and here you will get the format option. Now the format is coming in decimals. If I change this format to fractional and precision, I'm going to select as 1/10. Say apply and OK. Now you can see this value is being shown in fractions. Instead of decimals, these values are being shown now in fractions, 1/2. So in this way you can change the value type as from decimal to fractions. Again I'll update it to decimals here. Right click and in value tab only, just go downside, and here you will get format option, say decimal. Precision, now it is coming 1. If I want to change the precision, I can say 0.1, 0.01, 0.001 or 3 decimals also. So how much decimals I may require after point, I can add it here. Same option we have seen earlier also. If I want this value also to be taken in 2 decimals precision, select this, properties, and from here also you can update it, that is in value tab, precision 0.01. Say apply and OK. So there are 2 decimals coming after the point, 0.01. Okay. So this was the method for changing the precision as well as changing the text size. We can also change the dimensioning method from decimal to fraction or fraction to decimal. Next, now suppose I am going to select this value 60, go to properties, and in properties I am going to select the position here as perpendicular, say apply and OK. Now it is showing this height as 60 mm, and I want to add tolerances also here. So I am going to select it again, say properties, and here in tolerances option you can add the tolerances. So I am going to select and say tolerance by numerical, or ISO tolerance also we can take. So I'm going to select this one, tolerance num2, and here we can add the tolerance values. So I'll add 0.2 and 0.1. You can see here this type of tolerance that is coming only in positive side is known as unilateral tolerance. So one unilateral tolerance value has been provided for this particular dimension. If I want to make it bilateral, means on plus side one tolerance is coming and on minus side the other tolerance value will come. For that I'm going to select it, go to properties, same way I just need to add one minus sign here. Say apply and OK, and this tolerance in the form of bilateral way is added here. So in this way we can add the tolerances here. Suppose if I go for diameter value, I'm going to select the dimension option only and provide one diameter here. Now if I want this value to be shown in horizontal way, that is to break this line into two and make this value horizontal. I just need to select the dimension. Here you will have the option in second number, that is dimension line. So here this option is been changed. The toolbar name for doing this is dimensional properties. So in dimensional properties only, if I go again for this first option, that is dimension line, the text will be aligned with the dimension. So for changing, again go here and select the second option, that is dimension line. You can do this in properties also. Select, go to properties, and here in dimension line and say by two parts. Apply and OK. Here this dimension line is broken into two parts and this text is coming horizontal. Now one more thing. Every time I am selecting the text size is coming in 3.5 only, because it is standard size being set in the standard properties. Now the next type of dimensioning method is chain dimensions. So in chain dimension, first I am going to go for tool palette and I am going to select this type here as force vertical dimension. As I am going to provide this dimension, that is this vertical dimension from this line to this hole, then the other hole, and then the other feature. So I'm going to go vertically for dimensioning. That's why I'm going to select this option here as force vertical dimension. Select the first option, the second one, the third feature, and the last feature. And here we can see these dimensions are being provided. Chain dimensions means from point to point. This was the first point till the second point, then till the third point, and then till the last point. So chain dimensions means point to point dimensioning. Again, if I want to change the text size, select the chain dimension and change the text size here. Make sure that text are being placed away from the part in such a way that all the distances are constant while giving the dimensions. Here also and here above also. So this distance, if I am going to take this little bit more, and for this dimension I'll take this much close, then this is not a proper way of dimensioning. This drawing will be rejected directly from the company side. So if I want to provide dimensioning in a proper way, I just need to maintain this distance constant for every dimension. That should be followed for all the dimensions. So let's do it here. For this dimensioning method also, just zoom it little bit and position it by dragging it somewhere. So in this way, it will look proper now. Next, after chain dimensions, we are going to select and say cumulated dimensions. Cumulated dimensions are similar to coordinate dimensions, means starting the dimension from the zero reference and then going on continuous with the dimensionings. So I'm going to select cumulated dimension. I am going to select this one as zero reference. Then the second reference I'm going to give this whole, third reference, then this fourth, this fifth, and this last. So we can see here with the help of zero reference geometry, this was the zero position or start position. This hole was placed at the 15 mm distance. The other feature was placed at 40.21, the other one at 81.3, and so on. So this is also the another way of giving dimensioning, that is cumulated dimensions. Once more we are going to see cumulated dimensions. Select, I am going to say horizontal this time. Force horizontal. This will be the zero reference. This will be second reference. This will be the third one, and this will be the last one. So we can see here. I'll place this text somewhere here. Now if I want to change the font size, just select the dimensioning way and go for this font size. I'm going to say 1.8. So in this way you can provide the cumulated dimensions, maybe horizontal, or you can take vertical also, which we have taken here. First will be the datum reference or zero reference, then the other features one by one to be selected to add these values. After cumulated dimensions, we are going to select the other way, that is stacked dimensions. So for stacked dimensions, I am going to delete this dimensioning method here, and here we are going to select stacked dimensions. For stacked dimension, it is similar to cumulated dimension only, means only one datum reference is referred to start the dimensions, and the dimensions will end at the different features. Means starting point will be the same and the ending points will differ. So I'm going to select this one as the starting datum reference, then this second one. If I want horizontal or vertical, I'll decide it. I'll take it vertical only. Then select the second one, then select the third feature, then the last feature. I'm going to take this one. So in this way also you can provide the dimension. These are known as stacked dimensions. We'll change the text size here also. Select the dimensioning way. I'll say 1.8 only. We'll place it a little bit closer from the object. So this will be proper now. Next in dimensioning method is length dimension. So for length dimension, you just need to select the length you require for giving the dimension. I'm going to select this line and this line. This value has been provided. If I want to change the text size, I'm going to select this option, that is copy object format. Select the text size you want to change first and then select the destination text size. It will be updated according to the destination text size. So the next type will be for giving angles, angle dimensions. Select the type and select the lines in between which you want to provide the angle. So I'm going to take this side. I can refer this side also, or I can go for this side here. So I can position it at whatever side I want. I'm going to position it somewhere here. Again, if I want to change the size, copy object format, select the first value, select the second value. The size will be modified to second value. If I want to place it at the inner side, I can change the position of the text. This angle has been provided. One more time, angle. Select this line and this one. And here you can position the angle. Select the object format. Select the value you want to update and select the source value. One more time, it is updated with the size also now. Next, if I want to provide radius, I'm going to select this option. And for radius, I'm going to go and select one circle here. Now this value of the circle has been provided in radius. If I want to change it to diameter, I'll select and delete it. And here I have the option for diameter also. I'm going to select this type for diameter and select the circle here. Now we can see the diameter has been provided here. Format size. If I want to change the decimal and make it horizontal, right click, go to properties again, and here dimension line. I want it to be taken in two parts, and as well as I want this value precision to be updated by double digits to single digit. Precision I'm going to take 0. Instead of 0.01 I'm going to take 0.1 only. Say apply and OK. So the precision as well as the arrowhead type, that is this text will come horizontal, is been updated. Next, now we will see one more option in dimensioning for editing, that is reroute dimension. For that, first we'll provide one dimension here. So I'm going to take the first reference as this circle and second one as this circle. We are going to place the dimension somewhere here. We'll move this text from here to this side. Now for providing this dimension, I have taken the references of this two circle. But if I want this circle to be positioned from this line, means I want the position of this circle to be presented from the line instead of this circle, then I'm going to say reroute. Select the dimension first, then select the circle and select the reference from which I want to position this circle. So this dimension position has been reroute. So instead of taking the reference from this circle, now it is taking the reference from this line. Similar, we'll do one more time here. Select this circle and this circle. So this value, vertical value, it is coming as, we'll take this position downside, 34.42. This is the distance between these two circles. But if I want to change any one reference, I'm going to select this reroute. Select the dimension first. Select this circle and then select the reference. Instead of taking this circle, I'm going to take this line. So this reference value is also being changed. It is coming from this line now. Means the position of this circle is coming from this line. So this is the option reroute. Control press and select both the dimension, then go for the format, copy object format, and select the source text size as this value. The sizes will be updated again. Position them accordingly, not much away from the body. Now if I want to change the text style, I just select the dimension, go to properties, and here you will get the font tab. In font tab we can change the text styles also. So I'm going to select this one, say apply and OK. So now this text is looking little bit different as compared to this one. If I want to change it again, I just going to select the properties again. Here I'll change the style, say apply and OK. So we can see here it is now coming a little bit bold and much thicker as compared to earlier one. So in this way you can change the font styles or text styles also here. After giving radius and diameter, we are going to continue with the chamfer dimensions now. So we will see how to provide chamfer values. For this, select the option below diameter option, there is chamfer dimensions. Select it. Here in this tool palette, multiple options of presenting the chamfers are been given. First one is length and length, means both the lengths will be shown. Second one, here the length will be shown first and angle will be shown in second number. Third one, angle will be shown first and length will be shown later, and so on. There are multiple options. So we are going to try here angle and length. So as soon as I click on angle and length, I just need to go on this edge of this part and you will see some numbers are appearing there, 2, 1, 3. So this number, if If I drag this fingertip below side of the edge, the numbers will change. Now it is showing 312. If I drag it again at the upper side, the numbers are again changing, showing 213. So I just need to click on this ratio 213 and you will see one chamfer value is coming, 14.43 into 60. But I think this value is not correct because this value is coming in even numbers with higher precision. So I'll try the another one configuration. Again go for chamfer, select the length and angle option only, again click here, but this time I'm going to take 312. Before we have taken 213, now it is time to take 312. Means drag at the lower side of this edge and then click here. So now it is showing one more chamfer value, that is 25 by 30. So it is a roundup value and this was the value which I have provided for the chamfer. So I will delete the earlier one. So that is very important to understand that if you are having numbers there 213 or 312, means the references are changing for the chamfer. Here 25 into 30 means it is taking the value from vertical face and then angle for the horizontal face. And if I go for the earlier configuration, it was taking chamfer from the horizontal edge and then the vertical edge. That's why they were having two chamfer values, 213 configuration and 312 configuration. I'll delete this one again. We'll repeat this chamfer. If I go here, 213 means it is taking the reference from this horizontal edge and this incline edge. That's why the value is coming in this way. But if I go for the other configuration, selecting the same edge, just dragging it below side, 312 configuration is coming. Now it is taking the reference of the vertical edge and this incline edge. Earlier was horizontal reference and now this time as soon as we drag it downside, 312 means vertical configuration reference. So in this way we can provide the chamfer. Again, if I want to make this horizontal, just click it here, go to properties, and in properties go to dimension line. Here you will get representation. Just select it and say 2 parts. Say apply and OK. If I want to make this dimension also horizontal, I just need to select copy object format, select the dimension you want to change and select the source dimension. So you can see here it is updated now. Just the position of the chamfer has been made horizontal. I will delete this configuration as it was not correct. The right configuration for chamfer was 312. It is coming with this value. After chamfer, we are going to select the command known as thread dimension. So for thread dimension, first I will make this view threads visible. So I am going to select properties, go in properties. Here we are going to select thread and say apply and OK. But still the threads are not visible because we need to put on the hidden lines also. I am going to put on this hidden lines also here. Say apply and OK. Now we can see there are multiple holes been given having threads. I just need to select this option, thread dimension, and we need to click here and you will get the value. The thread size is M10 into 1. With the depth of thread, the value is coming 35. Means the threads are to be taken till 35 mm and the hole depth was 40 mm. And the size for this hole was M10 into 1. M10 means metric size 10 and into 1 means pitch was of the 1 value. If I minus this 1 from this 10 value, if I minus this value 1 from the 10, I will get the value 9. Now 9 is the diameter for these two lines, these two internal lines. And the metric size 10 refers to the outer to outer lines. In this size is outer to outer line size is 10 mm, inner size dimension will come as 9. So in this way threads are to be calculated. Next, if I again want to make a tap hole here, I just go to the part and here I'll create one tap hole. For that I'm going to select hole command, select the face, and here in thread definition I'm going to give the tap hole. I need to select the size here as M20 into 2. I'm going to select it, so it is coming now M20 into 2. Say apply and OK. Say Ctrl S for saving the part and then go for drafting again. And here we need to say update as we have changed one feature, as we have added one feature here. So this hole is coming now. So we will add one tap hole symbol here. So in dress up features we have the symbol. Just select this thread option and give it to this hole. Now I want this tapping to be shown here. We can see this hole coming. So I'll select the option thread dimension and I'm going to select this hole here. We will get the value M20 into 2 with the thread depth of 25 mm. This is the thread reference and this was the hole. It is not shown properly. From this line to this line, this was the hole, and the thread references these two edges, these two outer edges. We can see here M20 into 2. After giving these values, we are going to go for the next option, that is coordinate dimensions. So coordinate dimension refer to, if I want to give any single hole a position value, then we are going to go for this option, that is coordinate dimension. Suppose if I want to go for this hole's position, I'll just double click it here to activate this view. As soon as the view is activated, we can see the origin is coming here. Now if I want this whole position to have the references from the origin as a dimension, then we are going to go for this coordinate dimension option. But before that, first we'll add one center mark here. It is compulsory to add a center mark, then only you can use that option. So I'm going to add one center mark first. As soon as I have added the center mark, I'm going to go for the option, that is coordinate dimension. Select this hole here, click on the center mark here, and you will get the coordinates, X and Y coordinate for positioning the hole. It is very much needed if you are working on CNC, VMC or wire cut DDM machines to produce the holes, that ordinate dimension should be present there, so as to understand where to position the hole properly. We are getting the X coordinates here. As this hole is placed below the horizontal axis, that's why this X value is coming in -55, minus value. And as the hole is also placed at the left side of the y-axis, that's why this value is also coming in negative sign, that is -45. So this whole position has been defined now. Again, just add the center mark first and then go for the coordinate dimension. Click here and you will get the value. Now this y value is coming at little bit above the horizontal axis. That's why it is showing positive here. So in this way we can provide the coordinate dimensions. Next type in dimensioning is whole dimension table. So for whole dimension table, I'm just going to select the whole dimension table here. Next, we need to select all the holes present in this particular area. So I'm going to drag a window to select the holes. As soon as I've selected holes, this axis, system and table presentation chart is going to appear. Now it will ask you, how do you want to label it? I'm going to label it by capital ABC. There are multiple options, small ABC, index values, or if I don't want to label them, I'm going to select ABC here, then say OK. And one table is been generated showing the XY coordinates of all the selected holes which we have taken in the window. And the initials are also coming. Suppose if I refer to this D hole, I just need to go on the D value. D value is showing the X and Y coordinates of the hole as well as the diameter of the hole. You can see here. If I go for the C value hole, then the C1 is positioned at 75 in X direction and 45 in Y direction, and the diameter is coming as 8.92. It is tap hole only. If I change this precision to round up value, it will show 9 mm value. As we have taken M10 hole, that's why it is coming 8.92, means approximate 9 mm. So in this way you can refer this value from this table to understand whether which size of hole is being placed at what position. Next one is this coordinate dimension table. Now in coordinate dimension table, it is not much used, but if I want to show any coordinates, suppose if I am having multiple coordinates on this face, I'll take points as a reference of coordinates. Just double click it here. First point, second point and third point here, fourth point and fifth point. So total points I have taken here 5 points. If I select this option, that is the last option in the dimensioning, coordinate dimension table, I just need to select the view. I will drag and click the window here. We can see the orange window coming. It will select only the points. And now it is asking us how to present the table, whether to label them in ABC or 1, 2, 3. So I'm going to select ABC only. Just say OK and the table will appear here. This table now will show the X and Y coordinates of the holes here. So we can see here ABC, but now it is getting confusion because here also we have taken ABC only. So this time I'll delete this table and again go for the coordinate dimension table and select the points. I want only this area points to be taken. I've selected them, and instead of this ABC, we are going to take numbers here. Say 1, 2, 3, index numbers. Say OK now, and this table is appearing. Now it is showing the numbers. We can see here. This is 4 number. This is 5 number point. This is 3 number point, and so on. So these ordinates are showing the position of that points here, x and y ordinates. So this was the option. Only 5 points were there, but 6, 7, 8 are the center mark which we have provided for the holes. That's why they are also been considered in points. Now next type, we have seen this first option, that was reroute dimension. We are going to select this create interruption option. Now what is this create interruption? For that I'm going to go here and I'll give one more dimension here, adding one more dimension. Double click, just click on these two references and one dimension has been added. Similarly, this and this line reference and one more dimension has been added. Now I'm going to go for this option, that is create interruption. Just double click it here, click on the dimension, again click one more time where you want to create interruption. So I've clicked here on this portion where this 60 mm dimension line was intersecting this extension line of this value. So this interruption has been created. This option is not much used in industry, but we can try this option also. Next one is create modify clipping. Now if I go for this option create modify clipping, I just need to select the dimension and one side. You can see here, now this dimension is showing on the one side reference only. Both the sides are not referred while showing this dimension. So this was the option known as create modify clipping. If I want to remove this modify clipping, I just select the option below that, remove clipping, and click on this dimension. Again, both the sides are referred to show the dimensions. One more time, just say escape, go for this option, select the dimension and select the side you want to remove, and select this side. The dimension will be shown only from one side. This side has been removed. If I want to remove this clipping, select this and say remove clipping. So these were the options we need to see in dimensions other than the dimensioning options. We have seen this one earlier only, and now we have seen only these 4 options. So this was dimensioning in CATIA. Hope you understand the lecture. Do like, share and subscribe the channel. Share this video to your friends who want to learn CATIA. Contact us in the number which is given below in the link. My name is Sagar Rathod. We'll continue with the CATIA series in next lectures. Till then, thank you. We have completed with CATIA sketcher, part modeling, assembly, surfacing, and now at current we are uploading the lectures for CATIA drafting series. So in drafting we are going to see how to apply GD&T here. Before that we need to see some theory also. So for today we are going to take this shredder machine for drafting. Say start mechanical design, and here we are going to switch to drafting. We'll take this empty sheet A3 size, say OK. Go to front view now and go to window for selecting the product. I'm going to select this as the front view. So now we can see this view has been appearing, but the drafting sheet of A3 size has been shifted to background. We can see this rectangular shape. This is the drafting sheet of A3 size, but as compared to this view is coming a little bit larger, so we need to scale this view. I'll just click it somewhere here on the screen, drag this view aside, go to sheet first, right click and go to properties. First we need to set it to first angle or third angle, so I'm going to set it to third angle. Scale we are going to take 1:16, and now we are going to place this view in drawing sheet. So after placing the views, now we are going to take projections. This is the top view and one side view also. We'll delete this text. We have taken this model to apply GD&T, but before that now we are going to see some theory about GD&T. So we will switch to one PDF here and we will see some basics about GD&T. What is GD&T? So here we can see what is GD&T. The full form of GD&T is geometrical dimensioning and tolerancing. It is a symbolic language used on engineering drawings to clearly and precisely define the geometry, allowable variation, that is tolerance, and permissible deviation of part features. It ensures that parts fit and function as intended even with the variations in manufacturing. So basically GD&T is a kind of language which is used between manufacturers and design engineers so as to understand the part and design the part accordingly. So why GD&T is important here? The aspect according to functionality. It ensures the part will assemble and operate correctly with the mating parts. And according to the aspect of precision, it specifies exact form, orientation and location of features. According to interchangeability also it is very needed. It allows parts from different batches, vendors to work together properly. It also helps in cost optimization. It reduces over tolerancing, which saves cost on manufacturing and inspection. That's why GD&T is very important aspect here. Next, there are total 14 basic symbols of GD&T, and we are seeing that here in this chart. So the symbols are categorized in 5 categories here. There are total 14 characteristics and 5 categories. So the first category is form, which includes straightness, flatness, circularity and cylindricity. Second one is profile, that is profile of line and profile of surface. Third one is orientation, which includes angularity, perpendicularity and parallelism. Fourth one is location, which includes position, concentricity and symmetricity. And the last one is runout. There are 2 types, which are circular runout and total runout. We can see each of the characters symbols also here. In many interviews, the symbols are being asked. So better if you learn these symbols by heart only with the names of the characters. So we'll start with straightness first. So in straightness, this is the part and the upper edge of this part is been considered as straight. That's why this frame is been added. This frame is nothing but GD&T frame or characteristic feature frame. This frame firstly includes the symbol of GD&T. Second comes the tolerance value and third here will be the references, datum references. In some cases like this, modifiers are also included here in this frame, that is feature control frame. So we can see here this part is being shown and this edge is coming straight. That's why the symbol is been added, and the tolerance value to compensate with this straightness is 0.1. So what this 0.1 means? In actual drawing callout meaning, when you manufacture the part, this part will appear maybe something like this, and at that time we can see the deviation is coming here. But if this deviation is lying under the value 0.1, which was allowed to be deviated, then it is coming in the tolerance zone of 0.1, which is okay. So even if this deviation is occurring and that is within the tolerance zone, means this part is okay according to manufacturing. The way of measuring or manually gauging method is using dial gauge. You can apply dial gauge and consider what is the straightness variation here. So we have added the tolerance 0.1 in the tolerance control frame itself. That's why it can deviate from 0.1 mm at any side of the straightness. So in a pictorial view, we can see that these are the upper and lower lines under which this main surface line is coming. So we can consider that the tolerance zone for straightness is the parallel lines within which the actual surface element must lie. There are no zone modifiers here to be added in straightness. So for the example, we can see this angularity also here. So in angularity, we can see these 2 datums are given. Datum means the references from which we are going to measure the angles and all. So here the datum A, that is the horizontal surface, and datum B is the vertical surface, and this surface is been made inclined cut. So the angularity symbol is added in the control frame. 0.1 is the tolerance that is to be considered when manufacturing. So the part manufactured may come like this uneven, and at that time that 0.1 tolerance zone is being shown by these 2 planes or 2 lines, showing that this surface is still coming under the tolerance zone, means this surface is okay to be considered. So the first box in control frame is showing symbol, second one is showing tolerance, and third one and fourth one are showing datum references. So this is the basic way for adding the GD&T symbols. Now we will shift to software. So here we are having this part and we need to show straightness or flatness here. We'll take flatness for this part now, this upper surface. So to add flatness, for that we need to go to insert and dimensioning, and here in dimensioning we have tolerancing. First we need to add datums if required, but as I said, in form categories datums are not required. So we are going to directly switch to GD&T symbol or geometrical tolerance. Just click here, click on this surface and click outside where you want to place this frame, feature control frame. Need to select the symbol, just click on this drop down menu and we can see all the 14 symbols are coming here. We are going to select flatness symbol. So I'm going to select the flatness. We can see here this reference option is been freezed because all the 4 characters in the category of form doesn't require any datum. That's why this references frames are being freezed here. We need to add the value. So I'm going to say this as 0.02. This is the tolerance value for the flatness required. Say OK. This way you can add the frame symbol here. Now we will add some datum references also. For that, again go to insert, dimensioning, tolerances and datum features. So here I'm going to add this bottom face as datum A. Say OK. If I want to change the size of this character, just click on this datum reference, go to text and I'm going to say 1.5 only the size. This size will get updated here. After adding first datum, we'll add the second datum, that is perpendicular face. For this A is this face. For that I'm going to add the datum as datum B. So we can access this tolerance frame from this toolbar also, that is dimensioning. Just go here and say datum feature, click here. Datum B in is been added here, and datum C we are going to take here on this face in top view, the front face which is being shown by this edge reference. We are going to consider this face as datum C. Again we can add the datum in same way. Just click here, say OK. We'll update the text size for these datums now. Just select the text, go on this value, I'll say 1.5. Same size is to be updated here. So for that we are having the option copy object format. Select this option. First click the text you want to change and then click on the text which has been updated. We can see this datum feature text size has been updated now. After adding the datums, again we are going to add some tolerances. So I need to say this face is perpendicular to this bottom face. Go to the datum feature symbol again and click on the face where you want to add the datum feature control frame. We'll select perpendicularity. We'll give the value as 0.3 and the reference we are going to take it as A reference, means A datum. We need to show caps lock on and capital A only here. Capital text should be added for the references. So this datum A is considered in the frame. Now this frame means this face is going to be perpendicular with this bottom face having the datum reference as A. And if this perpendicularity deviates, it should be deviated within this tolerance zone, that is of 0.3. The deviation should be not more than this 0.3. So this is the meaning of this control frame. After perpendicularity we are going to go for cylindricity now. So for that same way we are just going to select the feature control frame. We can go here insert and we can directly select or apply GD&T from here also. So we are going to go for dimensioning, and in dimensioning we are going to select tolerances. Here we have geometrical tolerance frame, feature control frame. Here we are going to apply cylindricity for this part. It is actually a circular cylindrical part. So we are going to click on this edge, put the frame here. After placing the frame, just put up the required tolerance. So I'm going to select cylindricity here, place it properly. After placing the frame, we are going to apply the tolerance value. So I'll say 0.02 mm. But here we can see this reference features are being locked. It is because as we are applying form category character, this character cylindricity comes under form category. So in form category, references are not required. We can say datums are not required. That's why this option is being freezed here. Say OK. If you want to place the frame properly, you can just drag it here and place it properly as you want. Now cylindricity means this part is going to be straight as well as circular in cross section. Both the things are included, that is circularity and straightness, so as to make a part cylinder. So it is combination of circularity and straightness. In this way you can apply the feature control frame here. Next we are going to see surface finish symbol. So for applying the surface finish symbol, we are going to use the annotations toolbar here. We can see surface finish icon, and below that only we are having welding symbols. So we'll start with annotations and surface finish, but we'll change the model here. So for that we are going to put on this part, that is top plate. Now in this top plate, a vertical plate is been made on this face. So we need to show that this part is welded here. So let's move this part to drafting now. Say start. Here we are going to select mechanical design and drafting. Say OK. Now we'll call the first view, that is front view. Click on this option in view toolbar. Go in Windows and we are going to select this top plate. Here I'm going to consider this face as the front view. Just click it here. We need to change the scale. So go to properties, say right click and go for properties. We are going to update the scale as 1:3. After placing this part properly, we are going to change the angle method also here. Suppose if I don't change the angle method and go for directly projections, now it is by default first angle method. So this bottom side of the plate will be shown at the upper top view. So if you want to flip this side, you just need to delete this and change the method here. Say right click and go for properties again, but not on the model. We have to right click on the sheet number 1, that is in model tree area. So right click here, go to properties again and select the angle method. So the projection angle method here, it is showing first angle method. We are going to update it to third angle method. Say apply and OK. After applying the angle method, again go for projection views, drag it, and we can see here this plate that was made on the top face is now being shown. Now the visualization of this view is from top side only. Earlier in first angle, the opposite side was being shown at the top view. So in this way you can change the angle method and then update the views. Again we'll take the side view also here. Now first we will see the surface finish symbol here. I want to say that this upper surface of this plate is been machined properly. So for adding the machining symbol, we have already discussed that we are going to use annotation toolbar. You just need to go here and select the roughness symbol. After selecting the roughness symbol, you just need to click on the face where you want to apply this roughness finish symbol. As you click on here, this symbol has been appearing. Already the values were filled for the earlier model. I am just going to set reset here, and we are going to add the type of roughness or roughness symbol values we want. So here mainly 3 types of symbol are being shown. First one, it is known as basic symbol. We'll see the meaning of this each symbol one by one. For that I am going to open one file photo here. So in photo we can see this symbol here. This was the first option given in surface finish types of symbols in CATIA. So we'll switch to CATIA. We can see the same symbol is coming here. So what this symbol actually means is, it is kind of basic surface texture symbol that says surface may be produced by any method. So you can achieve the surface finish by 2 methods, that is by removal of material or without removal of material. So as we take this symbol here, it means that we are saying the manufacturer whatever type of process they want they can use there. We just need the roughness value to be settled down. He may take the machining method or non-machining method. But if I go for the second type, this line is coming with this 2 lines. This third line is coming. So this line is coming means the symbol stands for machining only. Means material will be compulsorily removed so as to add the surface finish. This line means compulsory material removal is going to take place. So for that different operations are there. We are going to see that operations also in one photo here. So I'll minimize it. Again go for this folder and we are going to select the machining methods. So classification of machining process has been given here. First, here it is showing at the left side that traditional machining processes, which contains cutting processes. And in cutting also there are 2 types, that is circular shapes and various shapes. So if you want to obtain the surface finish on circular shapes, then go for turning operation, boring operation or drilling operation. And if you want a different kind of shape to be taken for machining, then we can go for this option, that is milling, planing, shaping, broaching, sawing, filling, gear forming and gear generating. On the other hand, there are non-traditional machining processes also. Means they are not regularly being used. For some special cases only we can use this type of processes. So under this category, first there is chemical machining, then electrochemical machining, electrochemical grinding, electric discharge machine, also famously known as EDM machines, laser beam machining, abrasive jet machining. Different types of source material can be used for as an abrasive here for abrasive jet machining. Then water jet machining, plasma beam machining, ultrasonic machining. So these are the processes where compulsory material is going to be removed and then only we can obtain the surface finish. So all these different processes come under material removal, or we can say machining processes. Now the third symbol in this category. So if I select and say this symbol. Now in this symbol we can see a circle instead of line. This symbol means machining is prohibited. We have seen here the third type, this symbol. Here it is showing material removal is prohibited. It is saying that the circle in the V indicates that the surface must be produced by process such as casting, forging, hot finishing, cold finishing, die casting, powder metallurgy or injection molding without subsequent removal of material. This is the important line here. Means material is not going to be removed here. Even then the surface finish will be obtained without removal of material. So all these processes, forging, hot finishing, cold finishing, die casting, powder metallurgy, injection molding, also we can say powder coating. So these are some processes where surface finish can be obtained without subsequent removal of material. So in simple way, this symbol means manufacturer is totally independent whether he want machining process or non-machining process. This symbol, manufacturer is compulsorily going for machining process, that is material removal process, and the third one, machining will be prohibited. If we are adding this symbol in a design means manufacturer needs to go for the processes in which material removal is prohibited or not allowed. Without removal of material, surface finish will be obtained. We'll select the second process here. After selecting the process, it will ask for the roughness average value. We can go for the roughness average value here. For understanding the symbol, we are going to fill the columns here. So here in the first upper column, at the left line upper side, here the value of maximum roughness it is asking. So we are going to provide the maximum roughness value. I'll say 0.07, that is 70 microns. Here I'm going to add 0.03 means 30 microns. So these values were above this left line. Beside this left line, we are going to add machining allowance. So machining allowance is nothing but the extra material we have left for machining this part or machining that particular face. So here I have kept the allowance of 0.1, say 100 microns. So we are having extra material of 100 microns and we are going to machine that part and make this part with maximum or minimum roughness value as 0.07 to 0.03. After machining, this value should come here. Now as we have taken the machining process for the surface finish, we need to mention the type of machining process or working process. So I am going to add the machining process here as grinding. After adding this process, we need to say whether you want this machining to be done all over the face or at particular surface only. So if you are going to go for all over the surface, you need to add this symbol here, this circular symbol. It means the complete surface is going to be machined. If I go for this symbol, that is without circle, means we are going to machine only the partial surface, not complete surface here. Next, it will ask sampling length. If you are going to provide the machining till particular length, then we can mention that length also here. And here it will ask you for direction of lay. Direction of lay means here we are going to show the pattern or impression which is going to be left after machining. That impression on surface may be parallel to the workface, perpendicular to the workface, or else we can say at multi-directional or zigzag. It may be circular or radial also, or it may be particulated, means dot forms. So these are the different types of lay directions that are going to be left after machining is done on the surface. So to understand these lay directions, we are going to go on this image here. You can see here this surface lay is different. So what this symbol means, lay approximately parallel to the line representing the surface to which the symbol has been applied. If I go for perpendicular symbol, lay approximately perpendicular to the line representing the surface to which the symbol has been applied. So here the symbols have been added, we can see. We'll move to software again and we are going to select multi-directional. As we are going for grinding, we'll select multi-directional. Now say OK and we can see here this complete symbol has been added to this surface. Means this upper surface is to be machined by grinding process. Maximum and minimum roughness value should come 70 microns to 30 microns in between these two values. The allowance we have left for machining is of 100 microns. This line, horizontal line, above this line the machining operation has been shown. And here we can see this M symbol means what kind of surface lay direction is going to be generated after machining is being shown. I'll just click it here and go for the text size and update the text size here, say 1.8. For this also select and say symbol size as 1.8 only. So these symbols are being shown a little bit smaller now. So in this way we can add the surface finish symbols. Next one we are going to see is welding symbol. Now for welding I have taken this part and we can assume that here one plate is been welded here. So in side view we can see this plate and I want to show the welding symbol at this junction between this line and this perpendicular line. So for that I am going to add the welding symbol, select the symbol icon. Same in annotations, below the surface finish symbol only the symbol is given welding symbol and just click it here. And we can see this symbol is generated. Click on the first line and second line, the symbol will be directly generated and put up the values. So I'll say reset. Now we'll see everything one by one. So first it is asking for the size of weld. I'm going to say this size as 2. Here the type of weld required, I'm going to select the fillet weld. Here the finish required, whether you want the finish to be kept flat, convex or concave shape, or else you want the smooth surface finish. So whatever kind of symbol I require I can put there. I'm going to select the flat symbol. We can see around this icon this symbol of line is been added showing the finish required. Next, the length of the weld. So if I want a weld to be made till particular length only, then we'll put up the length value. So I will say 20 mm here. Means on this edge till 20 mm only this welding will be provided. If length is required, then only put the value. If you want to go for the complete weld on this edge, don't put this value. Say backspace. Next, here in tail note we can give the classification of welding rod. We can type the message for manufacturer regarding the type of welding process required. Anything we can put up in the tail. That message will be delivered to manufacturer by this tail note. So I'm going to say what kind of operation for welding we are going to go for. I'll say I want gas weld here. After putting up this value, this icon we can see that is field symbol. Means if you are providing this icon here, field symbol, then the welding will be done at the place where assembly is to be done. We can see this symbol is appearing here beside this size of the weld. This symbol is nothing but it is asking us to make the weld where the final assembly is going to be assembled, not in the welding shop. Instead of that, we are going to make this weld in the assembly spot where the final assembly is going to be assembled. Because sometimes if we are doing welding in the shop only, and if we are going to carry complete welding frame or any part from one place to another, it is little bit difficult to handle that welding part. So better if we are going to take the parts, individual parts only at the place where final assembly is going to be done, and then weld there only so as to make the assembly easy. Now this icon, that is well all around. It means that this complete plate having the bottom edge as a rectangular shape, everything is to be welded from each side. That is the symbol's meaning of all around. After completing all the formalities, we are going to say OK, and this welding symbol has been provided here. Next, if I want to show the icon also of the welding, then we can go in the same option but the last one, that is this icon weld. You just need to collect two edges and the welding sign is being shown there. We can see here this triangular shape is coming. Thickness, if I want to increase the thickness, I can increase the thickness also. I am going to take 3 mm thickness here. Say OK. So here welding sign is also been added and welding is also being shown. If I want the weld to be shown on the other side also, I'll add the thickness there also. Just need to collect two lines, perpendicular lines, and this symbol will be added. Say OK. So this is the weld symbol being added in the drawing. This icon is showing type of welding. This line, inclined line, is showing the type of finish required on the welding. In the tail note we have given the type of operation we require for the welding. This circular symbol means all around weld around this plate. This flag means we are going to weld this part at the final assembly spot only, not in the welding shop. So in this way we can add the weld symbol here. So this was the lecture for today. In next lecture we are going to continue with the bill of material and table and types. So continue following the playlist of CATIA to understand the further lectures also. In previous lectures we have seen the complete course. If anybody is seeing this lecture, they can follow the playlist so as to understand complete CATIA course. So for today, these were the points we were going to see. Till then, thank you. So hello everyone, we are continuing with the CATIA series. We have uploaded the drafting lectures last, and now today we are going to see tables. Tables means first one is the regular table and second one is the bill of material, that is BOM table. For that we have taken this assembly model. We have also applied material to this model. So if you want to learn how we have applied the material to the parts, you can watch the previous lectures or continue with the CATIA playlist. So for now, we will take this assembly to drafting, say mechanical design and drafting. Say OK. Here we will call the isometric view. For that we are going to select this icon, isometric view. Go to window and select the product window. Just go on this toolbar, that is view toolbar, and in view toolbar we have this fourth last option, that is isometric view. Click on this icon. Now it is properly arranged as an isometric view here. Just click on this face and click here at one side. We'll scale this object a little bit smaller. We'll take this scale here as 1:3. Now we can see in annotations this tables option is given. Simple regular table. You just need to click on this tables option and enter the number of columns and rows you require. We will take this value as 7 for the columns, and for the rows we will take this value as 5. Just click here and the table will appear. Now if I want to fill the properties for this table, you just need to double click in the cell and the cell will be activated. For example, if I take numbers, then I'll go for part name, double click here. Next we'll go for quantity. Here we'll take material. Next we'll go for mass. Double click first and then write the text required. So in this way we can add the text as required in the table. Now if I want to edit this table, if I want to increase the width of this column, you just need to click on the table first, double click it here, and you can see this gray dash marks. You just drag it and the column's width will be increased or decreased as required. So in this way we can fill the properties of the table. Suppose if I want to continue with the numbers, I just need to click here and apply the text. Say OK. If I want to decrease the size of the text or font, you just need to click on the font and here you will get the size. So at the upper right corner, I'll put the value as 2. We can see here the text size has been updated. So in this way we can use the simple regular table. You just need to double click in the cell. Whatever property you want to fill, you can directly type and fill it here. But remember one thing, these properties will not be linked with the parts. So if you want a general table where properties not needed to be linked with the part, then you can go for this table. But if you want a table where properties are linked with the parts with related to the assembly, then we can use the bill of material, that is BOM table. Go to this insert option and insert will see this bill of material option. Here there is advanced bill of material and here it is simple bill of material. We'll see both one by one. So for bill of material, first we'll go for ballooning. Now ballooning will only appear here. The balloons will only appear when you have applied the command for balloons in assembly itself. So we'll go in assembly first, and here we have seen this option previously also, that is in assembly we have this toolbar product structure tools, and in that option we have generate numbering. So generate numbering, just click on this option, click on the title, and it will ask you the mode of generating the numbers, whether you want integers or you want letters. So I'll say integers only, say OK. Once this is done, the balloons will appear with the numbers in drafting. Now two more things are to be done here in assembly, that is to apply the exploded view here. Now for exploded view, I have already applied the exploded view using this scenes. We can see here, but I will delete it and again go for this scenes option. So we will see the explode one more time. Now select this toolbar, that is scenes toolbar, and in scenes toolbar go for the first option, enhance scenes. After clicking on this option, just put off this automatic naming and you can write the name as required for this exploded view. So I'll say exp1. Save overload mode as full, say OK. For exploded view, you just need to go on this toolbar, that is enhance scenes, and click on this option explode. Here you need to show which part is to be kept fixed. So fixed product it is asking, so I'm going to select this part as a fixed part or product. It is coming here as base plate is fixed, say apply and OK. Now with the help of compass you can arrange the parts as you require. So I'll just click on the part and drag this compass on that part. I want to move this part a little bit inside. Same with this part also. As you have kept this compass on one part, you just need to select all the other parts and move directly with the compass placed on the first part. It will move the parts then also. So I'll place it somewhere here. Then this part, I'll take it here. The other part, guide bush. Same with this guide bush, a little bit inside. The other one also. And then the guide pillars. I'm just clicking on the parts and directly moving it with the compass. Now if you are done, just drag this compass and drop it on this UCS icon at the below right side. It will be placed at its original position after that. Now this exploded view is ready. I'll arrange it properly as I want to show or display it in the drafting. After that say exit scene. As you exit scene, go for the window and go for drafting now. And for calling the isometric view here also, the same exploded view, You just need to select the isometric option in view tab and then go for the window. Product. Here we'll expand this applications icon, say scenes. You need to expand the scenes also, and this title exp1 is coming. You just need to click it here and select any one face so as to generate the isometric view in exploded form. Here you will see this isometric view has been generated here. I will change the scale here first. Go to properties and update the scale. I will say 1:3 only for this one also. So in this way you can display the isometric view in the assembly. We can see only 3 guide bush are properly visible. This 4th one is not visible. So we will call it again. I'll delete this view. Go for product. I will manually adjust it as I want. After adjusting, go to window again. Go to the same option to call isometric view. Select the option. Return to the assembly. Select the application scene and the title of the scene. Click on this any one face and the isometric view will be arranged. Now in this manner all the parts are visible properly. Just click it somewhere at the right side. Go and change the scale here. I'll say scale as 1:3 only for this also. We are going to insert the bill of material. So as we have said, there are 2 types of bill of material. Advanced bill of material as well as standard bill of material. So for standard as well as advanced bill of material, we need to do one more formality in assembly feature window only. That is, go in this assembly feature window and go to analyze. So in assembly interface we need to select analyze. Here we will see bill of material, this option. Go for this option and here we need to go for this define formats option. Just click here. Now it will ask you which columns you need to reflect in bill of material. So here are some headers been given, that is quantity, part number, type, nomenclature and revision. If I don't want this nomenclature here, I'll just click it here. Click on this single arrow, not this double arrow. It will hide all the properties. So if I want to hide this property, single property only, just click on this single lined arrow, not the double lined arrow. So here this nomenclature has been hide. Again, if I want to hide this revision also, just click on this option, say hide property. Only 3 properties are being shown now, that is quantity, part number and type. If I want to show some of the property from the right side, this list, we can add that properties also here. So I want this owner to be shown. So just click on this show properties option with single arrow. Now this owner has been added to this display properties option. Means this properties will be displayed in the table. If I want product description, just click it here and say add, show properties. So after adding the properties which we want to display, say OK and finish. Here also say OK. So here we have defined the properties which we want to display by going on this analyze option and selecting this bill of material. Now let's move to drafting window again. Select the drawing option. Here first activate the view for which you want to take the bill of material. After activating the view by double clicking, just go here in insert, select this option generation and say bill of material. Select bill of material option and select the view here. As soon as you select this view, this bill of material has been appeared. Here 2 tables are being shown. First one is bill of material and second one is recapitalization of product. It will show how many parts are there that are similar and different. So there are total 10 parts in which different parts are only 4 and 6 parts are similar. And here is the main bill of material in which we can see whatever properties we have displayed, they are being shown here. That is quantity, part number, type, owner and product description. So if I want to click or edit the table, I just need to double click here. After double clicking, I'll manually type whatever I want. So I'll say 4DI is the owner. I'll just double click here and copy it again. Say OK. Next, just double click, say paste. This way you can fill the properties manually also here. But there is one issue with this table, that some properties are linked with the table, but some custom properties if I want to add, then I need to type each property content. Directly that properties will not be shown here, that is material or mass. I need to edit the column description and then type the custom property. Then only I can fill the content for that properties. This is the main problem with the regular bill of material. Directly linked mass properties and material will not be generated in this table. For that only there is advanced bill of material. So we will see the advanced bill of material also here. Now for advanced bill of material, first we will call the isometric view of this assembly again, that too in exploded form. So as to generate the balloons also, we have not generated balloons here. This time we are going to call the view as in an exploded form, as well as we are going to generate the balloons here. Then we are going to go for advanced bill of material. For that we have opened the assembly here. Just go to assembly by saying isometric view. We need to call isometric view, that's why we have selected this option. Select the window and shift to assembly. Here just select the application scene and this exploded title and select one face for the reference. Here this isometric view has been generated. Click here. Next we need to make it scale a little bit smaller. So I'll first activate the view, then say right click. After right clicking, go to properties, and here we need to show the scale. After right click, go to properties, and here we need to change the scale. So I'll say the scale as 1:3. After placing the scale, after setting the scale, we need to go for balloons now. So balloons must be generated here. So for balloon generation, first you need to make sure that in assembly you have applied this option, that is generate numbering. So generate numbering, just click on this title. It will ask you for the integers or letters. We have seen this point earlier also. So I'll say I want integers as 1, 2, 3 for the balloons. Say OK. If you have done this step, then only the balloons will be generated there. Again shift to Windows for the drafting, and here we'll generate the balloons now. For that we need to go to insert, select the option as generation and say balloon generation. And you can see here these balloons have been generated. Now place the balloons as you require. So you just need to drag it for the placement. You can see here these balloons are been placed properly now. If I want to change the location or reference for the balloon, you just need to drag this yellow point and you can change the position of this balloon. So this number 2 is representing the guide pillar. First one is representing the guide bush. Next, this is the fourth part. I'll place it somewhere here. Now you must see that this point is grasping only the edges, not the faces. So I'll keep it somewhere here. Next, the last one. This one, this plate. So now the balloons are also been generated. Now for balloon settings, there are some settings for balloons also. So for that, just click on the leader, and after clicking on the leader, you just need to click on this yellow point. Right click on it here, and you can see one option is given, that is add a breakpoint. This is optional. If you want to add a breakpoint, then only you can go for this option. So I've added one breakpoint after clicking that, and you can see one point has been added between this leader. So I can move or place this point as required, and we can see this balloon will also move with reference to taking this origin as this point. So in this way you can break the balloons also. Next, if I right click here and go to properties for this balloon, here you will see if you want to change the frame, I want to say change the frame as none. So I'll say apply and OK. Then balloon will not be appeared here. If I again go for properties, and if I want to change, I want it circle only. So I'll keep this as circle only. I can go on font, and for font size I can change the size here. I'll say 2 only. So this balloon size, you can see it has been decreased as compared to the other balloons, as we have kept the size for text as 2. So you can increase or decrease the text size or balloon size also here. Again right click and go to properties. I'll say 3.5 as default for the font size. Say apply and OK. Again we can see the balloon size has been updated. So after checking the settings for the balloon, we'll go for the advanced bill of material now. For that, select insert, go for generation and select the bill of material. Here we'll see advanced bill of material. Now as soon as you press that command, you will get this little title box showing whether you want to invert the format of the table. If I invert the format of the table, the format will be from lower side, from the bottom side till the upper side. Means title will be shown at the lower side, then first number, then second number at the upper side, third number at the upper side, and so on. If I don't invert it, then the table will come as a standard format, that will be title will come first, and below that all the contents will come as usual. So if you want to invert, that is optional. Suppose if I say invert, you can see this blue tagline, that is of header line, it will come at bottom. If I again off it, it will come at top as usual. So in whatever way I want, I can switch this invert option. We will see it later after applying the table. Now say OK and select the view for which you want the table to be placed. Now your table has been placed. Just shift or place the table wherever you want. Next, now for adding the mass properties and material, as well as the custom properties, you need to right click here. Now the thing that makes this table little bit different from the regular bill of material table is we can add the custom properties as well as we can show the mass properties as well as material here. So for adding all this, you just need to right click and go for properties. Now in properties, go for reported properties. You will see this reported properties here. Suppose I want to change the order of these properties. I want the quantity at first, second is part number, third one is type, fourth one is nomenclature. So I want to shift this nomenclature to lower side. I just need to select that property and you can see this arrows upside and downside. I'll click on this move down arrow and this property will be moved down. So in this way we can change the order of the table contents here. But I want to add some more properties here. That is my main motive. So for that I'll select the property and I will click on this option, that is select new property or add new property. So I'll click on this option. After clicking, whatever was the last property selected, the new property will come with the same name. But we can change the name as well as we can modify the title. So for that I'll modify the title. I'll say I want material here. You need to modify this title also here. If I just keep material and say move up, in table it will be highlighted as nomenclature only. So you need to change or manually type the property here also. The same modified property, the name should be typed here. So I'll say material here. And now I'll say move it up. So this new property has been added. Second, I'll select this revision and instead of revision I want there as weight. So I'll type the name or modify the title again here. Say weight only, same title which is coming beside. This weight has been also added here. We can see at the upper side this weight is also been added. After that I want one customized property. So for that I'll click on this nomenclature and instead of nomenclature I'll say delete here and I'll type the name of the custom property. I need to show hardening processes in the table. So the new property will be hardening process. I'll type the title here. Beside that, the same title should be added again. Actually it was nomenclature property, but we have changed the name at both the sides. And this way you can add the user defined property. So whatever property you don't want, you just need to replace that property by the user defined property. We can see this hardening process also been added here. This is the user defined property and material as well as weight are also being shown. I'll just click here, say apply and OK. Now we can see weight is being shown here, material is being shown, type it is showing as type part as CATIA, as well as hardening process column is also been added. Now if I want to add the properties here, you just need to double click and you can add the hardening process as you require. So I'll say tempering, say OK. Here for this part I'll say normalizing. If I want to repeat the same property, I'll just copy it, say copy, say OK and say paste here. Double click, say paste, say OK. Again here case hardening. So these properties are being added here. Now if I want to edit this table, I don't want this type column to be shown. I'll again right click and say properties and I'll go on this option that is reported properties. Here I'll select this type and I'll say to erase that or delete that particular content or column. So that column has been deleted here. Say apply and OK. So we can see here. Now next thing here is showing part number. Actually when we save the part in standard practice, we need to save that part in number format. Usually companies prefer number format only and the real names are given in description. So we'll do that same thing again here. So instead of part number, I will add this title here as description. Say right click and go to properties again. And instead of this part number, I want the title to be shown in the table as description. So I'll only just change the right side title, not the left side title, not needed to be changed, modified property. So title we need description. Say apply and OK. So now we can see that particular column's title is being shown description here instead of part number. Still if I want to add the part number, I'll just right click here again, select the properties and I'll say again one more property I need to add, that is new property. I'll give the name as description here, but the title I will say as part number. Say to add it. Now this part number will be shown as one more column there. Say apply OK. So this part number is also coming here now. If I want to change the width, I'll change it. Suppose if I want this part number series to be shown in such way that 1 2 6 5 4 5 3 1 0. This may be the part number. I will copy it, say OK. And again I'll double click and paste it. If I want to change the last 2 digits, usually this is done in numbering, that only last 2 or 3 digits are being changed. So I'll say 11 instead of 10, say OK. So this series is coming here. Again double click, paste the same number, but instead of last number I'll change it. I'll say 12. Double click here also, say again, paste. This time I'll say 13. Say OK again. Double click and remove this dash also here. Say OK. Now this part number is also been updated. Description has been updated. Weight has been updated, which was linked by the actual assembly or parts. And the material also, which was actually linked by the part, is been displayed here. These are not typed material. These are the actual materials which were linked by this part. As well as weight is also been shown according to that only. So that's why advanced bill of material is more preferable here. Now I'll delete this view, regular bill of material as well as the isometric view, and I'll shift this one into this title. Place the table also as required. If I want to add the title block also here, I'll just say edit, and here I'll say I need to add the table also. For that, I'll select this frame and title block, and I'll say I want the title block to be shown as sample 1. Say apply and OK. Now we can see here this title block is also been added. Again, for exiting this view, working views, select the working view option in edit. If I want to change the width, I'll decrease or compress this width little bit so as to adjust the table properly. Now place the table wherever you want, and this is done. Lastly, I want to save this file now. If I don't want this red border of the view to be shown, I'll just put it off. Here we have the option display view frame. I'll just put off this option. When it is on, it will be shown in orange color. I will put it off again after adjusting. Now for printing and plotting, go here and file and say save as. After saying save as, you just need to say the location where you want to save the file. So I want this file to be saved on desktop only with the same name, BOM lecture, that is bill of material lecture. And the extension I will add here as PDF. If I want to save this file to DWG, I can save that file to DWG also. Then that file can be used in AutoCAD also here. And the alternate option for using the file in AutoCAD, we have that DXF option here. So if either DXF or DWG, then we can open this file in AutoCAD also. But I'll save this file as PDF now. Save. I'll save in DXF and DWG also so as to show you. Next, file, save as. This time I will say DWG file. Say save. Again save as. This time I will say DWG file. And the location for saving, I will save it here on desktop. Format is DWG this time, second time. Next, I will save it one more time, save as. This is the third time I am saving it, but with different formats. So I will save it as JPG file. Same on the location that was desktop only, save again. Now if I close this and save the changes, it will be saved. Now if I want to open that same file for CATIA drafting as a CATIA drafting file, I will just go and say open, and that file was saved in the CATIA lectures. So I'll open that file here. This was the file BOM lecture. Now this is DWG file for CATIA. But for the other formats, I'll just directly go on the desktop and double click here. So this is the JPG file. I'll double click it here, JPG file. So you can see that is JPG file. It is like an image file only. You can forward this file or print this file directly. Next one is PDF file. Double click here on PDF file, and this is the PDF file. We can see here. We can directly take this file to printing and plotting now. And then the next format we have saved was AutoCAD file. So for AutoCAD file, this is the file, BOM lecture. I'll double click it here. We can see here, this file will be opened in AutoCAD format as the extension was saved DWG file. That's why it may take some time for opening in AutoCAD. Say OK. And we can see here, this file is been opened in AutoCAD also. All the table text, same it is coming here also. So in this way, you can convert the DWG file of CATIA to AutoCAD file also for printing and plotting. So this was the lecture for today. We'll continue with the further lectures. Continue watching 4 Dimensions Infotech and subscribe the channel. Do like, share it, and share it with your friends also, so as they can also learn CATIA. If you want to learn advanced CATIA, you can join the courses. The number will be given below for joining the courses. You can join offline as well as online courses both. Till then, thank you.